I'm taking a nap. Talk to you in the morning.
Excellent. Sweet dreams.
Thank you.
You're welcome.
So if you go back to the earliest quantitative studies of memory by Ebbinghaus, what you see is that he was trying so hard to memorize this arbitrary nonsense. And within a day, he lost about 60% of that information. And he was basically using a very, very generous way of measuring, right? So as far as we know, nobody has managed to violate those basics of having people forget, most of their experiences. So if your expectation is that you should remember everything, and that's what your optimum is, you're already off, because it's just not what human brains are designed to do. On the other hand, what we see over and over again is that the brain does basically, one of the cool things about the design of the brain is it's always less is more, less is more. It's like, I've seen estimates that the human brain uses something like 12 to 20 watts. That's just nuts, the low power consumption, right? So it's all about reusing information and making the most of what we already have. And so um, that's why basically, again, what you see biologically is, neuromodulators, for instance, these chemicals in the brain like norepinephrine, dopamine, serotonin. These are chemicals that are released during moments that tend to be biologically significant: surprise, fear, stress, etc. And so these chemicals promote lasting plasticity, essentially some mechanism for which the brain can prioritize the information that you carry with you in the future. Attention is a big factor as well, our ability to focus our attention on what's important. And so there's different schools of thought on training attention, for instance. So one of my colleagues, Amishi Jha, she wrote a book called Peak Mind and talks about mindfulness as a method for improving attention and focus. So she works a lot with military, like Navy SEALs and stuff, to do this kind of work with mindfulness meditation. Adam Ghazali, one of my friends and colleagues, does work on kind of training through video games, actually, as a way of training attention. And so it's not clear to me. One of the challenges, though, in training is you tend to overfit to the thing that you're trying to optimize, right? So you tend to, if I'm looking at a video game, I can definitely get better at paying attention in the context of the video game if you transfer it to the outside world. That's very controversial.
The implication there is that attention is a fundamental component of remembering something, allocating attention to it. And then attention might be something that you could train.
Yeah.
How you allocate attention and how you hold attention, kind of thing.
I could say that, in fact, we do in certain ways, right? So if you are expert in something, you are training attention. So we did this one study of expertise in the brain. And there's people used to think, let's say if you're a bird expert, we'll go like, if you get really into this world of birds, you start to see the differences in your visual cortex is tuned up and so on, plasticity of the visual cortex. And vision researchers love to say it. But it's like, we did the study of attention and working memory and expertise. And one of the things that surprised us were the biggest effects as people became experts in identifying these different kinds of just crazy objects that we made up. As they developed this expertise of being able to identify what made them different from each other and what made them unique, we were actually seeing massive increases in activity in the cortex. And this fits with some of the studies of chess experts and so forth, that it's not so much that you learn the patterns passively, you learn what to look for. You learn what's important and what's not. Right? And you can see this in any kind of expert professional athlete. They're looking 3 steps ahead of where they're supposed to be. So that's a kind of a training of attention. And those are also what you call expert memory skills. So if you take the memory athletes, I know that's something we're both interested in. And so these are people who train in these competitions and they'll memorize like a deck of cards in a really short amount of time. There's a great memory athlete. Her name, I think, is pronounced Yenya Wintersoul. But she, so I think she's got like a giant Instagram following. So she had this YouTube video that went viral where she had memorized an entire IKEA catalog. Right? And so how do people do this? By all accounts, from people who become memory athletes, they were born with some extraordinary memory. But they practice strategies over and over and over again. The strategy that they use for memorizing a particular thing, it can become automatic and you can just deploy it in an instant. Right? So again, it's not necessarily going to, one strategy for learning the order of a deck of cards might not help you for something else that you need, like remembering your way around Austin, Texas. But it's going to be these, whatever you're interested in, you can optimize for that. And that's just a natural byproduct of expertise.
There's certain hacks. There's something called the memory palace that I've played with. I don't know if you're familiar with that whole technique. And it works. It's interesting. So another thing I recommend for people a lot is I use Anki a lot every day. It's an app that does spaced repetition. So I think medical students and students use this a lot to remember a lot of different things.
Oh yeah. Okay, we can come back to this. Yeah.
Sure. It's the whole concept of spaced repetition. You just when the thing is fresh, you kind of have to remind yourself of it a lot, and then over time, you can wait a week, a month, a year before you have to recall the thing again. And that way, you essentially have something like note cards that you can have tens of thousands of, and can only spend 30 minutes a day and actually be refreshing all of that information, all of that knowledge. It's really great. And then for Memory Palace is a technique that allows you to remember things like that. You can't catalog it by placing them visually in a place that you're really familiar with. Like, I'm really familiar with this place, so I can put numbers or facts or whatever you want to remember. You can walk along that little palace and realize it. It's cool. Like, there's stuff like that that I think memory athletes could use, but I think also regular people could use. One of those things I have to solve for myself is how to remember names. I'm horrible at it.
Yeah.
I think it's because when people introduce themselves, I have the social anxiety of the interaction where I'm like, I know I should be remembering that, but I'm freaking out internally about social interaction in general, and so therefore I forget immediately. So I'm looking for good tricks for that.
So I feel like we've got a lot in common because when people introduce themselves to me, it's almost like I have this like just blank blackout for a moment, and then I'm just looking at them like, what happened? I look away or something. What's wrong with me?
Yeah.
So I mean, I'm totally with you on this. The reason why it's hard is that there's no reason we should be able to remember names, because when you say remembering a name, you're not really remembering a name. Maybe in my case you are, but most of the time you're associating a name with a face and an identity, and that's a completely arbitrary thing. Right? I mean, maybe in the olden days, somebody named Miller, it's like they're actually making flour or something like that. But for the most part, it's like these names are just utterly arbitrary. So you have no thing to latch onto. And so it's not really a thing that our brain does very well, to learn meaningless, arbitrary stuff. So what you need to do is build connections, visualize a connection, and sometimes it's obvious, or sometimes it's not. I'm trying to think of a good one for you now, but the first thing I think of is Lex Luthor.
That's great.
Yeah, so I think Lex Luthor.
Doesn't Lex Luthor wear a suit? I think.
I know he has a shaved head though, or he's bald, but you're not. You've got a great head. I'd trade hair with you any day. But like something like that. But if I can come up with something, like I could say, okay, so Lex Luthor is this criminal mastermind, and I just imagine you
talked about stabbing or whatever earlier.
Yeah, exactly.
So it's
right.
Kind of connected. And that's it.
Yeah. But I'm serious though that these kinds of weird associations now I'm building a richer network. I mean, one of the things that I find is if like you can have somebody's name that's just totally generic, like John Smith or something. Not that, no offense to people about that name, but if I see a generic name like that, but I've read John Smith's papers academically, and then I meet John Smith at a conference, I can immediately associate that name with that face because I have this pre-existing network to lock everything onto, right? And so you can build that network, and that's what the method of loci or the memory palace technique is all about. Is you have a pre-existing structure in your head of like your childhood home or this mental palace that you created for yourself. And so now you can put arbitrary pieces of information in different locations in that mental structure of yours. And then you could walk through the different path and find all the pieces of information you're looking for. So the method of loci is a great method for just learning arbitrary things, because it allows you to link them together and get that cue that you need to pop in and find everything, right?
We should maybe linger on this memory palace thing just to make obvious, because when people were describing to me a while ago what this is, it seems insane. You literally think of a place like a childhood home or a home that you're really visually familiar with, and you literally place in that three-dimensional space facts or people or whatever you want to remember, and you just walk in your mind along that place visually, and you can remind yourself of the different things. One of the limitations is there is a sequence to it, so I think your brain somehow you can't just like go upstairs right away or something. You have to like walk along the room. So it's really great for remembering sequences, but it's also not great for remembering like individual facts out of context. Like the full context of the tour is important. But it's fascinating how the mind is able to do that when you ground these pieces of knowledge into something that you remember well already, especially visually. It's fascinating. You can just do that for any kind of sequence. I'm sure she used something like this for IKEA catalog.
Oh yeah, absolutely. And I think the principle here is, again, I was telling you this idea that memories can compete with each other, right? Well, I like to use this example, and maybe someday I'll regret this, but I've used it a lot recently. Is like, imagine if this were my desk, it could be cluttered with a zillion different things. And so imagine it's just cluttered with a whole bunch of yellow Post-it notes, and on one of them I put my bank password on, right? Well, it's going to take me forever to find it. I might, it's just going to be buried under all these other Post-it notes. But if it's like hot pink, it's going to stand out, and I find it really easy, right? So that's one way in which, if things are distinctive, if you process information in a very distinctive way, then you can have a memory that's going to last. And that's very good, for instance, for name face associations. If I get something distinctive about you, that it's like that you've got very short hair, maybe I can make the association with Lex Luthor or something like that, right? But I get something very specific. That's a great cue. But the other part of it is, what if I just organized my notes so that I have my finances in one pile, and I have my reminders, my to-do list in one pile, so I organize them. Well, then I know exactly if I'm going for my banking, my bank password, I could go to the finance, right? So the method of loci works, or memory palaces work, because they give you a way of organizing. There's a school of thought that says that episodic memory evolved from this kind of knowledge of space, and basically these primitive abilities to figure out where you are, and so people explain the method of loci that way. And whether or not the evolutionary argument is true, the method of loci is not at all special. So if you're not a good visualizer, stories are a good one. So a lot of memory athletes will use stories, and they'll go, like, if you're memorizing a deck of cards, they have a little code for the different, like the king and the jack and the 10 and so forth. And they'll make up a story about things that they're doing. Songs are a great one, right? I mean, it's like, I can still remember there's this obscure episode of the TV show Cheers. They sing a song about Albania that he uses to memorize all these facts about Albania. I can still sing that song. it's just, I saw it on a TV show,
So what you mentioned spaced repetition. So what do you like this process? Maybe can you explain it?
Oh yeah. If I'm trying to memorize something, let's say if I have an hour to memorize as many Spanish words as I can. If I just try to do like half an hour, and then later in the day I do half an hour, I won't retain that information as long as if I do half an hour today and half an hour 1 week from now. And so doing that extra spacing should help me retain the information better. Now there's an interesting boundary, which is it depends on when you need that information. So many of us, for me, like I can't remember so much from college and high school because I crammed, because you just did everything at the last minute. And sometimes I would literally study, in the hallway right before the test. And it was great, because what would happen is I just had that information right there. And so actually not spacing can really help you if you need it very quickly, right? But the problem is that you tend to forget it later on. But on the other hand, if you space things out, you get a benefit for later on retention. And so there's many different explanations. We have a computational model of this. It's currently under revision. But in our computer model, what we say is that maybe a good way of thinking about this is this conversation that you and I are having. It's associated with a particular context, a particular place in time. And so all of these little cues that are in the background, these little guitar sculptures that you have, and that big light umbrella thing, right? All these things are part of my memory for what we're talking about, content. So now later on, you're sitting around and you're at home drinking a beer, and you think, God, what a strange interview that was, right? So now you're trying to remember it. The context is different. So your current situation doesn't match up with the memory that you pulled up. There's error. There's a mismatch between what you pulled up and your current content. And so in our model, what you start to do is you start to erase or alter the parts of the memory that are associated with a specific place and time, and you heighten the information about the content. And so if you remember this information in different times and different places, it's more accessible at different times and different places because it's not overfitted in a AI kind of way of thinking about things. It's not overfitted to one particular content. But that's also why the memories that we call upon the most also feel kind of like they're just things that we read about almost. We don't vividly reimagine them. Right? It's just these things that just come to us like facts, right? And it's a little bit different than semantic memory, but it's like basically these events have recalled every, over and over and over again. We keep updating that memory so it's less and less tied to the original experience. And then we have those other ones, which it's like you just get a reminder of that very specific context. You smell something, you hear a song, you see a place that you haven't been to in a while, and boom, it just comes back to you. And that's the exact opposite of what you get in space.
That's so fascinating. So the space repetition, one of its powers is that you lose attachment to a particular context. But then it loses the intensity of the flavor of the memory.
Mm-hmm.
I think.
Yeah, but at the same time, it becomes strong in the sense that the content becomes strong.
Yeah, so it's used for learning languages, for learning facts, for that generic semantic information type of memory.
Yeah, and I think this falls into a category we've done other modeling. One of these is a published study in PLOS Computational Biology, where we showed that another way, which is, I think, related to the spacing effect, is what's called the testing effect. So the idea is that if you're trying to learn words, let's say in Spanish or something like that, and this doesn't have to be words, it could be anything, you test yourself on the words, and that act of testing yourself helps you retain it better over time than if you just studied it, right? And so from traditional learning theories, some learning theories anyway, this seems weird. Why would you do better giving yourself this extra error from testing yourself rather than just, giving yourself perfect input that's a replica of what it is that you're trying to learn? And I think the reason is that you get better retention from that error, that mismatch that we talked about, right? So what's happening in our model, it's actually conceptually kind of similar to what happens with backprop and AI, or neural networks. And so the idea is that you expose, here's the bad connections and here's the good connections. And so we can keep the parts of the cell assembly that are good for the memory and lose the ones that are not so good. But if you don't stress test the memory, you haven't exposed it to the error. And so that's why I think this is a thing that I come back to over and over again, is that you will retain information better if you're constantly pushing yourself to your limit, right? If you are feeling like you're coasting, then you're actually not learning. So it's like
you should always be stress testing the memory system.
Yeah, and feel good about it. Even though everyone tells me, "Oh, my memory's terrible," in the moment they're overconfident about what they'll retain. So it's fascinating. And so what happens is when you test yourself, oh my God, I thought I knew that, but I don't. And so it can be demoralizing until you get around that and you realize, hey, this is the way that I learn. This is how I learn best. It's like if you're trying to star in a movie or something like that, you don't just sit around reading the script. You actually act it out. You're going to botch those lines from time to time.
There's an interesting moment. You probably experienced this. I remember a good friend of mine, Joe Rogan, I was on his podcast, and we were randomly talking about soccer, football. Somebody I grew up watching, Diego Armando Maradona, one of the greatest soccer players of all time. And we were talking about him and his career and so on. And Joe asked me if he's still around. No, and I said, yeah. I don't know why I thought yeah, because that was a perfect example of memories. He passed away. I tweeted about it, how heartbroken I was, with all this kind of stuff, like a year before. I know this, But in my mind, I went back to the thing I've done many times in my head, visualizing some of the epic runs he had on goal and so on. So for me, he's alive. So and part of also the conversation we're talking to Joe, the stress and like the focus is allocated, the attention is allocated in a particular way. But when I walked away, I was like, in which world was Diego Maradona still alive? Like in which? Because I was sure in my head that he was still alive. It was it's a moment that sticks with me. I've had a few like that in my life, where it just kind of like obvious things just disappear from the mind, and it's cool. Like it shows actually the power of the mind in a positive sense. Erase memories you want erased, maybe. But I don't know. I don't know if there's a good explanation for that.
One of the cool things that I found is that some people really just revolutionize a field by creating problems that didn't exist before. It's kind of like why I love science. Is like engineering is like solving other people's problems, and science is about creating problems. And just much more like a great thing. So a great problem.
Yeah.
Not necessarily move fast, but one of my former mentors, Marsha Johnson, who in my opinion is one of the greatest memory researchers of all time. She comes up, young woman in the field, and it's mostly guy field, and she gets into this idea of how do we tell the difference between things that we've imagined and things that we actually remember? How do we tell? I get some mental experience. Where did that mental experience come from, right? And it turns out this is a huge problem because essentially our mental experience of remembering something that happened, our mental experience of thinking about something, how do you tell the difference? They're both largely constructions in our head. And so it is very important. And the way that you do it is, it's not perfect, but the way that we also do it and succeed is by, again, using our prefrontal cortex and really focusing on the sensory information or the place and time and the things that put us back into when this information happened. And if it's something you've thought about, you're not going to have all of that vivid detail as you do for something that actually happened. But it doesn't work all the time. But that's a big thing that you have to do. But it takes time. It's slow and it's, again, effortful. But that's what you need to remember accurately. But what's cool, and I think this is what you alluded to about how that was an interesting experience, imagination is exactly the opposite. Imagination is basically saying, I'm just going to take all this information from memory, recombine it in different ways, and throw it out there. So, for instance, Dan Shacker and John Addis did cool work on this. Demis Hassabis did work on this with Eleanor McGuire in UCL. And this goes back actually to this guy, Frederick Bartlett, who was this revolutionary memory researcher at Bartlett. He actually rejected the whole idea of quantifying memory. He said there's no statistics in my book. He came from this anthropology perspective. And short version of the story is he just asked people to recall things. You give people stories and so on, ask people to recall them. And what he found was people's memories didn't reflect all of the details of what they were exposed to. And they did reflect a lot more. They were filtered through this lens of prior knowledge, the cultures that they came from, the beliefs that they had, the things they knew. And so what he concluded was that he called remembering an imaginative construction, meaning that we don't replay the past. We imagine how the past could have been by taking bits and pieces that come up in our heads. And likewise, he wrote this beautiful paper on imagination, saying when we imagine something and create something, we're creating it from these specific experiences that we've had and combining with our general knowledge. But instead of trying to focus it on being accurate and getting at one thing, you're just ruthlessly recombining things without any necessary kind of goal in mind. Or at least that's one kind of creation.
So imagination is fundamentally coupled with memory in both directions.
I think so. It's not clear that it is in everyone, but one of the things that's been studied is some patients who have amnesia, for instance, they have brain damage, say, to the hippocampus. And if you ask them to imagine things that are not in front of them, like imagine what could happen after I leave this room, right? They find it very difficult to give you a scenario of what could happen, or if they do, it would be more stereotyped, like yes, this could happen. But it's not like they can come up with anything that's very vivid and creative in that sense. That's partly because when you have amnesia, you're stuck in the present. Because to get a very good model of the future, it really helps to have episodic memories to draw on. And so that's the basic idea. And in fact, one of the most impressive things, when people started to scan people's brains and ask people to remember past events, what they found was there's this big networking called the default mode network. It gets a lot of press because it's like thought to be important. It's engaged during mind wandering, and if I ask you to pay attention to something, it only comes on when you stop paying attention. So people go, oh, it's just this kind of daydreaming network. And I thought this is just ridiculous. But then what people found was when people recall episodic memories, this network gets active, and so we started to look into it, and this network of areas is really closely functionally interacting with the hippocampus. And so, in fact, some would say the hippocampus is part of this default network. And if you look at brain images of people, or brain maps of activation, so to speak, of people imagining possible scenarios of things that could happen in the future, or even things that couldn't really be very plausible, they look very similar. I mean, to the naked eye, they look almost the same as maps of brain activation when people remember the past. According to our theory, and we've got some data to support this, we've broken up this network in various subpieces, is that basically it's kind of taking apart all of our experiences and creating these little Lego blocks out of them. And then you can put them back together if you have the right instructions to recreate these experiences that you've had, but you could also reassemble them into new pieces to create a model of an event that hasn't happened yet. And that's what we think happens when our common ground that we're establishing in language requires using those building blocks to put together a model of what's going on.
So there's a good percentage of time I personally live in the imagined world. I think I do thought experiments a lot. I take the absurdity of human life as it stands and play it forward in all kinds of different directions. Sometimes it's rigorous thought experiments, sometimes it's fun ones. So I imagine that has an effect on how I remember things. And then I suppose I have to be a little bit careful to make sure stuff happened versus stuff that I just imagined happened. And this also, some of my best friends are characters inside books that never even existed. And there's some degree to which they actually exist in my mind. Like these characters exist, authors exist, Dostoevsky exists, but also Brothers Karamazov.
I love that book.
Yeah.
One of the few books I've read. One of the few literature books that I've read. I read a lot in school. Brothers Karamazov.
But they exist. They exist, and I have almost kind of like conversations with them. It's interesting. It's interesting to allow your brain to kind of play with ideas of the past, of the imagined, and see it all as one.
Yeah, there was actually this famous mnemonist. He's kind of like back then the equivalent of a memory athlete, except he would go to shows and do this. That was described by this really famous neuropsychologist from Russia named Luria. And so this guy was named Solomon Cherishevsky, and he had this condition called synesthesia that basically created these weird associations between different senses that normally wouldn't go together. So that gave him this incredibly vivid imagination that he would use to basically imagine all sorts of things that he would need to memorize. And he would just imagine, just create these incredibly detailed things in his head that allowed him to memorize all sorts of stuff. But it also really haunted him by some reports that basically it's like he was at some point, drinking was part of this, but he at some point had trouble differentiating his imagination from reality, right? And this is interesting because it's like, that's what psychosis is in some ways, is you first of all, you're just learning connections from prediction errors that you probably shouldn't learn. And the other part of it is that your internal signals are being confused with actual things in the outside world. Right?
Well, that's why a lot of this stuff is both feature and bug, a double-edged sword.
Yeah, I mean, it might be why there's such an interesting relationship between genius and psychosis.
Yeah, maybe they're just two sides of the same coin. Humans are fascinating, aren't they?
I think so. Sometimes scary, but mostly fascinating.
Can we just talk about memory sport a little longer? There's something called the USA Memory Championship. Like, what are these athletes like? What does it mean to be like elite level at this? Have you interacted with any of them or reading about them? What have you learned about these folks?
There's a guy named Henry Rothschild who's studying these guys. There's actually a book by Joshua Foer called Moonwalking with Einstein, where he talks about he actually, as part of this book, just decided to become a memory athlete. They often have these life events that make them go, hey, why don't I do this? So there was a guy named Scott Hagwood, who I write about, who thought that he was getting chemo for cancer. And so he decided, like, because chemo, there's a well-known thing called chemo brain. People become like, they just lose a lot of their sharpness. And so he wanted to fight that by learning these memory skills. So he bought a book. And this is the story you hear in a lot of memory athletes is they buy a book by other memory athletes or other memory experts, so to speak. And they just learn those skills and practice them over and over again. And they start by winning bets and so forth. And then they go into these competitions. And the competitions are typically things like memorizing long strings of numbers, or memorizing quarters of cards and so forth. So there tend to be pretty arbitrary things, not like things that would be you'd be able to bring a lot of prior knowledge. But they build the skills that you need to memorize.
Yeah, it's fascinating. I've gotten a chance to work with something called NBAC tasks. So there's all these kinds of tasks, memory recall tasks that are used to kind of load up the quote-unquote working memory. And to see, the psychologists used it to test all kinds of stuff, like to see how well you're good at multitasking. We used it in particular for the task of driving. Like if you fill up your brain with intensive working memory tasks, how good are you at also not crashing? That kind of stuff. It's fascinating, but again, those tasks are arbitrary and they're usually about recalling a sequence of numbers in some kind of semi-complex way. Are you? Do you have any favorite tasks of this nature in your own studies?
I've really been most excited about going in the opposite direction and using things that are more and more naturalistic. And the reason is that we've moved in that direction because what we found is that memory works very, very differently when you study it, when you study memory in the way that people typically remember. And so it goes into a much more predictive mode. And you have these event boundaries, for instance, and you have, but a lot of what happens is this kind of fascinating mix that we've been talking about, a mix of interpretations and imagination with perception. And so, and the new direction we're going in is understanding navigation in memory places. And the reason is that the work that's done in rats, which is very good work, they have a rat, they put it in a box, and the rat goes chases cheese in a box, and they find cells in the hippocampus that fire when a rat is in different places in the box. And so the conventional wisdom is that the hippocampus forms this map of the box. And I think that probably may happen when you have like absolutely no knowledge of the world, right? But I think one of the cool things about human memory is we can bring to bear our past experiences to economically learn new ones. And so, for instance, if you learn a map of an IKEA, let's say if I go to the IKEA in Austin, I'm sure there's one here, I probably could go to this IKEA and find my way to the, where the wine glasses are without having to even think about it because it's got a very similar layout. Even though IKEA is a nightmare to get around, once I learned my local IKEA, I can use that map everywhere. Why form a brand new one for a new place? And so that kind of ability to reuse information really comes into play when we look at things that are, more naturalistic tasks. And another thing that we're really interested in is this idea of like what if instead of basically mapping out every coordinate in the space, you form a pretty economical graph that connects basically the major landmarks together, and being able to use that as, emphasizing the things that are most important, places that you go for food, and the places that are landmarks that help you get around, and then filling in the blanks for the rest. Because I really believe that cognitive maps or mental maps of the world, just like our memories for events, are not photographic. I think there's this combination of actual verifiable details and then a lot of inference that you make.
What have you learned about this kind of spatial mapping of places? How do people represent locations?
There's a lot of variability. I think that, and there's a lot of disagreement about how people represent locations. In a world of GPS and physical maps, people can learn it from basically what they call a survey perspective, being able to see everything. And so that's one way in which humans can do it that's a little bit different. There's one way we can memorize routes. Like, I know how to get from here to, let's say if I walk here from my hotel, and just rigidly follow that route. And there's another more integrative way, which would be what's called a cognitive map, which would be kind of a sense of how everything relates to each other. And so there's lots of people who believe that these maps that we have in our head are isomorphic with the world. They're like these literal coordinates that follow Euclidean space. And as you know, Euclidean mathematics is very constrained, right? And I think that we are actually much more generative in our maps of space, so that we do have these bits and pieces. We've got a small task that's right now not yet we need to do some work on it for further analyses, but one of the things we're looking at is these signals called ripples in the hippocampus, which are these bursts of activity that we see that are synchronized with areas in the neocortex, in the default network actually. And so what we find is that those ripples seem to increase at navigationally important points when you're making a decision or when you reach a goal. This speaks to the emotion thing, right? Because if you have limited choices, if I'm walking down the street, I could really just get a mental map of the neighborhood with a more minimal kind of thing by just saying, here's the intersections and here's the directions I take to get in between them. And what we found in general in RMI studies is basically the more people can reduce the problem, whether it's space or any kind of decision-making problem, the less the hippocampus can go. It really is very economical for the points of most highest information content.
So can you describe the encoding in the hippocampus and the ripples you're talking about? What's the signal in which you see the ripples?
Yeah, so this is really interesting. There are these oscillations, right? So there's these waves that you basically see. And these waves are points of very high excitability. And at least they happen actually during slow wave sleep too. So the deepest stages of sleep when you're just zonked out, right? You see these very slow waves where it's very excitable and very unexcited. And on top of them, you'll see these really sharp ripples. And when there's a ripple in the hippocampus, you tend to see a sequence of cells that resemble a sequence of cells that fire when an animal's actually doing something in the world. So it almost is like little, people call it replay. It's a little bit, I don't like that term, but it's basically a little bit of a compressed play of the sequence of activity in the brain that was taking place earlier. And during those moments, there's a little window of communication between the hippocampus and these areas in the cortex. And so that, I think, helps you form new memories, but it also helps you, I think, stabilize them, but also really connect different things together in memory and allows you to build bridges between different events that you've had. And so this is one of at least our theories of sleep and its real role in helping you see the connections between different events.
So during sleep is when the connections
the connections between different events.
Yeah.
Right? So it's like you see me now, you see me next week, you see me a month later. You start to build a little internal model of how I behave and what to expect of me. And we think sleep, one of the things that allows you to do is figure out those connections, connect the dots, and find the signal in the noise.
So you mentioned fMRI. What is it and how is it used in studying memory?
This is actually the reason why I got into this whole field of science. When I was in grad school, fMRI was just really taking off as a technique for studying brain activity. And what's beautiful about it is you can study the whole human brain, and there's lots of limits to it, but you can basically do it in the person without sticking anything into their brains, and very non-invasive. And for me, being an MRI scanner is like being in the room. If I'm not being asked to do anything, but you can have people watch movies while they're being scanned, or you can have them do tests of memory, like giving them words and stuff to memorize. But what MRI is itself is just this technique where you put people in a very high magnetic field. Typical ones we would use would be 3 Teslas to give you an idea. So a Tesla magnet, you put somebody in, and what happens is you get this very weak but measurable magnetization in the brain, and then you apply a radio frequency pulse, which is basically a different electromagnetic field. And so you're basically using water, the water molecules in the brain as a tracer, so to speak. And part of it in fMRI is the fact that these magnetic fields that you mess with by manipulating these radio frequency pulses and static field, and you have things called gradients, which change the strength of the magnetic field and different parts of the head. So they're all, we tweak them in different ways, but the basic idea that we use in fMRI is that blood is flowing to the brain, and when you have blood that doesn't have oxygen on it, it's a little bit more magnetizable than blood that does, because you have hemoglobin that carries the oxygen and iron basically in the blood and makes it red. And so that hemoglobin, when it's deoxygenated, actually has different magnetic field properties than when it has oxygen. And it turns out when you have an increase in local activity in some part of the brain, the blood flows there, and as a result, you get a lower concentration of hemoglobin that is not oxygenated, and then that gives you more sickness. So I gave you, I think I sent you a gift, as you like to say.
Yeah, we had off-record intense argument about which to pronounce gift or gift, but we shall set that aside.
We could have called it a stern rebuke, perhaps.
Rebuke. Yeah, I drew a hard line. It is true the creator of gifts that is pronounced gift. That's the only thing I pronounce gift. Anyway, yes, he sent a gift of.
This would be basically a movie of fMRI data. And so when you look at it, it's not very impressive. It looks like these very pixelated maps of the brain, but it's mostly white. But these tiny changes in the intensity of those signals that you probably wouldn't be able to visually perceive, like about 1%, can be statistically very, very large effects. And that allows us to see, hey, there's an increase in activity in some part of the brain than doing some task like trying to remember something. And I can use those changes to even predict, is a person going to remember this later or not? And the coolest thing that people have done is to decode what people are remembering from the patterns of activity. Because maybe when I'm remembering this thing, like I'm remembering the house where I grew up, I might have one pixel that's bright in the hippocampus and one that's dark. And if I'm remembering, something like more like the car that I used to drive when I was 16, I might see the opposite pattern or a different. So all that little stuff that we used to think of noise, we can now think of almost like a QR code for memories, so to speak. So different memories have a different little pattern of bright pixels and dark pixels. And so this really revolutionized my research. So there's fancy research out there where people really, not even that, we're saying this is Stone Age, but applying machine learning techniques to do decoding and so forth. And now there's a lot of forward encoding models. You can go to town with this stuff, right? And I'm much more old school designing experiments where we basically say, okay, here's a whole web of memories that overlap in some way, shape, or form. Do memories that occurred in the same place have a similar QR code? And do memories that occurred in different places have different QR codes? You can just use things like correlation coefficients, cosine distance to measure that stuff, right? Super simple, right? And so what happens is you can start to get a whole state space of how a brain area is indexing all these different memories. It's super fascinating because what we can see is this little like separation between how certain brain areas are processing memory for who was there, and other brain areas are processing information about where it occurred, or the situation that's kind of unfolding. And some are giving you information about what are my goals that are involved and so forth. And the hippocampus is just putting it all together into these unique things that just are about and where it happened.
So there's a separation between spatial information, concepts, like literally there's distinct, you said QR codes.
So to speak, let me try a different analogy too that might be more accessible for people. It could be like you got a folder and you open it up, there's a bunch of files there. I can sort those files by alphabetical order. And now things that both start with the letter A are lumped together, and things that start with D versus A are far apart, right? And so that is one way of organizing the folder, but I could do it by date. And if I do it by date, things that were created close together in time are close, and things that are far apart. So you can think of how a brain area or a network of areas contributes to memory by looking at what the sorting scheme is. And these QR codes that we're talking about that you get from fMRI allow you to do that. And you can do the same thing if you're recording from massive populations of neurons in an animal. And you can do it by recording local potentials in the brain, just a little waves of activity in, let's say, a human who has epilepsy, and you stick electrodes in their brain check and seizure. So that's some of the work that we're doing now. But all these techniques basically allow you to say, hey, what's the sorting scheme? And so we've found that some networks of the brain sort information in memory according to who was there. So I might have, we've actually shown one of my favorite studies of all time that was done by a former postdoc, Zach Ray. And Zach did the study where we had a bunch of movies with different people in my lab. So there are two different people, and he filmed them at two different cafes and two different supermarkets. And what you could show is in one particular network, you could find the same kind of pattern of activity, more or less, a very, very similar pattern of activity every time I saw Alex in one of these networks, no matter where he was. And I could see another one that was like a common pattern that happened every time I saw this particular supermarket nugget, And so, and it didn't matter whether you were watching a movie or whether you were recalling a movie. It's the same kind of pattern. Right? It was fascinating. So now you have those building blocks for assembling a model of what's happening in the present, imagining what could happen, and remembering things very economically from putting together all these pieces. So all the hippocampus has to do is get the right kind of blueprint for how to put together all these building blocks.
These are all like beautiful hints in a super interesting system that makes you wonder on the other side of it how to build it. But it's fascinating. Like the way it does the encoding is really, really fascinating. Or I guess the symptoms, the results of that encoding are fascinating things. Just as a small tangent, you mentioned sort of the measuring local potentials with electrodes versus fMRI.
Oh yeah.
What are some interesting limitations, possibilities of fMRI? Maybe the way you explain it is like brilliant with blood and detecting the activations or the excitation because blood flows in that area. What's like the latency of that? Like what's the blood dynamics in the brain? Like how quickly can it tap change and all that kind of stuff?
Yeah, I mean, it's very slow to the brain. 50 milliseconds. It's like it's an eternity. Maybe not 50. Maybe like let's say half a second, 500 milliseconds. Just so much back and forth stuff happens in the brain, right? So in fMRI, you can measure these magnetic field responses about 6 seconds after that burst of activity would take place. All these things, it's like, is it a feature or a bug, right? So one of the interesting things that's been discovered about fMRI is it's not so tightly related to the spiking. So we tend to think of the computation, so to speak, as being driven by spikes, meaning like there's just a burst of it's either on or it's off. It's like going up or down. But sometimes what you can have is these states where the neuron becomes a little bit more excitable or less excitable. And so fMRI is very sensitive to those changes in excitability. Actually, one of the fascinating things about fMRI is how is it we go from neural activity to, essentially blood flow to oxygen, all this stuff. It's such a long chain of, going from neural activity to magnetic fields. And one of the theories that's out there is most of the cells in the brain are not neurons. They're actually the support cells, called glial cells. And one big one is astrocytes, and they play this big role in regulating, kind of being a middleman, so to speak, with the neurons. So if you, for instance, like one neuron's talking to another, you release a neurotransmitter, it's a glutamate, and that gets another neuron starts getting active after you release it in the gap between the two neurons, called synapse. So what's interesting is if you leave that, imagine you just flood it with this like liquid in there, right? If you leave it in there too long, you just excite the other neuron too much. You can start to basically get seizure. You don't want this. So you got to suck it up. And so actually what happens is these astrocytes, one of their functions is to suck up the glutamate from the synapse. And that is and then break it down and then feed it back into the neurons so you can reuse it. But that cycling is actually very energy intensive. And what's interesting is, at least according to one theory, they need to work so quickly that they're working on metabolizing the glucose that comes in without using oxygen, kind of like what anaerobic metabolism. So they're not using oxygen as fast as they are using glucose. So what we're really seeing in some ways may be in fMRI, not the neurons themselves being active, but rather the astrocytes, which are feeding the metabolic demands of the process of keeping the whole system moving.
It does seem to be that fMRI is a good way to study activation. So with these astrocytes, even though there's a latency, it's pretty reliably coupled to the activation.
Oh, well, this gets me to the other part about So now let's say, for instance, if I'm kind of like, I'm talking to you, but I'm kind of paying attention to your cowboy hat, or I'm thinking about the right, even if I'm not looking at it. What you'd see is that there would be this little elevation in activity in areas in the visual cortex, which process vision, around that point in space, okay? So if then something happened, like, sudden the light flash in that part of, right in front of the cowboy hat, I would have a bigger response to it. But what you see in fMRI is even if I don't see that flash of light, there's a lot of activity that I can measure because you're kind of keeping it excitable. And that in and of itself, even though I'm not seeing anything particularly interesting, there's still this increase in activity. And so it's more sensitive. So is that a feature or is it a bug? Some people who study spikes in neurons and say, well, that's terrible. You don't want that. Likewise, it's slow, and that's terrible for measuring things that are very fast. But one of the things that we found in our work was when you give people movies and when you give people stories to listen to, a lot of the action is in the very, very slow stuff. It's in because if you're thinking about like a story, like you're listening to a podcast, listening to Les Friedman podcast, right? You're putting this stuff together and building this internal model over several seconds, which is basically, we filter that out when we look at electrical activity in the brain. If you were interested in this milliseconds, massive amounts of information, right? So the way I see it is every technique gives you a little limited window into what's going on. fMRI is a huge problem. People lie down in the scanner, there's parts of the brain where it'll show you these images where you'll see kind of gaping holes because you can't keep the magnetic field stable in those parts. You'll see parts where it's like there's a vein and so it just produces big increases, decreases in respiration that causes these changes. There's lots of artifacts. You know. Every technique has its limits. If I'm lying down in an MRI scanner, I'm lying down. I'm not interacting with you in the same way that I would in the real world. But at the same time, I'm getting data that I might not be able to get otherwise. And so different techniques give you different.
What kind of big scientific discoveries, maybe the flavor of discoveries have been done throughout the history of the science of memory, studying of memory? What kind of things have been like understood?
There's so many. It's really so hard to summarize it. I mean, I think it's funny because it's like when you're in the field, you can get kind of blasé about this stuff, but then once you start writing the book, I'm like, oh my gosh, this is really interesting. How did you do all this stuff? I would say that some of the, from the first studies, just showing how much we forget is very important. Showing how much schemas, which is organized knowledge about the world, increase our ability to remember information. It's massively increasing. Studies of expertise, showing how experts like chess experts can memorize so much in such a short amount of time because of the schemas they have to check. But then also showing that those lead to all sorts of distortions. The discovery that the act of remembering can change the memory, strengthen it, but it can also distort it if you get misinformation. And it can also strengthen or weaken other memories that you didn't even recall. So just this whole idea of memory as an ecosystem, I think, is a big discussion. I could go this idea of like breaking up our continuous experience into these discrete events. I think was a major discovery.
So the discreteness of our encoding of events.
Maybe, yeah. I mean, and again, there's controversial ideas about this, right? But it's like, yeah, this idea that, and this gets back to just this common experience as we walk into the kitchen. Like, why am I here? Just end up grabbing some food for your fridge. And then you go back and like, oh, wait a minute, I left my watch in the kitchen. That's what I was looking for. And so what happens is that you have a little internal model of where you are, what you're thinking about. And when you cross from one room to another, those models get updated. And so now when you're in the kitchen, you have to go back and mentally time travel back to this earlier point to remember what it was that you went there for. So these event boundaries, turns out, like in our research, again, I don't want to make it sound like we've figured out everything, but in our research, one of the things that we found is that basically, as people get older, the activity in the hippocampus, event boundary, tends to go down. But independent of age, if I give you outside of the scanner, you're done with the scanner, I just scan you while you're watching the movie. You come out, I give you a test of memory story. What happens is you find this incredible correlation between the activity in the hippocampus at these singular points in time, these event boundaries, and your ability to just remember stories outside of the scanner. So it's marking this ability to encode memory. Just these little snippets of neural activity. So I think that's a good one. There's all sorts of work in animal models that I can get into, sleep. There's so much interesting stuff that's being discovered in sleep right now. Being able to just record from large populations of cells and then be able to relate that. And I think the coolest thing gets back to this QR code thing, because like what we can do now is like I can take fMRI data while you're watching a movie, or let's do better than that. Let me get fMRI data while you use the joystick to move around in virtual reality in metaverse. Right? But it's kind of a crappy metaverse because there's only so much metaverse that you can do in an MRI. Right? So we do this crappy metaverse. So now I can take a rat, record from his hippocampus and prefrontal cortex and all these areas, these really new electrodes with massive amounts of data, and have it move around on a trackball in virtual reality in the same metaverse that I did, record that rat set. I can get a person with epilepsy who have electrodes in their brain anyway to try to figure out their species. and a healthy part of the brain record from that person, right? And I can get a computational model. And one of the brand new members in my lab, Tyler Bond, is doing great stuff. He relates computer vision models, looks at the weaknesses of computer vision models, and relates to what the brain does well. And so you can actually take a ground truth, code for metaverse, and you can feed in the visual information, let's say the sensory information, whatever that's coming in, to a computational model that's designed to take real world input. And you could basically tie them all together by virtue of the state spaces that you're measuring in neural activity in these different formats, these different species, and in the computational model. I just find that mind-blowing. You could do different kinds of analyses on language and basically come up with, basically it's the guts of LLMs, right? You could do analyses on language, and you could do analyses on, sentiment analyses and emotions. So all this stuff together, I mean, it's almost too much. But if you do it right, and you do it in a theory-driven way, as opposed to just throwing all the data at the wall and see what sticks, I mean, that to me is just exceptional.
So you can take fMRI data across species and across different types of humans and conditions of humans, and construct models that help you find the commonalities, or like the core thing that makes somebody navigate through the metaverse, for example.
Yeah, I mean, more or less. I mean, there's a lot of detail. But yes, I think, and not just fMRI, but you can relate it to, like I said, recordings from large populations of neurons that can be taken in a human or even in a non-human animal that is, where you think it's an anatomical homologue. So that's just mind-blowing.
What's the similarities in human beings? Like, that's the way Smashing Pumpkins,
Despite all of your rage,
that's Smashing Pumpkins, I think.
Despite all of your rage with gifts, you still just arachnoid.
Oh, yeah. Good callback.
Good callback. These memory retrieval exercises are actually helping you build a lasting memory in this conversation.
And it's strengthening the visual thing I have of you is getting stronger. I'm stronger by the second. But anyway, but animal studies work as well.
Yeah. So let's go to the. So I think I've got great colleagues I talk to who study memory in mice. And there's some. One of the valuable things in those models is you can study neural circuits in an enormously targeted way, because you could do these genetic studies, for instance, so you can manipulate particular groups of neurons, and it's just getting more and more targeted to the point where you can actually turn on a particular kind of memory just by activating a particular set of neurons that is active during that. Okay? So there's a lot of conservation of some of these neural circuits across, evolution in mammals, for instance. And then some people would even say that there's genetic mechanisms for learning that are conserved even going back far before. But let's go back to the mice and humans. There's a lot of differences. So for one thing, the sensory information is very different. Mice and rats explore the world largely through smelling, olfaction, but they also have vision that's kind of designed to kind of catch depth from above. So it's a very big view of the world. And we move our eyes around in a way that focuses on particular spots in space. We get very high resolution from a very limited set of spots in space. So that makes us very different in that way. We also have all these other structures of social animals that allow us to respond differently. There's language, there's so you name it, there's obviously God's differences. Humans aren't just giant rats, there's so much complexity. Time scales are very important. So primate brains and human brains are especially good at integrating and holding on to information across longer ranges. And also, finally, it's like our history of training data is very, very different than, human's world is very different than a wild mouse's world. And a lab mouse's world is extraordinarily impoverished. Yeah.
But still, what can you understand that's studying next? Just basic, almost behavioral stuff about memory?
Well, yes, but that's very important. Right? So you can understand, for instance, how do neurons talk to each other? That's a really big question. Neural computation, in and of itself, you think it's the most simple question, right? It's not at all. I mean, it's a big question. And understanding how two parts of the brain interact, meaning that it's not just one area speaking. It's not like Twitter, where one area of the brain is shouting and then another area of the brain is just stuck listening to itself. It's like they're actually interacting on a millisecond scale. How does that happen? And how do you regulate those interactions, dynamic, interactions? We're still figuring that out, but that's going to be coming largely from model systems that are easier to understand. You can do manipulations like drug manipulations to manipulate circuits and use viruses and so forth and turn on circuits that you just can't do in humans. So I think there's a lot that can be learned from mice, there's a lot that can be learned from primates, and then there's a lot that you need to learn from humans. Unfortunately, some of the people in the National Institute of Health think you can learn everything from the mouse. Like, why study memory in humans that I can study learning in the mouse? It's just like, oh my God, I'm going to get my funding from somewhere else.
Well, let me ask you some random fascinating questions.
Yeah, sure.
How does deja vu work?
So, deja vu is it's actually one of these things. I think that some of the surveys suggest that like 75% of people report having a deja vu experience sometime or another. I don't know where that came from, but I told people in my class, and most of them say they've experienced deja vu. It's this kind of sense that I experienced this moment sometimes before I've been here before. And actually, there's all sorts of variants of this all these different moods, but deja vu is the sense that it can be like almost disturbing, intense sense of familiarity. So there was a researcher named Wilder Penfield. Actually, this goes back even earlier, just the earliest. Like, Hewins Jackson was this neurologist who did a lot of the early characterizations of epilepsy. And one of the things he noticed is in epilepsy patients, some group of them, right before they would get a seizure, they would have this intense sense of deja vu. So it's this artificial sense of familiarity. It's a sense of having a memory that's not there, right? And so what was happening was there was electrical activity in certain parts of his brain. So this guy Penfield later on, when he was trying to look for how do we map out the brain to figure out which parts we want to remove and which parts don't we, he would stimulate parts of the temporal lobes of the brain and find you could elicit the sense of deja vu. Sometimes you'd actually get a memory that a person would re-experience just from electrically stimulating some parts. Sometimes they just have this intense feeling of being. So one theory which I really like is that in higher order areas of the brain that integrate into many different sources of input, what happens is that they're tuning themselves up every time you process this input, right? And so that allows you to just get this kind of a fluent sense that I'm very familiar. You're very familiar with this place. It's like a team here. You're not going to be moving your eyes all over the place. You kind of have an idea of where everything is. And that fluency gives you a sense of like, I'm here. Now I wake up in my hotel room and I have this very unfamiliar sense of things, right? But, there's a great set of studies done by Ann Cleary at Colorado State where she created these virtual reality environments. And when you go back to the metaverse, imagine you go through a virtual museum, right? And then she would put people in virtual reality and have them go through a virtual arcade. But the map of the two places was exactly the same. She just put different skins on them. So one looks different than the other, but they got same landmarks, the same places, same objects and everything, but carpeting, colors, theme, everything's different. People will often not have any conscious idea that the two are the same, but they can report this very intense sense of deja vu. So it's like a partial match that's eliciting this kind of a sense of familiarity. And that's why, in patients who have epilepsy that affects memory, you get this artificial sense of familiarity that happens. And so we think that, and again, this is just one theory amongst many, but we think that we get a little bit of that feeling. It's not enough to necessarily give you deja vu, even for very mundane things, right? So it's like if I tell you the word rutabaga, your brain's going to work a little bit harder to catch it than if I give you a word like apple, right? That's because you hear apple a lot. Your brain's very tuned up to process it efficiently, but rutabaga is a little bit longer and more intense. You can actually see a difference in brain activity in areas in the temporal lobe when you hear a word just based on how frequent it is in the English language. So we think it's tied to this it's basically a byproduct of our mechanism of just learning, doing this error-driven learning as we go through life, become better and better and better as we process things more and more efficiently.
So I guess deja vu is just extra elevated stuff coming together and firing for this artificial memory versus the real memory. Why does it feel so intense?
Well, it doesn't happen all the time, but I think what may be happening is it's a partial match to something that you have. And it's not enough to trigger that sense of, that ability to pull together all the pieces, but it's a close enough match to give you that intense sense of familiarity without the recollection of exactly what happened when.
But it's also like a spatial temporal familiarity, so like it's also in time. Mm-hmm. There's a weird blending of time that happens. And we'll probably talk about time because I think that's a really interesting idea how time relates to memory. But you also kind of artificial memory brings to mind this idea of false memories that comes in all kinds of contexts. So how do false memories work?
Well, I like to say there's no such thing as true or false memories, right? It's like Johnny Rotten from the Sex Pistols here saying, it's like, I don't believe in false memories any more than I believe in false songs, right? It's like, and so the basic idea is that we have these memories that reflect bits and pieces of what happened, as well as our inferences and theories, right? So I'm a scientist and I collect data, but I use theories to make sense of that data. And so a memory is kind of a mix of all these. So where memories can go off the deep end and become what we would call conventionally as false memories are sometimes little distortions where we filled in the blanks, the gaps in our memory based on things that we know, but don't actually correspond to what happened, right? So if I were to tell you that on a story about this person who's like worried that they have cancer or something like that, and then they see a doctor and the doctor says, well, things are very much like you would have expected, or like what you were afraid of or something. When people remember that, they'll often remember, well, the doctor told the patient that he had cancer, even if that wasn't in the story, because they're infusing meaning into it. Right? So that's a minor distortion. But what happens is that sometimes things can really get out of hand, where people have trouble telling the difference between things that they imagine versus things that happen. But also, as I told you, the act of remembering can change the memory. And so what happens then is you can actually be exposed to some misinformation. Those who have lost this was real pioneer in this work. Lots of other work that's been done since. Basically, it's like if you remember some event, tell you something about the event. Later on, when you remember the event, you might remember some original information from the event, as well as some information about what I told you. And sometimes, if you're not able to tell the difference, that information that I told you gets mixed into the story that you had originally. So now I give you some more misinformation, and you're exposed to some more information somewhere else. And eventually, your memory becomes totally detached from what happened. And so sometimes you can have cases where people, it's very rare, but you can do it in lab too, where like significant, not everybody, but a chunk of people will fall for this, where you can give people misinformation about an event that never took place, And as they keep trying to remember that event more and more, what happens is they start to imagine, they start to pull up things from other experiences they've had, and eventually they can stitch together a vivid memory of something that never happened. Because they're not remembering an event that happened, they're remembering the act of trying to remember what happened, and basically putting it together into the wrong story.
It's fascinating because this could probably happen at a collective level. Like, this is probably what successful propaganda machines aim to do, is creating false memory across thousands, if not millions of minds.
Yeah, absolutely. This is exactly what they do. And so all these kind of foibles of human memory get magnified when you start to have social interactions. There's a whole literature on something called social contagion, which is basically when misinformation spreads like a virus. You remember the same thing that I did. I give you a little bit of wrong information, and that becomes part of your story. Because once you and I share a memory, like I tell you about something I've experienced, and you tell me about your experience at the same event, it's no longer your memory or my memory, it's our memory. And so now the misinformation spreads, and the more you trust someone, or the more powerful that person is, the more of a voice they have in shaping that narrative. And there's all sorts of interesting ways in which misinformation can happen. There's a great example of when John McCain and George Bush Jr. were in a primary, and there are these polls where they would do these, like, I guess they were like not robocalls but real calls, where they would poll voters. But they actually inserted some misinformation about McCain's beliefs on taxation, I think, and maybe something about illegitimate children. I don't really remember. But they included misinformation in the question that they asked him. How do you feel about the fact that he wants to do this or something? And so people would end up becoming convinced he had these, policy things or these personal things that were not true, just based on the polls that were being used. So it was a case where, interestingly enough, the people who were using misinformation were actually ahead of the curve relative to the scientists who were trying to study these questions.
Yeah, it's really interesting. So it's not just about truth and falsehoods, like us as intelligent reasoning machines, but it's the formation of memories where they become visceral. You can rewrite history. If you just look throughout the 20th century, some of the dictatorships, Nazi Germany with the Soviet Union, effective propaganda machines can rewrite our conceptions of history, how we remember our own culture, our upbringing, all this kind of stuff. You can do quite a lot of damage in this way. And then there's probably some kind of social contagion happening there. Like certain ideas that maybe initiated by this propaganda machine can spread faster than others. You can see that in modern day, certain conspiracy theories, there's just something about them that they are like really effective at spreading. There's something sexy about them to people, to where something about the human mind eats it up and then uses that to construct memories. It's almost as if they almost were there to witness whatever the content of the conspiracy theory is. It's fascinating because once you feel like you remember a thing, I feel like there's certainty, there's a emboldens you to like say stuff. Like, you really like. It's not just you believe an idea is true or not. You like it's at the core of your being that you feel like you were there to watch it happen.
Yeah, I mean, there's so much in what you're saying, and one of the things is that people's sense of collective identity is very much tied to shared memories. If we have a shared narrative of the past, or even better, if we have a shared past, we will feel more socially connected with each other, and I will feel part of this group. They're part of my tribe. I remember the same thing in the same way. And you brought up this weaponization of history, and it really speaks to, I think, one of the parts of memory, which is that if you have a belief, you will find, and you have a goal in mind, you will find stuff in memory that aligns with it, and you won't see the parts in memory that don't. So a lot of the stories we put together are based on a perspective, right? And so let's just zoom out for the moment from like misinformation to something even more fascinating, but not as like, scary. I was reading on Viet Minh, but he wrote a book about the collective memory of the Vietnam War. He's a Vietnamese immigrant who was flown out after the war was over. And so he went back to his family to get their stories about the war. And they called it the American War, not the Vietnam War, right? And that just blew my mind, having grown up in the U.S. and I've always heard about it as the Vietnam War. Of course they call it the American War. That's what happened. America came in, right? And that's based on their perspective, which is a very valid perspective. And so that just gives you this idea of the way we put together these narratives based on our perspective. And I think the opportunities that we can have in memory is if we bring groups together from different perspectives and we allow them to talk to each other and we allow ourselves to listen. I mean, right now you'll hear a lot of just jammering, people going blah, blah, blah about free speech, but they just want to listen to themselves. I mean, it's like, let's face it, the old days before people were totally woke, they were trying to ban 2 Live Crew. Just think about it. Lenny Bruce got canceled for cursing. Jesus Christ, It's like, it's nothing new. People don't like to use things to disagree with us. But if you're in it, I mean, you can see 2 situations in groups with memory. One situation is like people who are very dominant who just take over the conversation. Basically, what happens is the group remembers less from the experience and they remember more of what the dominant memory. Right? Now, if you have a diverse group of people, and I mean diverse in necessarily the human resources, I mean diverse in any way you want to take it, right? So diverse in every way, hopefully. And you give everyone a chance to speak, and everyone's being appreciated for their unique contribution. You get more accurate memories, and you get more information, right? Even 2 people who come from very similar backgrounds, if you can appreciate the unique contributions that each one has, you can do a better job of generating information from memory. And that's a way to inoculate ourselves, I believe, from misinformation in the modern world. But like everything else, it requires a certain tolerance for discomfort. And I think when we don't have much time, and I think when we're stressed out, and when we are just tired, it's very hard to tolerate discomfort.
And I mean, social media has a lot of opportunity for this because it enables this distributed one-on-one interaction that you're talking about where everybody has a voice, but still our natural inclination, you see this on social media, is a natural clustering of people and opinions. You just kind of form these kind of bubbles. I think that's, to me personally, I think that's a technology problem that could be solved. If there's a little bit of interaction, kind, respectful, compassionate interaction with people that have a different memory, that respectful interaction will start to intermix the memories and ways of thinking to where you're slowly moving towards truth. But that's a technology problem. Because, naturally, that's our own devices. We want to cluster up in a tribe.
Yeah, and that's the human problem. I think a lot of the problems that come up with technology aren't the technology itself as much as the fact that people adapt to the technology in maladaptive ways. I mean, one of my fears about AI is not what AI will do, but what people will do. I mean, take text messaging, right? It's like a pain in the ass to text people, for me. And so what happens is the communication becomes very Spartan and devoid of meaning. And it's just very telegraphic. And that's people adapting to the medium, right? I mean, look at you, you've got a keyboard, right? That's like got these like dome-shaped things. You've adapted to that to communicate, right? That's not the technology adapting to you, it's you adapting to the technology. And I think that, one of the things I learned when Google started to introduce autocomplete in emails, I started to use it, and about a third of the time I was like, this isn't what I want to say. A third of the time I'd be like, this is exactly what I want to say. And a third of the time I was saying, oh, this is good enough, I'll just go with it, right? And so what happens is it's not that the technology necessarily is doing anything so much as it's just going to constrain my language because I'm just doing what's being suggested to me. And so this is why I say, kind of like my mantra for some of what I've learned about everything in life is to diversify your training data. Because otherwise you're going, so like humans have this capability to be so much more creative than anything generative AI would put together, at least right now. But it can also go the opposite direction where people become much, much less creative if they just become more and more like resistant to discomfort, and resistant to exposing themselves to novelty, to cognitive dissonance, and so forth.
I think there is a dance between natural human adaptation of technology and the people that the design and engineering of that technology. So I think there's a lot of opportunity to create like this keyboard, things that on net are positive for human behavior. So we adapt and all this kind of stuff, but when you look at the long arc of history across years and decades, has humanity been flourishing? Are humans creating more awesome stuff? Are humans happier? All that kind of stuff. And so there, I think technology on net has been, and I think, maybe hope will always be on net a positive thing.
Do you think people are happier now than they were 50 years ago or 100 years ago?
Yes. Yeah.
I don't know about that.
I think humans in general like to reminisce about the past, like the times are better, and complain about the weather today, or complain about whatever today, because there's this kind of complaining engine that just, there's so much pleasure in saying, life sucks for some reason.
That's why I love punk rock.
Exactly. I mean, it's something in humans that loves complaining, even about trivial things. But complaining about change, complaining about everything. But ultimately, I think on net, on every measure, things are getting better. Life is getting better.
Well, life is getting better. I don't know necessarily that tracks people's happiness. I mean, I would argue that maybe, and who knows, I don't know this, but I wouldn't be surprised if people in hunter-gatherer societies are happier. I mean, I wouldn't be surprised if they're happier than people who have access to modern medicine and email and cell phone.
Well, I don't think there's a question whether you take hunter-gatherer folks and put them into modern day and give them enough time to adapt, they'll be much happier. The question is, in terms of every single problem they've had is now solved. There's now food, there's guarantee of survival and shelter and all this kind of stuff. What you're asking is a deeper sort of biological question. Do we want to be Werner Herzog in the movie Happy People, Life in the Taiga? Do we want to be busy 100% of our time hunting, gathering, surviving, worried about the next day? Maybe that constant struggle ultimately creates a more fulfilling life. I don't know, but I do know this modern society allows us to, when we're sick, to find medicine, to find cures. When we're hungry, to get food, much more than we did 100 years ago. And there's many more activities that you can perform, or creative, all this kind of stuff that enables the flourishing of humans at the individual level. Whether that leads to happiness, I mean, that's a very deep philosophical question. Maybe deep struggle is necessary for happiness.
Or maybe cultural connection, maybe it's about like functioning in social groups that are meaningful and like having kind. But I do think there's an interesting memory related thing, which is that if you look at like things like reinforcement learning, you're not learning necessarily every time you get a reward. If it's the same reward, you're not learning that much. You mainly learn if it deviates from your expectation of what you're supposed to get, right? So it's like you get a paycheck every month from MIT or whatever, right? And it's like you probably don't even kind of get excited about it when you get the paycheck. But if they cut your salary, you're going to be pissed. And if they increase your salary, you're good, I got a bonus, And that adaptation and that ability that basically you learn to expect these things, I think, is a major source of, I guess, it's a major way in which we're kind of more, in my opinion, wired to strive and not be happy. to be in a state of wanting. And if, so people talk about dopamine, for instance, being this pleasure chemical. And it's like there's a lot of compelling research to suggest it's not about pleasure at all. It's about the discomfort that energizes you to get to seek a reward, right? And so you can give an animal that's been deprived of dopamine a reward, and they're like, oh, I'm enjoying it, pretty good. But they're not going to do anything to get it. And just one of the weird things in our research is I got into curiosity from a postdoc in my lab, Matthias Gruber. And one of the things that we found is when we gave people a question, like a trivia question that they wanted the answer to, that question, the more curious people were about the answer, the more activity in these dopamine-related circuits in the brain we would see. And again, that was not driven by the answer per se, but by the question. So it was not about getting the information, it was about the drive to seek the information. But it depends on how you take that. If you get this uncomfortable gap between what you know and what you want to know, you could either use that to motivate you and energize you, or you could use it to say, I don't want to hear about this. This disagrees with my beliefs. I'm going to go back to my echo chamber.
Yeah. I like what you said, that maybe we're designed to be in a kind of constant state of wanting. Which, by the way, is a pretty good either band name or rock song name, state of wanting.
That's like a hardcore band. I mean, yeah,
it's pretty good.
But I also like that hedonic treadmill.
Hedonic treadmill's pretty good.
Yeah, we could use that for like our techno project, I think.
You mean the one we're starting?
Yeah, exactly.
Okay, great. We're going on tour soon. This is our announcement.
We could build a false memory of a show, in fact, if you want. Let's just put it all together. So we don't even have to do all the work to play the show. We can just create a memory of it and might as well happen, because the remember itself is in charge anyway.
So let me ask you about, we talked about false memories, but in the legal system, false confessions. I remember reading 1984 where, sorry for the dark turn of our conversation, but through torture, you can make people say anything and essentially remember anything. I wonder to which degree there's truth to that. If you look at the torture that happens, so reunions for confessions, all that kind of stuff. How much can you really get people to really, just force false memories, I guess?
Yeah, I mean, I think there's a lot of history of this actually in the criminal justice system. You might have heard the term the third degree. If you actually look it up historically, it was a very intense set of beatings and starvation and physical demands that they would place on people to get them to talk. And there was certainly a lot of work that's been done by the CIA in terms of enhanced interrogation techniques. And from what I understand, the research actually shows that they just produce what people want to hear, not necessarily the information that is being looked for. The reason is that, I mean, there's different reasons. I mean, one is people just get tired of being tortured, they say whatever. But another part of it is that you create a very interesting set of conditions where there's an authority figure telling you something, that you did this, we know you did this, we have witnesses saying you did this. So now you start to question yourself under stress. Maybe they're not feeding you, maybe they're making you be cold, or exposing you to music that you can't stand, or something, whatever it is, right? It's like they're creating this physical stress. So stress starts to act on, starts to downregulate the prefrontal cortex. You're not necessarily as good at monitoring the accuracy of stress. Then they start to get nice to you and they say, imagine, okay, I know you don't remember this. Maybe we can walk you through how it could have happened, feed you the information. And so you're in this weakened mental state and you're being encouraged to imagine things like people who give you a plausible scenario. And at some point, certain people can be very coaxed into creating a memory for something that never happened. And there's actually some pretty convincing cases out there where you don't know exactly the truth. There's a sheriff, for instance, who came to believe that he had a false memory. That he had a memory of doing sexual abuse based on, essentially, I think it was, I'm not going to tell the story because I don't remember it well enough to necessarily accurately give it to you, but people can look this stuff up. There are definitely stories out there like this where people confess to crimes that they just didn't do and objective evidence came out later on. But there's a basic recipe for it, which is you feed people the information that you want them to remember. You stress them out. You have an authority figure kind of like pushing this information on them. Or you motivate them to produce the information you're looking for, and that pretty much over time gives you what you want.
It's really tragic that centralized power can use these kinds of tools to destroy lives. Bad. Since there's a theme about music throughout this conversation, one of the best topics for songs is heartbreak, love in general, the heartbreak. Why and how do we remember to get heartbreak? Asking for a friend.
That's so hard to asking for a friend. I love that. It's such a hard one. Well, part of this is we tend to go back to particular times that are the more emotionally intense periods. And so that's a part of it. And again, memory is designed to kind of capture these things that are biologically significant. And it is a big part of biological significance because human relationships are super important. And sometimes that heartbreak comes with massive changes in your beliefs about somebody, say they cheated on you or something like that, or regrets, and you kind of ruminate about things that you've done wrong. There's really so many reasons, though. That, I've had this. My first cat I had was, we got it for a wedding present. Cat. Got it after that it died of FID when he was 4 years old, and just could see it everywhere around the house. We got another cat, then we got a dog. The dog eventually died of cancer, and the cat just died recently. And so we got a new dog because I kept seeing the dog around, and I was so heartbroken. But I still remember the pets that died. It just comes back to it. It's part of this. I think there's also something about attachment. It's just so crucial that drives, again, these things that we want to remember, and that gives us that longing. Sometimes it's also not just about the heartbreak, but about the positive aspects of it, right? Because the loss comes from not only the fact that the relationship was over, but had all of these good things before that you can now see in a new life, right? And so one of the things that I found from my clinical background that really gave me a different perspective on memory is so much of the therapy process was guided towards reframing and getting people to look at the past in a different way. Not by changing people's memories, or not by imposing an interpretation, but just offering a different perspective, and maybe one that's kind of more optimized towards learning, and an appreciation, maybe, or gratitude, whatever it is, right? That gives you a way of taking. I think you said it in the beginning. Right? You can have this kind of like dark experiences, and you can use it as training data to grow in new ways. But it's hard.
I often go back to this moment, the show Louis with Louis C.K., where he's all heartbroken about a breakup with a woman he loves, and an older gentleman tells him that's actually the best part, that heartbreak, because you get to intensely experience how valuable this love was. Because the worst part is forgetting it. It's actually when you get over the heartbreak. That's the worst part. So I sometimes think about that because having the love and losing it, like the losing it is when you sometimes feel it the deepest, which is an interesting way to celebrate the past and relive it. it sucks that you don't have a thing, but when you don't have a thing, it's a good moment to viscerally experience the memories of something that you now appreciate even more.
So you don't believe that an owner of a lonely heart is much better than an owner of a broken heart? You think an owner of a broken heart is better than the owner of a lonely heart?
Yes, for sure. I think so. But I'm gonna have to day by day. I don't know. I'm gonna have to listen to some more Bruce Springsteen to figure that one out.
Well, it's funny because it's like after I turned 50, I think of death all the time. Like I just think that and then I have probably a fewer years ahead of me than I was behind. So think about one thing, which is what are the memories that I want to carry with me for the next period of time, and also about like just the fact that everything around me could be. I know more people who are dying for various reasons, and so I'm not lost. I'm not baffled, right? It's something I think about a lot, and I'm reminded of like how I talked to somebody who's like, this Buddhist, and I was like, the whole idea of Buddhism is renouncing attachment. In some way, the idea of Buddhism is like staying out of the world of memory, staying in the moment, right? And they talked about, it's like, how do you renounce attachments to the people that you love, right? And they're just saying, well, I appreciate that I have this moment with them, knowing that they will die makes me appreciate this moment that much more. I mean, you said something similar, right? In your daily routine, what you think about this, right?
Yeah, I meditate on mortality every day. But I don't know. At the same time, that really makes me appreciate the moment and live in the moment. And I also appreciate the full, deep roller coaster of suffering involved in life, the little and the big too. So I don't know. The Buddhist kind of removing yourself from the world, or the Stoic removing yourself from the world of emotion. I'm torn about that one. I'm not sure.
Well, this is where Hinduism and Buddhism, or at least some strains of Hinduism and Buddhism, differ. In Hinduism, like if you read the Bhagavad Gita, the philosophy is not one of renouncing the world, because the idea is that not doing something is no different than doing something. So what they argue, and again, you could interpret it in different ways, positive and negative, but the argument is that you don't want to renounce action, but you want to renounce the fruits of the action. You don't do it because of the outcome, you do it because of the process. Because the process is part of the balance of the world that you're trying to preserve, right? And of course, you can take that different ways, but I really think about that from time to time in terms of like, letting go of this idea of does this book sell, or trying to, like impress you and if you laugh at my jokes or whatever, and just more like I'm sharing this information with you, getting to know you or whatever it is. But it's hard, right? It's like you're so driven by the reinforcement of the outcome.
You're just part of the process of telling the joke, and if I laugh or not, that's up to the universe to decide.
Yep, it's my trauma.
How does studying memory affect your understanding of the nature of time? So, like, we've been talking about us living in the present, making decisions about the future, standing on the foundation of these memories, the narratives about the memories and perception. So it feels like it does weird things to time.
Yeah, and the reason is that in some sense, I think, especially the farther we go back, there's all sorts of interesting things that happen. So your sense of like, if I ask you how different does 1 hour ago feel from 2 hours ago, I'd probably say pretty different. But if I ask you, okay, go back 1 year ago versus 1 year and 1 hour, the same difference in time, it won't feel very different. Right? So there's this kind of compression that happens as you look back farther in time. So that it's kind of like why when you're older, the difference between somebody who's like 50 and 45 doesn't seem as big as the difference between like 10 and 5 or something. Right? When you're 10 years old, everything seems like a long period of time. Here's the point: is that so one of the interesting things that I found when I was working on the book actually was during the pandemic. I just decided to ask people in my class when we were doing remote instruction. So one of the things I did was I polled people. And so I just asked people, do you feel like the days are moving by slower or faster or about the same? Almost everyone in the class said that the days were moving by slower. So then I would say, okay, so do you feel like the weeks are passing by slower, faster, or the same? And the majority of them said that the weeks were passing by faster. So according to the laws of physics, I don't think that makes any sense, right? But according to memory, it did, because what happened was people were doing the same thing over and over in the same context. And without that change in context, their feeling was that they were in one long, monotonous event. And so, but then at the end of the week, you look back at that week and you say, well, what happened? Memories of what happened. So it must fly without even my notice. That week went by during the same amount of time as an eventful week where you might have been going out, hanging out with friends on vacation, whatever, right? It's just that nothing happened because you're doing the same thing over and over. So I feel like memory really shapes our sense.
Well, I just fundamentally feel like the same person. It's interesting what that company does. It makes me feel like we're all connected, not just amongst humans spatially, but in terms of back in time. There's a kind of eternal nature, timelessness, I guess, to life. It could be also genetically just for me. I don't know if everyone agrees to this view of time, but to me it all feels the same.
Like you don't feel the passage of time?
No, I feel the passage of time the same way that your students did from day to day. There's certain markers that let you know that time has passed, before great birthdays and so on. But the core of who I am and who others I know are events, it like that compression of my understanding of the world removes time. Because time is not useful for the compression. So like the details of that time, at least for me, is not useful for understanding the core of the thing. So
maybe what it is that you really like to see connections between things. This is like really what motivates me in science actually too. But it's like when you start recalling the past to, and seeing the connections between the past and present, now you have this kind of web of interconnected memories, right? And so I can imagine in that sense, there is this kind of the present is with you, right? But what's interesting about what you said too that struck me is that your 16-year-old self is probably very complex. And by the way, I'm the same way, but it's like it really is the source of a lot of darkness for me. So, but when like you can look back at like let's say you hear a song that you used to play like before you would go to a sports thing or something like that. You might not think of yourself as an athlete. Once you get back to that, you mentally time travel to that particular thing, you open up this little compartment of yourself that wasn't there before, right? That didn't seem accessible for us. Dan Schachter's lab did this really cool study where they would ask people to either remember doing something altruistic or imagine doing something altruistic. And that act made them more likely to want to do things for other people. So that act of mental time travel can change who you are in the present. We tend to think of, this goes back to that illusion of stability, and we tend to think of memory in this very deterministic way. I am who I am because I have this past. But we have a very multifaceted past and can access different parts of it and change in the moment based on whatever part we want to reach.
how does nostalgia connect into this? Like this desire and pleasure associated with going back.
Yeah, so my friend Felipe de Brigard wrote this, and it just like blew my mind. Where the word nostalgia was coined by a Swiss physician who was actually studying traumatized soldiers, and so he described nostalgia as a disease. And the idea was it was bringing these people extraordinary unhappiness because they were remembering how things used to be. And I think it's very complex. So as people get older, for instance, nostalgia can be an enormous source of happiness, right? And being nostalgic can improve people's moods in the moment. But it just depends on what they do with it, because what you can sometimes see is nostalgia has the opposite effect of thinking those were the good old days and those days are over. Right? It's like America used to be so great and now it sucks. My life used to be so great when I was a kid and now it's not. And you're selectively remembering the things that we don't realize how selective our remembering self is. And so, I lived through the 70s. It sucked. Partly it sucked more for me, but I would say that even otherwise, it's like there's all sorts of problems going on. Gas lines, people were worried about Russia, nuclear war, blah, blah, blah. So, it's just this idea that people have about the past can be very useful if it brings you happiness in the present, but if it narrows your worldview in the present, you're not aware of those biases that you can end up, it can be toxic, either at a personal level or at a collective level.
Let me ask you both a practical question and an out there question. So let's start with the practical one. What are your thoughts about BCIs, brain computer interfaces, and the work that's going on with Neuralink? We talked about electrodes and different ways of measuring the brain, and here Neuralink is working on basically two-way communication. And the more out there question is the idea of stuff. But more practically, what do you think about Neuralink?
Yeah, I can't say specifics about the company studies that much, but I think there's two parts of it. So one is they're developing some really interesting technology. I think with these like surgical robots and things like that. BCI though has like a whole lot of innovation going on. I'm not necessarily seeing any scientific evidence from Neuralink, and maybe that's just I'm not looking for it, but I'm not seeing the evidence that they're anywhere near where the scientific community, there's lots of startups that are incredibly innovative. So one of my colleagues, Sergey Sadisky, is a genius in this area. They're working on it. Big speech prosthetics like that are incorporating, decoding techniques with AI and movement. Just like the rate of progress is just enormous. So part of the technology is having good enough data and understanding which data to use and what to do with it. Right? And then the other part of it then is the algorithms for decoding it and so forth. And I think part of that has really resulted in some real breakthroughs in neuroscience. So there's lots of new technologies like neuropixels, for instance, that allow you to harvest activity from many neurons from a single electrode. I know Neuralink has some technologies that are also along these lines, but again, because they do their own stuff. But I think BCI is much bigger. There's just so much innovation. I think the interesting question, which we may be getting into, is I was talking to Sergey a while ago about, so a lot of language is not just what we hear and what we speak, but also our intentions and our internal models. And, so are you really going to be able to explore language without that part of it? And he brought up a really interesting question, which is the ethics of reading out people's intentions and understanding of the world, as opposed to more, the more concrete parts of hearing and producing movement.
Just so we're clear, because you said a few interesting things. When we talk about language and BCI, what we mean is getting signals from the brain and generating the language. Say you're not able to actually speak. It's as a kind of linguistic prosthetic. It's able to speak for you exactly what you wanted to say. And then the deeper question is, well, saying something isn't just the letters, the words you're saying, it's also the intention behind it, the feeling behind all that kind of stuff. And is it ethical to reveal that full shebang, the context of what's going on in our brain? That's really interesting. That's really our thoughts. is it ethical for anyone to have access to our thoughts? Because right now the resolution is so low that we're okay with it, even doing studies and all this kind of stuff. But if neuroscience is a few breakthroughs where you can start to map out the QR codes to different thoughts, for different kinds of thoughts, maybe political thoughts, McCarthyism. What if I'm getting a lot of them communist thoughts, or however we want to categorize or label it? That's interesting. That's really interesting. I think ultimately there's always, the more transparency there is about the human mind, the better it is. But there could be always intermediate battles with how much control does a centralized entity have, like a government, and so on. What is the regulation? What are the rules? What's legal and illegal? You talk about the police, whose job is to track down criminals and so on, and look at all the history, how the police could be abuse its power to control the citizenry, all that kind of stuff. People are always paranoid, and rightfully so. It's fascinating. It's really fascinating. You talk about freedom of speech, freedom of thought, which is also a very important liberty at the core of the country and probably humanity. Starts to get awfully tricky when you get more intellectual stuff. But what I wanted to actually ask you is, do you think, for fun and for practical purposes, we would be able to modify memory? So how difficult is it? How far away we are from understanding the different parts of the brain, everything we've been talking about, in order to figure out how can we adjust this memory at the crude level from unpleasant to pleasant. We talked about we can remember the mall and the people, the location of the people, and we keep the people and change the place, this kind of stuff. How difficult is that?
Well, I mean, in some sense, we know we can do it just behaviorally. I tell you, under certain conditions, and, it can give you the misinformation, and then you can change the people places and so forth, right? On the crude level, there's a lot of work that's being done on a phenomenon called reconsolidation, which is this idea that essentially when I recall a memory, what happens is that the connections, the neurons that cells that give you the memory, are going to be like more modifiable. And so some people use techniques to try to, for instance, with fear memories, to reduce that physical, visceral component of the memory when it's activated. Right now, I think, as an outsider looking at the data, I think it's mixed results. And part of it is, and this speaks to the more complex issue, is that you need somebody to actually fully recall that traumatic memory in the first place, and in order to actually modify it. And what is the memory? That is the key part of the problem. So if we go back to reading people's thoughts, what is the thought? I mean, people can sometimes look at this like behavior. The memory is like giving you A and you produce B. And I think that's a very bankrupt concept about memory. I think it's much more complicated than that. And, one of the things that when we started studying naturalistic memory for movies, that was so hard was we had to change the way we did the studies, because if I show you a movie and I watch the same movie, and you recall everything that happened, and I recall everything that happened, we might take a different amount of time to do it. We might use different words, and yet to an outside observer, we might have recalled the same thing. Right? So it's not about the words necessarily, and it's not about how long we spent or whatever. There's something deeper that is there. It's this idea, but it's like, how do you understand that thought? I encounter a lot of concrete thinking that it's like, if I show a model, like, the visual information that a person sees when they drive, I can basically reverse engineer driving. That's not really how it works. I once saw a talk by somebody, or I saw somebody talking in this discussion between neuroscientists and AI people, and he was saying that the problem with self-driving cars that they had in cities as opposed to highways was that the car was okay at, doing the things it's supposed to. But when there were pedestrians around, it couldn't predict the intentions of people. And so that unpredictability of people was the problem that they were having in self-driving car design. They didn't have a good enough internal model of what the people were, what they were doing, what they wanted. Or what do you think about that?
Well, I spent a huge amount of time watching pedestrians, thinking about pedestrians, thinking about what it takes to solve the problem of measuring, detecting the intention of a pedestrian, really of a human being in this particular context of having to cross the street. And it's fascinating. I think it's a window into how complex social systems are that involve humans. Because, I would just stand there and watch intersections for hours. And what you start to figure out is every single intersection has its own personality. So, like, there's a history to that intersection. Like jaywalking, certain intersections allow jaywalking a lot more. What happens is we're leaders and followers. So if there's a regular, let's say, and they get off the subway and they start crossing at a red light, and they do this every day. And then there's people that don't show up to that intersection often, and they're looking for cues of how we're supposed to behave here. And if a few people start to jaywalk and cross on a red light, they will also. They will follow. And there's just a dynamic to that intersection. There's a spirit to it. And if you look at Boston versus New York versus a rural town, versus even Boston, San Francisco, here in Austin, there's different personalities citywide, but there's different personalities area-wide, region-wide, and there's different personalities, different intersections. And it's just fascinating for a car to be able to determine that. It's tricky. Now, what machine learning systems are able to do well is collect a huge amount of data. But for us, it's tricky because we get to understand the world with very limited information and make decisions grounded in this big foundation model that we've built of understanding how humans work. AI could literally, in the context of driving, this is where I've often been really torn in both directions. If you just collect a huge amount of data, all of that information, and then compress it into a representation of how humans cross streets, it's probably all there. In the same way that you have a Noam Chomsky who says, no, AI can't talk, can't write convincing language without understanding language. And more and more you see large language models without quote unquote understanding can generate very convincing language. But I think what the process of compression from a huge amount of data compressing into a representation is doing is in fact understanding deeply. In order to be able to generate one letter at a time, one word at a time, you have to understand the cruelty of Nazi Germany and the beauty of sending humans to space. And you have to understand all of that in order to generate I'm going to the kitchen to get an apple and do that grammatically correctly. You have to have a world model that includes all of human behavior.
You think an LLM is building that world model?
It has to in order to be good at generating one word at a time between convincing sentences. And in the same way, I think AI that drives a car, if it has enough data, will be able to form a world model that would be able to predict correctly what a pedestrian is. But as humans are watching pedestrians, we slowly realize, damn, this is really complicated. In fact, when you start to self-reflect on driving, you realize driving is really complicated. There's subtle cues we take about just this is a million things I can say, but one of them determining who around you is an asshole, aggressive driving, potentially dangerous.
Yes, I was just thinking about this. Yeah,
or
you can read it a mile once you become a great driver. Yeah. You can see it a mile away. This guy is going to pull an asshole move in front of him.
Exactly.
He's way back there, but you know it's going to happen.
And I don't know what, because we're ignoring all the other cars.
Yeah.
But for some reason, the asshole a red, like a glowing, obvious symbol is just right there, even in the periphery vision. Where again, we're usually when we're driving just looking forward. But we're like using the peripheral vision to figure stuff out. And it's like a little puzzle that we're usually only allocating a small amount of our attention to. It's like cognitive attention. It is fascinating, but I think AI just has a fundamentally different suite of sensors in terms of the bandwidth of data that's coming in that allows you to form the representation and perform inference on the representation you form, using the representation you form. That for the case of driving, I think it could be quite effective. But one of the things that's currently missing, even though OpenAI just recently announced adding memory, and I did want to ask you, like, how important it is, how difficult is it to add some of the memory mechanisms that you've seen in humans to AI systems?
I would say superficially not that hard, but then in the deeper level, very, very hard because we don't understand episodic memory. Right? So one of the ideas I talk about in the book is one of the oldest kind of dilemmas in computational neuroscience is what Steve Grossberg called the stability plasticity dilemma. Right? When do you say something is new and overwrite the pre-existing knowledge versus going with what you have before and changes? So, part of the problem with going through like massive, part of the problem of things like you're trying to design an LLM or something like that is, especially for English, there's so many exceptions to the rules, right? And so if you want to rapidly learn the exceptions, you're going to lose the rules. And if you want to keep the rules, you have a harder time learning the exceptions. And so David Marr is one of the early pioneers in computational neuroscience. And then Jay McClellan and my colleague Randy Wiley, people like McClellan, all these people started to come up with the idea that maybe that's part of what we need and what the human brain is doing, is we have this kind of actually a fairly dumb system, which just says this happened once at this point in time, which we call episodic memory, so to speak. And then we have this knowledge that we've accumulated from our experiences in semantic. So now, when we encounter a situation that's surprising and violates all our previous expectations, what happens is that now we can form an episodic memory here. And the next time we're in a similar situation, boom, we can supplement our knowledge with this information from episodic memory and reason about what the right thing to do is, right? So it gives us this enormous amount of flexibility to stop on a dime and change without having to erase everything. And that solution is incredibly powerful because it gives you the ability to learn from so much less information. And it gives you that flexibility. So one of the things I think that makes humans great is having both episodic and semantic. Now, can you build something like that? I mean, computational neuroscience people, just record a moment and you just get it and you're done, right? But when do you record that moment? How much do you record? What's the information you prioritize and what's the information you don't? These are the hard questions. When do you use episodic memory? When do you just throw it away? And these are the hard questions we're still trying to figure out. And then you start to think about all these mechanisms that we have in the brain for figuring out some of these things. It's not just one, it's many of them that interact with each other. Then you just take not only the episodic and the semantic, but then you start to take the motivational survival things, right? It's just like the fight or flight responses that we associate with particular things, or the kind of like reward motivation that we associate with certain things, and so forth. And those things are absent. I frankly don't know if we want it. I don't necessarily want a self-motivated LLM, right? It's like, and then there's the problem of how do you even like build the motivations that should guide a proper reinforcement learning kind of thing. And so a friend of mine, Sam Gershman, I might be missing the quote exactly, but he basically said, if I wanted to train like a typical AI model to make me as much money as possible, first thing I might do is sell my house. So it's not even just about one goal or one objective, but just having all these competing goals and objectives, right? Then things start to get really complicated.
Well, it's all interconnected. I mean, just even the thing you mentioned is the moment. if we record a moment, it's difficult to express concretely what a moment is, like how deeply connected it is to the entirety of it. Maybe to record a moment, you have to make a universe from scratch. You have to include everything. You have to include all the emotions involved, all the context, all the things that built around it, all the social connections, all the visual experiences, all the sensory experience, all of that, all the history that came before that moment is built on. And we somehow take all of that and we compress it and keep the useful parts and then integrate it into the whole thing, into our whole narrative. And then each individual has their own little version of that narrative, and then we collide in a social way and we adjust it and we evolve.
Yeah. I mean, well, even if we want to go super simple, right? Like Tyler Bonin, who's a postdoc who's collaborating with me, he actually studied a lot of computer vision at Stanford. And so one of the things he was interested in is some people who have brain damage in areas of the brain that were thought to be important for memory. And but they also seem to have some perception problems with particular kinds of object perception. And this is super controversial. Some people found this effect, some didn't. And he went back to computer vision and he said, let's take the best state-of-the-art computer vision models and let's give them the same kinds of perception tests that we were giving to these people. And then he would find the images where the computer vision models would just struggle, and you would find that they just didn't do well. Even if you add more parameters, you add more layers, on and on and on, it doesn't help, right? The architecture didn't. It's just the problem. And then he found those were the exact ones where these humans with particular damage to this area called the periorbital cortex, that was where they were struggling. So somehow this brain area was important for being able to do these things that were adversarial to these computer vision models. So then he found that it only happened if people had enough time, they could make those discriminations. But without enough time, if they just get a glance, they're just like computer vision. So then what he started to say was, maybe let's look at people's eyes, right? So computer vision model sees every pixel. It's not, and we don't. We never see every pixel all at once. Even if I'm looking at a screen with pixels, I'm not seeing every pixel at once. I'm grabbing little points on the screen by moving my eyes around and getting a very high resolution picture of what I'm focusing on and kind of a lower resolution information about everything else. But I'm not necessarily choosing, but I'm directing that exploration and allowing people to move their eyes and integrate that information gave them something that the computer vision models weren't able to do. So somehow integrating information across time and getting less information at each step gave you more out of the process.
I mean, the process of allocating attention across time seems to be a really important process. Even the breakthroughs that you get with machine learning mostly has to do with attention is all you need. It's about attention, transform, it's about attention. So attention is a really interesting one.
Yeah.
But then how you allocate that attention, again, is at the core of what it means to be intelligent, what it means to process the world, integrate all the important things, discard all the unimportant things. Attention is at the core of it. It's probably at the core of memory too. Because there's so much sensory information. There's so much going on. You filter it down to almost nothing. And just keep those parts. And to keep those parts, and then whenever there's an error, to adjust the model such that you can allocate attention even better to new things that would result, maybe maximize the chance of confirming the model or disconfirming the model that you have, and adjusting it since then. Yeah, attention is a weird one. I was always fascinated. I mean, I got a chance to study peripheral vision for a bit and indirectly study attention through that. And it's just fascinating how good humans are at looking around and gathering information.
Yeah, at the same time, people are terrible at detecting changes that can happen in the environment if they're not attending in the right way. if their predictive model is too strong, So you have these weird things where like the machines can do better than the people. It's not that it's like, so this is the thing is people go, oh, well, the machines can do this stuff that's just like humans. It's like, well, the machines make different kinds of mistakes than the people. And I will never be convinced unless that we've replicated human. I don't even like the term intelligence. But it's like I don't think we've replicated human intelligence unless I know that the simulator is making exactly the same kinds of mistakes that people do. People make characteristic mistakes. They have characteristic biases. They have characteristic heuristics that we use, and those I have yet to see evidence that ChatGPT will do that.
Since we're talking about attention, is there an interesting connection to you between ADHD and memory?
Well, it's interesting for me because when I was a child, I was actually told by school, I don't know if it came from a school psychologist, they did do some testing on me, for IQ and stuff like that. Or if it just came from teachers who hated me, but they told my parents that I had ADHD. And so this was, of course, in the 70s. So basically, they said, he has poor motor control and he's got ADHD. So, and, there was social issues. So, like, I could have been put a year ahead in school, but then they said, oh, but he doesn't have the social, he doesn't have the social capabilities. So I still ended up being, like, an outcast even in my own grade. But then, so then my parents said, okay, well, they got me on a diet free of artificial colors and flavors because that was the thing that people talked about back then. So, well, I'm interested in this topic because I've come to appreciate now that I have many of the characteristics, if not, full blown. It's like I'm definitely time blindness, rejection sensitivity, you name it. Talk about it. It's like impulsive behavior. I can tell you about all sorts of fights I've gotten into in the past. Just you name it. But yeah, so ADHD is fascinating though because right now we're seeing more and more diagnosis of it. I don't know what to say about that. I don't know how much of that is based on kind of inappropriate expectations, especially for children, and how much of that is based on true kind of like maladaptive kinds of tendencies. But what we do know is this, is that ADHD is associated with differences in prefrontal function, so that attention can be both you're more distractible, you have a harder time focusing your attention on what's relevant. And so you shift too easily. But then once you get on something that you're interested in, you can get stuck. And so, the attention is this beautiful balance of being able to focus when you need to focus and shift when you need to shift. And so it's that flexibility plus stability again. And that balance seems to be disrupted in ADHD. And so as a result, memory tends to be poor. But it's not necessarily because there's a traditional memory problem, but it's more because of this attentional issue, right? And so, and people with ADHD often will have great memory for the things that they're interested in, and just no memory for the things that they're not interested in.
Is there advice from your own life on how to learn and succeed from that? From just how the characteristics of your own brain with ADHD and so on. How do you learn? How do you remember information? How do you flourish in this sort of education context?
I'm still trying to figure out the flourishing per se. But education, being in science is enormously enabling of ADHD. It's like you're constantly looking for new things. You're constantly seeking that dopamine hit, and that's great. They tolerate your being late for things. Nobody's going to die if you screw up. It's just not like being a doctor or something where you have to be much more responsible and focused. You can freely follow your curiosity, which is great. But what I would say, like, I'm learning now about so many things, like about how to structure my activities more, and basically say, okay, if I'm going to be email is like the big one that came right now. I'm just constantly like shifting between email and my activities. And what happens is that I don't actually get the email. I just look at my email and I get stressed because I'm like, oh, I have to think about this. Let me get back to it. And I go back to something else. And so I've just got fragmentary memories of everything. Right? So I'm trying to set aside a time where like, this is my email. This is my, writing time. This is my goofing off time. And so blocking these things off, you give yourself the goofing off time. Sometimes I do that. Sometimes I have to be flexible. Go like, okay, I'm definitely not focusing. I'm going to give myself the downtime, and it's an investment. It's not like wasting time. It's an investment in my attention later on.
And I'm very much with Cal Newport on this. He wrote Deep Work and a lot of other amazing books. He talks about task switching as a sort of the thing that really destroys productivity. So like, switching. It doesn't even matter from what to what, but checking social media, checking email, maybe switching to a phone call, and then doing work, and even switching between, if you're reading a paper, switching from paper to paper to paper, because curiosity and whatever the dopamine hit from the attention switch, like limiting that, because otherwise your brain is just not capable to really like load it in and really do that deep deliberation. I think that's required to remember things and to really think.
Yeah, I mean, you probably see this, I imagine, in AI conferences, but definitely in neuroscience conferences. It's now the norm that people have their laptops out during talks, and conceivably they're writing notes. But in fact, what often happens if you look at people, speak from a little bit of personal experience, is you're checking email and you're like. Or I'm working on my own talk, but often it's like you're doing things that are not paying. And I have this illusion, well, I'm paying attention. And then what happens is I don't remember anything from that day, just vanish. Because what happens is I'm creating all these artificial event boundaries. I'm losing all this executive function every time I switch. I'm getting like a few seconds slower, and I'm catching up mentally to what's happening. And so instead of being in a model where you're meaningfully integrating everything and predicting and generating this kind of like rich model, I'm just catching up, And so, yeah, there's great research by Melina Unkefer and Anthony Wagner on multitasking that people can look up that talks about just how bad it is for memory and it's becoming worse and worse of a problem.
So you're a musician. Take me through how'd you get into music? Like what made you first fall in love with music? With creating music?
So I started playing music just when I was like doing trumpet in school for school band, and I would just read music and play, and it was pretty decent at it. Not great, but I was decent.
How'd you go from trumpet to guitar, especially the kind of music you're into?
Yeah, so basically in high school, so I kind of was a late bloomer in music, but just kind of MTV. I grew up with MTV, and so then you started seeing all this stuff, and then I got into metal. Was kind of like my early genre. And I always reacted to just things that were loud and had a beat, like ADHD, right? It's like everything from Sgt. Pepper's by the Beatles to like Led Zeppelin 2. My dad had both. My parents had both those albums, so I listened to them a lot. And then like the Police. Ghost in the Machine, but then I got into metal, Def Leppard, and AC/DC, Metallica. Went way down the rabbit hole of speed metal, and that time was kind of like, why don't I play guitar? I could do this, and I had friends who were doing that, and I just never got it. Like I took lessons and stuff like that, but it was different because when I was doing trumpet, I was reading sheet music, and this was like I was learning. By looking, there's a thing called tablature, this where it's like you see like a drawing of the fretboard with numbers, and that's where you're supposed to put it. It's kind of like paint by numbers, right? And so I learned it in a completely different way, but I was still terrible at it. And I didn't get it. It's actually taken me a long time to understand exactly what the issue was. But it wasn't until I really got into punk and I saw bands I saw Sonic Youth, I remember especially, and it just blew my mind. because they violated the rules of what I thought music was supposed to be. I was like, this doesn't sound right. These are not power chords. And this doesn't just have like a shouty verse and then a chorus part. It's not going, this is just like weird. And then it occurred to me, you don't have to write music the way it's people tell you it's supposed to sound. I just opened up everything for me. And I was playing in a band and I was struggling with writing music because I would try to write like, whatever was popular at the time and or whatever sounded like other bands that I was listening to. And somehow I kind of morphed into just grabbing a guitar and just doing stuff. And I realized part of my problem with doing music before was I didn't enjoy trying to play stuff that other people played. I just enjoyed music just dripping out of me and just spilling out and just doing stuff. And so then I started to say, what if I don't play a chord? What if I just play like notes that shouldn't go together and just mess around with stuff? And I said, well, what if I don't do 4 beats? No, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. What if I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and started messing around with time signatures. Then I was playing in this band with a great musician who was really Brent Ritzel, who was in this band with me, and he taught me about arranging songs. And it was like, what if we take this part and instead of make it go like back and forth, we make it like a circle? Or what if we make it like a straight line? Or a zigzag, just make it like non-linear in these interesting ways. And then next thing you know, it's like the whole world sort of opens up as like you. And then what I started to realize, especially, so you can appreciate this as a musician, so time signatures, right? So we are so brainwashed to think in 4/4. Right? Every rock song you can think of is in 4/4. I know you're a Floyd fan, so think of Money by Pink Floyd, right?
Yeah.
Bum, bum, bum. You feel like it's in 4/4 because it resolves itself, but it resolves on the last note of, basically it resolves on the first note of the next measure. So it's got 7 beats instead of 8 where the riff is actually happening. But you're thinking in 4 because that's how we're used to thinking. So the music flows a little bit faster than it's supposed to. And you're getting a little bit of prediction error every time this is happening. And once I got used to that, I was like, I hate writing in 4/4 because it was like everything just feels better if I do it in 7/4, if I alternate between 4 and 3, and doing all this stuff. And then it's like jazz music is like that. They just do so much interesting stuff with it.
So playing with those time signatures allows you to like really break it all open. I guess there's something about that where it allows you to actually have fun.
Yeah, and it's like, so I'm actually like a very one of the genres we used to play in was math rock, is what they call it, which is like, there's so many weird time signatures.
What is math? Oh, interesting.
Yeah, so
that's the math part of rock is what the mathematical disturbances of it, or what?
Yeah, I guess it would be like, so you might go like, instead of playing 4 beats in every measure, no, you go no. And just do these things, and then you might arrange it in weird ways so that there might be 3 measures of verse, and then 1, and then 5 measures of chorus, and then 2 measures. So you could just mess around with everything. Right?
What does that feel like to listen to? There's something about symmetry or like patterns that feel good and like relaxing for us, or whatever it feels like home. And disturbing, that can be quite disturbing.
Yeah.
So is that the feeling you would have if you math rock? I mean,
yeah,
it's stressing me out just listening.
Well, yeah.
Learning about it.
So I mean, it depends. So a lot of my style of songwriting is very much like in terms of like repetitive themes, but messing around with structure, because I'm not a great guitarist technically, and so I don't play complicated stuff. And there's things you could hear stuff where it's just like so complicated. But often what I find is like having a melody, and then adding some dissonance to it, just enough, and then adding some complexity that gets you going just enough. But I have a high tolerance for that kind of dissonance and prediction. I think I have a pet theory that it's like basically you could explain most of human behavior as some people are lumpers and some people are splitters, And so it's like some people are very kind of excited when they get this distance and they want to like go with it. Some people are just like, no, I want to lump every. I don't know. Maybe that's even different, but it's like basically, it's like I think some people get scared of that discomfort, and I really
thrive on it. Yeah,
you know.
I love it. What's the name of your band now?
The cover band I play in is a band called Pavlov's Dogs, and so
Yeah.
So it's a band, unsurprisingly, of mostly memory researchers, neuroscientists.
I love this.
And
I love this so much.
Yeah, actually, one of your MIT colleagues, Earl Miller, plays bass.
Plays bass.
So,
you play like do you play
so
rhythm or
you could
lead
compete if you want. Maybe we could audition
for audition. Oh yeah, coming for you, Earl.
Earl's gonna kill me. He's like very precise.
I'll play triangle or something. Where's the cowbell? Yeah, I'll be a cowbell guy. And you guys, what kind of songs you guys do?
So it's mostly late 70s punk and 80s new wave and post-punk. Blondie, Ramones, Clash. I sing Age of Consent by New Order and Lovely Terrace.
You said you have a female singer now?
Yeah, Carrie Hoffman and also Paula Croxton. And so they do, so Carrie does Blondie amazingly well. And we do like Gigantic by the Pixies. Paula does that one.
Which song do you love to play the most? What kind of song is super fun for you?
Of someone else's?
Yeah, cover, yeah.
And it's one we do with Pavlov's Dogs. Mm-hmm. I really enjoyed playing I Want to Be Your Dog by Iggy, which is perfect because we're Pavlov's Dogs.
Yeah.
And Pavlov, of course, was like basically creative learning theory. So, there's this, but also it's like, but I mean, Iggy and the Stooges, that song, so I play and sing on it, but it's just like it devolves into total noise and it just like fall on the floor and generate feedback. I was like, I think in the last version, it might have been that or a Velvet Underground cover in our last show. I have a guitar made of aluminum that I got made. And I thought this thing's indestructible. So I kind of like was just, moving it around. I had it upside down and all this stuff to generate feedback. And I think I broke one of the tuning pegs.
Oh, wow.
Yeah, so I managed to break an all-metal guitar. Go figure.
Bit of a big, ridiculous question, but let me ask you, we're talking about neuroscience in general. What do you've been studying the human mind for a long time. What do you love most about the human mind? Like when you look at it, we look at the fMRI, just the scans and the behavioral stuff, electrodes, the psychology aspect, reading the literature on the biology side, neurobiology, all of it. When you look at it, what is most beautiful to you?
I think the most beautiful, but incredibly hard to put your finger on, is this idea of the internal model. That it's like there's everything you see, and there's everything you hear, and touch, and taste, and whatever. But it's all connected by this dark energy that's holding that whole universe of your mind together. Right? And without that, it's just a bunch of stuff. And somehow we put that together, and it forms so much of our experience. And being able to figure out where that comes from and how things are connected to me is just amazing. But just this idea of the world in front of us, sampling this little bit, trying to take so much meaning from it. And we do a really good job, not perfect. But that ability to me is just amazing.
Yeah, it's an incredible mystery, all of it. It's funny you said dark energy, because the same in astrophysics. You look out there, look at dark matter and dark energy, which is this loose term assigned to a thing we don't understand, which helps make the equations work in terms of gravity and the expansion of the universe. In the same way, it seems like there's that kind of thing in the human mind that we're striving to understand.
Yeah. It's funny that you mentioned that. So one of the reasons I wrote the book, amongst many, is that I really felt like people needed to hear from scientists, and COVID was just a great example of this, because people weren't hearing from scientists. One of the things I think that people didn't get was the uncertainty of science and how much we don't know. And I think every scientist lives in this world of uncertainty. And when I was writing the book, I just became aware of all of these things we don't know. And so I think of physics a lot. I think of this idea of like overwhelming majority of the stuff that's in our universe cannot be directly measured. I used to think, haha, I hate physics. Physicists get the Nobel Prize for doing whatever stupid thing. It's like there's 10 physicists out there. I'm just kidding. Just
Strong words.
Yeah, no. I'm kidding. The physicists who do neuroscience could be rather opinionated.
It's all love.
It's all love. That's right. It's an ADHD talking. So, but at some point I had this aha moment where I was like, to be aware of that much that we don't know and have a bead on it and be able to go towards it, that's one of the biggest scientific successes that I could think of. You are aware that you don't know about this gigantic section, overwhelming majority of the universe, right? And I think the more, what keeps me going to some extent is realizing changing the scope of the problem, figuring out, oh my God, there's all these things we don't know. And I thought I knew this because science is all about assumptions, right? So have you ever read The Structure of Scientific Revolutions?
Yes.
That's like my only philosophy really that I've read. But it's so brilliant in the way that they frame this idea of he frames this idea of assumptions being core to the scientific process. And the paradigm shift comes from changing those assumptions. And this idea of finding out this kind of whole zone of what you don't know, to me is the exciting part.
Well, you are a great scientist and you wrote an incredible book, so thank you for doing that. And thank you for talking today. You've decreased the amount of uncertainty I have just a tiny little bit today and revealed the beauty of memory. This is a fascinating conversation. Thank you for talking today.
Oh, thank you. It's been a blast.
Thanks for listening to this conversation, Sharon. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from Haruki Murakami. Most things are forgotten over time. Even the war itself, the life and death struggle people went through, is now like something from the distant past. We're so caught up in our everyday lives that events of the past are no longer in orbit around our minds. There are just too many things we have to think about every day, too many new things we have to learn. But still, no matter how much time passes, no matter what takes place in the interim, there are some things we can never assign to oblivion. Memories we can never rub away. They remain with us forever, like a touchstone. Thank you for listening. I hope to see you next time. Where are we right now, Paul?
Lex, we're in the middle of nowhere.
It's the Amazon jungle. There's vegetation, there's insects, there's all kinds of creatures. A million heartbeats, a million eyes. So, really, where are we right now?
We are in Peru in a very remote part of the western Amazon basin, and because of the proximity of the Andean cloud forest and the lowland tropical rainforest, we are in the most biodiverse part of planet Earth. There's more life per square acre, per square mile out here than there is anywhere else on Earth, not just now, but in the entire fossil record.
The following is a conversation with Paul Rosalie, the second time on the podcast. But this time, we did the conversation deep in the Amazon jungle. I traveled there to hang out with Paul, and it turned out to be an adventure of a lifetime. I will post a video capturing some aspects of that adventure in a week or so. It included everything from getting lost in dense, unexplored wilderness with no contact to the outside world to taking very high doses of ayahuasca and much more. by the way, aside from being my good friend, is a naturalist, explorer, author, and is someone who has dedicated his life to protecting the rainforest. For this mission, he founded Jungle Keepers. You could help him if you go to junglekeepers.org. This trip, for me, was life-changing. It expanded my understanding of myself and of the beautiful world I'm fortunate to exist in with all of you. So, I'm glad I went, and I'm glad I made it out alive. This is the Lex Review Podcast. To support it, please check out our sponsors in the description. And now, dear friends, here's Paul Rothschild. I can't believe we're actually here.
I can't believe you actually came.
And I can't believe you forced me to wear a suit.
That was the people's choice, trust me.
We've been through quite a lot in the last few days.
We've been through a bit.
Let me ask you a ridiculous question. What are all the creatures right now, if they wanted to, could cause us harm?
The thing is, the Amazon rainforest has been described as the greatest natural battlefield on Earth because there's more life here than anywhere else, which means that everything here is fighting for survival. The trees are fighting for sunlight, the animals are fighting for prey, everybody's fighting for survival. So everything that you see here, everything around us will be killed, eaten, digested, recycled at some point. The jungle is really just a giant churning machine of death, and life is kind of this moment of stasis where you maintain this collection of cells in a particular DNA sequence, and then it gets digested again and recycled back and renamed into everything. And so the things in this forest, while they don't want to hurt us, there are things that are heavily defended because, for instance, a giant anteater needs claws to fight off a jaguar. A stingray needs a stinger on its tail, which is basically a serrated knife with venom on it to deter anything that would hunt that stingray. Even the catfish have pectoral fins that have razor long steak knife sized defense systems. And you have, of course, the jaguars, the harpy eagles, the piranha, the candiru fish that can swim up the penis, lodge themselves inside. It's the Amazon rainforest. The thing is, as you've learned this week, nothing here wants to get us, except for an exception of maybe mosquitoes. Every other animal just wants to eat and exist in peace. That's it.
There is, each of those animals that you described have a kind of radius of defense.
Yeah.
So if you accidentally step into its home, into that radius, it can cause harm.
Or make them feel threatened.
Make them feel threatened. There is a defense mechanism that is activated.
Some credible defense mechanism. We're talking about 17-foot black caiman, crocodiles that with significant size that could rip you in half, anacondas, the largest snake on Earth, bushmasters that can grow up to be 9 to I think even 11 feet long. And I've caught bushmasters that are thicker than my arms.
So for people who don't know, bushmaster snakes, what are these things?
These are vipers. So I believe it's the largest viper on Earth.
Venomous.
Extremely venomous, with hinged teeth, tissue-destroying venom. Like if you get bitten by a bushmaster, they say you don't rush and try and save your own life. You try to savor what's around you. Look around at the world. Smoke your last cigarette. Call your mom. That's it.
So that moment of stasis that is life is going to end abruptly when you interact with one of those.
Even this seemingly.
Can I just pause on how incredibly beautiful it is that you can just reach to your right and grab a piece of the jungle?
It's like even this seemingly beautiful little fern. If you go this way on the fern, you're fine. As soon as you go this way, there's invisible little spikes on there. If you want to.
Oh, I see.
Yeah. See that? It's like everything is defended. If you're driving on the road and you have your arm out the side, or if you're on a motorcycle going through the jungle, and you get one of these, it'll just tear all the skin right off your body. It's kind of doing that to you.
So what would you do? Like we're going through the dense jungle yesterday, and you slide down the hill, your foot slips, you're sliding down, and then you find yourself staring a couple feet away from a bushmaster snake. What do you do? You're, for people who somehow don't know, as somebody who admires snakes, who has met thousands of snakes, has worked with them, respects them, celebrates them, what would you do with a bushmaster snake? Face to face.
Face to face, this has happened.
It's nice.
I've come face to face with the bushmaster, and there's there's two reactions that you might get. One is if the bushmaster decides that it's vacation time, if it's sleeping, if he just had a meal, they'll come to the edges of trails or beneath a tree and they'll just circle up, big spiral, big pile of snake on the trail, and they'll just sit there. And one time there was a snake sitting on the side of a trail beneath a tree for 2 weeks. This snake was just sitting there, resting, digesting food out in the open, in the rain, in the sun, in the night. Didn't matter. You go near it, even crack its tongue. Now, the other option is that you get a bushmaster that's alert and hunting and out looking for something to eat, and they're ready to defend themselves. And so I once came across a bushmaster in the jungle at night, and this bushmaster turned its head towards me, looked at me, and made it very clear, I'm going to go this way. So I did the natural thing that any snake enthusiast would do, and I grabbed its tail. Now, 11 feet later, by the head, the snake turned around and just said, if you want to meet God, I can arrange the meeting. I will oblige. And I decided to let the bushmaster go. And so it's like that with most animals. You know, a jaguar will turn and look at you and just remind you of how small you are.
Like, what did you see in the snake's eyes? How did you sense that this is not the right, this is going to be your end if you proceed?
His readiness. I wanted to get him by the tail and show him to the people that were there, maybe work with the snake a little bit. As an 11-foot snake, the snake turned around and made it very clear, like, not today, pal. It's not going to happen.
Is it in the eyes and the movement and the tension of the
body?
movement,
it was the movement and the S of the neck. It was as if you pushed me and I went, let's go, make my day.
Yeah.
Like he just looked a little bit too ready. He's like, I love this.
Okay.
All right.
So you know.
You just know. Whereas like the snake you met last night,
yeah, beautiful snake.
Such a calm little thing, just focuses on eating baby lizards and little snails and things. And that snake has no concept of defending itself. It has no way to defend itself. So even something the size of a blue jay could just come and peck that thing in the head and swallow it. It's a helpless little snake. So it's really, it kind of depends on the animal, it depends on the mood you catch them in. Each one has a different temperament.
The grace of its movement was mesmerizing, curious almost. Maybe I'm anthropomorphizing, projecting onto it. But it was
the tongue flicking was a sign of curiosity, trying to figure out what was going on. So why am I on this treadmill of human skin? You know, they're just trying to get to the next thing, trying to get hidden, trying to get away from the light.
Also, the texture of the scales is really fascinating. It's my first snake I've ever touched. It's so interesting, and it's just such an incredible system of muscles that are all interacting together to make that kind of movement work, and all the texture of its skin, of its scales. What do you love about snakes? From my first experience with a snake to all the thousands of experiences you had with snakes, what do you love about these creatures?
I think it's when you just spoke about it, that's the first snake you've met, and it was a tiny little snake in the jungle, and you spoke about it with so much light in your eyes. And I think that because we've been programmed to be scared of snakes, there's something wondrous that happens in our brain. Maybe it's just this joy of discovery that there's nothing to be scared of. And whether it's a rattlesnake that is dangerous and that you need to give distance to, but you look at it from a distance and you go, whoa. Or it's a harmless little grass snake that you could pick up and enjoy and give to a child. They're just these strange legless animals that just exist. You know, they don't even have eyelids. They're so different than us. They have a tongue that senses the air, and they, to me, are so beautiful. And I've my whole life been defending snakes from humans, and they seem misunderstood. I think they're incredibly beautiful. There's every color and variety of snakes. There's venomous snakes, there's tree snakes, there's huge crushing anacondas. It's just, of the 2,600 species of snakes that exist on Earth, there's just such beauty, such complexity, and such simplicity. They're just to me, I feel like I'm friend with snake, and they rely on me to protect them from my people.
Friend with snake.
Me friend snake.
Me friend snake. You said some of them are sometimes aggressive, some of them are peaceful. Is this a mood thing, a personality thing, a species thing? What is it?
So, as far as I know, there's only really 2 snakes on Earth that could be aggressive, because aggression indicates offense. And so, a reticulated python has been documented as eating humans. Anacondas, although while it hasn't been publicized, they have eaten humans. Every single other snake, from boa constrictor to bushmasters to spitting cobra to grass snake to garter snake to everything else, every single other snake does not want to interact with you. They have no interest. So there's no such thing as an aggressive snake once you get outside of anaconda and reticulated python. Aggression could be trying to eat you. That's predation. But for every other snake, a rattlesnake, if it was there, would either go escape and hide itself, or it would rattle its tail and tell us, don't come closer. A cobra will hood up and begin to hiss and say, don't approach me. I'm asking you nicely not to mess with me. And most other snakes are fast, or they stay in the trees, or they're extremely camouflaged, but their whole MO is just don't bother. I don't want to be seen. I don't want to be messed with. In fact, all I want to do is be left alone. And once in a while, I just want to eat. And by the way, when you see a snake drink, your heart will break. It's like it's the only thing that's cuter than a puppy. Like watching a snake touch its mouth to water, and you just see that little mouth going as they suck water in, and it's just so adorable watching this scaled animal just be like, I need water.
In a state of vulnerability.
Yeah.
But bro, there's nothing cuter than a little puppy with a tongue like
baby ball python,
all right,
baby king cobra, man.
baby
elephant.
So what are they? They're like at a puddle and they just take it in.
They can be at a puddle and they just take it in. Or one time in India, I was with a snake rescuer and we found this 9-foot king cobra, this god of a snake. They're Ophiophagus hanna is their Latin name, and they're snake eaters. They're the king of the snakes, the largest venomous snake. And the people that called the snake rescuer, because that's a profession in India, it had gotten into their kitchen or their backyard, and so we showed up and we got the snake, and the snake rescuer, he knew. He looked at the snake and he went to me, he's like, why do you think the snake would go in the house? And he was quizzing me, and I actually went, I don't know. Is it warm? Is it cold? Like sometimes cats like to go into the warm cars in the winter. And he was like, he's thirsty. He goes, watch this. He took a water bottle. The snake is standing up. The snake stands up 3 feet tall. This is a huge king cobra, a terrifying snake to be around. He leans over to the snake, and the snake is standing there trusting him. And he takes a water bottle and pours it onto the snake's nose, and the snake turns up its nose and just starts drinking the water bottle. Human giving water to snake. Big, scary snake. But this human understood. Snake gets water, snake gets released in jungle, everybody's okay.
So sometimes the needs are simple. They just don't have the words to communicate that to us humans.
Yeah.
And is it disinterest or is it fear? Almost like they don't notice us, or is it where the unknown aspect of it, the uncertainty is a source of danger?
Well, animals live in a constant state of danger. Like if you look at that deer that we saw last night, it's stalking through the jungle, wondering what's going to eat it, wondering if this is the last moment it's going to be alive. It's like animals are constantly terrified of that this is their last moment.
Yeah, just for the listener, we're walking through the jungle late at night. It's just darkness except our headlamps on. And then all of a sudden, Paul stops. He's like, shh. He looks in the distance. He sees 2 eyes. I think you thought, is that a jaguar or is that a deer? And it was moving its head like this. Like, scared or maybe trying to localize itself,
Trying to see around.
You're doing the same to it. the two of you like moving your head and like deep into the jungle. Like I don't know. It's pretty far away through the trees. You can still see it. That's
30 feet or so. Yeah.
That's the thing to actually mention. I mean, with headlamp, you see the reflection in their eyes. It's kind of incredible. Just to see a creature, to try to identify a creature by just the reflection in its eyes.
Yeah. And so the cats, sometimes you'll get like a greenish or a bluish glow from the cats. The deer are usually white to orange. Caiman, orange. Nightjars, orange. Snakes can usually be like orange moths. Spiders sparkle. And so you have all these different, as you walk through the jungle, you can see all these different eyes. And when something large looks at you, like that deer did, your first thing is, what animal is this that I am staring back at? Because through the light, you kind of you see the reflection off the bright light off the leaves. And I couldn't tell at first, because actually those big bright eyes, it could have been an ocelot, could have been a jaguar, could have been a deer. And then when it did this movement, that's what the cats do. They try to see around your light. Maybe Lex Friedman's here, we're going to get lucky. It's going to be a jag right off trail.
Your definition of lucky is a complicated one.
Yeah.
It's a fascinating process when you see those 2 eyes trying to figure out what it is, and it is trying to figure out what you are, that process. Let's talk about caiman. We've seen a lot of different kinds of sizes. We've seen a baby one, a bigger one. Tell me about these 16-foot plus apex predators of the Amazon rainforest.
The big bad black caiman, which is the largest reptilian predator in the Amazon, except for the anaconda. They kind of both share that notch of apex predator. They were actually hunted to endangered species level in the 70s because they're leather, black scale leather. But they're coming back. They're coming back, and they're huge and they're beautiful. And I was walking near a lake, and I never understood how big they could get, except for I was walking near a lake last year, and I was following this stream. You know what it's like when you follow a little stream, there's just a little trickle of water, and all of a sudden this river otter had been running the other direction on the stream. River otter comes up to me, and I swear to God, this animal looked at me and went, "Hey!" And I went, "Hey!" You didn't expect to see me there. When he turned around, did a little spin, started running down the stream. Then he turned around, and you could tell he was like, "Let's go!" And I'm not anthropomorphizing you. The animal was asking me to come with him. So I followed the river otter down the stream. We started running down the stream. The river otter looks at me one more time, is like, "Yo!" Jumps into the lake. What does he want me to see? Now, in the lake, there's river otters doing dives and freaking out and going up and down and up and down, and they're very excited. They're screaming, they're screeching. All of a sudden, and I've never seen anything like this except for in like Game of Thrones, this crockhead comes flying out of the water. All of the river otters were attacking this huge black caiman, 16 feet, head half the size of this table, and she was thrashing her tail around, creating these huge waves in the water, trying to catch an otter, and they're so fast that they were zipping around her, biting her, and then going around. And this otter, swear to God, interspecies, looked at me and went, "Watch this. We're fucking with this caiman." It was amazing. And for the first time, I got to stand there watching this incredible interspecies fight happen. They weren't trying to kill the caiman. They were just trying to mess with it. And the caiman was doing his best to try and kill these otters. And they were just having a good time in that sick sort of hyper-intelligent animal, like wolf sort of way, where they were just going, "You can't catch us."
Yeah, like intelligence and agility versus like raw power and dominance. I mean, I got to handle some smaller caiman, and just the power they had. You scale that up to imagine with a 16-foot, 10-foot, any kind of black caiman, the kind of power they deliver. Maybe can you talk to that, like the power they can generate with their tail, with their neck, with their jaw.
Alligators and caiman and crocodiles have some of the strongest bite forces on Earth. I think the saltwater crocodile wins as the strongest bite force on Earth. And you got to hold about a 4-foot spectacle caiman. And you got to feel, you're a black belt in jiu-jitsu. How do you compare the explosive force you felt from that animal compared to what a human can generate?
It's difficult to describe in words. There's a lot of power, and we're talking about the power of the neck, like what is it? I mean, there's a lot. It could generate power all up and down the body. So probably the tail is a monster, but just the neck, and not to mention the power of the bite, that, and the speed too. Because the thing I saw and got to experience is how still and calm, at least from my amateur perspective, it seems calm. Still, and then from that sort of 0 to 60, you could just go wild,
Just thrash.
And then there's also a decision it makes in that split second whether, as it thrashes, is it going to kind of bite you on the way or not.
And that's where of the 4 species of caiman that we have here, you see differences in their personalities as a species.
Yeah.
And so you can generally golden retrievers are viewed as a friendly dog. Generally, not every single one of them, but as a rule. Spectacle caiman, puppies. You released one in the river, and it did nothing. It didn't bite one of your fingers, it just swam away. We dropped one in the river, and what did it do? It chose peace. Now, I had a smooth-fronted caiman a few weeks ago, and this was probably about a 3.5-footer, not big enough to kill you, but very much big enough to grab one of your fingers and just shake it off your body, just death roll it right off. And as I was being careful, totally different caiman than the one that you got to see. This one has spikes coming off. They're like leftover dinosaurs. It's like they evolved during the dinosaur times and never changed. They have spikes and bony plates and all kinds of strange growths that you don't see on the other smoother caiman. And I tried to release this one without getting bitten, and I threw it into the stream, gently into the water, just went whack, and tried to pull my hands back. And as I pulled my hand back, this caiman in the air turned around and just tried to give me one parting blow, and just got one tooth whack right to the bone of my finger. And bone injury feels different than a skin injury, so you instantly And it just reminds you of, that's a caiman with a head this big, and it hurt. And I know that it could have taken off my finger. Now, if you scale that up to a black caiman, it's rib crushing. It's zebra head removing size. Just meat destroying. It's incredible. It's nature's metal, sort of. Just raw power.
So what's the biggest croc you've been able to handle?
We were doing caiman surveys for years, and we would go out at night, and you want to figure out what are the populations of black caiman, spectacled caiman, smooth-fronted caiman, dwarf caiman, and the only way to see which caiman you're dealing with is to catch it. A lot of times you get up close with the light, you can see the eyes at night, but you can't quite see what species it is. For instance, this past few months, we found 2 baby black caiman on the river, which is unprecedented. We haven't seen that in decades. So it's important that we monitor our croc population. So I started catching small ones. In Mother of God, I write about the first one that me and JJ caught together, which was probably a little bigger than this table. And probably mid-20s bravado and competition with other young males of my species led to me trying to go as big as I could. And I jumped on a spectacle caiman that was slightly longer than I am. And I'm 5'9", so I jumped on this probably 6-foot croc and quickly realized that my hands couldn't get around its neck and my legs were wrapped around the base of its tail, and the thrash was so intense that as it took me one side, I barely had enough time to realize what was happening before it beat me against the ground. My headlamp came off, so now I'm blind, in the dark, laying in a river in the Amazon rainforest, hugging a 6-foot crocodile. And I went, JJ! As I always do. But in that moment, before I even let go, I knew I couldn't let go of the croc, because if I let go of the croc, I thought she was going to destroy my face. So I said, okay, now I'm stuck here. If I just stay here, I can't release her. I need help. But I was like, I'm never, ever, ever, ever going to try and solo catch a croc this big again. I was like, this is. I knew in that moment, I was like, this is good enough.
So anything longer than you don't control the tail. You barely control anything. Really.
Yeah, and that's a spectacle caiman. A black caiman is a whole other order of magnitude there. It's like saying like, oh, I was play fighting with my golden retriever versus I was play fighting with what's the biggest, scariest dog you can think of? This is the dog from Sandlot, a giant gorilla dog thing, like a Malamute, something huge. What do they call it? Mastiffs.
Yeah,
Mastiffs.
I mean, you mentioned dinosaurs. What do you admire about black caiman? They've been here for a very, very long time. There's something prehistoric about their appearance, about their way of being, about their presence in this jungle.
With crocodiles, you're looking at this mega survivor. They're in a class with sharks where it's like they've been here so long. When you talk about multiple extinctions, you talk about the 6th extinction, Earth's going through all this stuff, the crocodiles and the cockroaches have seen it all before. They're like, man, we remember what that comet looked like. And they're not impressed.
Yeah, they carry this wisdom.
Yeah.
And their power.
Yeah.
In the simplicity of their power, they carry the wisdom.
Yeah. And they're just sitting there in the streams and they don't care. And even if there's a nuclear holocaust, you know that there'd just be some crocs sitting there dead-eyed in that stagnant water waiting for the life to regenerate so they could eat again.
It's going to be the remaining humans versus the crocs and the cockroaches. And the cockroaches are just background noise. They'll always be there. Sons of bitches. We're talking about individual black caiman and different species of caiman. Whenever they're together, you see multiple eyes. They've gotten to experience. It's quite a feeling. There's just multiple eyes looking back at you. Of course, for you, that's immediate excitement. You immediately go towards that. You want to see it, you want to explore it, maybe catch them, analyze what the species is, all that kind of stuff.
Yeah.
Can you just describe that feeling when they're together and they're looking at you, so head above water, eyes reflecting the light?
Yeah, so the other night, Lex and I were in the river with JJ, surviving a thunderstorm. We're in the rain, and we had covered our equipment with our boats, and the only thing that we could do was get in the river to keep ourselves dry. And so we were in the river at night, in the dark, no stars, just a little bit of canopy silhouetted with all this rain coming down. It was such a din you could hardly hear anything. And all the way downriver, I just see this caiman eye in my headlamp light. And I started walking towards it because I was like, this is even better. We can catch a caiman while we're in this thunderstorm in the Amazon River. And when JJ went, Paul, it's too far. JJ very rarely, like he'll make a suggestion. Like he'll usually go, maybe it's far. But in that situation, deep in the wilderness, unknown caiman size, he went, Paul, it's too far. Don't leave the three of us right now. We're too far out to take risks. We're too far out to be walking along the riverbed at night, because then, right here at the research station, if you step on a stingray, you get evac'd. Out where we went, nothing. So for me, seeing those eyes, I think I've become so comfortable with so many of these animals that I may have crossed into the territory where I feel so comfortable with many of these animals that they just don't worry me anymore. I mean, I looked at you in a raft while you had a sizable, probably about 12-foot black caiman right next to your raft. I watched its head go under. The bubbles, it was all coming up right next to your raft as he was just moving along the bottom of the river, because he looked at me, went under, and then my raft passed and yours came over him. So now I'm looking back and your raft is going over this black caiman. And I'm going, I'm not worried at all. I was not worried. I was not worried that the caiman would freak out. I was not worried that it would try to attack you. I knew 100% that caiman just wanted us to go so you could go back to eating fish. That's it.
Man, it's humbling. It's humbling, these giant creatures. And especially at night, like you were talking about. And for me, it's both scary and just beautiful when the head goes under. Because like underwater, it's their domain. So anything can happen. So what is it doing that its head is going under? It could be bored. It could be hungry, looking for some fish. It could be maybe wanting to come closer to you to investigate. Maybe you have some food around you. Maybe it's an old friend of yours who just wants to say hi. I don't know.
I have a few on there. No, when we see their heads go under, it's just, they're just getting out of the way. We're shining a light at them and they're going, why is there a light at night? I'm uncomfortable. Head under. So these caiman, again, you think of it as this big aggressive animal, but I don't know anybody that's been eaten by a black caiman. And the smaller species, smooth-fronted caiman, dwarf caiman, spectacled caiman, they're not going to eat me. But again, at the worst, if you were doing something inappropriate with a caiman, you jumped on it and were trying to do research and bit your hand, it could take your hand off. But that's the only time. I've been walking down the river and stepped on a caiman, and the caiman just swims away. And so in my mind, caiman are just they're peaceful dragons that sit on the side of the river. So to me, they are my friends. And I worry about them because 2 months ago we were coming upriver, and on one of the beaches was a beautiful 5-foot black caiman with a big machete cut right through the head. The whole caiman was wasted. Nothing was eaten, but the caiman was dead.
What do you think that was?
Curious humans.
Just committing violence?
Yeah, just loggers, people who aren't from this part of the Amazon, because a local person would either eat the animal or not mess with it. Like Pico would never kill a caiman for no reason because it doesn't make any sense. So these are clearly people who aren't from the region, which usually means loggers because they've come from somewhere else. They're doing a job here, and they're just cleaning their pots in the river at night, and they see eyes come near them because the caiman probably smells fish, and then they just whack because they want to see it, and they're just curious monkeys on a beach. And again, me, friend of caiman, I protect from my type.
That said, you protect your friends and you analyze and study your friends, but sometimes friends can have a bit of a misunderstanding. And if you have a bit of a misunderstanding with the black caiman, I feel like just a bit of a misunderstanding could lead to a bone-crushing situation.
But not for a little 5-foot caiman. And I think that's incredibly speciesist of me.
Bald humans or bald caiman?
No, right. Like all my friends do the same thing. They go, you swim in the Amazon rainforest? You swim in that river? And I go, yes, every day. Backflips into the river. We've been swimming in the river how many times? With the piranha and the stingray and the kangaroo and the caiman and the anacondas, all of it in the river with us. And we just do it. And what's that for you? So what allows you to do that? Knowing and having researched all the different things that can kill you, which I feel like most of them are in the river. What allows you to just get in there with us?
Well, I think it's something about you where you become like this portal through which it's possible to see nature as not threatening but beautiful. And so in that, you kind of naturally, by hanging out with you, I get to see the beauty of it. There is danger out there, but the danger is part of it. Just like there's a lot of danger in the city, there's danger in life. There's a lot of ways to get hurt, emotionally, physically. There's a lot of ways to die in the stupidest of ways. We went on an expedition to the forest, just twisting your ankle, breaking your foot, uh, getting a bite from a thing that gets infected. There's a lot of ways to die and get hurt in the stupidest of ways, in a non-dramatic came eating you alive kind of way.
It strikes me as unfair because humans were still in our minds so programmed to worry about that predator. What predator? We've killed everything. Black caimans are coming off the endangered species list. We exterminated wolves from North America. I actually heard a suburban lady one time tell her son, "Watch out, foxes will get you." Foxes.
Yeah.
They eat baby rabbits and mice.
Well, in the case of apex predators, I think when people say dangerous animals, they really are talking about just the power of the animal. And the black caiman have a lot of power. And it's almost just a way to celebrate the power of the animal.
Sure. And if it's in celebration, then I'm all for it because my God, is that power. Like the waves of fury that you saw. Like when that tail, I mean you saw the tail, the spectacle, that perfect, amazing thing with all those interlocking scales that works so it's like a perfect creation of engineering. And then when you have one that's this thick and all of a sudden that thing is moving with all the acceleration of that power. The volume of water, the sound that comes out of their throat. They're dragons.
We talked about the scales of the snake, but like the caiman, just the way it felt, was incredible. Just the armor, the texture of it was so cool. I don't know, like the bottom of the caiman had a certain kind of texture. And it just all feels like power, but also all feels like designed really well. It's like exploring through touch, like a World War II tank or something like that. Just the engineering that went into this thing.
Yeah.
That like the mechanism of evolution to create a thing that could survive for such a long time. It's just like incredible. This is a work of art. The defense mechanisms, the power of it, the damage you can do, how effective it is as a hunter, all of that. All you can feel that in just by touching it.
Do you ever see the mashup where they put side by side the image of, I think it's a falcon in flight next to a stealth bomber, and they're almost the exact same design. It's incredible. Like that.
What's the equivalent for a croc?
Like I said, maybe a tank. Like
Maybe a
down
tank.
more like an armadillo turtle.
Yeah. Like hippos.
Yeah, there may not be a war machine equivalent of a crocodile. You have to have like a big jaw element to it.
In the water, I mean, we talked also about hippos. Those are interesting creatures from all the way across the world. Just monsters. Hippos and rhinos. Hippos are bigger usually, or rhinos are bigger.
Rhinos is after elephants. Is the largest.
They can be terrifying too. Again, when you step into the defense.
Absolutely, but I have to tell you, after being around so many rhinos,
You have friends.
I have rhino friends.
Yeah.
Black and white rhinos.
Yep.
And they're all sweethearts. And I mean sweethearts. And I mean, when you look at a rhino, it's like a living dinosaur. I know it's a mammal, but somehow it screams dinosaur because it seems like Pleistocenic and from another age with the giant horn. And they're so much bigger than you think. Like they're minivan-sized animals. Like we're not taller than they are at the shoulder, and they have this strange-shaped head and a huge horn, and they sit there eating grass all day. So if a rhino is dangerous to a human, it's because the rhino is going, "Don't hurt me, don't hurt me, don't hurt my baby." And then they're like, "You know what? I'll just kill you with easier because you're scaring me. You're too close to that rhino." And so, like there again, I just think it's funny because humans were so quickly to go, "Which snakes are aggressive?" There are no aggressive snakes. Rhinos can be dangerous if provoked. Otherwise, they're peaceful, fat grass unicorns. Like they're really pretty calm. And we have these incredible giant animals, and the largest animals on our planet, the black caiman, the rhinos, the elephants, all the big, beautiful stuff is becoming less and less. And it almost reminds me, like in Game of Thrones, they're like, in the beginning, they're like, there used to be dragons. And it was like this memory. It's like, we used to have mammoths, and we used to have stellar sea cows that were 16 feet long, manatees, and there were things we used to have, the Caspian tiger, that only went extinct in the 90s, our lifetimes. And that's mind blowing to me. That has haunted me since I'm a child. I remember learning about extinction, and I went, "Wait, you're telling me that?" I remember being a kid, and by the time I grew up, you're saying that gorillas could be gone, elephants could be gone, and because we're doing it, and then I remember looking at the nightlight being blurry because I was crying. I was so upset, and it was Lonesome George, that turtle, the Galapagos tortoise, where there was one left, and they said, if we just had a female, he could live. And I, as a 6, 7, 8-year-old, that destroyed me.
We're all just trying to get laid, including that turtle
For a few hundred years.
So for young people out there, you think you're having trouble, think about that turtle.
Yeah. You know, there's a turtle that Darwin and Steve Irwin both owned?
Yeah, I heard about that turtle. And they live a long time. Yeah. They've seen things.
That there's a great internet joke where they're accusing him of being incongruous with modern times. So he did nothing to stop slavery. He didn't fight in World War II. Yeah, canceled the turtle.
Oh shit! What a world we live in. So it's interesting you mentioned black caiman and anacondas are both apex predators. So it seems like the reason they can exist in similar environments is because they feed on slightly different things. How is it possible for them to coexist? I read that anacondas can eat caiman, but not black caiman. How often do they come in conflict?
So anacondas and caiman occupy the exact same niche, and they're born at almost the exact same size. And unlike most species, they don't have sort of a size range that they're confined to. They start at this big. Baby caiman are this big. Baby anacondas are a little longer, but they're thinner and they don't have legs. So it's the same thing in terms of mass. And they're all in the streams or at the edges of lakes or swamps. And so the baby anacondas eat the baby caiman. Baby caiman can't really take down an anaconda. They're going for little insects and fish. They have quite a small mouth. So it's in their interest to hide from everything. A bird, a heron can eat a baby caiman, pop it back. So they have to survive. But the anaconda and the caiman kind of joust as they grow.
Can you actually explain how the anaconda would take down a caiman? Would it first use constriction and then eat it? What's the methodology?
Yeah, so anacondas have a kind of a 3-point constriction system where the first thing is anchor. So jiu-jitsu. So the first thing is latch onto you.
I like how I'm writing this down.
Yes.
Right? This is jiu-jitsu, master class.
This is for when you're wrestling an anaconda, just in case.
You'd be like the coach on the sidelines.
You got relax. Don't let him take the back.
Yeah.
All right. So one time, me and JJ were following a herd of collared peccary, and JJ's teaching me tracking. So we're following, the hoof prints through the mud, and we're doing this. And I'm talking about no backpacks, just machetes, bare feet, running through the jungle. And we come to this stream, and JJ's like, "I think we missed him. I think they went." And I'm like, "No, they went here. Look." And not because I'm a great tracker, because I can see, a few dozen footprints, hundreds of individual footprints right there. And we go, no, they just crossed here. And JJ was like, "You know what? We're not going to get eyes on him today." He was like, "It's okay." He's like, "You did good. We followed him for a long time." I was like, "Cool." And then I was trying to gauge, can I drink this stream? And I see a culpa. And a culpa is a salt deposit where animals come to feed, because sodium is a deficiency that most herbivores have here. And all of a sudden, I just hear the sound of a wet stick snapping, just that bone crunch. And I look down, and there's about a 16-foot anaconda wrapped around a freshly killed peccary, wild boar. And what this anaconda had done was, as all the pigs were going across the stream, the anaconda had grabbed it by the jaw, swiped the legs, wrapped around it, bent it in half, and then crushed it to ribs. And that's what the anaconda do, whether it's to mammals, to caiman, it's all the same thing. It's grab on. They have 6 rows of backwards facing teeth. So once they hit you, they're never going to come off. You actually have to go deeper in and then open before you get them out. All those backward facing teeth. So they have an incredible anchor system, and then they use their weight to pull you down to hell, to pull you down into that water, wrap around you, and then start breaking. And every breath you take, you're up against a barrier, And then when you exhale, they go a little tighter, and you're never going to get that space back. Your lungs are never going to expand again. And I know this because I've been in that crush before JJ pulled me out of it. And so this pig, the anaconda had gotten it, and as the pig was thrashing, the anaconda was wrapping around it, it bent it in half. And I just heard those vertebrae going. And so for a caiman, it's the same thing. They just grab and they wrap around it, and then they have to crush it until there's no response. They'll wait an hour. They'll wait a long time until there's no response from the animal. They'll overpower it. Then they'll reposition, probably yawn a little bit, should open their jaw, and then start forcing that entire. Now, here's the crazy thing, is that an anaconda has stomach acid capable of digesting an entire crocodile where nothing comes out the other side. And when you see how thick the bony plate of a crocodile's skull is, that can go in the mouth and nothing comes out the other side. That's insane. And so it always made me wonder on a chemistry level how you can have such incredible acid in the stomach that doesn't harm the anaconda itself. And someone said,
but it's able to digest. Oh, it's some kind of mucus. Oh,
like
the
mucus.
There's interesting. There's levels of protection from the anaconda itself. But it seems like the anaconda is such a simple system as an organism. Like that simplicity taken at scale, it could just do the swallow the caiman and digest it slowly.
I know, but my question was how on earth is it physically possible to have this hellish bile that can digest anything, even something as horrendous as a caiman, scales, bones, and all the hardest shit in nature, and then not hurt the snake itself? And I had a chemist explain to me that it's probably some sort of mucus system that lines the stomach and neutralizes the acid and keeps it floating in there. But my God, that must be powerful stuff.
So what does it feel like being crushed, choked, anaconda?
When an anaconda is wrapped around you, and you find yourself in the shocking realization that these could be your last moments breathing, you are confronted with the vast disparity in power. That there is so much power in these animals, so much crushing, deliberate, reptilian, ancient power that doesn't care. They're just trying to get you to stop. They just want you to stop ticking, and there's nothing you can do. And I find it very awe-inspiring when I encounter that kind of power. When even if it's that you see a dog run, you ever try to outrun a dog, and they just zip by you, and you go, wow, or you see a horse kick, and you go, if that hoof hit anyone's head, it'd knock them 3 states over. And it's like there is muscular power that is so far that, like you said, that explosive that we dream of doing. Imagine if like a Muay Thai kickboxer could harness that sort of caiman power, that smash. And so it's just awe-inspiring. I think it's really, really impressive what animals can do. And we're all the same sort of makeup for the most part. All the mammals, we all have our skeletons look so similar. We all have if you look at like a kangaroo's biceps and chest, it looks so much like a man's. And same thing goes for a bear, or you ever see a naked chimp. There's chimps with alopecia.
Oh shit!
And so
they're shredded.
It looks like a bodybuilder. Like it's got cuts and huge everything. It's got pecs, and they got that face that's just like, just let me in.
What? No.
Yeah. Where's your wallet?
Yeah, do something. But there's the specialization of a lifetime of doing damage to the world and using those muscles. It just makes you just that much more powerful than most humans, because humans, I guess, have more brain, so they get lazy. They start puzzle solving versus using the biceps directly.
Well, yes and no. And I have this question. Okay, so that whole "you are what you eat" thing. Now, we one time here had 2 chickens, and one of them was a wild chicken, like from the farm, had walked around its whole life finding insects, and the other chicken was like factory raised. And so we cut the heads off of both of them and started getting ready to cook them. Now, the factory raised chicken was like a much higher percentage of fat, had less muscle on its body, was softer tissue, a lighter color. The farm raised chicken had darker, more sinewy muscles, less fat, was clearly a better made machine. So my question is that what's happening with us? Like if you go see a Sherpa who's been walking his whole life and pulling, and walking behind musk oxes and lifting things up mountains and breathing clean air and not being in the city, versus someone that's just been chowing down at IHOP for 40 years and never getting off the couch. Like, I imagine it's the same thing, that you become what you eat.
Yeah, I mean, like you and I were like half dead running up a mountain. Meanwhile, there's a grandma just like walking. She's been walking that road, and she's just built different.
With her alpaca on her
Yeah,
shoulders.
with a baby. And they're just built different when you apply your body in a physical way your whole life.
Yeah, like you can't replicate that. Like just like that chimp has those from constantly moving through the canopy, constantly using those arms. Just like if you ever, you see an Olympic athlete or you hug Rogan,
Exactly.
you just go, why is there so much muscle here?
That's exactly what I feel like when you give him a hug. This is definitely a chimp of some sort. How does that just that the constriction of the anaconda, just the feeling of that? Are they doing that based on instinct, or is there some brain stuff going on? Like, is this just like a basic procedure that they're doing, and they just really don't give a damn? They're not like thinking, oh, well, this is this kind of species, we taste good, or is it just a mechanism to just start activating and you can't stop it?
With an anaconda, I really think it's the second one.
Yeah.
I do think that they're impressive and beautiful and incredibly arcane. I think they're a very simple system, very ancient system. And I think that once you hit predation mode, it's going down, no matter what. The stupid mosquito, I'm going like this, and every time he just flies around my hand, like I'm a big, slow giant, and he just goes around my hand, and then he goes back to the same spot. And I'm like, no, and he goes right back to the same spot. It's like he's just going, fuck you.
Now, here's the question. If the mosquito is stupid and you can't catch it, what does that make you?
Stupid. Dude, I flicked a wasp off me the other day. It flew back like 12 feet, and then in the air, corrected, and then flew back at my face.
Yeah.
It made so many calculations and corrections and decided to come back and let me know about it.
The wasp probably went back to the nest, said, guess what happened today?
This bitch ass kid from Brooklyn tried to flick me, and I showed him what's up. I had him running.
Yeah, you had a good chuckle on that one. Yeah, you actually mentioned to me, just on the topic of anacondas, that you've been participating in a lot of scientific work on the topic. It's like, really, in everything you've been doing here, you are celebrating the animals, you're respecting the animals, you're protecting the animals, but you're also excited about studying the animals and their environment. So you're actually a co-author on a paper, on a couple of papers. One of them is on anacondas and studying marine anaconda hunting patterns. What's that about?
So, the lead authors of that paper, Pat Champagne and Carter Payne, friends of mine, and what we started noticing for me began at that story I told you, where we were coming across the stream and we saw the anaconda had been positioned just below a culprit. And then other people began noticing that anacondas seem to always be beneath these culprits, where mammals were going to be coming. And that contrasted with what we knew about anacondas. What we understood about anacondas was that they're purely ambush predators and they don't pursue their prey. But what we began finding out here, and Pat led the process of amazing scientists who worked with Acadia University for a long time, worked with us for a long time, and he was one of the first to put a transmitter in an anaconda right around here, and we were able to see their movements. And that's what these papers are showing, is that they actually do pursue their prey. They do move up and down using the streams as corridors through the forest. They actually do pursue their prey. They actually do seek out food. So, I mean, think about it. It's a giant anaconda. Obviously, it can't just sit in one spot. It has to put some work into it. So they're using scent and they're using communication to use the stream. So you could be walking in the forest in a very shallow stream and see a sizable anaconda looking for it.
So in the shallow stream, it moves not just in the water, but in the sand.
Yeah.
So it also likes to burrow a little bit.
They burrow quite a bit. So these large snakes operate subterranean more than we think. Like there's times that you'll go with a tracker, you go with a telemetry set, and they'll say like we'll be over the snake. The snake's underground. The snake has found either a recess under the sides of the stream. You saw it last night, where all the fish have their holes under the side of the stream. There was a 6-foot dwarf caiman right in the stream, right where we were standing. He had his cave. He goes under there. They know. They have their system.
Yeah, we walked by it.
We walked by it. And he stuck his head out. We thought we had gone. And then we turned around. And I just got a glimpse of him because I was in the front of the line. And he just went right back into his cave. You guys are not going to touch me. And so, yeah, with the anacondas, it's been really exciting. And in 2014, JJ and me and Mosin and Pat and Lee, we ended up catching what at the time was the record for Eunectes marinus scientifically measured. It was 18 feet 6 inches, 220 pounds, one of the largest female anacondas on record. And since that time, these guys have been continuing to study the species, continuing to just add a little bit by little bit to the knowledge we have of the species, and studying green anacondas in lowland tropical rainforest. You've seen how hard it is to move, to operate, to navigate in this environment. And so when you think of the fact that in order to learn anything about this species, you have to spend vast amounts of time first locating them and then finding out a way to keep tabs on it. Because even if you get lucky enough to see an anaconda by the edge of a stream, to be able to observe it over time, to learn its habits, or to put a radio transmitter on it, or to take any sort of valuable information from the experience is almost impossible. And so a lot of the stuff that I wrote about in Mother of God, us jumping on anacondas and trying to catch them, and at first it just seemed like something we were doing to learn to just try and see them, but it ended up being that we were wildly trying to figure out methodology that would have scientific implications later on, because now it's allowing us to try and find the largest anacondas. And people used to say there's no way there's 25 foot, 27 foot. Well, there's just that video of the guy swimming with a 20-foot anaconda. And so now as we keep going, I'm going, well, maybe through drone identification, we could find where the largest anacondas are sitting on top of floating vegetation. And even then, how do we restrain them so that we could measure them and prove this to the world? It's sort of a side quest. But
so by doing these kinds of studies, you figure out how they move about the world, what motivates them in terms of when they hunt, where they hide in the world, as the size of the anaconda changes. So all of that, those are scientific studies.
Yeah, I mean, look, there's so much that we don't know about this forest. We don't know what medicines are in this forest. We don't know, with a lot of the 1,500, there's something like 4,000 species of butterflies in the Amazon rainforest, and of the 1,500 species that are here in this region, all have a larval stage, caterpillars, right? And each of the caterpillars has a specific host plant that they need to eat in order to become a successful butterfly to enter the next life cycle. And for most of the species that fill the butterfly book, we don't know what those interactions are. I recently got to see the white witch, which is a huge moth. It's one of the 2 largest moths in the world. It's the largest moth by wingspan. Wow, huge! It looks like a bird. Big white moth. We still, I believe that we still don't know what the caterpillar looks like. It's 2024. We have iPhones and penis-shaped rocket ships. We don't know where that moth starts its life.
Yeah,
we still haven't figured that out.
By the way, the rocket ships are shaped that way for efficiency purposes, not because they wanted to make it look like a penis. Speaking of which, I've ran across a lot of penis trees while exploring.
Have you?
And make me. I know it's not just a figment of my imagination. I'm pretty sure they're real. In fact, you explained it to me, and they make me very uncomfortable. There's just a lot of penises hanging off of a tree. Yes. I don't know what the purpose is. I don't know who they're supposed to attract. It certainly makes. But certainly, Paul really enjoys them.
Yeah. Well, clearly you've done some research. You've noticed a lot of them. I haven't even seen them.
There was a time where I almost fell, and to catch my balance, I had to grab one of the penises of the penis tree, and unforgettable. Anaconda, the biggest, baddest anaconda in the Amazon versus the biggest, baddest black caiman. As you mentioned, there's a race. If there's a fight, it's UFC in cage, who wins? Underwater.
The biggest and the baddest.
Biggest and the baddest. That you can imagine, given all the studies you've done of the 2 animals species.
So you're talking about an 18-foot, several hundred-pound black caiman versus a 26-foot, 350-pound anaconda. Yeah. I think it's a death stalemate. I think the caiman slams the anaconda, bites onto it. The anaconda wraps the caiman, and then they both thrash around until they both kill each other. Because I think the caiman will tear him up so bad,
And the caiman's not going to let go.
the caiman's never going to let go. But then he's gonna realize that he's also being constricted. So then he's going to stop. He's going to keep slamming down on that anaconda, and the anaconda's just going to keep constricting. But if the caiman can do enough damage before the end, it's almost like a striker versus a jiu-jitsu.
Yeah.
You know, if you can get enough elbows in before they lock you.
How fast is the constriction? So it's pretty slow.
It's incredibly quick. So you take the back and get me in chokehold. It's that. I have maybe 30 seconds, maybe on the upward side if you haven't cinched it under my throat. But if you've gotten good position, so
is there any way to unwrap the choke, undo the choke,
not unless you have outside help, unless you have another human or another 10 humans coming to unwrap the tail and help you. But for an animal, like if a deer gets hit by an animal, they don't stand a chance.
So the black caiman would bite somewhere close to the head, and then just try to hold on, a thrash.
Yeah, I don't think a large black caiman. Here's the thing. Every fisherman knows this. So like the biggest fish, they're smart, and more importantly, they're shrewd. They're careful. A huge black caiman that's 16 feet long isn't going to be messing with you. Like they won't cross paths, because while they technically occupy the same type of environment, that black caiman's going to have this deep spot in the lake, and that anaconda is going to have found this floating forest, like sort of black stream backwater where it's going to be, and they'll have made that their home for decades, and they'll already have cleaned out the competition. So maybe if there was a flood and they got pushed together, that they could have some sort of a showdown. But almost more certainly is that when they get to that size, that caiman, at any sign of danger, boom, right under the water. It's almost like, even if you, what do you learn when you're a black belt? You know, what do you do with a street fight? You still run away. There's no reason for a street fight. And I think the animals really understand that. There's no reason for this.
So like a giant anaconda and a giant black caiman, they could probably even coexist in the same environment, just using the wisdom to avoid the fight.
Or they would have a big showdown, and one of them would either die or have to leave. They would have a territorial dispute. Yeah.
Without killing either of them.
Yeah. On it, dude. Nature. Anything could happen. One of the things that me and Pat wrote up was that I saw a yellow-tailed creepo, which is like a 6-foot rat snake, eating an Oxyropus melanogenes, which is the red snake that we found last night. And just no one had ever, in scientific literature, we'd never seen a creepo eating an Oxyropus before. And so I had the observation in the field. I sent it to Pat Champagne. Pat writes it up. Hey. And so it's this really cool, that's a really cool system, because we're just out here all the time. You end up seeing things. JJ's dad saw an anaconda eating a tapir. Tapir is the size of a cow. Yeah. And that guy didn't lie. Some people, you trust your sources on that. He saw enough stuff. He didn't need to make up stories. You know what I love now is when you ask people, when we were going up the mountain with Jimmy, JJ said to him, he goes, have you ever seen a puma up here in the mountains? And Jimmy goes, they're up here. And JJ went, no, have you seen it? And Jimmy went, no, never seen it. And you know how most people will go, yeah, I've seen it. That makes me trust the person when they admit, nah, I haven't seen it.
They're up here. I haven't seen it. And Jimmy's been living there his whole life. There's pumas in the mountains.
Mountain lions, pumas, whatever there's all different names for them. They're distributed from Alaska down through Argentina. They're everywhere. It's an extremely successful species. From deserts to high mountains, everything.
I think you're saying pumas have a curiosity, have a way about them where they explore, follow people, just to kind of figure out just curiosity, versus as opposed to causing harm or hunting and that kind of stuff. What is this about?
I think it's based in predatory instincts, but I also think there is a playfulness to higher intelligence animals that you don't see in lower intelligence animals. And so something like a rabbit, for instance, you're never going to see a rabbit come in to check you out. You can't even think of it like that. Like a rabbit's just going to either eat or run away. There's really two settings. When you think of something like a giant river otter or a tyra, which is they call it manco here. It's a huge arboreal weasel. They'll come check you out. I woke up at my house the other day, and there was a tyra climbing up the side of the house, and he was looking down at me sleeping. And it's like, he came to check me out. Like, it's like they're smart enough and they're brave enough. Here's the important thing. They know that they can fend for themselves. They can fight, they can climb, they can run. And so they're like, I'm curious. I got time. Let me check this out.
Yeah, they're gathering information. I wonder how complex and sophisticated their world model is. Like how they're integrating all the information about the environment. Like where all the different trees are, where all the different nests of the different insects are, what the different creatures are, different by size, all that kind of stuff. I'm sure they don't have enough, storage up there to like keep all of that. But they probably keep the important stuff. So sort of integrate the experiences they have into like what is dangerous, what is tasty, all that kind of stuff.
I think it's more complex than we realized. You go back to that Friends to Wall book. Are we smart enough to know how smart animals are? There's so many incredible examples of controlled studies where the researchers weren't understanding how to shed being so insurmountably human and understand that there are other types of intelligence. And whether that's elephants or cats. So big cats, for instance, we just saw a camera trap video from last night where you see one of our workers walk down the trail and then 5 minutes later a cat behind him.
By the way, we're walking just exactly the same area, also exact the same time.
Yeah. So we're out there, and there's deer, there's cats, there's a jaguar, there's a puma, there's all these animals out there. And we're out in the night, in the inky black night, in this ocean of darkness beneath the trees, and we're just exploring and getting to see everything. And there's all these little eyes and heartbeats. I love the jungle at night, man. It's the most exciting thing.
One of the things you do when you turn off the headlamp, complete darkness all around you. And just the sounds.
Everything you hear, the cicadas, the birds, they're all screaming about sex.
Yeah.
All the time. So they're just trying to get laid. So all of them are making mating calls. Now the trick is to make your mating call without attracting a predator. But at night, what amazes me is that for us, it's so from the caveman logic of it's hard to make fire here. It's hard to even light a fire here. To having this incredible beam of it, all of a sudden we can look at the jungle and walk through that darkness. Then we're seeing the frogs on those leaves, the snakes moving through the undergrowth, and the deer sneaking through the shadows. It's almost as supernatural as skydiving. It's a strange thing to be able to do that technology allows us to do. We're doing something really complex. We're walking on trails that have been cleared for us, that we've planned out. And so walking through the jungle at night, you just get this freak show of biodiversity, and I'm addicted to it. I truly love it.
Except for the times over the last few days when we walked on the jungle without a trail. And that's just a different experience.
But how would you categorize if somebody said, Lex, I think I'm going to go for a hike through the jungle, not on the trail?
Yeah.
What would you tell them?
Every step is really hard work. Every step is a puzzle. Every step is full of possibility of hurting yourself in a multitude of ways. Just a wasp nest under a leaf, a hole under a leaf on the ground where if you step in it, you're going to break a knee, ankle, leg, and going to not be able to move for a long time. There's all kinds of ants that can hurt you a little or can hurt you a lot. Bullet ants. There's snakes and spiders. And my favorite that I've gotten to know intimately is different plants with different defensive mechanisms. One of which is just spikes. So sharp. I don't know if you brought it, but
I didn't bring it.
There's an epic club with spikes, but there's so many trees that have spikes on them. Sometimes they're obvious spikes, sometimes less than obvious spikes. And, it could be just an innocent, as you take a step through a dense jungle, it could be an innocent placing of a hand on that tree that could just completely transform your experience, your life, by penetrating your hand with like 20, 30, 40, 50 spikes and just changing everything. That's just a completely different experience than going on a trail where you're observer of the jungle versus the participant of it. And it truly is extreme hard work to take every single step.
Now, just think about this. I think scientifically, because people like to summarize, people like to get really, really sort of cavalier with our scientific progress. We've already explored the Amazon, have we? Because in between each tributary is, let's say just between some of them, let's just say 100 miles of unbroken forest. Who's explored that? Yeah. Maybe some of the tribes have been there. Maybe. Some areas they haven't been. Now, when you're talking about scientists, whether they're indigenous scientists, Western scientists, whatever, so many of the areas in this jungle that is the size of the continental U.S. still have not been accessed. And the places where people are doing research, see, I've been down here long enough. I see all the PhDs come down here and they all go to the same few research stations. They're safe. They have a bed. If you get hella dropped into the middle of the jungle in the deepest, most remote parts, you're going to find micro ecosystems. You're going to see little species variations. You're going to see a type of flower that JJ's never seen before, like what happened the other day. As you start walking through new patches of forest, you start finding new species, and everything here changes. You just go a little bit upriver, and the animals you see differ. You go on this side of the river versus on the north side of the river, there's two other species of primates there that don't exist here. That's in the mammal paper that we did with the emperor tamarins and the pygmy marmosets that the rangers found.
Yeah, the mammal paper is looking at the diversity of life in this one region of the Amazon. What kind of can you talk more about that paper? Mammal diversity along the Las Piedras River.
Once again, the mammal paper, Pat Champagne, the prodigy. He was sort of leading on this with a bunch of other scientists who have worked in the region, including Holly O'Donnell out of Oxford. Myself, I really just made a few observations. The Jungle Keepers Rangers got featured because they're the ones that spotted a pygmy marmoset that had previously been unrecorded on the river. I got to contribute because I had the only photograph that I believe anyone has of an emperor tamarin on this river. It's the first proof of emperor tamarin on this river, and that's exciting. It's exciting because you can post a picture or share a scientific observation or write about something, and then what happens is you get these like couch experts, these armchair experts who will come and say, no, you don't get blue and yellow macaws there. I can tell from my bird book, it says they're not there. And they'll tell you you're wrong. No, you don't get woolly monkeys there or emperor tamarins. But we have proof. And so we're coming together to try and add to that knowledge.
My general sort of amateur experience of the species I've encountered here is like, this should not exist. Whatever this is not real. This is CGI. Like what? Just the colors, the weirdness. Like there's, I think I called it the Paris Hilton caterpillar because it's like furry. It looks like one of those
Paris Hilton's dog.
Like it's like really furry and it's transparent and sort of it's transparent. All you see is this white, beautiful fur, and it's just this caterpillar. It doesn't look real.
Yeah.
Do you think there are species? How many species have we not discovered? And is there species that are like extremely badass that we haven't discovered yet?
If you look up how many trees are in the Amazon rainforest, it's something in the order of 400 billion trees. There's something like 70 to 80,000 species of plants, individual types of plants here, 1,500 species of trees. It's so vast that it's comparable. Like the scale is like only comparable to the universe in terms of stars and galaxies and for the sheer immensity of it. So we're describing new species every year. And just walking on the trail at night, you and I have seen, just a tiny little spider hidden in a crevice. Has the scientific eye ever seen that spider before? Has it been documented? Do we know anything about its life cycle? There's still so much that's here that is completely unknown. We have pictures of all these butterflies. Somebody went out with a butterfly net and caught these butterflies, took a picture of it, gave it a name, put it in a butterfly book. What do we know? What host plant do they use for their caterpillars? What's their geographical range? What do we actually know? Not that much. So are there creatures out here that haven't been described? Absolutely.
And some of them could be extremely effective predators in a niche environment.
Yeah, absolutely. I mean, certainly in the canopy, 50% of the life in a rainforest is in the canopy, and we've had very limited access to the canopy for all of history. You know, if you wanted to get up into the rainforest canopy, you basically have to climb a vine. Or with scientists, when I was a kid, I always used to see them with like the slingshots or the bow and arrows. They would shoot a piece of paracord over a branch, pull the rope up, and then do the ascension thing, and then you're up in this tree, getting swarmed by sweat bees, getting stung by wasps. You're trying to do science up there in that environment. It's incredibly hostile, and so I actually met a guy at a French film festival who had used hot air balloons to float over the canopy of the Amazon and then lay these big nets over the broccoli of the trees. And the nets were dense enough that humans could walk on the nets and then reach through and pull cactuses and lizards and snakes, whatever, just take specimens from the canopy. That's how difficult it is that scientists have resorted to using hot air balloons. And so having treehouse, having canopy platforms, it's starting to be more and more access to the rainforest canopy. And so we're beginning to log more data. We've even observed in our treehouse, which is supposed to be the tallest in the world, we're seeing lizards that we don't see on the ground, lizards that have never been documented on this river. Like we're seeing snakes where they're saying we saw the snake inside a crevice on that tree in the stranglefoot. We don't know what it is. It's just people haven't been up there.
And that's where a lot of the monkeys are. That's where there's just a lot of dynamic life up there.
Yeah. I mean, when you wake up in the canopy in the morning in the Amazon rainforest, as soon as the darkness lifts, as soon as that purple comes in the east in the morning, the howler monkeys start up. And then the parrots start up. And then the tinamous start going, and the macaws start going. And pretty soon everybody's going. And the spider monkey groups are all calling to each other. And it's just the whole dawn chorus starts, and it's so exciting.
So what you're saying when they're screaming is usually about sex?
Sex or territory, usually.
Sex and violence. Or implied violence, or the threat of violence.
Yeah. I mean, howler monkeys in the morning, they're letting other groups know this is where we're at. We're going to be foraging over here. You better stay away. So it's a little bit respectful as well. There's order in the chaos.
So just speaking of screaming, macaws are like these beautiful creatures. They're lifelong partners. They stick together. So you often see just they're monogamous. So you see two of them together. But when they communicate, their love language seems to be very loud screaming.
Yeah.
What do you learn about relationships from macaws?
That it can be loud and rough and still be loving.
And still be loving. But is that interesting to you that there's like monogamy in some species that they're lifelong partners, and then there's like total lack of monogamy in other species?
It's all interesting. I mean, there's the anti-monogamy crew who's like, we were never meant to be monogamous. We're supposed to just be animals. And then there's the other side of the crew that's like, we were meant to be monogamous. We are monogamous creatures. That's what God wanted between a man and a woman. And then other people are like, yeah, but I know about these two gay penguins, and so that's natural too. And so then everyone tries to draw their identity. They're trying to justify their identity off of the laws of nature. So the fact that macaws are monogamous really doesn't have anything to do with anybody except for that it's beneficial for them to work together to raise chicks. It's difficult. They rely on ironwood trees or aguaje palms, and it's difficult to find the right hole in a tree. There's only so much macaw real estate, so they need to use those holes. And each one of those ancient trees, it's usually 500 years or more, is a valuable macaw generating site in the forest. And so if those trees go down, you lose exponential amounts of macaws, and that's how you get endangered species. And so that's why we're trying to protect the ironwood trees.
Another ridiculous question. Tell me, if every jungle creature was the same size, who would be the new apex predator, the new alpha at the top of the food chain?
Dude, that's like Super Smash Brothers of the jungle. That's incredible.
Yeah.
Like bullet ants. If you had a bullet ant that was the size,
can it be like a tournament?
So everyone is pound for pound ratioed.
Yeah.
For efficiency. So you have basically like a 6-foot bullet ant versus a huge black caiman versus an anaconda versus ocelots are the size of jaguars versus.
Yeah. Well, let's go bullet ant versus black caiman.
But they're comparable
same size.
I don't know, man. I never thought about it. I mean, bullet ant has these giant giant mandibles. It could probably grab the black caiman, and then at that amount of venom, you're talking about a bucket of venom going into that black caiman. Black caiman's going to be paralyzed immediately.
Well, insects have just a tremendous amount of like strength. I don't know how they generate with the geometry that is. The natural world can't create that same kind of power in the bigger thing. It seems like ants and like just these tiny creatures are the ones that are able to have that much strength. So I don't know how that works. What the physics of that
like
is.
a leafcutter ant lifting that leaf, that doesn't make any sense.
Yeah. Doesn't make any sense. I don't know if that's the limit of physics. I think it's just the limit of evolution, how that works.
One of the most interesting limits that I heard somebody talking about recently was the reason that dinosaurs didn't get bigger, even bigger, because it's the conditions on Earth were favorable towards it, was that at some point their eggs reached this physical limits, that their eggs reached a size that the eggs were so big that eggs need to breathe for the embryo to survive, and their eggs reached a limit where in order to have a shell that could hold the mass of the liquid and the young dinosaur, if they got bigger, it wouldn't be permeable anymore. Mm-hmm. And I thought that was so interesting because the entire size of physical creatures was determined by how thick shell can be before it breaks or before it can't pass air through it.
Yeah, there might be a lot of the biophysics limits.
Fascinating stuff.
Just like the interplay between biology, chemistry, and physics of a life form. It's like this thing. There's a lot involved in creating a single living organism that could survive in this world. And bigger, being big is not always good. Being a big creature is for many reasons. Like you were saying, big creatures seem to be going extinct for many reasons. But in the human world, it's because they seem to be of higher value.
Given the current size of the jungle, I think that the MVP, the pound for pound goat, is ocelots. You're talking about mid-size, 40, 50 pound cat that can climb, that does, unlike a jaguar, every time it hunts, it's going after a deer. It catches a deer, the deer can hit it with its antlers, it can tear it with its hooves. It's risking its life for that meal. Ocelots walk around at night, and they climb a tree, eat a whole bunch of eggs, eat the mother bird too, kill a snake, maybe mess around and eat a baby caiman. They can have whatever they like. And they're sleek enough and smart enough to get away from predators. They don't really have predators. And so they sort of occupy this perfect niche where they can hunt small prey in high quantity without taking on big risks. And so if you had to choose an animal to be, it would probably be like an ocelot, or I would say giant river otters, which are so damn cool because the locals call them lobos de rio, river wolves, because they're so tough and they're so social and they're so like us because they're intensely familial groups. They live in holes by the sides of lakes and swim through the water and they catch fish all day long, piranhas. They eat them just like the scales go flying as they eat these piranhas. And they're so joyous in the way they swim and they have friends and they have family and I think we could relate to being a river otter really, because I can't picture being a cat and being so solitary and just marching along a 15-mile route and making sure there's no other cats and coming in on your territory and marking that territory. It seems very solo and very cat-like.
It's a lonely existence. And we humans are social.
We're so social. So to me, river otters is like having a big Italian family. Constantly eating, you're freaking out, you're just like causing problems with the black caiman.
Goes down the black caiman.
Starts street fights.
Yeah, it's a family thing. You mentioned piranhas.
Yeah.
What do you think? They're a source of a lot of fear for people. What do you find beautiful and fascinating about these creatures? They're also kind of social, or at least they hunt and operate in groups.
Yeah, not in the mammalian way though. Piranhas are in large schools, but fish are so different. Like if I could talk to you all day about how much I'd love to be an otter. Also, going back to the fighting thing, otters and weasels, muscelidae, tend to be very loose in their skin. So if you grab an otter, it can still rotate around to bite you. So it's like if I grab you by the back, you're stuck. We can't. You grab them by the skin.
Yeah,
they can rotate around and just shred you apart. So they're really cool fighters. Piranha fish. I don't identify with fish in terms like that. I think living out here has made me think of fish as kind of rapid food that can or can't be gotten. So to me, a piranha is when I see a piranha, I think about how I want it to taste.
Yeah. So like a fish is is a food source of so many creatures in the jungle. So they're primarily food source. But piranhas are, I mean, they're predators. They're serious predators.
They are serious predators. I found a baby black caiman not that long ago, and he was missing all of his toes because the piranhas had eaten them off. It was really sad. He just had these stumps and he was swimming around the water, and I was like, you are not going to make it. He was like 8 inches, and he was such a cute little puppy. He had those big eyes. And I was just like, man, you already are missing all your toes. So it's like, it's just a matter of time. Now he can't get away, so some big agami heron's going to come and just nail him, pop him down his throat. That's the end of that for the caiman. Nature, sure, shit is metal.
Bite off a little bit, and then makes you vulnerable, and then that vulnerability is exploited by some other species, and then that's it. That's the end.
Yeah, but humans are brutal too. Like that story we heard about that guy the other day who caught a stingray on a fishing hook, chopped its tail off to make it safe for humans, cut a piece of the stingray off so he could use it for bait, and then threw the live fish back in the river. To me, that is incomprehensible amounts of cruelty with flawed logic in every direction. Like, if you're gonna use the thing as bait, use bait. If you're gonna remove its tail, well, then just kill it all. If you want to save the animal and not kill it, then don't maim it before you return it to it. It was such a weird.
So if you kill an animal, you want to use it to its fullest by using it as a food source, by cooking it, by eating every part of it, all that kind of stuff.
Yeah. So we've been eating Paco in your time here.
Fried Paco, it's great.
Fried Paco. It's delicious. Full of nutrients. You can tell it makes you healthy. I feel like we have better workouts so that we can go harder in the jungle. And so a few months ago, in August, when the river was down, there was a day that the river was clear. And a friend of mine, Victor, who's married to a native girl, he said, it's time to go Paco fishing. And at the time, we were stuck out here and we had no resupply. Everybody was busy. So everyone was demoralized. The staff was hungry. We were hungry. And it really became this thing of like, hey, go catch us some Paco. They were working on the trails. They were installing the solar. We were working hard. We didn't have food. And so we went out to the river. And what we did was we went upriver, camped on the beach. And in the morning, Victor's wife was canoeing with the paddle, dead quiet. Don't let the paddle touch the wooden boat. And Keith was balanced in the middle of the thing. Victor's on the front with this huge fishing rod. And I'm sitting there, and he goes, I'll catch the first one, you catch the second one. He's got this huge fishing rod and a piece of half-rotten meat from the day before. He's smacking it against the wall, 6 a.m. He's just like, smack against the water. And I'm going, and we're floating down the river. And I'm going, this is not going to work. And we're floating, and a half hour passes, and I'm going, it's dawn. I want to go back to sleep. I'm just not a morning person. And all of a sudden, a fish hits that line, almost pulls this man off of his feet. And he swings the thing in. The fish comes on the boat, and then I realize he's got a big metal mallet on the boat so that you could try to shut that fish off. And it's this huge oar-shaped, thick, muscular Paco. And as soon as I saw that fish, I just thought, wow, the strongest of this species for millions of years have been swimming in this river. And suddenly through this incredible combination of the boat and the cord and the hook, none of which we made, and the skill that he had from knowing how to fish a Paco. Because otherwise, there's no chance that you're getting that fish. They hide. They're very, very suspicious of what you're doing. We had gotten this fish onto the boat. Boom, you hammer it like a caveman. Boom, doesn't die. Boom, you have to crush its skull. And now you have this fish, and you're holding this genetic material, this sustenance for your life that has been developing since the dinosaur times. It's so beautiful, the sacred act of eating that, of the fish, of the competition with the fish. And we spent the morning fishing. We got 3 Pacos, 3 huge, giant vegetarian piranha. And I just remember touching them with so much reverence, thinking about the incredible history and how that before these rivers existed, those Pacos were swimming through the water and trying to survive through history until we took just a few. And we did it respectfully, and we did it when we needed it most, not at a time when it was just for fun, and it was really, really special.
Well, humans using them for sustenance, there's a collaboration there. That's something also that's seen in the jungle, that there's creatures using each other, and it's like a dance of either mutually using each other, or it's parasitic or symbiotic. It's interesting. Like there's a medicinal plant you grabbed that was full of ants that were like trying to murder you by biting, but they were defending the plant they were using for whatever purpose. There's a clear dance there. The ants using the plant and the plant existing there for other applications and other use for humans, and there's that kind of circle of life happening. But the ants were a defense mechanism. So the plant didn't have its own defense mechanism. The ants, the army of ants, was there to protect the plant.
And did you actually, when you remember we put our backpacks down at that one spot and it was like the ants got on your backpack and I said, oh shit, this is that tree. Did you actually get bitten by one of those? Because they're incredibly painful. The Tangarana one. They like.
Yeah, surprisingly painful. Because they're small. They're just nothing like. Luckily, have not been bitten by a bullet ant yet.
But it's amazing because they live inside the tree. The tree comes standard with holes in it that allow the ants to move and to exist safe, and it protects their eggs, and they protect the tree. And so we saw that spot where there was a perfect circle around the trees because the ants had excavated the other vegetation so that those trees could have no competition to grow. The incredible calculation of how ants know to come programs to garden that tree, and the tree somehow has been genetically informed to have ant habitat within itself. It's mind-blowing, and it actually is the foundation of a lot of existential confusion for me, because how the hell is this possible?
Yeah, well, one of the things you mentioned that's also a source of a lot of existential confusion for me is ants and the intelligence of different creatures in the forest. There's these giant colonies, there's just giant systems. And even just looking at a single colony of ants and collaborating leafcutter ants is an incredible system. So individually, the ants seem kind of dumb and simplistic, but taken together, there is a vast intelligence operating that's able to be robust and resilient in any kind of conditions, is able to figure out a new environment, is able to be resilient to any kinds of attacks and all that kind of stuff. What do you find beautiful about them?
Like, as you said, just leafcutter ants in this jungle. That's forgetting all the other hundreds of species of ants that are in this jungle. But just the leafcutters apparently digest roughly 17% of the total biomass of the forest. Everything, all these giant trees, all that leaf litter, 17% of that, almost a fifth of this forest cycles through leafcutter ant colonies. So they're constantly regenerating the forest. They're a huge source of the driver of this ecosystem. And so to me, when you see them working, it's, again, like I said, you see friends as you go through the jungle. You see all the K-pop trees, the Kinea tree. So there's leafcutter ants doing what they're supposed to do, and it's just so beautiful. I find them very beautiful. Army ants, they're so tough. They're so ready to fight. They have these huge mandibles. They're just ready to. They're transporting their eggs. They're moving from here to there. Anything that's in the way is getting eaten. They're just savage. And they're kind of cute for that, unless you're tied to a tree.
The savagery is cute.
I find that, it's kind of reassuring. You know, you want certain things to be tough. That's their part.
Oh, that everybody plays a part in the entirety of the nature mechanism. Yeah,
the powerful play. But But the army ants are so savage. You know, like if you step on army ants, they will all kamikaze, just attack onto your feet, and they'll just sacrifice their own life for the good of the thing, and they'll be trying to kill your shoes. And there's something funny about that to me. There's something like kind of reassuring. Again, unless imagine if you're going through the jungle and you slip and you fall and you twist your knee and you fall in just the right way, but you can't get up. You can't. You're stuck there. And then army ants find you. They will take you apart. There are records of horses that have been tied up, and army ants come, and they'll take out the whole horse.
Imagine the pain of that.
It might be raining on us very hard very soon.
You want to pause?
Nope. I think we'll stay here until the ship goes down.
We should mention that there's this one source of light, and we're shrouded in darkness.
And now the night shift is going to take over soon. We are in the Amazon rainforest.
What does the rainforest represent to you? When you zoom out, look at the entirety of it.
Carl Sagan's pale blue dot resonated with a lot of people. That everything you've ever heard of, all the heroes, all the villains, all of your ancestors, every achievement, tragedy, triumph, everything has happened on that one spot. This one tiny, tiny little rock that has life on it. And to me, the rainforests represent the crown jewel of that. As far as we know, and to the best of our knowledge, and with our shrewd scientific brains at their fullest capacity, this is still the only place that we know that has life. And given that, the fact that there are still these tropical, towering, complex ecosystems that we are barely understand, crawling and full of the most incredible life. It's just, to me, it's so wonderful. It's so incredible. Those the waterfalls and the birds and the macaws and the jaguars. It's barely believable. Like if you were to theoretically tell a hypothetical alien that I live on this planet, and there's just these places where everything is interconnected. Everything means something to something else, and the whole thing is this system that keeps us alive. And each tree is pumping air into the river. And there's an invisible river above the actual river, and the whole thing goes into stabilizing our global climate. And each little tiny leafcutter ant somehow contributes to this giant biotic orchestra that keeps us alive and makes our environment possible. That is beautiful. I love that. And so the rainforests to me are the greatest celebration of life, and probably the greatest challenge for us as a global society, because if we can't protect the crown jewel, the best thing, the most beautiful part, then we're really, really missing the point.
Yeah, the diversity of organisms here is the biggest celebration of life. That is at the core of what makes Earth a really special thing. That said, you and I have been arguing about aliens pretty much the day I showed up. All right, so you brought a machete to this fight. Luckily, the table is long enough.
I can't reach it.
You can't reach me. So, to you, Earth is truly special.
Yeah.
You don't think there's other Earths out there, millions of other Earths in our galaxy. When you look up, we were sitting in the Amazon. The storm rolled over.
Yeah.
And you started counting the stars.
Yeah.
1, 2. And that was, once you can count the stars, that was a sign that the storm will actually pass. Eventually pass, and that's what you're doing. 3, 4, 5, and it's going to pass. You're not going to have to sit in that river for like all night. So just a couple hours to keep yourself warm. Okay. Each of those stars, there's Earth-like planets around them.
Okay.
Why do you think there are not alien civilizations there?
You can write down a calculation on a napkin. You can cite different Hollywood movies. You can point up to the pieces of light in the stars. But if I talk about show me a single cell that's not from this planet, it's still not possible. So I agree with you. The likelihood is there. All indications point to it. It would be fascinating, especially if it was done in, imagine finding a planet of alternative life forms, not necessarily even intelligent. Imagine just a planet of butterflies, whatever, or something else. That would be amazing. But I'm concerned with the reality that we have in front of us is that this is the spaceship. This is life.
Yeah.
And so right now, given that reality, maybe that's the case. Maybe there are other planets. Or maybe we are the first. Maybe life originated here. Maybe God, the universe, whatever. Maybe this is it. This is the testing ground for something bigger, and this complexity and this diversity of life and this life that we have is that important. And I think that part of what we do when we go, oh yeah, but there's other planets, where first of all we're taking an assumption into reality without, aliens right now are about as real as Santa Claus. We think they're out there, but we're not sure. A little more real because, it makes sense. No one has an alien. No one's seen an alien. No one's even seen cellular life. And so I'm not, again, if they showed up tomorrow, great, let's study them. But right now, we have this very simple threat going on where we can't stop killing each other and our living environment. And so while some people can specialize in looking to the stars and to other planets and talk about being an interplanetary species, I'm very much concerned with the fact that here in our home turf, our living environment, where the air is good and the rivers are clean and The trees are big, and there's macaws flying through the sky, and salmon in the rivers. Not only do we have a responsibility to each other and to our children to protect this incredible gift that is our entire reality. It seems kind of weird to, at some point, conservation seems kind of ridiculous. Like you're begging people to not pollute the things that keep them alive. It's almost kind of silly at a point. But we have this incredible thing where there are fish in the ocean and in the rivers that come standard with life on Earth, and we're harming the ability of Earth's ecosystems to provide for that life. And we are the generation that's going to decide if those systems continue to provide life to all the people on Earth and all the generations. And by the way, all the other animals that exist for their own reasons, other consciousnesses that we're just beginning to understand, elephants, humpback whales, whatever, families of giant river otters. Not everything can be seen from a human perspective. These are other species that have their own stories. And so I'm more biocentric than anthropocentric in that I think that nature is important, but I also believe that we are special. We are the most intelligent animal.
So one, I agree with. There's some degree to which when you imagine aliens, you forget for a moment how special and important life is here on Earth. Yes. But it's also a way to reach out through curiosity and trying to understand what is intelligence, what is consciousness, what is exactly the thing that makes life on Earth special. Another way of doing that, and I see the jungle in that same way, is basically treating the animals all around us, the life forms all around us, as kinds of aliens. As that's a humbling way, that's an intellectual humility with which to approach the study of like, what the hell is going on here? This is truly incredible. Are the animals we've met over the last few days conscious? What is the nature of their intelligence? What is the nature of their consciousness? What motivates them? Are they individual creatures, or are they actually part of a large system? And how large is the system? Is Earth one big system, and humans are just little fingertips of that system? Or are each of the individual animals really the key actors, and everything else is in the emerging complexity of the system? So I think thinking about aliens is a necessary. I like my town with a little drop of poison from Tom Waits. Is a necessary perturbation of the system of our thinking to sort of say, hey, we don't know what the fuck's going on around here. Sure. And aliens is a nice way to say, okay, the mystery all around us is immense. Because to me, likely, aliens are living among us. Not in the trivial sense, little green men, but the force that created life, I think, permeates the entirety of the universe. That there is a force that's creative.
Now, the force that created life is a big one. And then the other thing is, what do you mean by that? There's aliens living among us. You mean extraterrestrials
Yes.
living among us?
Yes.
You believe that?
Not like 100%, but there's a good percentage. I don't understand how it's possible for there not to be a very large number of alien civilization throughout just our galaxy.
But that's different than saying they're living among us. If you tell me that there's aliens living 5 galaxies over, and they're just out there somewhere, I'm kind of more on your side than that they're here. Because just like Bigfoot, like we have camera traps, we have DNA sequencing through water now. Like we can. You're telling me no one found one wing nut of a ship in all, like the Egyptians up until right now? No one in Russia saw like a crashed ship, took a picture, tweeted that shit real quick, and
I think there's no Bigfoot, there's no trivial manifestations of aliens. I think if they're here in ways that are not comprehensible by humans, because they're far more advanced than humans. They're far more advanced than any life forms on Earth. So they're, even if it's just their probes, we cannot just even comprehend it. I think it's possible that They operate in the space of ideas, for example. That ideas could be aliens. Feelings could be aliens. Consciousness itself could be alien. So we can't restrict our understanding of what is a life form to a thing that is a biological creature that operates via natural selection on this particular planet. It could be much, much, much more sophisticated. It could be in a space of computation, for example. As we in the 21st century are developing increasingly sophisticated computational systems with artificial intelligence, it could be operating on some other level that we can't even imagine. It could be operating on a level of physics that we have not even begun to understand. We barely understand quantum mechanics. We use it. Quantum mechanics is a way we use to make very accurate predictions, but to understand why it's operating that way, we don't. And there's so many gigantic, powerful cosmic entities out there that we detect. Sometimes can't detect dark matter, dark energy, but it's out there. We know it exists, but we can't explain why and what the fuck it is. We give it names, black holes and dark energy and dark matter, but those are all names for things that mathematical equations predict, but we don't understand. And so all of that is just to say that aliens could be here in ways that are, for now and maybe for a long time, going to be impossible for humans to understand.
So aliens in the strict biological sense, like horseshoe crabs, we agree that they're not. We haven't found physical aliens.
The only way I can imagine finding physical aliens is if alien species are trying to communicate with us humans or with other life forms, and are trying to figure out a way to communicate with us such that we dumb humans would understand. Like, let's create a thing.
Yo, there's a moth the size of a small eagle.
Let's try to get us 15 minutes of attention.
It just might.
Big fan of the podcast.
Okay. Lex, I love you. All right, so wouldn't it be interesting? It would be really fascinating to me if we found out that there were aliens living among us and we couldn't see them. And what some of the people were calling aliens, the scientists, the religious people were calling angels, and then everybody had this realization that whether you call them aliens or angels, there are these there is way more to the universe than we're realizing. For me, the fact that there's
a skull on the table.
There's a skull on the
There's not a
table.
skull in your hand.
There's now a skull in my hand of a monkey with a bullet in its head that I found on the floor of an indigenous community where they eat monkeys. I didn't kill the monkey, so save your comments. But in terms of the animals, I think that when I see space, my feeling, and I'm not requiring anybody else to have this feeling, but because it's the only place that we know that there's life, we have no idea how it started. I just think it's so important to protect it, and for me, it's just as much about our children as it is about the little spider monkeys and the little baby caiman that are in the river right now, because life is so beautiful. And I think that there's a huge amount of intellectual responsibility that we can transfer off of ourselves if we go, yeah, the rivers are filled with trash, and yeah, extinction is happening, but we have to be an interplanetary species anyway, because at any moment, this could all end from an asteroid, and everything's going to shit anyway, and so it's we're fucking up this planet. It's we're just being angry teenagers who are, going goth for a while, and it's what if you just rolled up your sleeves and said, holy shit, wait a second. We can pretty much do whatever we want. We can fly all over the world. We can do heart transplants. We can watch Netflix and the Amazon if we wanted to. We can do all this amazing stuff. We can capture on video our adventures and go back and watch them again and again and again. There's so much incredible opportunity that technology has allowed us to do, and we're the richest in history. We can do everything. We could cross the whole planet in a second. It's that's an amazing time to be alive. And if we just don't fuck up the ecosystems and kill all the other animals.
Yeah, so it is true that we can destroy ourselves with nuclear weapons, but it also is true that snake that I got to handle yesterday is one of the most beautiful things Earth has ever created. In that little organism that is encapsulated the entire history of Earth, and it's beautiful. So both things are true. We should worry about the existential destruction of human civilization through the weapons we create, and we should become a multiplanetary species as a backup for that purpose. But also remember, this place is really, really special and probably, if not difficult, probably impossible to recreate elsewhere. And by the way, there's something incredibly powerful about a skull.
Yeah. If you ever hold a human skull, it'll give you, it'll weigh on you for a second. You look into the hollow eyes of this face, and suddenly you feel your own cheek. You feel your own skull, and you go, holy shit. You go, what is going on? It's like taking acid. I forgot that I'm a ghost inhabiting a meat vehicle on a floating rock.
But even a monkey, it's like looking at a ancestor. You know, not a direct ancestor, but it's like like you're looking at a puddle at a reflection.
A little blurry, but
it's a little blurry, but it's still there.
Yeah.
It's still there, and like the roots of who we are is still there. And it's all kind of incredible. Do you ever think of the tree of life, just kind of like where we came from? Yeah. The jungle is ephemeral. It just keeps, it's a system that just keeps forgetting because it's just churning and churning and churning and churning. It has, in some ways, no history. But to create the jungle, to create life on Earth, there's a deep history of lots of death, sex and death, festival of sex and death, life on Earth. That's what I see in the skull.
Yeah. There's something kind of terrifying about that image to me. Like when I hold that skull, every now and then at night, you hold that skull, and it just reminds you that you're temporary.
Yeah, both you and I will one day have one of those. Yeah. Mine would be bigger. The male competition continues.
The silverback slaps the lesser male once again.
Do you have a lighter?
Yeah, bro. You want to light this blunt?
Yeah. What are your favorite animals to interact with?
I mean, my absolute favorite animal to interact with is 100% elephants, which there's no elephants here, but I've been incredibly privileged to spend some time with elephants, both in India and in Africa, and I think that they're so smart and so complex that we do a really bad job of understanding what an elephant really is. I think that most children probably think of elephants as like something kind of cuddly. Most adults probably have a similar misconception of them. When you see an elephant, you see a 12-foot tall bull elephant with bone coming out of its face, with huge tusks, and those giant, it's an octopus-faced, butterfly-eared behemoth that's a survival machine. And they'll look at you and just go, do I have to kill you to keep safe? And it's just, they're so tough. And they have dirt on their back, and they have flower petals, and their little hair, you realize they have hair all over their body, and the power to throw a car over, flip it. Just one of the most impressive animals on Earth. And I think that I've gotten really good at interacting with wild elephants in a way that's respectful to them. And I think that when an elephant allows you to be in its space, it's because you're showing submissiveness and respect for the elephant space. And they're so intelligent that they're communicating with seismic vibrations through the earth, that they have a matriarchal society, that they can remember the maps of their ancestors, and they know how to find water, that they can solve problems. They're such beautiful animals. And talk about aliens. They're so alien looking. These big, weird heads and the trunks with all those muscles, and they're so different than us. But yet, I actually think that we grew up together. You know, they kind of raised us, sibling species, that we've inhabited the same epoch in history. And we've relied on the ecosystems that they've created. And I think that they have a deep understanding of humans, elephants. And I think I see them more like aliens, more like non-human beings that we share the earth with. So I don't see it as we're humans and they're animals. I actually see elephants as sort of a separate society, along with humans as one of the dominant species on the planet.
So almost every species, especially the intelligent ones, especially the big ones, have their own societies that overlap and sometimes co-develop.
Yeah, I think whales, I think elephants, I think there's those higher, no one's suggesting that sardines are, somehow need human rights or something, but I think that elephants need representation in governments because they influence their landscape, they engineer their environment, they have emotions, they have families, they have burial rituals, they're so like us. And yet we treat them like they're just oversized cows that we have to be scared of. They're not the same as domesticated livestock. They're one of the treasures of Earth. I mean, look, let's just say little green men showed up, and they said, well, what's Earth? It's like, well, there's mountains, there's rivers. It's like, well, how do I do this? There's mountains, rivers, there's elephants. Like, it's like one of the first things a baby learns is elephant, even if he's never seen one. It's just so iconic on Earth. Like you said,
Darren Aronofsky.
The elephant walking over the camera. I haven't seen it. You said it's incredible.
Yeah. So at the Sphere, the postcard from Earth, I mean, it's a celebration of Earth.
Yeah.
In all forms, and one of the critical big creatures in that film is an elephant, and it steps over the audience, and the whole sphere reverberates that power. I mean, some of it is size.
Yeah.
Some of it is like, how did Earth create this? It is a weird looking creature, but we take it for granted because we've accepted that this Earth can't create this kind of thing. But it's weird, beautifully weird.
I mean, elephants. There's something really impressive and wise about them. There's also beautiful weird that doesn't come with so much grandeur. Like, to me, a giraffe is beautifully weird.
Yeah.
But they're just, they're 18-foot tall camel deer things with, giant necks, and they're strange, and they're absolutely serenely beautiful, but they don't have that deep intelligence that elephants have. There's something that elephants have.
You see it in their eyes. How does the intelligence manifest itself?
Well, this is the thing. When I was reading Franz de Waal's book, a lot of what he was saying was that, people give elephants human problems to solve in controlled environments and call it, a study on elephant intelligence. Whereas if you're watching wild elephants and you're in the wild, you're going to be watching them in a way that they're looking. You've pulled up in a safari vehicle or you've pulled over to the side of the road, and the elephants are wary of you, so they're not acting natural. As soon as you start watching wild elephants, truly in the wild, comfortable with your presence, you see how they start caring for their babies, or how they can get annoyed. I once watched elephants around a waterhole, and there's this warthog, and I don't know why, but this warthog decided he needed to get in, and there's this young male elephant, and he kept turning around to this warthog and just being like, don't make me do it. Now, this elephant did not need to hurt the warthog, and the warthog was just, I need a drink, much simpler brain. The elephant was like, you could just tell, he was like, watch this, and he just went, and crushed the warthog like it was a big beetle, and crushed his pelvis, and the warthog dragged itself away on his front legs and probably went off to die. But this young elephant put out his ears, and he paraded around with his tail up, and he was like, look what I did, destruction. And it's like, that's a very relatable type of, he was annoyed with the warthog. And so you see them do these things. I mean, the most magical thing, and I've spoken about this many times, was that I was walking with a herd of semi-wild elephants that were crossing through a village in India, because elephants have lost a lot of their territory because there's so much population in India. And so we're crossing through a village which is very delicate because the matriarchs are leading the babies, and there's villagers who have no idea what an elephant is, and they're watching elephants crossing. And the matriarchs backed this girl up against the wall, and she was terrified, standing there with her back against the wall. And the elephant just put her trunk out and touched the girl's stomach, and then the other elephants came, and they all started touching her stomach. And the ranger there explained to me, she's pregnant. They know she's pregnant. They can smell it. They can tell, and they're curious. And all the female elephants came to investigate the pregnant girl, and she had no idea what was going on. So it's like that stuff. Whoa.
And it's cool to hear that, with the crushing and the pride of the young elephant, that there's a complexity of behavior, just like with humans. I mean,
Yeah, it's not
humans,
always pretty.
that's the thing, man. Humans are capable of good and evil, and sometimes we attach these words. I love that there's just an orchestra of different sounds. And that one is sexy, which,
That's a bamboo rat calling out for me.
okay, all right.
Good luck.
Lucky, buddy.
Good hunting.
Humans are capable of evil things and beautiful things, and I wonder if animals are the same. You think there's just different personalities and different life trajectories for animals, like as they develop in their understanding of social interaction, of survival, maybe even primitive concepts of right and wrong within the social system. Do you think there's a lot of diversity in personalities and behavior? Just like different people, is there different elephants?
Of course. And what I really like is, as you said, is their perception of what's right and wrong, because elephants have a code of ethics. And so for the simplest example is that as young males begin to grow, they start developing these tusks. And those tusks are a tool, and they use them. So for Indian elephants, the females don't have tusks and the males do. Females kick the males out of the herd. Females keep all the sisters and the aunts and the cousins together, but the males are their own thing. So here's the thing: so what you get is these crews of male elephants, and the older males will, there's play fighting that goes on around, two young males can play fight, but the older males, they'll kick some ass. They'll show them how to behave. They'll explain who gets to talk to the females, who gets to interact, who gets to mate, who gets the best vegetation to eat. And so there's an order established. And so young male elephants have to be taught how to act. Just like a teenage human has to be taught, you can't just haul off and break another kid's nose. There's going to be consequence. Maybe you get suspended. Or maybe that kid will get his friends and beat the living shit out of you. Whatever it is, society regulates your behavior. And elephants have a very strict, very predictable sort of, like the males teach the males how to run things, and the females, which really have the final say, they're matriarchal. They're the ones leading the herd where to go. The males follow where the wise females tell them where to go.
So that regulation mechanisms, from that emerges a kind of moral system under which they operate. It's right and wrong
For an elephant.
for an elephant.
Right and wrong for an elephant is not the same as what's right and wrong for a grizzly bear. Grizzly bear, if you're a male grizzly bear and you see a female with cubs, you just kill those cubs, and then you can mate with her and put your own cubs in there. It's like that's a whole different type of ethics.
Yeah, the value of child life is different from species to species. Some of them hold it sacred, some of them not at all.
And that's why I think I resonate so much with elephants, because I think that we are kind of matriarchal. At least I grew up matriarchal. Like, women were the force in my life. My family and most of my friends' families, women kind of have the final say, and I feel like that's the way it is with elephants. Like, you might be bigger and stronger, but it doesn't really account for much if you're not smarter and more emotionally intelligent, and you know how to take care of the group.
Just to zoom out into the ridiculous questions, as we're talking about aliens, there's a lot of people trying to study the origin of life. Oh, I love this. First of all, what do you think is life versus non-life? Like, when you look at like ants, or even like the simplest of organisms. I saw a frog in the stream yesterday. That was like a leaf frog. It was like as flat as a sheet of paper, and it does a lot of weird things. And it found a way to exist in this world. But that's a single living organism with a bunch of components to it. But like, there's a life form that exists in this world. What is the difference between that and a rock? What is the essence of that life? This might be an unanswerable question. There's probably a chemistry, physics, biology way of answering that. Like, what to you is that?
I think to me, life is something that grows in response to stimuli, like in basic biology 101. I think, and I'm fine with that. I don't need it to be more romantic than that, but I think it's actually comical how do you get from a rock to an orangutan? You know, and our answer for that is primordial soup. Maybe there was just stuff on Earth, and then the stuff just got up and started walking. Maybe there was nothing happening, and then there was all of a sudden there was a cell, and the cell had function, and then it complexified, and then it started reproducing and found male and female parts, and what? Like we are so under-equipped to understand how the hell we got here, let alone ants or even bacteria.
I see this so many in very simple mathematical models, like something called Game of Life, their cellular automata. You could see from simple rules and simple objects, when they're interacting together, as you grow that system, complex objects arise. Like that emergence of complexity is not understood by science, by mathematics at all. And it seems like from primordial soups, you can get a lot of cool shit. And the force of getting from soup to like two humans on microphones, not understood, and it seems to be a thing that happens on Earth. I tend to think that it's a thing that happens everywhere in the universe, and there's some deep force that's pushing this along in some way. That there's something I don't want to sort of simplify it, but there is something that creates complexity out of simplicity that we don't quite understand. And that's the thing that created the first living organism on Earth. That like leap from no life to life on Earth, that's a weird one.
Because you can imagine, I think that the Earth is 4.5 billion years old, and you can imagine just this rock of a planet with like rain and storms and elements and iron and granite and like just random stuff. It's pretty easy to imagine. But then I remember that book. I think we all had the same book when we were kids, and like they show this like fish-like animal crawling out of the primordial soup, and it's like, bro, you just missed the most important part. Author of that book, bro. And I think the first bacteria came in around 3.7 billion years ago. So there's like at least like, you know, a bunch of billion years where there's just nothing, just a planet. And then we start seeing fossils of the first bacteria.
And bacteria stuck around for a long time, 2 billion years. It's just very, very long.
Just bacteria.
Just bacteria, but a lot of them. A lot of them. There's probably a lot of innovation, a lot of murder, a lot of interaction. Yeah. And then, I mean, there's a few big leaps along the history of life on Earth.
Yeah.
You know, the predator-prey dynamic, that was a really cool innovation. It's almost like innovation. It's like featured on an iPhone. It's like, it's nice. Like predator-prey, eukaryotes, so complex multicellular organisms emerging from water to land. That was weird. That was an interesting innovation. Whatever led to humans, there's a lot of interesting stuff there.
I can't even get that far. I can't get from rock and sand to cells.
Yeah.
That's a huge. I mean, to everything around us that has cells. It's just it's wild. Even again, and I could imagine being on another planet and how incredibly valuable this thing would be. This it's impossible to replicate. I'm looking at it through the candlelight right now, and I can see all of the structures in this leaf, the incredible structures in this leaf that look exactly like the veins in my arm, which look exactly like the rivers that are flowing across this landscape. And it's like life has this overwhelming pattern that it uses. It's so beautiful. I just think it's when you imagine that the days of the lightning and the volcanoes and the primordial soup, there's a big gap there, and it's fascinating to think about. It's fascinating to see how different people's belief systems lead them to different answers there.
Not to give any spoilers, but Postcard from Earth, Darren Aronofsky's film, the idea there is there's probes that are sent out from Earth to all these other planets, and each probe contains two humans, a man and a woman, and those two humans are in love. So think of a couple in love. They're sent there with all the information, basically a leaf that holds the information of what it takes to create life on other planets, to recreate on Earth and other planets. And the two humans hold all the information for the things that make life on Earth special, especially in human civilization, is love, consciousness, the social connection. So all that information is set in the probe. And the Postcard from Earth is those humans waking up, remembering all the information that is Earth, that like a celebration of all the things that make Earth magical throughout its history, all the diversity of organisms, all of that. You're loading all that in to create life on that new planet, which is something I think alien civilizations are doing. They're sending probes all throughout the galaxy, and they just haven't arrived yet. But anyway, that's another.
That's so beautiful, and one of the things that I think I want to see that so much, and one of the things that I love about Aronofsky's work is the fountain. And what I find so beautiful about that is that now here he's saying, okay, we're sending probes out to other worlds, alien civilizations, and in the fountain it was sort of what I thought he did so beautifully was braid together those three stories, where in one, I don't remember if he's in a spaceship or if that's supposed to be like his soul. The other one, he's a scientist in sort of like comparable times to ours, and then he's the Spanish explorer. But either way, there's the tree of life, and it sort of braids together all of the major religions. And it made me think of that quote that you hear where it says, oh God, what was it? Christ wasn't a Christian, and Buddha wasn't a Buddhist, and Muhammad wasn't a Muslim. They were all just teachers who were teaching love. And it's like the fountain sort of says nature is that driving force, and it's our job to understand that the game is love. And that's what the main character in the fountain needs to learn, is that it's nature that's going to carry your soul through this thing. And if there's so much you don't understand, in the epiphany at the end, God,
among many things, you're also an artist is trying to convert the thing that is nature into a thing that we humans can understand. The complexity, the beauty of it. That's what Darren Aronofsky tried to do with those couple of films. That's something that I hope you do, actually in the medium of film too. That would be very interesting. And you do that in the medium of books, probably. How much do you think we understand about the history of life on Earth?
I think we got it all wrong. I don't know. It seems like they change it all the time. They say that Easter Island, when I was in college, they were big on telling you that Easter Island, they ruined their environment, and they had environmental collapse. And that's why there was nobody on Easter Island. It was a cautionary tale. We could ruin our environment. And now it seems like they've changed their mind on it. When humans entered North America seems to be hugely up to speculation. And, the Africa spreading, that we all spread out of Africa, and then the Pleistocene overkill extinction theory. And it's like, it seems like every few years they update it and they change it. And say, the guys, no. The guys from 10 years ago, actually my new theory is the best theory. Let's write some books and get me on Letterman. And it seems like there's a new prevailing theory that's really always exciting and edgy about how we got here and where we came from and how we dispersed, and maybe even has some political implications, like how we should use the Amazon moving forward. Like, the Amazon was engineered by people, so fuck it. Let's just cut it down.
Yeah, I tend to believe that we mostly don't understand anything, but there's an optimism in continuously figuring out the puzzle.
Sure.
And we offline talked about the Graham Hancock Flint Dibble debate on Rogan. I like debates personally.
Yeah.
So Flint Dibble represents mainstream archaeology, and I actually like the whole science, the whole field of archaeology. You're trying to figure out history with so little information. You're trying to put together this puzzle when you have so little, and you're desperately clinging on to little clues. And from those clues, using a simple possible explanation to understand. And now with modern technology, as Flint was trying to express, that you can use large amounts of data that's like imperfect, but just the scale, and using that to reconstruct civilizations. their different practices, from the little details of what kind of things they eat, how they interact with each other, what kind of art they create, to when they existed, what are the time frames, all that kind of stuff. And that starts to fill in the gaps of our understanding. But still, the error bars are large in terms of what really happened. And that leaves room for things like Graham Hancock talks about, like lost civilizations, which I like also because it gives you have a kind of humility about maybe there's giant things we don't know about or we got completely wrong. And that's always good to like remember.
It's confusing to me to imagine like what I don't even know what ended where did the Egyptians go? What happened to it seemed like they were doing so good. They had so much cool shit. But I mean, I was reading anthropological stuff in the Amazon about tribes that, you know, just through their societal structures and through their hunting practices that didn't really develop practices that worked, and kind of bands of people that went extinct before they could turn into larger societies. And there's a lot of people that got it wrong. You know, for every explorer that leaves Borneo and arrives in South America, there's hundreds more that just die at sea, get eaten by sharks, you know, avalanche. And it's so fascinating to me that all of us really, past our grandparents, don't really even know where we came from. Like, do you know who your great-great-great-grandparents are? You know?
I mean, there's methods to try to figure that out, but really, again, the error bars are so large that it's almost like we're trying to create a narrative that makes sense for us. You know, that I'm 10% Neanderthal, therefore I can bench press this much, and therefore my aggressive tendencies have an explanation, when in reality there's so much diversity of personalities that they far overshadow any possible histories we might have.
Your aggressive tendencies don't have any explanation.
No, you need to you listen to me right now.
I'm sorry, don't hit me again. Don't choke me out again.
Yeah, man. One of the things you and I talk a lot about is different explorers.
Yeah.
Who do you think is? I'm just throwing a ridiculous question one after the other. Who do you think is the greatest explorer of all time?
Oh God, I love Shackleton, but I hate the cold, so I can't even read about it. I hate the cold so much. I can't even go there for fun. I think Percy Fawcett in the Amazon was the GOAT in terms of just sheer, the last of the Victorian era, you know, march forward, go deeper, just stop at nothing, and then eventually take such big risks that you never come back. It's hard for me to relate to that kind of exploration, because to me, I'm such a softie. I wouldn't want to like leave my family behind. I wouldn't want to, like, even if you told me that I could leave Earth and go exploring and I could go touch the moon, I'd be like, nope, absolutely not. Like, the highway is dangerous enough. Like, I would never risk dying in space. And this guy left his home, went out into the jungle out there with horrendous gear compared to the camping gear we have today. No headlamp. And just explored for years on it.
Well, let me actually push back. Like, you have that explorer. There's definitely a thing in you, just me having observed you behave in the jungle and in the world. You're pulled towards exploration, towards adventure, towards the possibility of discovering something beautiful, including like a small little creature or like a whole new part of the rainforest, a part of the world that like it's like, holy shit, this is beautiful. I think that's the same kind of imperative. So maybe not going out to the stars, but like,
Yeah.
like I could see you doing exactly the same thing. So he disappeared in 1925 during an expedition to find an ancient lost city, which he and other people believed existed in the Amazon rainforest. So there's that pull. Like, I'm going to go to there with shitty equipment, with the possibility of finding something.
And they said he ran into uncontacted tribes and started goofing off. I think he started dancing and singing. Like, the tribes were ready to kill him, and he started goofing and like doing a song and a dance and just being ridiculous. And the tribes were like, "What now?" Mm-hmm. And they're like, "Wait! Don't shoot him yet. That's a funny one."
Yeah.
And they actually, he kind of like on a human level used humor to save his own life on multiple occasions, to the point where he de-escalated the situation. Was like, "Look, we're not here to fight. We have a pile of maps. all my guys have beriberi, dengue, and malaria. Like, we're dying out here. If you guys just go on your merry way, we'll go on our merry way. And like, incredible. He was so tough. And then that guy from Shackleton's expedition ended up on one of Fawcett's expeditions, and he's a proven explorer. He's been through the Antarctic, and the guy was like, "Fuck the jungle." Absolutely fuck the jungle. He was like, and there's a great quote where he says, "Without a machete," and something, I don't remember exactly the words he used, but he said, "Without a machete in this environment, you don't last." And you know that now. Like, you in that tangle, to just take 3 steps that way I would immediately be taking on, and I'm not wearing shoes right now.
Yeah.
Bullet ants, venomous snakes, spikes through my feet, tripping over myself. I don't have a headlamp. An unbelievable risk right there. We're sitting on the edge of tragedy.
Can you explain what the purpose of the machete in this situation is? Like, what is a machete? How does it work? How does it allow you to navigate in this exceptionally dense environment?
So this is the tool that I spend most of my life carrying. This is in my hand for 90% of my time. And in the jungle, you really need a machete. There's so much plant life here that you have to cut your way through. And like a jaguar, an ocelot, a lot of these other animals that are more horizontally based and low to the ground, they can make it. Like when we got stuck in those bamboo patches and we were just hacking through them, and it's dangerous. And there's, as you hit the bamboo, it ricochets and there's spikes, and then one piece falls and it pulls a vine that has spikes on it, and that hits you in the neck, and the jungle is savage to humans. But if you are an agouti, a little rodent, or a jaguar, or a deer, you can kind of slip through this stuff. And the deer have developed really small antlers. They can just kind of weave through, low to the ground. And so for us, being these vertical beings walking through the jungle, it really helps to be able to move the sticks that are diagonally opposing your movement at all times. So machete is just a very, very useful tool. It can help you pull thorns out of your body. As you saw last night, we can use it to find food.
Mm-hmm. You went machete fishing. You cut a fish head off with a machete by like you were swimming, and then you basically macheted the water. And the other fascinating thing about that fish without its head, he kept moving. So it was just using, I guess, its nervous system to swim beautifully. I mean, there's so many questions there about how nature works.
Let's explain. Because the way the machete hit this fish, it kind of took his eyes off, and his lower jaw was still there. So it was really just like the brain and the little top jaw that came off. And this fish, as the dust cleared in the stream, I found it very haunting in a very like interstellar way. Like it was just the programming was still there, but the brain was gone, and the fish was just still moving, and it was gonna die, but it was still swimming, and it looked like a live fish. It was.
And you're still trying to catch it, which is interesting.
And I still had to work to catch it. So every time I caught it, it would freak out, and then it would jump back in the water. And I'm programmed here from years and years of living in the Amazon that everything can hurt you. So you actually become quite, if a moth lands on you, you can flick it because it could be a bullet in it. And so even the fish here, a lot of the fish here have spikes coming out of them. So even though I know that fish, I know its name, I've eaten it many times. As I was holding it, when it would twitch with that explosive power, just like the caiman, I would get that fear response and release it. And so that happened 3 or 4 times before I finally said, this is stupid. Even though he's slippery, he hasn't got a head. I can hold on to him. I put him in my pocket.
Yeah, we put him in the pocket.
And then we fried him up.
And he was delicious. So, and I'm grateful for his existence, for his role, and for my existence on this planet, brief existence, that I was able to enjoy that delicious, delicious fish. So the machete is used to cut through this extremely dense jungle. There's vines, by the way. There's rope-like things that are extremely strong, and they go all kinds of directions, go horizontal and all this. I don't even... We have a tree right above us. That makes no sense. There's like a tree that kind of failed, and then a new tree was created on top of it. It just makes no sense. It feels like sometimes trees come from the sky, sometimes they come from the ground. I don't really quite understand how that works, because there's new trees that grow on old trees, and old trees rot away, and the new trees come up.
Yeah,
that
so
whole mechanism.
Strangler figs. And so strangler figs, as you go across the world's ecosystems, that whole belt of, whether you're in rainforests in the Amazon, Congo, Indonesia, all across the tropics you have strangler figs, and the amazing thing that this species does, it's become a keystone species across the planet with a hyper influence on its ecosystem wherever it is, because they produce fruit in the dry season when the rest of the forest is making it hard for animals to find fruit. And so the bats, the birds, the monkeys, they all go to the strangler fig. They eat the fruit, and the fruit, of course, is just tricking the animals. The plants are tricking the animals into carrying their seeds to another tree. And so they're getting free transportation. Monkey takes a poop on another tree after eating strangler figs, and then that strangler fig sends out its vines, gets to the ground, and then as soon as it begins sucking up nutrients, out-competes that tree for light, grows hyper dry around the trunk of that tree, and then eventually that tree will die and the strangler fig will win because it got a boost up to the top. Whereas these little trees down here, they're gonna have to wait their turn. They have to wait until a tree falls, until there's a light gap, and then they have enough food to grow quick. And so this whole thing is an energy economy. Everything is just trying to get sunlight. And so strangler figs, top-down trees growing, or parasitic top-down octopus trees growing over other giant trees. And you've seen the size of some of the trees here.
So, back to Percy Fawcett and exploration. What do you think it was like for him back then, 100 years ago, going to the jungle?
See, the thing is, those guys didn't go with the locals. They came down here with like mules, and they tried to do it their way. And so he's one of the people that wrote about the green hell, the jungle as the oppressive war zone, where there's nothing to eat and everything is killing you. And I think that image is so wrong, because as you saw last night, we could go, if we went out with JJ right now, we'd shetty fish some fish, we could start a little fire, we'd do it all in shorts. Like to JJ, it's green paradise. And it's intense, but if you know what you're doing, which the local people surely do, well then just beneath the sand there's turtle eggs that you can eat. And inside the nuts on the ground there's grubs that you can eat. And if you really needed to, you could just jump on a caiman and eat that, because the tails are pretty full of meat. And it's like, there's actually unending amounts of food here. And so they were pretty, they were strange.
If you're able to tune into that frequency, I feel like you and JJ are able to tune to the frequency of the jungle that is a provider, not a destroyer of human life. Right?
Yeah.
Like, I think to be collaborated with, not fought against.
Yes, but we're coming at that with our modern lens, because we're coming down here with, I've survived how many infections in the jungle, where those probably would have killed me before. So my dead ass opinion of the jungle would have been overwhelming and collective murder, as Herzog says. And so Percy Fawcett was coming down here with this view of, it's trying to kill us at all times. But we are flying down here and coming out here with our superior medicines and our ability to survive infections. And so it is different for us. It is different. We're coming at this very, very different. But Fawcett, to me, was like the last of like the real swashbucklers, like the really batshit crazy explorers that just went out into the dark spaces on the map. And it's very hard for me to identify with him. But for instance, Richard Evans Schultes from Harvard, that's someone where you go, okay, now we're getting to the point where I can start to understand. I mean, just like the conquistadors. And they tell you the conquistadors showed up, they killed, the Spanish killed 2,000 Inca on the first day, and then they marched to this city. And like, when I hear about this, can you imagine yourself just like slaughtering a bunch of women and children and soldiers, and then just like drinking some wine and doing it again tomorrow? I can't actually wrap my head around that.
Yeah, it just seems like an entire different world.
No, like different world,
different value system, like
different value system,
different relationship with violence and life and death. I think we value life more. We resist violence more.
Yeah, like I can't. Like if we saw a car accident, I feel like if I saw a car accident, like if you see a little bit of or some violence, like it affects you. These people were so comfortable with those things. It was such a normal part of the Spartans, the Comanches, like they became so comfortable with war to the point that it became what they did.
And they
as a culture.
celebrated it
They
too.
celebrated it.
And direct violence too, like taking that machete and murdering me. Or if I got to the machete first, me murdering you.
Not a chance, bitch.
And then I would put it on Instagram
On
and
his own
show
show.
off. And the number of DMs I would get from murdering you with a machete.
Meanwhile, half the world right now is messaging me saying, my DMs are filled with, take care of Lex, don't lose Lex, make sure Lex comes back safe. Lex is a national treasure. We love Lex. Make sure he holds a snake. The amount of love that is out there.
Meanwhile, I emerge from the jungle with blood around me with a machete, and I take over your Instagram account.
He's very humble. He doesn't want to hear about the love.
All right. So, what do you think makes a great explorer? Whether it's Percy Fawcett, Richard Evans Schultes, whether it's, say who Richard Evans Schultes is, he's a biologist, so that's another lens through which to be an explorer.
Yes.
Is to study the biology, the immense diversity of biological life all around us.
Richard Evans Schultes, I know about him from reading Wade Davis's book One River, which is this big, hefty, 500 or 600 page tome about the Amazon, and it covers two stories. It's Richard Evans Schultes, and I think it's in the 40s. I think it's like pre-World War II era, where he's in the Amazon looking for blue orchid and the cure for this and that, and he's pressing plants, and he's going to these indigenous communities where they still live completely with the forest, and they drink ayahuasca, and they talk to the gods, and he learns about how they believe that the anaconda came down from the Milky Way and swam across the land and created the rivers. And sort of, he came down and even though he was a Western scientist from Harvard, he embraced the indigenous perspective on the world, on creation, on spirituality, and he sort of resigned himself and gave himself fully to that, and spent years and years traveling around parts of the Amazon that had hardly been explored, and certainly never been explored in the way he was doing it, in the ethnobotanical, spiritual way of what medicinal compounds are contained in these plants, and how do the local indigenous people use and understand them. For example, of 80,000 species of plants in the Amazon rainforest and 400 billion trees in the Amazon rainforest, the statistics of likelihood that through trial and error that humans could discover ayahuasca, it's astronomical. That one of these trees and a root, when put together, allow you to go and access the spirit realm and see hallucinogenic shapes and talk to the gods. That's almost enough to inspire spiritual thought itself. The fact that trial and error, it would take like millions of years or something. It's I forget what the figure is. It's incredible. But Richard Evans Schultes was one of the first people that came down and saw that. And then One River is where Wade Davis comes back, I believe, in the 70s. And the heartbreak of the book is that all of these incredibly wild places with naked native tribes and these intact belief systems, Wade Davis comes back, and a lot of the same places that Schultes went. Now there's missionary schools, and they're wearing discarded Nikes and whatever. I don't know if there's Nikes in the 70s, but like Western stuff has made it in. They've been contacted, domesticated, forced into Western society, and a lot of them then forget the thousands and thousands of years that have gone into creating the medicinal, botanical knowledge that the indigenous possess about how to cure ear infections and how to treat illnesses from the medicinal compounds flowing through these trees is lost in a single generation with the modernization.
Yeah, he wrote the plants of the gods, their sacred healing and their hallucinogenic powers. That's interesting. You mentioned like how to discover that. How do you find those incredible plants, those incredible things that can warp your mind in all kinds of ways? Of course, physically heal, but also like take you on a mental journey. That's interesting. So you don't think trial and error is possible?
I was reading about ayahuasca, and they were saying statistically, if you put 1,000 humans in the Amazon and gave them villages to live in, because humans are communal species, it would take tens and tens of thousands of years, or perhaps even centuries, before even the possibility. It's like that thing, a bunch of chips on a keyboard. How do they write Hamlet? It's like astronomical odds to get to oh wait, this and this goes together. So what the local people believe is that the gods revealed this secret through the jungle to us as a link to the spirit world, and that's how we know this. Because if they didn't remember it from their ancestors, we would have no idea how to get this information from the wild.
So I will likely do ayahuasca. What do you think exists in the spirit world that could be found by taking that journey?
I think that ayahuasca is, I can only speak from personal experience. And for me, it was as if your brain is a house you've lived in your entire life. It's a big house, it's a mansion. And there's many, many rooms that you didn't even know exist, hidden rooms behind the bookshelves, under the floorboards, rooms that you had no idea were there. And some of them are fantastic, and some of them are terrifying basements. And ayahuasca takes you on a journey through that. At its most effective, you sit in front of the shaman with the candlelight, with the sounds of the jungle. And you drink the substance, and after that, what happens is the journey is all inside, and the shaman's supposed to be able to guide you through that. But in my experience, you're so deep inside, like falling through nebulas, out in space, no physical form, or crawling through the jungle. It's really, really powerful. Like it's not like the recreational drugs that everyone does, like where you go, oh, I did mushrooms and I could see music, like. And I was talking to my friends, but no, like you're face down on the floor, usually vomiting, sometimes shitting, having dialogues with the creator, and that can be traumatizing as well as amazing.
It's a really good way of looking at it. It's a big house, and you get to open doors that you've never had before and discover what rooms are there inside you. You ever think about that? Like, that there's parts of yourself you haven't discovered yet, or maybe you've been suppressing? How much are you exploring the shadow? Oh boy. So say you, me, Carl Jung, and Jordan Peterson are in a deserted island together.
Fuck, I didn't even make my bed today.
There's no bed on an island.
Great.
It's a campsite.
I want to see you and Jordan Peterson do ayahuasca together. I think that's the thing. Ayahuasca to me, I've kind of told you about, like I've experienced some things that really made me believe that there's a benevolent force around us. But to me, ayahuasca was a ride through the scariest parts of the universe, to sort of be like, here's what it could be like. That's where I came up with my idea that, like deep space, or just space, outer space, is just the outside of the video game, and this is it. Because when I was on ayahuasca, I was one of the jungle creatures, and I wasn't Paul, and I didn't have a name. And for a long time, I saw many things, and I arrived at this spot in the jungle where there's a big tree, and all the animals were there, and they were all not in words, not in any language that we can understand, but they were all discussing what to do about the threat, and it was all leaving, it was all flying up, and it was fire, and the jungle was being destroyed, and it was like I went, and then after that it was just space and stars and silence, like crushing vacuum silence for years, and that was terrifying. That was fucking terrifying. When I came back and I had hands, man, I can remember my own name.
You're grounded. Things are simpler. You're back inside the video game. What are the chances you think we're actually living in a video game?
When you say a video game, it implies that there's a player. Who's the player? Is God?
No, there's a main player usually. That's not going to be God. God is the thing that creates the video game.
Oh, so then we're just...
And there's somebody's there NPCs. Like, I'm an NPC.
You're an NPC. Jesus Christ.
Yeah. You created me. See,
is this like Halo, where you can kind of kill the NPCs?
I see. I show you behind you.
Okay, I think I'm just going to take a stand here. I think that because people, I'm just sick of fucking playing it halfway. I think that because people live indoors in climate-controlled boxes and cities far away from nature, they've completely lost track of everything that's real, and they've started to think that we're living inside of a simulation. Notice that nobody carrying an alpaca up a mountain thinks that we're living inside of a video game. They all know that it's real because they've had babies on the floor of a cold hut. They understand the consequences of life. They understand the fish and how hard it is to get them and the basic rules of the wind and the rain and the river, and that we all have to play by those. And that it's and you talk to a grieving mother and ask her if she's living inside a video. It's like the people. To me, this whole thing of, oh, are we living in a simulation? To me, that's the infirmary of society starting to parody itself. It's people going, I have no meaning in my life anymore. So is this even real? And again, go ask the Sherpa, go ask the Eskimo. They're not.
You forget what fundamentally matters in life. What is the source of meaning in the human life? If you talk about such subjects, nevertheless, you could, for a time, stroll in the big philosophical questions. And if you do it for short enough time, you won't forget about the things that matter. That there is human suffering, that there is real human joy, that is real. Our time in the jungle was very hard.
Did you suffer enough to know that it's real?
Yeah, I was hoping we were in a video game that whole time.
So that's actually a really good way to. There was this moment that I watched where you were washing a shirt in this pathetic puddle because we had no water, because we had walked all day and tripped all day and gotten thorns in our hands and our feet and our legs, and we were lost in the jungle, and it was nighttime, and we didn't know if a big tree was going to just fall on us and mousetrap kill us, and there's a lot of uncertainty. But I watched something very special happen to you, and that was I saw you crouching by the side of this puddle. It wasn't even a flowing stream, so we couldn't drink it. And you were just trying to wash the sweat off of your shirt, and you looked at me and you just said, the only thing that I care about right now is water. Mm-hmm. And I feel like in that moment we were united in the simple reality of the fact that we were so thirsty that it hurt, and that it was a little scary.
Yeah, it was scary, but also there's like a joy in the interaction with the water because it cools your body temperature down, and there's like a faith in that interaction that eventually we'll find clean water because water's plentiful on Earth. It's kind of like a delusional faith. Eventually we'll find. It was just like a little celebration. I think the cooling aspect of the water is the body temperature is really high. Traversing the really dense jungle, it's just the cooling was somehow grounding in a way that nothing else really is. Yeah, it was a little celebration of life on Earth, of the jungle, of everything. It was nice. It was a nice moment. I think about that. I had a couple of those. There's one in the puddle and one in the river. One was full of delusion and fear, and the other one was full of relief and celebration.
Yeah, I've there's this thing that they say with the all the pleasure in life is derived from the transitions. When you're cold, warm feels good. When you're hot, cold feels good. When you're hungry, food feels good. And when you're that thirsty, water becomes God, and it's all you want. And also the other thing is that when we're out there, it felt so good to be so lost and so tired and so like we were doing levels. Like how would you describe the physicality of what we were doing, the level of physical exertion?
Well, it's something that I haven't trained. I don't even know how you would train for that kind of thing, but it's extremely dense jungle. So every single step is like completely unpredictable in terms of the terrain your foot interacts with. So the different variety of slippery that is on the jungle floor is fascinating because some things, the slope matters, but some roots of trees are slippery, some are not. Some trees on the ground are already rotted through, so if you step through, you're going to potentially fall through. So it could be a shallow hole, or it could be a very deep hole with some leaves and vegetation covering up a hole where if you fall through, you could break a leg and completely lose your footing, or fall rolling downhill, and if you roll downhill, I'm pretty sure there's a 99% probability that you'll hit a thing with spikes on it. So there's so many layers of avoiding dangers, of small dangers and big dangers all around you at every single step. So there's like a mental exhaustion that sets in, like just the perception, and you're just observing you. You're extremely good at perceiving, having situational awareness of taking the information in that's really important and filtering out the stuff that's not important. But even for you, that's exhausting. And for me, it was completely exhausting, just paying attention to everything around you. So that exhaustion was surprising. It's like, there's moments where you're like, I don't give a damn anymore. I'm just going to snap. I'm just going to.
And so that's it. You go, I don't care anymore. And you reach out and I'm just going to lean against this tree. And then what happened?
And then
Every time.
spikes in it. Yeah.
And then you have to care.
And then there's just bad luck because there is wasp nests. There's just like a million things. And that is physically, is mentally, psychologically exhausting because there's the uncertainty. When is this going to end? It's up, in our particular situation, up and down hills, very steep downward, very steep upward, no water, all this kind of stuff. It's the most difficult thing I've ever done, but it's very difficult to describe what are the parameters that make it difficult. Because I run long distances very regularly. I do extremely difficult physical things regularly that on some surface level could seem much more challenging than what we did. But no, this was another beast. This is something else. But it was also raw and real and beautiful because it's like, it's what the explorers did.
Yeah.
It's what Earth is without humans. And also just like the massive scale of the trees around us was the humbling size difference between human and tree. It's both humbling in that like that tree is really old. It's a time difference, lifetime difference, and just the scale. It's like, holy shit. We live on an earth that can create those things. It makes me feel small in every way. That life is short. That my physical presence on this earth is tiny. How vulnerable I am. All of those feelings are there. And in that, the physical endurance of traversing the jungle, was the hardest journey that I remember ever taking. Every step. And that made making it out of the jungle and then made it the swim in the water that we could drink. That was just pure joy. It was probably one of the happiest moments in my life. Just sitting there with you, Paul, and with JJ in the water, full darkness, the rain coming down, and us all just laughing, having made it through that, having eaten a bit of food before, and the absurdity of the timing of all of it, that it somehow worked out. And how we're just three little humans sitting in a river. Just our heads immersed barely above water, with jungle all around us. What a life.
That was a real adventure.
That was a real adventure.
That was a real one.
I'll never forget that. So it's a real honor to have shared that. Of course, we had very different experiences. When you saw a caiman in that situation, you're like, I have to go meet that guy. It's a friend of
Well,
mine.
I mean, we were in the river in a thunderstorm, just next above. We're all laughing our asses off, and I mean, we're in the river with the stingrays and the black caiman and the piranha and all of the electric eels and everything, and it's pitch black out. And then what were we doing? We're holding our headlamps up, and there's those swirling moths, the infinity moths, all making those geometric patterns, and it's like we're just three ridiculous primates, three friends in a river, just laughing.
Yeah.
Because we were safer in that river than we had been in there, and we were rejoicing that the thunderstorm was compared to the war zone that we'd been living in, Thunderstorm was safe, and it really was a beautiful moment.
And also that like very different life trajectories have taken these three humans into this one place.
Yeah.
It's like what
Yeah. Wow.
is
Yeah,
this
that's true.
universe that would like? Because we're kind of like those moths. You know what I mean? Like we come from some weird place on this earth, and we have all kinds of shit happen to us, and we're all pursuing some shit, some light, and we ended up here together, enjoying this moment.
Yeah.
Of something else. It just felt absurd, and in that absurdity was this like real human joy. And damn, water tasted good.
Oh, it's good. Man, water and those little oranges.
Yeah.
Those things, and then I would just say, like, do you feel like I feel like running, like no matter how much I run, I feel like you run, you do a workout and then you stop. Like maybe people who do ultras feel this, but like I felt like we woke up. It was like, wake up at dawn, 6 a.m. Let's start walking. Break camp, go, and it's like pretty much you just don't stop all day, and it's level 10 cardio all day long, and you're sweating buckets and there's no water. It's like you would never put yourself through that voluntarily. You could. You would never have the resolve to continue torturing yourself, except for that we were trying to make it to freedom, to get out. And it's like the obsession of that with the compass and the machete and the navigating. Fuck.
I think there's something to be said about like the fact that we didn't think through much of that, and we just dived into it. I think there was like we're like laughing, enjoying ourselves moments before, and once you go in, you're like, oh shit, and you just come face to face with it.
Yeah.
I think that's what whatever that is in humans that goes to that. That's what the explorers do. And the best of them do it to the extreme levels.
Well, I think that what we did was to a pretty extreme level because we left the safety of a river, of knowing where we were, and voluntarily got lost in the Amazon with very little provisions. On a very, now that we're back, now that we experienced what we experienced, I really can't stop thinking about how fucking stupid it was that we did that. Because if we had gotten lost, Pico was saying to me, even if one of you had broken your leg, it's days in either direction. Even if they had sent help for us, help would take how long to scour all that jungle? Sound doesn't travel. Even a helicopter, even if they looked for us, they wouldn't be able to see us. How would we signal for help? Can't really build a fire, and so it's like if anything had gone wrong, if we'd gone a few degrees different to the west, it would have taken us 2 more days. If we'd gotten injured, we'd be carried through that.
Yeah.
And so somehow only afterwards am I really going, wow, thank God we got out of this. Thank God. After I see so many people going, make sure nothing happens to Lex Friedman.
Yeah.
I'd be the deadest motherfucker on earth.
It somehow works out.
It does seem to somehow work out.
Let me ask you about Jane Goodall, another explorer of a different kind. What do you think about her? About her role in understanding this natural world of ours?
I think that Jane is like a living historical treasure. Like I think somehow she's alive, but she's already reached that level where it's like Einstein, Jane Goodall. Like there's these incredible minds. And growing up as a child, my parents would read to me because I was so dyslexic. I didn't learn to read until I was quite old. And my mom was a big Jane Goodall fan, and all I wanted to hear about was animals. And so I would get read to about this lady named Jane Goodall, this girl who went to Africa and studied chimps and who broke all the rules and named her study subjects, even though that wasn't what she was supposed to do. And she became this incredible advocate for Earth and for ecosystems, and she seemed to realize as her career went on that teaching children to appreciate nature was the key. Because they're going, that thing where she says we don't so much inherit the earth from our ancestors, but borrow it from our children. We're just here. We're just passing through. So if we destroy it, we're dimming the lights on the lives of future generations. And so she's been really, really cognizant of that. She's been a light in the darkness. She's sort of, in terms of saying that animals have personalities and culture and their own inalienable rights and reasons for existing, and and that human life is valuable. She's very big on that. Every day we influence the people around us and the events of the earth, even if you feel like your life is small and insignificant, that you do have an impact. And I think that's a really powerful little candle out there in the darkness that Jane carries.
What do you think about her field work with the chimps?
Badass. The fact that she did what she did at the age that she did, at the time that she did, is incredible. It's actually incredible. She has that explorer gene, and she also has that relentlessness. Is like this incredible quality. She just, she travels 300 days a year, educating people, talking around the world, trying to help bolster conservation now before it's too late. And traveling 300 days a year is not fun. Traveling at all can be not fun.
So I started reading The River of Doubt, which you recommended to me on Teddy Roosevelt.
Yeah.
So that guy's badass on many levels. But I didn't realize how much of a naturalist he was, how much of a scholar of the natural world he was. So that book details his journey into the Amazon jungle. What do you find inspiring about Teddy Roosevelt and that whole journey of just saying fuck it, of going to the Amazon jungle, of taking on that expedition?
Well, I mean, Teddy Roosevelt, you could write volumes on what's inspiring about him. I think that, he was a weak, asthmatic little rich kid that wasn't physically able, that had no self-confidence, and he was very, and he had pretty severe depression. He had tragedy in his life. He was very, at least for me, he's been one of the people, one of the first historical figures where he wrote about the struggle to overcome those things, and to make himself from being a weak, asthmatic little teenager to sort of strengthening himself and building muscle, becoming this barrel-chested lion of a guy who could be the president, who could be an explorer, and one of the Rough Riders. And he's just everything he does is so hyperbolically, incredible. To come out of war and have the other people you fought with go, this guy has no fear. I mean, he must have just been a psychopath and had no fear. And then proving it further was that thing where he was going to give a speech to a bunch of people and he got shot in the chest.
Yeah,
and it went through his spectacle case and through his speech. And even though the bullet was lodged in his chest, this man said, "Don't hurt the guy that shot me." I believe he asked him, "Why'd you do it?" And then as he's bleeding and in the rain, said, "No, I'm not going to the hospital. I'm going to keep going with the speech." What a badass. That's incredible.
But going to the jungle on many levels is really difficult for him at that time. There's so many more things even than now that can kill you. All the different infections, everything. And the lack of knowledge, just the sheer lack of knowledge. So that truly is an expedition. A really, really challenging expedition. So there's lessons about what it takes to be a great explorer from that. The perseverance. How important do you think is perseverance and exploration, especially through the jungle?
I think it's all there is. If you hear about the people, and I think that is a tremendous metaphor for life, because whether you hear about that plane that crashed in the Andes and the people were alone and freezing and they had to eat each other, and some of them made it out. Some of them kept the fire burning. And Teddy Roosevelt voluntarily, after being president, threw himself into the Amazon rainforest and survived. Came so close to dying, but survived. And so perseverance is all of it. I mean, I think that's our quality as a human.
So they also mapped. So on the biology side is interesting.
Yeah.
But they mapped and documented a lot of the unknown geography and biodiversity. What does it take to do that? So when I see you move about the jungle, you're always like, you capture a creature, take a picture, write down, like, so you can find new creatures, find new things about the jungle, document them, sort of a scientific perspective on the jungle. But back then, there's even less known, much less known about the jungle. So what do you think it takes to document, to map that world, that new unexplored wilderness?
I mean, they're clearly pressing botanical specimens. They're probably shooting birds, and Roosevelt knew how to preserve those specimens. I mean, he really was a naturalist, so he knew exactly. So if he's seeing these animals, to them, whereas we'll take a picture and identify it, they were harvesting specimens, taking them with them, drying them out. For them, it was totally different, and it could be the first. There's, I don't know, I forget what JJ said. There's something like 70 species of ant birds here. It's like, so how likely are you to be the first person to ever see this one species of bird? And so for them, and you have this bird, so perfectly preserving that specimen. And I think a lot of non-scientific people don't realize that every species, from blue whale to elephant to blue jay to sparrow, whatever it is, whatever species we have on record, they're scientific specimens. And the first people to see them shot them. Mm-hmm. And that's the museums are filled with these catalogs, preserved birds that these explorers brought back from New Guinea and South America and Africa, and put into these drawers, and now we label them. So this is, this is red and green macaw, this is scarlet macaw, this is the brown crested antbird, and this is, and it's just categorized.
That book of birds you have, like encyclopedia of birds.
What the human achievement in these pages.
For people listening, while just flipping through a huge number of pages, these are just, is this in the Amazon or is this in Peru?
This is just here. This is birds of Peru. Dude, pages on pages of toucans and arasaris and hummingbirds and antbirds and smoky brown woodpecker and tropical screech owl, which we just heard, by the way. It's endless. Who knew there were so many birds? I had no idea there were so many birds.
Documenting all of that, analyze. I mean, there's also, which we got to experience, and you're pretty good at it also, is actually understanding and making the sounds of the different birds. What's your favorite bird sound to make?
Undulated tinamou, because in the crepuscular hours of dawn and dusk, they're usually the ones that make up what is considered by many to be the anthem of the Amazon.
Can you do a little bird for us?
That's what an undulated tinamou sounds like, and it's usually like, oh, it is getting to be afternoon. It's almost like hearing church bells on a Sunday. It's like there's something about it. You go, there he is.
And like you were saying, it's a reminder. Oh, that's a friend of mine.
Yeah.
Surrounded by friends.
I have so many friends.
What does it take to survive out here? What are some basic principles of survival in the jungle?
Cleanliness. I mean, really, we talked about this, but I have so many holes in my skin right now with that mosquito. I have so many spots that I've scratched off of my skin because the mosquito bites me and then I scratch it. Or the other big one is that I worry that I have a tick. Mm-hmm. Not deliberately, not with my thinking brain, but my simian brain just wants to find and remove ticks. And so I scratch, and then if my fingernails get too long, I remove my skin, and then those get infected. And so staying hyper clean, using soap, like basic stuff, keeping order to your bags, order to your gear, things in dry bags. Make sure, we explained that we got in the river during a thunderstorm. We didn't explain why we did that, because the thunderstorm came when we had eaten dinner, but we hadn't set up our tents. And so we decided to cover our bags with our boats that we had been carrying, our pack rafts that we've been carrying in our backpacks. So all of our gear would stay dry. So the only thing we could do was either sit in the rain and be cold or sit in the river and be warm. And so keeping our gear dry, momentary discomfort for future, that to me was an incredibly smart calculation to make. Is you got to be smart out here. You can't, not running out of a headlamp while you're out on the trail and being stuck in that darkness. It really takes just being a little bit on your toes. And I find that necessity of being on your toes is a place that I like to live in. It's just the right amount of challenge here.
So keeping the gear organized and all of that, but also being willing to sort of improvise. I've seen you improvise very well because there's so much unknowns. There's so much chaos and dynamic aspects that planning is not going to prevent you from having to face that at the end of the day.
No, it's been really funny watching you sort of shed your planning brain Like day one, it was very much like, so are we gonna? And then I could see your brow sort of furrow when I would go, I don't know what time we're gonna get there. And you'd go, well, just tell me. I'd be like, I don't know what the jungle's gonna let us do. You know, let's record the podcast tomorrow. Okay, but if it rains, if it gets windy, if Riahe comes, if there's a jaguar with rabies, like anything could happen. Landslide, like anything, literally.
Tree. I mean, the thing you mentioned, trees falling, that's a thing in the jungle.
That's a major thing.
Holy shit. First of all, a lot of trees fall.
Yeah.
And they fall quickly and they can just kill you.
They fall quickly. They're huge. We're talking about trees that are like the size of school buses stacked and connected to other trees with vines so that when they fall, this millennium tree, this 1,000-year-old tree, boom, shakes the ground, pulls down other trees with it. So if you're anywhere near that for a few acres, you're getting smashed. That's the end of you. And so the jungle at any moment that you're out there could just decide to delete you. And then the leafcutter ants and the army ants and the flies and everything, you'll be digested in 3 days. You'll be gone. Gone. No bones, nothing.
What do you think would eat most of you?
I would hope that like a king vulture with a colorful face would just get in there, like right in the ass, just like nature's metal, just like when they like walk in through the elephant's ass. I'd want that on camera trap. I think that would be great.
And we slowly look up and just kind of smile.
Yeah, just rip out your intestine and shake. Victorious over your dead body.
Well, but also honor a friend.
Yeah, sure, but you look so, your white naked ass laying there in the jungle, you'd be like face down and shit.
That's why you always have to look good. Any moment a tree can fall on you and a vulture just swoops in and eats your heart.
That's right.
We talked about Alone, the show a bit.
Rock House.
Yeah, what do you think about that guy? Rock House, Roland Welker from season 7. He built the Rock House. He killed the muskox with bow and arrow and finished it with a knife.
And had the GoPro mounted, to document it. That's really mind-blowing.
I mean, so for people who don't know, that show is you're supposed to survive as long as possible. On season 7 of the show, they literally said you can only win it if you survive 100 days. And there's a lot of aspects of that show that's difficult, one of which is it's in the cold. The others, they get just a handful of supplies, no food, nothing, none of that. So they have to figure all of that out. And this is probably one of the greatest performers on the show, Roland Welker. He built a rock house shelter. So what does survival entail? It's building a shelter, fire, catching food, so staying warm, getting enough energy to sort of keep doing the work. It takes a lot of work. Like building the rock house, I read that it took 500 calories an hour. So he had to feed himself, right? Quite a lot. You're lifting 200-pound boulders. And still the guy lost, I read 44 pounds, which is 20% of his body weight. So that's survival. What lessons, what inspiration do you draw from him?
I think he was fun to watch because he had this indomitable spirit. He wasn't there to commune with nature. He was there to win. And he was like, to me, that's the pioneer mentality. He goes, I'm a hunting guide. I'm out here. I'm going to win that money. I'm going to survive through the winter. He wasn't worried. I feel like so many people are like, they worry, second guessing themselves. Am I in a video game? I don't know. What's my, just questioning their entire existential identity. And this guy was like, you know what? There's a muskox over there. I'm going to shoot it. I'm going to stab it. And then I'm going to make a pouch out of its ball sack. And I'm going to live off that for the next few months. Win $500,000. And that's an amazing amount of pragmatic optimism that I just enjoy. Yeah. And every time he would go, we got to get back to Rock House. And it became, even though he's all alone, he had a big smile on his face. And what made that season so great was that it was him, and then it was Callie. And Roland had, the muscle and could make Rock House. And then Callie was the opposite. She was this girl who, she could hunt with her bow and she knew how to fish. And she wasn't using raw power, but what was so endearing about her was like how much she loved being out there. As hard as it was and as isolationist as it was, she was smiling every time the show cut to her. She was like, "Hey, everybody, it's morning. Can you believe the frost? Like, you've been out there for 100 days." Amazing I think it was really an amazing show of that the game is all here. The game of life. The game of alone and the game of life. It's the same thing.
Yeah, she maintained that sort of silliness, the goofiness all through it when the condition got really tough. And she had a very different perspective. As you know, Roland didn't want any of the spirituality. It's very pragmatic.
Yeah.
And from Callie, it's a very spiritual connection to the land. She said something like she wanted not only to take from the land, but to give back. I mean, there's this kind of poetic, spiritual connection to the land. It's such a dire contrast to Roland. But she's still a badass. I mean, to survive, no matter what, no matter the kind of personality you have to be a badass. I think she took a porcupine quill from her shoulder.
That was crazy because I think it went in somewhere completely different and it migrated to her shoulder.
Yeah.
And the way that I understood that is because I said, that's impossible.
Yeah.
Because I remember that. She's like, hold on. She's like, there's something. And then she like pushes it out.
Yeah.
And I remember I was like, hold up. How?
Yeah.
And it was because the barbs, once it goes in, as you move and flex your body, it moves a little bit each time. And didn't even think of that shit.
Plus, if I remember correctly, I think she caught 2 porcupines. The second one was like rotting or something, or it had an infected body, whatever.
It had the spots on it.
Yeah.
She chose not to eat it.
No, and then she chose not to eat it at first, and then she decided to eat it eventually. Yeah,
I forgot that.
Yeah, and that was an insane, sort of really thoughtful, focused, collective decision. Waiting a day and then saying, "Fuck it, I need this fat." And that was the other thing. Is like fat is important. It's like meat is not enough. You learn about like what are the different food sources there. Apparently, there's like rabbit starvation is a thing because when you have too much lean meat, it doesn't nourish the body. Fat is the thing that nourishes the body, especially in cold conditions. So that's the thing.
She was incredible, and I thought as brash and sort of fun as Roland was, she represented a much more beautiful take on it, and it was really heartbreaking when she lost because I mean, and like you said, still a badass.
Yeah.
It's kind of like Forrest Griffin versus Stefan Bonner. Like it was like it doesn't matter who won. Yeah. You guys beat the shit out of each other. Like,
and she didn't really lose, right?
No,
so she got evac'd because her toe was going frostbite. 100 days. You think you can do 100 days?
Honestly, I'm 18 years in the Amazon, man. I just at this point, it's I wouldn't sign up for another 100 days.
Yeah.
You know, at this point, I don't have that to prove. I've survived in the wild, and I wouldn't want to voluntarily take 100 days away from everyone I know.
Yeah, the loneliness aspect is tough.
We're not meant for that. I really love the people I have in my life, and I wouldn't and you see it on the show. A lot of the people, big, tough ex-Navy SEALs who are survival experts who know what they're doing, they get out there and they go, you know what? I miss my family. And they go, it's not worth it. They have this existential realization. They go, I only got so many years here. Like, this is crazy. It's just some money. Fuck it. And they go home.
You know, it's funny because you sometimes feeling yourself in the jungle when you're alone. And there's another guy, Jordan Jonas, Hobo Joro. He's the season 6 winner, and he said that the camera made him feel less lonely. I've heard of him from multiple channels. One of the things is he spent all of his 20s in living in Siberia with the tribes out there. Herzog, happy people. So he actually talked about that it's one of the loneliest times of his life because when he went up there, he didn't speak Russian, and he needed to learn the language. And even though you have people around you and you don't speak their language, it feels really, really lonely. And he felt less lonely on the show because he had the camera. and you felt like you could talk to the camera. There is an element when you have, in these harsh conditions, if you like record something, you feel like you're talking to another human through it, even if it's just a recording. I sometimes feel that, like, maybe because I imagine a specific person that will watch it, and I feel like I'm talking to that person.
I noticed that when things got especially hard, and they did get especially hard when we were out in the wilderness, that you would begin film to share that struggle. But I also think that I've used that at times where, yeah, you go, maybe because if you can tell someone else about it, then you're on the hero's journey. And then it sort of has to make you braver. And it changes how because I'm cold and I'm tired and I'm hungry and this hurts and that hurts and I don't know when we're going to make it and how is this going to go. And all of a sudden, well, guys, we're here, we're going that way. And then you're like, well, I got to keep going because you're like, they're still out there. If you forget.
You have to step up. That's one of the reasons I want a family. I think when you have kids, you have to be the best version of yourself, like for them.
All my friends with kids that I've seen them go through, where until you have a family, you're just playing around, man. I mean, you could do important work, you can have skin in other games, but it's once you have a little tribe of humans that depends on you. If you take that seriously, if you want to do that right, it's one of the hardest things you could do, and it just changes everything.
How has your life changed since we last met?
Speak about changing everything.
So you've been, for people who don't know, pushing jungle keepers forward into uncharted territories, saving more and more and more and more rainforests. There's a lot I could ask you about that. There's a lot of stories to be told there. It's a fight. It's a battle. It's a battle to protect this beautiful area of rainforest, of nature. But since we last met, you've continued to make a lot of progress. So what's the story of Jungle Keepers, leading up to the moment we met and after, and everything you're doing right now?
18 years ago, when I first came to the jungle, I was a kid from New York who always dreamed since I was 6 years old, maybe even younger, of going to a place where animals were everywhere and there's big trees and skyscrapers of life. And so being dyslexic and not fitting in school and reading about Jane Goodall and having Lord of the Rings be one of the things I grew up on, I just chose to come to the Amazon. And the first person I met was this local indigenous conservationist named Juan Julio Duran, who was trying to protect this remote river, the Las Piedras River, which in history, apparently Fawcett referenced either the Las Piedras, but he called it Tawamanu, and said, don't go there. You'll surely die from tribes. And so there's very few references to this river in history. It's stayed very wild because it's been a place that the law hasn't made it, the government hasn't really extended to, sort of past the police limit. And so JJ was out here ages ago trying to protect this river before it was too late. And when I met him, I was just a barely out of high school kid with a dream of just seeing the rainforest, let alone seeing a giant anaconda or having any sort of meaningful experience or contribution to the narrative. And somehow, over all the years that we began working together and sparked a friendship and began exploring and going on expeditions and bringing people to the rainforest and asking them for help and manifesting the hell out of this insane dream that we had. I mean, we didn't even have a boat. We would take logs down the river. We would have to cut a tree down every time we wanted to return to civilization. We'd have to cut down a balsa tree and float down the river
on it. Yeah.
It's madness. It's madness. It's pure madness. And I don't know what made us keep going, but along the way, people showed up who cared and who wanted to help. And if it was a movie, it wouldn't even necessarily be a good movie because you'd go, oh, please. You're just telling me that you just kept doing the thing and just magically people showed up. But yeah, that's what happened. That's exactly the way it worked. We kept doing the thing that we loved. We said, it doesn't matter if we don't have funding or a boat or gasoline or friends or anything. We just kept going. And Along the way, we found someone who could help us start a ranger program. And then we found Dax da Silva, who helped us fund the beginning of Jungle Keepers. And then people like Mosin and Stefan, who were there making sure that this thing actually took flight off the ground. And then right around the time that we were wondering what was going to happen and if we're all going to have to quit and get real jobs and if we could actually save the rainforest from the destruction that was coming, Lex Friedman sent me a DM and honestly changed the entire narrative. Because up until then, we've been playing in the minor leagues, pretending, trying real hard, and the listeners of your show, in the moments after you published your episode with our conversation, began showing up in droves and supporting Jungle Keepers, putting in 5, 10, 100, 1,000. We started getting these donations, and the incredible team that I work with, we all went into hyperdrive. Everybody started going nuts. We all started spending 16-hour days working to try and deal with the tidal wave that Lex sent towards us, just because so many people knew that we were doing this, that was an indigenous-led fight to protect this incredibly ancient virgin rainforest before it was cut, and people resonated with that. So we got this huge swell of support. And this year we've protected thousands and thousands of more acres of rainforest because of that swell of support.
So current 50,000 acres. What's the goal? What's the approach to saving this rainforest?
Since we printed this, it's gone up to 66,000 acres. And as you know, in each of those little acres are millions and millions of animal heartbeats and societies of animals. And the goal here is that we're between Mano National Park, Alto Purus National Park, the Tambopata Reserve. We're in a region that's known as the biodiversity capital of Peru, one of the most biodiverse parts of the Western Amazon. And we're fighting along the edge of the Trans-Amazon Highway. And so it's just a small group of local people and some international experts who have come together and used these incredibly out-of-side-of-the-box strategies to sort of crowdfund conservation. To go, look, we know that this incredible life is here. We have the scientific evidence. We have the national park system. If we can protect this before they cut it down, we could do something of global significance. All these jaguars, all these monkeys, all these undescribed medicines, the uncontacted tribes that we share this forest with, could all be protected. And people have stepped up and begun to make that happen. And there's people from all over the world. It's incredible.
Well, what's the approach? So trying to, with donations, to buy out more and more of the land and then protect it.
So the approach is that currently the government favors extractors. So if you're a gold miner or an illegal logger, or you just want to cut down and burn a bunch of rainforests and set up a cacao farm, the government's fine with that. It doesn't matter. You're not really breaking the law if you destroy nature.
So as long as you're producing something from the land, they don't see it as a loss that the nature was destroyed permanently.
Yeah, it's just wilderness. It's sort of just beyond the scope of or the local people that technically own the land out here, the local indigenous people. For instance, we fought this year to help the community of Puerto Nuevo, who's been fighting for 20 years to have government-recognized land. These are indigenous people in the Amazon fighting to protect their own land. And you know what it was that was holding them back? They didn't understand how the system of legal documents worked to certify that title. They didn't really have the funding to go from their very, very remote community into the offices. And so Jungle Keepers helped them with that. And so really all we're doing is helping local people protect the forest that is their world. That's it.
If people donate, how will that help?
If people donate to Jungle Keepers, what you're doing is you're helping someone like JJ, who's an indigenous naturalist, who has the vision, who has seen forests be destroyed. He's trying to protect it before it's too late. You're saving mahogany trees, ironwood trees, kapok trees, skyscrapers of life, just monkeys, birds, reptiles, amphibians, birds, mammals, this entire avatar on Earth world of rainforest that produces a fifth of the oxygen we breathe and the water we drink. This incredible thing as far as I know, it's the most direct way to protect that. So the fact that we've, we have large funders who give us, $100,000 to protect this huge swath of land, and that goes through things like this and through Instagram. It goes directly to the local conservationists who work with the loggers to protect that land before it's cut. But one of the most impactful things that has happened this year in the wake of our last conversation was that I got an email from a mother, and she said, I'm a single mom and I work a few jobs and I can't afford to give you a ton of money, but me and my kids look at your Instagram often after dinner, and they really want to protect the heartbeats. They really want to protect the animals in the rainforest. And so we give $5 a month to Jungle Keepers. And it was, to me, that was so impactful because I used to be that little kid worried about the animals. And I saw how a few million raindrops can create a flood.
Yeah, I ask that people donate to Jungle Keepers. You guys are legit. That money is going to go a long way. JungleKeepers.org. If you somehow were able to raise very large, so the raindrops would make a waterfall, a very large amount of money. I don't know what that number is. Maybe $10 million, $20 million, $30 million. What are the different milestones along the way that could really help you on the journey of saving the rainforest?
If let's just say some company organization, or if enough people donated it, let's just say we got that 30 million. That money would go directly into stopping logging roads, into creating a corridor, a biological corridor that connects the uncontacted indigenous reserves with other tribal lands, with Manu National Park, with the Tambopata, which establishes essentially the largest protected area in the Amazon rainforest. And what makes this groundbreaking is that we're not doing this in the traditional way. We're doing this, take it to the people. And that's what's been so exciting, is that, when he started this, when JJ started this 30 years ago, he had no idea. His father wanted him to be a logger. He didn't have shoes until he was 13 years old. He grew up bathing in the river. He had no idea that a bunch of crazy foreigner scientists were going to show up, and some guy in a James Bond suit was going to come down here with microphones, and that all of a sudden the world would know that he was on this quest to protect this incredible ecosystem and all those little aliens.
Well, that's all the important thing to remember, that the people that are cutting down the forest, the loggers, are also human beings. Their families, they're basically trying to survive, and they're desperate, and they're doing the thing that will bring them money. And so they're just human beings. At the core of it, if they have other options, they will probably choose to give their life to saving the community, to first and foremost providing for their family, and after that, saving the community, helping the community flourish. And I think probably a lot of them love the rainforest. They grew up in the rainforest.
Yeah. I mean, look at Pico. Yeah. Pico used to be a logger, full-time logger, long-time logger. Now he loves conservation. Yo soy muy conservacionista.
Yeah. It's all about just providing people options. There's some dark stuff on the gold mine stuff you've talked about. You showed me parts of the rainforest where the gold mines are, and they're just kind of erasing the rainforest.
Yeah.
So at the edges, that's when the mining happens. And it's this ugly process of they're just destroying the jungle just for the surface layer of the sand or whatever that they process to collect just little bits of gold. And there's also very dark things that happen along the way as the communities around the gold mines are created. So the entirety of the moral system that emerges from that has things like prostitution, where 1/3 of the women that are drawn into that sex trafficking and prostitution are minors under 17 years old, 13 to 17-year-old. There's just a lot of really, really dark stuff.
I think that we have a rare chance to do something against that darkness. I think that this is an example of local people who have taken action done good work, been good to the people that have visited, harnessed a certain amount of international momentum. And now we're on the cusp of doing something historic. And so for the children in the communities along this river, it won't be being a prostitute in a gold mine. It'll be becoming a trained ranger. Like last month, our ranger coordinator and one of our female rangers went to Africa for a ranger conference. And it's like we're beginning to. This is someone from a little tiny village with thatched huts upriver. She went to Africa to talk about being a professional conservation ranger. And it's like that's changing lives. And her daughters then, she's married to Ignacio, the guy. Their kids are going to grow up seeing their parents walking around with the emblem on and go, oh, I want to. And then people like Pico and Pedro and all these guys that work here are going to go, well, we have to protect this forest. And then they start getting fascinated about the snakes. And then they start caring about the turtle eggs. And then all of a sudden they have a way of life, and nobody needs to go steal anybody's kids to be a prostitute in a gold mine. That's horrible. And so it's really a win-win for the animals, for the river, for the rainforest, for people. We're improving. It's biocentric conservation. It's just making everything better.
Yeah, I've read in an article that an estimated 1,200 girls between ages of 12 and 17 are forcibly drafted into child prostitution around the communities in the gold mines. At least 1/3 of the prostitutes in the camp are underage. The girls had ended up in the camp after receiving a tip that there were restaurants looking for waitresses and willing to pay top dollar. They jumped on a bus together and came down to the rainforest. What they found was not what they were expecting. The mining camp restaurants served food for only a few hours a day. The rest of the time, it was the girls themselves who were on the menu. Literally at the end of the road, and without the money to return home, the girls would soon become trapped in prostitution.
It's interesting to me that the most devastating destruction of nature, the complete erasure of the rainforest, burned to the ground, sucked through a hose, spit out into a disgusting mercury puddle, like the complete annihilation of life on Earth, goes hand in hand with the complete annihilation of a young life. It's like it's all based around the same thing. It's the light versus the dark. It's the destruction and the chaos versus a move towards order and hope. And it is incredibly dark, and this region is heavy with it.
Well, I'm glad you're fighting for the light. Is there like a milestone in the near future that you're working towards, like financially to the donations?
There is. In the next year and a half, as you saw in your time here, there's roads working around the Jungle Keepers concessions. All the work that the local people are doing to protect this land is trying to be dismantled by international corporations that are subcontracting logging companies here. And really what we need is $30 million in the next 2 years to protect the whole thing. You've seen the ancient mahogany trees, you've seen the families of monkeys, you've seen the caiman in the river. All of this is standing in the pathway of destruction. That road, they're going to come down that road, and men with chainsaws are going to dismantle a forest that has been growing since the beginning. This is so magical. Do you see the snake over there?
Yeah.
Do you?
Okay.
I'm just going to, don't move. I don't want you to move. I'm going to use this. The Amazon rainforest. This is the snakes. I've been hoping that you would get to see this snake. I have been praying.
Oh boy.
Okay. Let's just go right back into this. Look at this little beauty creation. Let's keep you away from the fire. Look at this little blood-headed tree snake.
Wow.
Such an incredible.
So tell me about the snake.
Harmless little snake. If you put your hand out, he'll probably just crawl onto your hand. Just be real careful with the fire. So look, I'm just going to put him like this. Yeah, that's just snake safety. So he's a tree snake. Yep, nice and slow, nice and slow, nice and slow. So you nice and slow, just really slow. Just be the tree. Be the tree that he climbs on. And this is like, again, this is a snake that's so thin and so small. And there you go. Nice and slow. Just be the tree. Let him crawl around. So he's going to try and do all this stuff. Let me see if I can just calm him down. Very active. So see like the snake the other night. Look at this. I can see the light through his body. To me, this is an animal. This is this strange little life form. His eyes are 2/3 of his head. I'm not joking. Look at their skull.
He's so tiny.
He's so
For
tiny.
people listening, there's a snake in Paul's hands right now. It's very, it's long, of course, but very skinny,
Very,
very light.
And also for everyone listening, the odds of that as we're sitting here doing this podcast, that a snake would just be crawling by in the jungle might sound like something that would happen, but the density of snakes in the Amazon rainforest makes this a very unique experience.
Can you tell me a little bit about the coloration?
Yeah,
A
so
little bit brown.
yeah, just to describe this as we were talking here, it's just a sort of banded white and brown snake with this tiny little head about the size of my pinky nail. 2/3 of this snake's head is made up of its gigantic eyes. It's got a small mouth, and it's about a third as thick as a pencil. It's basically a moving shoestring. It's incredibly thin. The only thing I am thinking, Lexo, is that if we have Dan come and just do some shots of.
Yeah, that's true.
Dan!
So what are we looking at?
The snake that was crawling behind us in the jungle that we were talking about jungle keeping and what we could do. And the snake just showed up at that moment. And this is a very active little snake who's out for a hunt tonight and wants to find something to eat. So this is a blunt-headed tree snake, totally harmless literally a moving shoestring, super beautiful little animal. When you talk about aliens, to me, this is an alien. Like, what are you thinking? What are you doing right now? What do you think about the fact that you are being handled by these giant humans?
And as you were saying, it reaches up to the leaves.
Yeah,
and
the
gets
snake
closer.
just naturally knows to go, look, put him anywhere near leaves, and he's like, I got this. He just wants to go right up into that tree. I just want you to try holding him, and real gentle, just be the tree. Yeah, and just kind of do the same thing you learned last night, just nice and gentle. Yep, and see, he's holding on to my finger right now. He's just going up. There you go. Perfect. Nice and easy. He's a little erratic. He's a little goofy.
Maybe his camera shot. Maybe a fan of the podcast. And gigantic eyes relative to his body size.
Oh, jeez.
Hello, moth. Traffic in the jungle.
And then for everyone listening, as we're handling the snake that we found that was crawling by us, like literally by our shoulders as we're talking, a bat flies through, no joke, 8 inches from Lex's ear. Like just zips past his head as he's holding a snake while we're sitting here in the middle. We're just in it. Now he's gonna try and back up.
How do you?
Yeah, why don't you let's encourage him.
He's weaved this way.
Yes. Okay. This is what I'm gonna do. I'm gonna say, thank you, Mr. Snake.
Thank you, Mr. Snake.
Thank you, Mr. Snake. Back up into the tree. There you go. And then we can resume normal podcasting now. Because
We really are in the jungle.
we
right
really
now.
are in the jungle. That's one of my favorite snakes. That's one of my favorite little aliens on this planet.
it's going on some long journey. It's gonna carry the rest of the night. So that little snake is one of the millions of life forms, heartbeats that you're trying to protect.
Exactly. To me, I, after almost 20 years down here, the people here have become my friends. The caiman on the river, the monkeys. When I fall asleep at night, I think about all the different heartbeats, all the different little creatures here that when they bulldoze this forest, when they chop down these trees, that they vanish, that we take away their world. And in that very evolutionary, historical sense of remembering the primordial soup, it's like these little creatures surviving out here somehow. We have the chance to save it. And even if you don't care about the little creature on the pale blue dot, each of these little creatures contributes to this massive orchestral whole that creates climactic stability on this planet. And the Amazon is one of the most important parts of that, and each of these little guys is playing a role in that.
One of the other fascinating life forms is other humans, but living a very different kind of life. So, uncontacted tribes. What do you find most fascinating about them?
What I find most fascinating about the uncontacted tribes is that while me and you are sitting here with microphones and a light, somewhere out there, in that darkness, in that direction, not so far away as the crow flies, there are people sitting around a fire in the dark, probably with little more than a few leaves over their heads, who don't even have the use of stone tools, who only have metal objects that they've stolen from nearby communities. They're living such primitive, isolated, nomadic lives in the modern world, and they're still living naked out in the jungle. It's truly incredible, truly remarkable, and I think that it's because they can't advocate for themselves, they can't protect themselves. It's sort of like, well, we can let them get shot up by loggers and let their land get bulldozed while they hide. They have no idea that their world is being destroyed. But they're sort of the scariest and most fascinating thing out there.
What do you think because you've spoken about them being dangerous, what do you think their relationship with violence is? Why is violence part of their approach to the external world?
So from the best I understand is that at the turn of the century, Industrial Revolution, we had sudden immense need for rubber, for hoses and gaskets and wires and tires and the war machine, and the only way to get rubber was to come down to the Amazon rainforest and get the local people who knew the jungle to go out into the jungle and cut rubber trees and collect the latex. And Henry Ford tried doing Fordlandia, tried having rubber plantations, but leaf blight killed it. And so you had this period of horrendous extraction in the Amazon where the rubber barons were coming down and just raping and pillaging the tribes and making them go out to tap these trees. And the uncontacted tribes said no. They had their 6-foot-long longbows, 7-foot-long arrows with giant bamboo tips, and they moved further back into the forest. And they said, we will not be conquered. And since that time, they've been out there, and it's confusing because in a way they're still running scared a century later, and their grandparents would have told them, the outside world, everyone you see in the outside world is trying to kill you, kill them first. So can you blame them for being violent? No. Is this river still wild because loggers were scared to go here for a long time, for almost a century late? That's why this forest is still here? Yes. And so is it a human rights issue that we protect the last people on Earth that have no government, no affiliation, no language that we can explain? We don't know what their medicinal plant knowledge is. We don't know their creation myths. We know nothing about them. And they're just out there right now with bows and arrows, living in the dark, surviving in the jungle, naked, without even spoons. Forget about the wheel. Forget about iPhones. They got nothing. And they're making it work.
We don't know their creation myths. So they have a very primitive existence. But do you think their values? First of all, do you think their nature is similar to ours, and how do their values differ from ours?
It's complicated because the anthropologist in me wants to say that they have a historical reason for the violent life that they have. You know, they experienced incredible generational trauma some time ago, and because they've been living isolated in the jungle, that has permeated to become their culture. They've become a culture of violence. But yet, the contacted modern indigenous communities that we work with, that are my friends that work here. Just the other day, we were speaking to one of them who was pulling spikes out of your hand while he was explaining that he tried to help them, the brothers, los hermanos. He tried to help them. He tried to give them a gift. And what did they do? They shot him in the head.
Yeah, he said there are brothers, and he tried to give them bananas, plantains, boat full of plantains, and they shot him.
They shot 3 arrows at him, and one of them actually hit him in the skull, put him in the hospital. He got helicopter evacuated from this community. And so he's brave for surviving, but he's a lucky survivor. They are incredibly accurate with those bamboo-tipped arrows, and those arrows are 7 feet long. So when you get hit by one, they come at a velocity that can rip through you. And the range on a shotgun is way shorter than the range on a longbow. You're talking about a couple hundred meters on a longbow. And they're deadly accurate. They can take spider monkeys out of a tree. And so there's stories of loggers, and I've seen the photos of the bodies of loggers who attacked one of the tribes. And the tribe hadn't done anything. These loggers came around the bend and started shooting shotguns at the tribe. And the tribe scattered into the forest. And as the loggers' boat went around the bend, they just started flying. Took out the boat driver, boat skidded to the side, and then everybody was standing in the river. You can't run. And the tribe just descended on them and just porcupined them full of arrows.
Shotgun versus bow. There's a shotgun shell here, by the way. Yeah, from the loggers.
Yeah, we picked that up yesterday.
Was that yesterday? I don't know. One of the things that happens here is time loses meaning in some kind of deep way that it does when you're in a big city in the United States, for example, and there's schedules and meetings and all this kind of stuff. It transforms the meaning, your experience of time, your interaction with time, your role of time, all of this. I've forgotten time, and I've forgotten the existence of the outside world.
And how does that feel?
It feels more honest. It also puts in perspective, like all the busyness, it kind of takes the ant out of the ant colony. It says, hey, you're just an ant, and this is just an ant colony, and there's a big world out there. Yeah, it's a chance to be grateful, to celebrate this earth of ours, and the things that make it worth living on, including the simple things that make the individual life worth living, such as water and then food. And the rest is just details. Of course, the friendships and social interaction, that's a really big one, actually. That one I'm taking for granted because I didn't get a chance yet to really spend time alone. And when I came here, I got a chance to hang out with you. And there's a kind of camaraderie, there's a friendship there. That's broken. That's a tough one too. I mean, you spent quite a lot of time alone in the jungle. You ever get alone on here?
Yeah. I mean, the first 15 years we were doing this, there would be times that JJ would be busy in town with his family, and I would, for sheer love of the rainforest, I would have to come alone out here. And we didn't have running water. I didn't have running water. I didn't have lights. All I had was a couple of candles in the darkness and a tent, and I was 20-something years old, living in the Amazon by myself. The boat sunk, and yeah, it's incredibly long. I had to learn through experience because I thought there's a period, I think when you're young, as a young man, I had this thing, like I wanted to prove that I could be like the explorers. I wanted to prove that I could handle the elements, that I could go out alone, that I could have these deep connective moments with the jungle. And it's like, I did that, and that's great. And you know what the kid from Into the Wild learned right before he died in that bus? That if you don't have somebody to share it with, it doesn't matter.
But I don't know, some kind of like even just deep human level. Like even if you have somebody to share it with, you ever just get alone out here? Just like this sense of like existential dread of like what the jungle has a way of not caring about any individual organism. It just kind of churns. It's like it makes you realize that life is finite quite intensely.
Yeah, just for me, it's comforting, because I find the rat race, the national narrative, the need to make money, but to worry about war, to be outraged about the newest thing that politician said and what that actor did, and it just is always just this just unending sort of media storm, and everyone's worried, and everyone's trying to optimize their sunlight exposure and find the solution and buy the right new thing. And to me, coming out here, first of all, I need something out here because I can help someone, I can help people, I can help these animals, and so I find my meaning out here. But also, there's losing the madness over the mountains. It's nature has always, and for many people, been where things make sense. And to me, I think I'm a simple analog type person, that it makes sense that when it rains, you get in the river to stay warm, and you wait for the dawn, and you see a little tree snake, and you say it makes more sense. And I think that the overwhelming, teeming complexity that is inside the ant mound of society can be dizzying for some people. And I think that maybe it's the dyslexia, maybe it's just that I love nature. But now, when I land in JFK, I feel like a frightened animal. Like it's as if you release like a some animal that had never seen it onto like into Times Square, and you just imagine this dog with its ears back running away from taxis and just cowering from the noise, and it's just hustle and bustle, and people are brutal, and how much you want it for? Get in the car, and screaming over the intercom, and just everything, sensory changes, and let's get home, okay, let's go, you got a meeting, you got to get to the next place, you got to give a talk, you got to say, here, when we finish up here, what are we going to do? We're going to eat some food, maybe go catch a crocodile, go walk around the jungle at night. Like, it's slower, it makes sense. And there's that deep meaning of that here, where we can be the guardians for good. We can hold that candle up and know for sure that we're protecting the trees from being destroyed. And it's that simple thing of just, this is good. There you go. It's simple. In society, I feel like everyone's always losing their minds and forgetting the most basic of fundamental truths. And out here, you can't really argue with them. When we needed water, it was like, shit, if we don't get water, we're fucked. And that's, to me, that's where the camaraderie comes from, because no matter what, we could go to the most fancy ass restaurant, the biggest, most famous people in the world, doesn't matter. We still remember what it was like standing around in the jungle. We're scared. We don't have water. We got reduced to the simplest form of humans, and that's something. And we survived, and that's cool.
And you take all those people in their nice dresses, in those fancy restaurants, you put them in those conditions, they're all going to want the same thing, it's water. Yes, it's all the same thing. How has your view of your own mortality evolved over your interaction with the jungle? How often do you think about your death?
Well, I don't anymore because I've come to believe that there is a benevolent God, spirit, creator, taking care of us, and I don't know. I think about my own dad. We have a little bit of time here, and we clearly know nothing about what we're doing here. And it seems like we just have to do the best we can. And so it doesn't scare me. I've come close to dying a lot of times, and I just don't think that you don't want to have a bad day. First of all, you don't want to be a statistic. You don't want to find out. You don't want to like be the first to try out a new product and oops, it crushed you. You know that's a terrible way to go. Or the people that used to, in the gold rush, they were using mercury and rhodium. Or lead, it was lead poisoning. And it's like, a few million people died that way. And it's like, you want a good guy. Standing down, hanging off the cliff, something worthy, warrior stuff.
But riding a 16-foot Black Cayman, just
boots on, screaming. Yeah. That'd be fun. That'd be a good one.
a lot of people say that you carry the spirit of Steve Irwin. In your heart, in the way you carry yourself in this world. I mean, that guy was full of joy.
If I have a percentage of Steve Irwin, I would be honest. But that guy, I think there's only one Steve. I think that he occupied his own strata of just shining light. Everything was positive, enthusiasm, love, and happiness, and save the animals, and do better, and let's make it fun. And that was so infectious that it sort of transcended his TV show, it transcended his conservation work, it transcended business and entrepreneurship. It just, through sheer magnetism and enthusiasm, everyone knew who Steve was. Everyone loved Steve. We still all love Steve. And so it's just amazing what one spirit can do. So if anybody, makes that comparison, I get really uncomfortable, because to me, Steve Irwin is like just the GOAT. And so I'm okay with that.
Well, I at least agree with that comparison. Having spent time with you, there's just an eternal flame of joy and adventure too, just pulling you. Dark question, but do you think you might meet the same end, giving your life in some way to something you love?
That is a dark question, but I think most likely I'll get whacked by loggers. I think that loggers or gold miners will take me out. I don't picture myself going from animals, but
that would be heartbreaking too.
Yeah, it would. But yeah, at the same time though, like the Kurt Cobain value of that, if I died doing what I love to protect the river, that'd be worth so much more. A lot. Like we'd get to 30 million if I died tomorrow for sure. So we've already talked about this with my friends. I'm like, if I get whacked, do the foundation, make the documentary, protect the river, protect the heartbeats, call it the heartbeats, jungle. Be ready for it, because these things do happen. People get pissed if you get in their way, and as many happy people whose lives were changing, there's also going to be some jealous, shitty, upset people who are mad that they can't make prostitutes out of young girls and keep destroying the planet, and so they might just erase you. Me.
Well, I hope you Clint Eastwood character. It's impossible to kill. I like how you squinted your eyes. On cue. Who do you think will play you in a movie?
God, somebody with the right nose. Somebody who can live up to this schnozzle.
Yeah. Italian. It's funny. Do you think of yourself as Italian or human, American?
That's the thing. I don't, fake. My life has been the United Nations of whatever. Like I don't. That's the other thing. You go back to society, everyone's obsessed with race. To me, I'm like, look, leopards have black babies and yellow babies, one mother. Like they're all leopards, and I'm so colorblind and race blind and everything else. I've lived in India. My friends are Peruvian. My family, we got Italian, Filipino, just everything. And so I'm so immersed in it that when I find it very jarring and disconcerting how much time we spend talking about different religions and just the differences in humans. I'm like, dude, we're talking about whether or not our ecosystems are going to be able to provide for us. We're talking about nuclear, but we're talking about this pretty serious shit on the table. And we're over here arguing over like shades of gray. It's so trivial. And that shit drives me crazy, and as does the outrage where it's like, no, you have to care more. I've been criticized for not caring enough about that, and I'm like, I'm gonna who cares what the hell I am? Who gives a shit what the hell? I'm a human. We're all human. Yeah, it's not that easy, but it's kind of fun sometimes. And we're at a better time. And like when you think about like the Middle Ages, like even if you were a king, you still didn't have that good. You didn't have pineapples in the winter. You didn't even know what the fuck a pineapple was. We have pineapples whenever we want. We can fly on planes to other countries.
Let's clarify. We, you mean a large fraction of the world. You know, I mentioned to you one of the biggest things I've noticed when I immigrated from the Soviet Union to the United States is how plentiful bananas and pineapples were, the fruit section, the produce section of the. Didn't have to wait in line at the grocery store to just eat as many bananas and pineapples and cherries and watermelon as you want. That's not everybody has that.
No, that's true. Not everybody has that,
but everybody could be that king.
But a growing number of people today
And feast on pineapple.
feast on pineapple and have toasters and new distracting apps all the way until
That's the thing that I also noticed is I don't think so much about politics when I'm here, or
you haven't even talked.
don't talk about the stupid differences between humans. Except to just kind of laugh at the absurdity of it on occasion.
Because you're trying to survive glaciers and jungles and avalanches and all kinds of shit.
Do you think nature is brutal, as Werner Herzog showed it, or is it beautiful?
I think the brutality of nature is the chaos, and I think that we are the only ones in it that are capable of organizing in the direction of order and life. So yes, there are going to be hyenas tearing each other apart. Yes, there's going to be war-torn nations and poor, starving children. But we as humans have the power to work towards something more organized.
So there is a force within nature that's always searching for order.
It's kind of a unifying theory if you think about it. I mean, all of the chaos of history and the wars and the chaos of nature, we through technology and organization, there's so many people, more people today than ever before, I think, who are so concerned, who realize that the incredible power, like what Jane Goodall says about, how you can affect the people around you, how you can do good in the world, how you can change the narrative of conservation from one of loss, of darkness, to one of innovation and light. Like we can do incredible things. We are the masters as humans. And I think that we're on the cusp of sort of understanding the true potential of that. Like I just think that more than ever, people have harnessed this ability to do good in the world, to be proud of it, and just change the darkness into something else.
When you have lived here and taken in the ways of the Amazon jungle, how are your views of God mentioned? How have your views of God change? Who is God?
I've come to believe that, again, back to that Christ wasn't a Christian, Muhammad wasn't a Muslim, and Buddha wasn't a Buddhist. That, like, the game is love and compassion. And the universe is chaotic and dangerous, and nature is chaotic and dangerous. But if this is some sort of a biological video game, our reality, that the test is, can we be good? And we go through it every day. Can you be good to your parent? Can you be good to your partner? Can you be good to your coworkers? It's so difficult. And we see how people can cheat and steal and hurt and destroy and the incredible impact that it has on the world, the returning exponential impact that one act of kindness, one act of good can do. And so I see nature as God. I see the religions as different cultural manifestations of the same truth, the same creative force. Maybe me and you have the same beliefs, and your aliens are my angels. Well, thank you for being one of the humans trying to do good in this world. And thank you for bringing me along for some adventure. And I believe more adventure awaits. Thank you for being enough of a psychopath to actually just sign on to come into the Amazon rainforest in a suit. And a year ago, when you told me that you were going to do this, I truly didn't believe you. So for being a man of your word and for the incredible work you do to connect humans and to create dialogue and to do good in the world, for all the adventures that we've had, thank you so much.
Thank you, brother.
Lex, thanks for that.
Thanks for listening to this conversation with Paul and Will. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from Joseph. The big question is whether you are going to be able to say a hearty yes to your adventure. Thank you for listening, and hope to see you next time.
The whole point of relativity is to say there's no such thing as right now when you're far away. And that is doubly true for what's inside a black hole. You might think, well, the galaxy is very big. It's really not. It's some tens of thousands of light years across and billions of years old. So you don't need to move at a high fraction of the speed of light to fill the galaxy.
The number of worlds is
Very big.
very, very, very big. Where do those worlds sit? Where do they go?
The short answer is the worlds don't exist in space. Space exists separately in each world.
The following is a conversation with Sean Carroll, his third time in this podcast. He is a theoretical physicist at Johns Hopkins, host of the Mindscape podcast that I personally love and highly recommend, and author of many books, including the most recent book series called The Biggest Ideas in the Universe. The first book of which is titled Space, Time, and Motion, and it's on the topic of general relativity. And the second, coming out on May 14th, so you should definitely pre-order it, is titled Quanta and Fields, and that one is on the topic of quantum mechanics. Sean is a legit active theoretical physicist, and at the same time, is one of the greatest communicators of physics ever. I highly encourage you to listen to his podcast, read his books, and pre-order the new book, support his work. This was, as always, a big honor and a pleasure for me. This is the Lex Friedman Podcast, and now, dear friends, with Sean Carroll. In book one of this series, The Biggest Ideas in the Universe, called Space, Time, Motion, we take on classical mechanics, general relativity, by taking on the main equation of general relativity and making it accessible, easy to understand. So, maybe at the high level, what is general relativity? What's a good way to start to try to explain it?
Probably the best way to start to try to explain it is special relativity, which came first, 1905. It was the culmination, right, of many decades of people putting things together, but it was Einstein in 1905. In fact, it wasn't even Einstein. I should give more credit to Minkowski in 1907. So Einstein in 1905 figured out that you could get rid of the ether, the idea of a rest ring for the universe, and all the equations of physics would make sense, with the speed of light being a maximum, But then it was Minkowski, who used to be Einstein's professor in 1907, who realized the most elegant way of thinking about this idea of Einstein was to blend space and time together into space-time. To really imagine that there is no hard and fast division of the four-dimensional world in which we live into space and time separately. Einstein was at first dismissive of this. He thought it was just like, oh, the mathematicians are over-formalizing again. But then he later realized that if space-time is a thing, it can have properties. And in particular, it can have a geometry. It can be curved from place to place. And that was what let him solve the problem of gravity. He had previously been trying to fit in what we knew about gravity from Newtonian mechanics, the inverse square law of gravity. It was new relativistic theory. It didn't work. So the final leap was to say gravity is the curvature of space-time. And that statement is basically general relativity.
And the tension with Minkowski was, he was a mathematician.
Yes.
So it's a tension between physics and mathematics. In fact, in your lecture about this equation, one of them, you say that Einstein is a better physicist than he gets credit for.
I know that's hard. That's a little bit of a joke there, right?
Yeah.
Because we all give Einstein a lot of credit, but then we also, partly based on fact, but partly to make ourselves feel better, tell ourselves a story about how later in life Einstein couldn't keep up. There were younger people doing quantum mechanics and quantum field theory and particle physics, and he was just sort of unable to really philosophically get over his objections to that. And I think that story about the latter part is completely wrong, like almost 180 degrees wrong. I think that Einstein understood quantum mechanics as well as anyone, at least up to the 1930s. I think that his philosophical objections to it are correct, so he should actually be taken much more seriously about that. And what he achieved in trying to think these problems through is to really basically understand the idea of quantum entanglement, which is kind of important these days when it comes to understanding quantum mechanics. Now, it's true that in the 40s and 50s, he placed his efforts in hopes for unifying electricity and magnetism with gravity that didn't really work out very well. All of us, try things that don't work out. I don't hold that against him. But in terms of IQ points, in terms of trying to be a clear-thinking physicist, he was really good.
What does greatness look like for a physicist? So how difficult is it to take the leap from special relativity to general relativity? How difficult is it to imagine that, consider space-time together, and to imagine that there's a curvature to this whole thing?
Yeah, that's a great question. I think that if you want to make the case for Einstein's greatness, it's not hard to do. There's two things to point at. One is in 1905, his famous miracle year, he writes 3 different papers on 3 wildly different subjects, all of which would make you famous just for writing that one paper. Special relativity is one of them. Brownian motion is another one, which is just little vibrations of tiny little dust specks in the air. But who cares about that? What matters is it proves the existence of atoms. He explains Brownian motion by imagining there are molecules in the air and deriving their properties. Brilliant. And then he basically starts the world on the road to quantum mechanics with his paper on, which again is given a boring label of the photoelectric effect. What it really was is he invented photons. He showed that light should be thought of as particles as well as waves. And he did all 3 of those very different things in 1 year. Okay. But the other thing that gets him genius status is, like you say, general relativity. So this takes 10 years, from 1905 to 1930. He wasn't only doing general relativity. He worked on other things. He invented the refrigerator. He did various interesting things. And he wasn't even the only one working on the problem. There were other people who suggested relativistic theories of gravity. But he really applied himself to it, and I think as your question suggests, the solution was not a matter of turning it. It was something fundamentally creative. In his own telling of the story, his greatest moment, his happiest moment, was when he realized that the way that we use modern, and say it in modern terms, if you were in a rocket ship, accelerating at 1 g, at 1 acceleration due to gravity, If the rocket ship were very quiet, you wouldn't be able to know the difference between being in a rocket ship and being on the surface of the Earth. Gravity is sort of not detectable, or at least not distinguishable from acceleration. So number one, that's a pretty clever thing to do. So number two, if you or I had that thought, we would have gone, we're pretty clever. He reasons from there to say, okay, if gravity is not detectable, then it can't be like an ordinary force, right? The electromagnetic force is detectable. You can put charged particles around. Positively charged particles and negatively charged particles respond differently to an electric field or to a magnetic field. He realizes that what his thought experiment showed, or he suggested, is that gravity isn't like that. Everything responds in the same way to gravity. How could that be the case? And then this other leap he makes is, it's the curvature of space-time, right? It's a feature of space-time. It's not a force on top of it. And the feature that it is curvature. And then finally, he says, okay, clearly I'm going to need the mathematical tools necessary to describe curvature. I don't know them, so I will learn that. And they didn't have MOOCs or AI helpers back in those days. He had to sit down and read the math papers and taught himself differential geometry and invented general relativity.
What about the step of including time as just another dimension? So combining space and time. Is that a simple mathematical leap, as Minkowski suggested?
It's certainly not simple, actually. It's a profound insight. That's why I said I think we should give Minkowski more credit than we do. He's the one who really put the finishing touches on special relativity. Again, many people had talked about how things change when you move close to the speed of light, what Maxwell's equations of electromagnetism predict and so forth, what their symmetries are. So people like Lorentz and Fitzgerald and Poincaré, the stories out there. And in the usual telling, Einstein sort of puts the capstone on it. He's the one who says, all of this makes much more sense if there just is no ether. It's undetectable. We don't know how fast. Everything is relative, thus the mean relativity. But he didn't take the actual final step, which was to realize that the underlying structure that he had invented is best thought of as unifying space and time together. I honestly don't know what was going through Minkowski's mind when he thought that. I'm not sure if he was, so mathematically adept that it was just clear to him, or he was really struggling it and did trial and error. I'm not sure.
So do you, for him or for Einstein, visualize the four-dimensional space, try to play with the idea of time is just another dimension?
Oh yeah, all the time. I mean, we of course make our lives easy by ignoring two of the dimensions of space. So instead of four-dimensional space-time, we just draw pictures of one dimension of space, one dimension of time, the so-called space-time diagram. But, maybe this is lurking underneath your question, but even the best physicists will draw, a vertical axis and a horizontal. Space, time. But deep down, that's wrong, because you're sort of preferring one direction of space and one direction of time, and it's really the whole two-dimensional thing that is space-time. The more legitimate thing to draw on that picture are rays of light, are light lines. From every point, there's a fixed direction at which the speed of light would represent. And that is actually inherent in the structure. The division into space and time is something that's easy for us to use.
What is the difference between space and time from the perspective of geometry?
It's the difference between X and Y when you draw axes on a piece of paper.
So there's really no difference.
There's almost no difference. There's one difference that is kind of important, which is the following. You have a curve in space. I'm going to draw it horizontally because that's usually what we do in space-time diagrams. You have a curve in space. You've heard the motto before that the shortest distance between 2 points is a straight line. If you have a curve in time, which is, by the way, literally all of our lives, right? We all evolve in time. So you can start with one event in space-time and another event in space-time. What Minkowski points out is that the time you measure along your trajectory in the universe is precisely analogous to the distance you travel on a curve through space. And by precisely, I mean it is also true that the actual distance you travel through depends on your path, right? So a straight line, shortest distance, and curvy line would be longer. The time you measure in space-time, the literal time that ticks off on your clock, also depends on your path. But it depends on it the other way. so that the longest time between 2 points is a straight line. And if you zig back and forth in space-time, it takes less and less time to go from point to point.
How do we make sense of that? The difference between the observed reality and the objective reality underneath it, or is objective reality a silly notion given general relativity?
I'm a huge believer in objective reality. I think that objective reality is real.
Yeah.
But I do think that people kind of are a little overly casual about the relationship between what we observe and objective reality in the following sense. Of course, in order to explain the world, our starting point and our ending point is our observation, our experimental input, the phenomena we experience and see around us in the world. But in between, there's a theory. There's a mathematical formalization of our ideas about what is going on. And if a theory fits the data and is very simple and makes sense in its own terms, then we say that the theory is right. And that means that we should attribute some reality to the entities that play an important role in that theory, at least provisionally until we find a better theory down the road.
I think a nice way to test the difference between objective reality and observed reality is what happens at the edge of the horizon of a black hole. So technically, as you get closer to that horizon, time stands still.
Yes and no. It depends on exactly how careful you're being. So here is a bunch of things I think are correct. If you imagine there is a black hole space-time, so like the whole solution of Einstein's equation, and you treat you and me as what we call test particles. So we don't have any gravitational fields ourselves. We just move around in the gravitational field. And that's obviously an approximation, okay? So let's imagine. And you stand outside the black hole, and I fall in. And as I'm falling in, I'm waving to you, from going into the black hole, you will see me move more and more slowly. And also the light from me is redshifted, so I'm embarrassed because I'm falling into a black hole. And there is a limit. There's a last moment that light will be emitted from me, from your perspective, forever, okay? Now you don't literally see it, because I'm emitting photons more and more slowly, right? Because from your point of view. So it's not like I'm equally bright. I basically fade from view in that picture. Okay, so that's one approximation. The other approximation is I do have a gravitational field of my own, and therefore as I approach the black hole doesn't just sit there and let me pass through, it kind of moves out to eat me up, because its net energy mass is going to be mine plus its. But roughly speaking, yes, I think so. I don't like to go to the dramatic extremes because that's where the approximations break down. But if you see something falling into a black hole, you see its clock ticking more and more slowly.
How do we know it's going?
You know? I mean, how would we? Because it's always possible that right at the last minute it had to change its heart and starts accelerating away, right? If you don't see it faster, you don't know. And let's point out that as smart as Einstein was, he never figured out black holes, and he could have. It's kind of embarrassing. It took decades for people thinking about general relativity to understand that there are such things as black holes, because basically Einstein comes up with general relativity in 1950. 2 years later, Carl Schwarzschild, derives the solution to Einstein's equation that represents a black hole, the Schwarzschild solution. No one recognized it for what it was until the 50s. David Finkelstein and other people. And that's just one of these examples of physicists not being as clever as they should.
Well, that's the singularity. That's the kind of the edge of the theory, the limit. So it's understandable that it's difficult to imagine the limit.
It is absolutely hard to imagine, and the black hole is very different in many ways from what we're used to. On the other hand, I mean, the real reason, of course, is that between 1915 and 1955, there's a bunch of other things that are really interesting going on in physics, all particle physics and quantum physics. So many of the greatest minds were focused on that. But still, if the universe hands you a solution to general relativity in terms of curved space-time, and it's kind of mysterious, certain features of it, I would put some effort in trying to figure it out.
So how does a black hole work? Put yourself in the shoes of Einstein. and take general relativity to its natural conclusion about massive.
It's best to think of a black hole as not an object so much as a region of space-time. Okay, it's a region with the property, at least in classical general relativity. Quantum mechanics makes everything harder, but let's imagine we're being classical for the moment. It's a region of space-time with the property that if you enter, you can't leave. Literally, the equivalent of escaping a black hole would be moving faster than the speed of light. They're both precisely equally difficult. You would have to move faster than the speed of light to escape from the black hole. So once you're in, that's fine. You know, in principle, you don't even notice when you cross the event horizon, as we call it. The event horizon is that point of no return, where once you're inside, you can't leave. But meanwhile, the space-time is sort of collapsing around you to ultimately a singularity in your future, which means that the gravitational forces are so strong they tear your body apart, and you will die in a finite amount of time. The time it takes, if the black hole is about the mass of the sun, to go from the event horizon to the singularity takes about 1/1,000,000th of a second.
And what happens to you if you fall into the black hole? Like, when you think of an object as information, that information is destroyed.
Well, you've raised a crucially difficult point. So that's why I keep needing to distinguish between black holes according to Einstein's theory of general relativity, book one of space-time and geometry, which is perfectly classical. And then come the 1970s, you start asking about quantum mechanics and what happens. According to classical general relativity, the information that makes up you when you fall into the black hole is lost to the outside. It's there, it's inside the black hole, but we can't get it. In the 1970s, Stephen Hawking comes along and points out that black holes radiate. They give off photons and other particles to the universe around them, and as they radiate, they lose mass, and eventually they evaporate, they disappear. So once that happens, I can no longer say the information about you or a book that I threw in the black hole or whatever is still there sitting behind the black hole. The black hole has gone away. So either that information is destroyed, like you said, or it is somehow transferred to the radiation that is coming out, to the Hawking radiation. A large majority of people who think about this believe that the information is somehow transferred to the radiation and information is conserved. That is a feature both of general relativity by itself and of quantum mechanics by itself. When you put them together, that's what we don't know that for sure. There are people who have doubted it, including Stephen Hawking for a long time. But that's what most people think. And so what we're trying to do now in a topic which has generated many, many hundreds of papers called the Black Hole Information Loss Puzzle is figure out how to get the information from you or the book into the radiation that is escaping the black hole.
Is there any way to observe Hawking radiation to a degree where you can start getting insight, or is this all just in the space theory?
Right now, we are nowhere to observing Hawking radiation. Here's the sad fact: the larger the black hole is, the lower its temperature. So, a small black hole, like a microscopically small black hole, might be very visible. It's giving off light. But something like the black hole at the center of our galaxy, 3 million times the mass of the sun or something like that, Sagittarius A star, that is so cold and low temperature that its radiation is never observed. Black holes are hard to make. We don't have any nearby. The ones we have out there in the universe are very, very faint. So there's no immediate hope for detecting them.
Allegedly, we don't have any nearby.
As far as we know.
Could tiny ones be hard to detect? Somewhere at the edges of the solar system?
So you don't want them to be too tiny or they're exploding, right? So they're very bright and then they'll be visible. But there's absolutely a regime where black holes are large enough not to be visible. Because the larger ones are fainter, right? Not giving off radiation, but small enough to not be detected through their gravitational wave. Yeah.
Psychologically, just emotionally, how do you feel about black holes? They're scary.
I love them. I love black holes. But the universe, weirdly, makes it hard to make a black hole, right? Because you really need to squeeze an enormous amount of matter and energy into a very, very small region of space. So we know how to make stellar black holes. A supermassive star can collapse to make a black hole. We know we also have these supermassive black holes, the center of the galaxies. We're a little unclear where they came from. I mean, maybe stellar black holes that got together and combined, but that's one of the exciting things about new data from the James Webb Space Telescope is that quite large black holes seem to exist relatively early in the history of the universe. So it was already difficult to figure out where they came from. Now it's going to be a tougher puzzle.
So these supermassive black holes were formed somewhere early on in the universe. I mean, that's a feature, not a bug, right? That we don't have too many of them. Otherwise, we wouldn't have the time or the space to form the little pockets of complexity that we call humans.
I think that's fair. Yeah. It's always interesting when something is difficult but happens anyway, right? I mean, the probability of making a black hole could have been 0. It could have been 1. But it's this interesting number.
Are there more intelligent alien civilizations than there are supermassive black holes?
Yeah, I have no idea. But I think your intuition is right that it would have been easy for there to be lots of civilizations, and then we would have noticed them already. And we haven't. So absolutely the simplest explanation for why we haven't is that they're not there.
Yeah, I just think it's so easy to make it now. But there must be, I understand that's the simplest explanation. But also,
how easy is it to make life? Or eukaryotic life, or multicellular life?
It seems like life finds a way. Intelligent alien civilization, sure, maybe there is somewhere along that chain a really, really hard to meet. But once you start life, once you get the origin of life, it seems like life just finds a way everywhere, in every condition. It just figures it out.
I mean, I get it. I get exactly what you're thinking. I think it's a perfectly reasonable attitude to have before you confront the data. I would not have expected there to be special anyway. I would have expected there to be plenty of very noticeable extraterrestrial civilizations out there. But even if life finds a way, even if we apply everything you say, how long does it take for life to find a way? What if it typically takes 100 billion years? Then we'd be alone.
But to you, really, there's most likely there's no alien civilization. I can't see it. I believe there's a ton of them, and there's another explanation why we can't.
I don't believe that very strongly. Look, I'm not going to place a lot of bets here. I would not. I'm both pretty up in the air about whether or not life itself is all over the place. It's possible, when we visit other worlds, other solar systems, very tiny microscopic life, ubiquitous, but none of it has reached some complex form. It's also possible there isn't any. It's also possible that there are intelligent civilizations that have better things to do than knock on our doors. So I think we should be very humble about these things.
And it's also possible there's a great filter where there's something fundamental about once the civilization develops complex enough technology, that technology is more statistically likely to destroy everybody versus to continue being creative.
That is absolutely possible. I'm actually putting less credence on that one just because you need it to happen every single time, right? Because even one, I mean, this goes back to von Neumann Johnson Neumann pointed out that you don't need to send the aliens around the galaxy. You can build self-reproducing probes and send them around the galaxy. And you might think, well, the galaxy is very big. It's really not. It's some tens of thousands of light years across and billions of years old. So you don't need to move at a high fraction of the speed of light to fill the galaxy.
So if you were an intelligent alien civilization, the dictator of one, you would just send out a lot of probes, self-replicating probes.
100%. And
spread out.
Yes. And what you should do, so if you want the optimistic spin, here's the optimistic spin. People looking for intelligent life elsewhere often tune in with their radio telescopes, right? At least we did before Arecibo was decommissioned. That's not a very promising way to find intelligent life elsewhere, because why in the world would a super intelligent alien civilization waste all of its energy by beaming it in random directions into the sky? For one thing, it just passes you by, right? So if we're here on Earth, we've only been listening to radio waves for 100 or a couple hundred years. Okay. So if an intelligent alien civilization exists for 1 billion years, they have to pinpoint exactly the right time to send us this signal. It is much, much more efficient to send probes and to park to go to the other solar systems, just sit there and wait for an intelligent civilization to arise in that solar system. This is kind of the 2001 monolith hypothesis, right? I would be less surprised to find sort of quiescent alien artifact in our solar system than I would to catch a radio signal from an intelligent civilization.
So you're a sucker for in-person conversation versus remote.
I just want to integrate over time. A probe can just sit there and wait, whereas a radio wave goes outside.
How hard is it for an alien civilization that you have to dig in to figure out a probe that is most likely to find a common language with whatever it finds?
Would that be like the elected leader of
Elected
the
leader,
alien?
democratic leader, elected leader of a democratic alien civilization. Yes.
I think we would figure out that language pretty quickly. I mean, maybe not as quickly as we do when different human tribes find each other, because obviously there's a lot of commonalities in humanity, but there is logic in math, and there is the physical world. You can point to a rock and go, rock, right? I don't think it would take that long. I know that Arrival, the movie, based on a Ted Chiang story, suggested that the way that aliens communicate is going to be fundamentally different, but also they have recognition and other things I don't believe in. So I think that if we actually find aliens, that will not be our long.
So there's a folks, one of the places you're affiliated with is Santa Fe, and they approach the question of complexity in many different ways, and ask the question in many different ways of what is life. Do you be able to find it? The thing you show up, probe shows up, the planet, we'll see a thing, and be like, yeah, that's a living thing.
Well, again, if it's intelligent and technologically advanced, the more short-term question of if we get some spectroscopic data from an exoplanet, so we know a little bit about what is in its atmosphere, how can we judge whether or not that atmosphere is giving us a signature of life existence? That's a very hard question that people are debating about. I mean, one very simple-minded, but perhaps interesting approach is to say small molecules don't tell you anything, because even if life could make them, something else could also make them. But long molecules, that's the kind of thing that life could do.
Size of complexity. I don't know. I just have this nervous feeling that we won't be able to detect it. We'll show up to a planet, have a bunch of liquid on it. We take a swim in the liquid, and we won't be able to see the intelligence. Whether that intelligence looks like something like ants, or we'll see movement, perhaps strange movement, but we won't be able to see the intelligence in it or communicate with it. I guess if we have nearly infinite amount of time to play with different ideas, we might be able to.
I'm in favor of this kind of humility, this intellectual humility that we won't know, because we should be prepared for surprises. But I do always keep coming back to the idea that we all live in the same physical universe. And let's put it this way. The development of our intelligence has certainly been connected to our ability to manipulate the physical around us. And so I would guess, without 100% credence by any means, but my guess would be that any advanced kind of life would also have that capability. Both dolphins and octopuses are potential counterexamples to that, but I think in the details there would be enough similarities.
I don't know how we got on this topic, but I think it was from supermassive black holes. So if we return to black holes and talk about the holographic principle more broadly, you have a recent paper on the topic. You're thinking about the topic in terms of rigorous research perspective, or just as a popular book writer. So what is holographic principle?
Well, it goes back to this question that we were talking about with the information and how it gets out. In quantum mechanics, certainly, arguably even before quantum mechanics comes along in classical statistical mechanics, there's a relationship between information and entropy. Entropy is my favorite thing to talk about. I've written books about and will continue to write books about. So Hawking tells us that black holes have entropy. And it's a finite amount of it. It's not an infinite. But the belief is, and now we're already getting quite speculative, the belief is that the entropy of a black hole is the largest amount of entropy that you can have in a region of space. It's sort of the most densely packed that entropy can. And what that means is there's sort of a maximum amount of information that you can fit into that region of space, and you call it a black hole. And interestingly, you might expect if I have a box and I'm going to put information in it, and I don't tell you how I'm going to put the information in, but I ask, how does the information I can put in scale with the size of the box? You might think, well, it goes as the volume of the box, because the information takes up some volume, and I can only fit in a certain amount. And that is what you might guess for the black hole, but it's not what the answer is. The answer is that the maximum information, as reflected in the black hole entropy, scales as the area of the black hole's event horizon, not the volume itself. So people thought about that in both deep and superficial ways for a long time, and they proposed what we now call the holographic principle. That the way that space-time and quantum gravity convey information or hold information is not different bits or qubits for quantum information at every point in space-time. It is something holographic, which means it's sort of embedded in or located in or can be thought of as pertaining to one dimension less of the three dimensions of space that we live in. So in the case of the black hole, the event horizon is two-dimensional, that is a three-dimensional universe. And the holographic principle would say all the information contained in the black hole can be thought of as living on the event horizon rather than in the interior of the black hole. I need to say one more thing about that, which is that this was an idea. What the idea I just told you was the original holographic principle, put forward by people like Gerard de Toof and Leonard Susskind, super famous physicist. Leonard Susskind is on my podcast. That gave a great talk. He's very, very good at explaining these things.
Landscape
podcast. That's right. Yes.
You don't just have physicists on.
I don't.
I love landscape.
Oh, thank you very much.
Curiosity is good.
Yeah, ideas.
Inspiration of ideas.
Yeah. But anyway, what I was trying to get at with Susskind and also with Cook were a little vague. They were a little hand-wavy about holography and what it meant. Where holography, this idea that information is sort of encoded on a boundary, really came into its own with Juan Maldacena in the 1990s and the ADS-CFE cosmos. We don't have to get into that in any detail, but it's a whole full-blown theory. It's two different theories. One theory in n dimensions of space-time without gravity, and another theory in n+1 dimensions of space-time with gravity. And the idea is that this n-dimensional theory is casting a hologram into the n+1 dimensional universe to make it look like it has gravity. And that's holography with a vengeance. And that's an enormous source of interest with theoretical physicists.
How should we picture what impact that has? The fact that you can store all the information. You can think of as all the information that goes into a black hole can be stored at the event horizon.
Yeah, I mean, it's a good question. One of the things that quantum field theory indirectly suggests is that there's not that much information in you and me compared to the volume of space-time we take up. As far as quantum field theory is concerned, you and I are mostly empty. And so we are not information dense, right? The density of information in us, or in a book, or a CD, or whatever, computer RAM, is indeed encoded by volume. There's different bits located at different points in space, but that density of information is super duper low. So we're just like the speed of light, or just like the Big Bang. For the information in a black hole, we are far away in our everyday experience from the regime where these questions become relevant. So it's very far away from our intuition. We don't really know how to think about these things. If you do the math, we don't feel it.
You can just write off that weird stuff happens.
Well,
in a
we'd
black
like
hole.
to do better, but we're trying. I mean, that's why we have our information loss puzzle, because we haven't completely solved it. So here's just one thing to keep in mind. Once space-time becomes flexible, which it does according to general relativity, And you have quantum mechanics, which has fluctuations in virtual particles and things like that. The very idea of a location in space-time becomes a little bit fuzzy, right? Because it's flexible, and quantum mechanics says you can't even pin it down. So information can propagate in ways that we might not have expected. And that's easy to say, and it's true, but we haven't yet come up with the right way to talk about it.
It's crazy how dense the information a black hole is. And then plus, like, quantum mechanics starts coming into play. So, you know, you almost want to romanticize the kind of interesting computation type things that are going on inside the black hole.
You do. But I'll point out one other thing. It's information dense, but it's also very, very high energy. So a black hole is kind of like a very, very, very specific random number, right? It takes a lot of digits to specify it, but the digits don't tell you anything. They don't give you anything useful to work on. So it takes a lot of information, but it's not of a form that we can learn a lot from.
But hypothetically, I guess as you mentioned, that information might be preserved. The information that goes into a black hole doesn't get destroyed. So what does that mean when the entropy is really high?
Well, the black hole, I said that the black hole is the highest density of information, but it's not the highest amount of information, because the black hole can evaporate. And when it evaporates, and people have done the equations for this, when it evaporates, the entropy that it turns into is actually higher than the entropy of the black hole was, which is good, because entropy is supposed to go up. But it's much more dilute, right? It's spread across a huge volume of space-time. So in principle, all that you made the black hole out of, the information that it took, is still there, we think, in that information, but it's scattered to the floor.
We just talked about the event horizon of a black hole. What's on the inside? What's the percent of it?
No one's been there, so
Came back to
yeah,
tell.
this is a theoretical prediction. But I'll say one super crucial feature of the black holes that we know and love, that the kind that Rothschild first invented. There's a singularity, but it's not at the middle of the black hole. So space and time are parts of two different parts of one unified space-time. The location of the singularity in the black hole is not the middle of space, but our future. It is a moment of time. It is like a big crunch. The Big Bang was an expansion of the singularity in the past. Big crunch probably doesn't exist, but if it did, it would be a collapse to a singularity in the future. That's what the interiors of black hole are like. You can be fine in the interior, but things are becoming more and more crowded. Space-time is becoming more and more warped, and eventually you hit a limit, and that's the singularity.
I wonder what time is like on the inside of a black hole.
Time always ticks by 1 second per second. That's all it can ever do. Time can tick by differently for different people, and so you have things like the twin paradox, where two people initially are the same age, one goes off and the speed of light and comes back. Now they're not. It doesn't work out, but the one that goes out and comes back will be younger because they did not take the shortest distance back. But locally, as far as you and your wristwatch are concerned, time is not funny. Time is your neurological signals in your brain and your heartbeat and your wristwatch. Whatever's happening to them is happening to all of them at the same time. So time always seems to be ticking along at the same time.
Well, if you fall into a black hole, and then I'm an observer just watching it, and then you come out once it evaporates a million years later, I guess you'd be exactly the same age. Have you aged at all?
You would be converted into photons. You would not be here.
Right. So it's not at all possible that the information is preserved exactly as it is.
It depends on what you might preserve. It's there in the microscopic configuration of the unit. It's exactly as if I took a regular book, made of paper, and I burned it. The laws of physics say that all the information in the book is still there in the heat and light and ash. You're never going to get it. It's a matter of practice. The principle is still there.
But what about the age of things from the observer perspective, from outside the black hole?
From outside the black hole, doesn't matter. Because they're inside the black hole.
No, so but is there okay? There's no way to escape the black hole except
To let it evaporate. But also, by the way, it's just in relativity, special relativity, forget about general relativity. It's enormously tempting to say, okay, here's what's happening to me right now. I want to know what's happening far away right now. The whole point of relativity is to say there's no such thing as right now when you're far away. And that is doubly true for what's inside a black hole. So you're tempted to say, well, how fast is their clock ticking? Or how old are they now? Not allowed to say that, of course.
Because it's the same, and so it doesn't make sense. What happens to time in the holographic place?
As far as we know, nothing dramatic happens. We're not anywhere close to being confident that we know what's going on here yet. So there are good unanswered questions about whether time is fundamental, whether time is emergent, whether it has something to do with quantum entanglement, whether time really exists at all. Different theories, different proponents of different things. But there's nothing specifically about holography that would make us change our opinions, whatever they have to do.
So holography is fundamentally about the question of space.
It really is, yeah.
And so time is just like a
time just goes along.
So all the questions about time is just almost like separate questions, whether it's emergent, all that.
Yeah, I mean that might be a reflection of our ignorance right now, but yes.
If we figure out a lot, millions of years from now about black holes, how surprised would you be if they travel back in time and told you everything you want to know about black holes? How much do you think there is still to know? And how mind-blowing would it be?
It does depend on what they say. I think that there are colleagues of mine who think that we're pretty close to figuring out how information gets out of black holes, how to quantize gravity, things like that. I'm more skeptical that we are pretty close. I think that there's room for a bunch of surprises to come. So in that sense, I suspect I would be surprised. The biggest and most interesting surprise would be if quantum mechanics itself were somehow superseded by something better. As far as I know, there's no empirical evidence-based reason I think quantum mechanics is not 100%. But it might not be. That's always possible. So, and there are, again, respectable friends of mine who speculate about it. So that's something that's the first thing I'd want to know.
Oh, so like the black hole would be the most clear illustration.
Yeah, that's what
If there's something really shown there.
I mean, maybe. The point is that black holes are mysterious for various reasons. So, yeah, if our best theory of the universe is wrong, that might help explain why.
Do you think it's possible we'll find something interesting like black holes sometimes create new universes, or black holes are a kind of portal through space-time to another place? And then our whole conception of what is the fabric of space-time changes completely because black holes, it's like Swiss cheese type of situation.
Yeah, that would be less surprising to me because I've already written papers about that. We don't have, again, strong reason to think that the interior of black hole leads to another universe. But it is possible, and it's also very possible that that's true for some black holes and not others. This is stuff we don't know. It's easy to ask questions, we don't know the answer to. The problem is, the questions that are easy to ask that we don't know the answer to are super hard to answer.
Because these objects are very difficult to test.
The regimes are just very far. So either literally far away in space, but also in energy or mass or time.
You've published a paper on the holographic principle, or that involves the holographic principle. What can you explain the details of that?
Yeah, I'm always interested in, since my first published paper, taking these wild speculative ideas and trying to test them against it. And the problem is, when you're dealing with wild speculative ideas, they're usually not well defined enough to make a prediction, right? Like, it's kind of, I know what's going to happen in some cases, I don't know what's going to happen in other cases. So we did the following thing. As I've already mentioned, the holographic principle, which is meant to reflect the information contained in black holes, seems to be telling us that there's less information, less stuff that can go on than you might naively expect. So let's upgrade naively expect to predict using quantum field theory. Quantum field theory is our best theory of fundamental physics right now. Unlike this holographic black hole stuff, quantum field theory is entirely local. In every point of space, something can go on, and you add up all the different points in space. Okay, not holographic at all. there's a mismatch between the expectations for what is happening, even in empty space, in quantum field theory, versus what the whole gravity principle would predict. How do you reconcile these two things? So there's one way of doing it that had been suggested previously, which is to say that in the quantum field theory way of talking, it implies there's a whole bunch more states, a whole bunch more ways the system could be than there really are. And yes, and just I'll do a little bit of math, because there might be some people in the audience who like math. If I draw two axes on a two-dimensional geometry, like the surface of the table, right? You know that the whole point of it being two-dimensional is I can draw two vectors that are perpendicular to each other. I can't draw three vectors that are all perpendicular to each other, right? They need to overlap a little bit. That's true for any numbers of dimensions. But I can ask, okay, how much do they have to overlap? If I try to put more vectors into a vector space than the dimensionality of the vectors, I make them almost perpendicular. And the mathematical answer is, as the number of dimensions gets very, very large, you can fit a huge extra number of vectors in that are almost perpendicular. So, in this case, what we're suggesting is the number of things that can happen in a region of space is correctly described by holography. It is somewhat overcounted by quantum field theory, but that's because the quantum field theory states are not exactly perpendicular. I should have mentioned that in quantum mechanics, states are given by vectors in some huge dimensional way. Very, 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 very large dimensional vectors. So maybe the quantum field theory states are not quite perpendicular to each other. If that is true, that's a speculation already, but if that's true, how would you know? What is the experimental deviation? And it would have been completely respectable if we'd gone through, made some guesses, and found that there is no noticeable experimental difference because, again, these things are in regimes very, very far away. We stuck our necks out. We made some very, very specific guesses as to how this weird overlap of states would show up in the equations of motion for particles like neutrinos. And then we made predictions on how the neutrinos would behave on the basis of those wild guesses, and we compared them with data. And what we found is we're pretty close, but haven't yet reached the detectability of the effect that we are predicting. In other words, well, basically one way of saying what we predict is if a neutrino, and there's reasons why it's neutrinos, you can look into it if you want, but it's not that interesting. A neutrino comes to us from across the universe, from some galaxy very, very far away. There is a probability as it's traveling that it will dissolve into other neutrinos because they're not really perpendicular to each other as vectors, as they would ordinarily be in quantum. And that means that if you look at neutrinos coming from far enough away, with high enough energy, they should disappear. Like if you see a whole bunch of nearby neutrinos, then further away, you should see fewer. And there's an experiment called IceCube, which is this amazing testament to the ingenuity of human beings, where they go to Antarctica and they drill holes and they put photodetectors on a string, a mile deep in these holes, and they basically use all of the ice in a cube. I don't know whether it's a mile or not. It's like a kilometer or something like that, some big region. That much ice is their detector. And they're looking for flashes when a cosmic ray or neutrino or whatever hits ice molecule, water molecule in the ice.
They make flashes in the ice.
Yes, they're looking for flashes.
And isn't there some crazy? I mean, what detector does that look like?
It's a bunch of strings, many, many, many strings with 360-degree photodetectors.
Yeah,
and you will.
That's really cool.
It's extremely cool. They've done amazing work, and they find neutrinos.
So they're looking for neutrinos.
Yeah. So the whole point is most cosmic rays are protons. Because why? Because protons exist, and they're massive enough that you can accelerate them very high energy. So high energy cosmic rays tend to be protons. They also tend to hit the Earth's atmosphere in decay. So neutrinos, on the other hand, punch rate. Occasionally, a neutrino will interact with a particle here on Earth. And there's neutrinos going through your body all the time, from the sun, from the universe, etc. And so if you're patient enough and you have a big enough part of the Antarctic ice sheet to look at, the nice thing about ice is it's transparent. So nature has built you a neutrino detector.
So why ice? So is it just because of the low noise and you get to watch this thing and it's
much more dense than air, but it's transparent.
so you have much more dense, so higher probability, and then it's transparency, and then it's also nowhere.
Well, that's all you need. There's not that
I
much
love
ice, right? Yeah. So there's more ice in Antarctica than anywhere else. Right. So anyway, you can go and you get a plot from the ice cube experiment on how many neutrinos there are that they detected with very high energy. And we predict in our weird little holographic guessing game that there should be a cutoff. You can see neutrinos as you get to higher and higher energies, and then they should disappear. If you look at the data, their data gives out exactly where our cutoff is. That doesn't mean that our cutoff is right. It means they lose the ability to do the experiment exactly where we predict the cutoff.
Oh boy. Okay. For why is there a limit?
Oh, just because there are fewer high energy neutrinos. So there's a spectrum, and it goes down. But what we're plotting here is the number of neutrinos versus energy. It's fading away, and they just get very, very few.
And you need the high energy neutrinos for your
Our
prediction.
effect is a little bit bigger for high.
And that effect has to do with almost a particular thing.
And let me just mention the name of Oliver Friedrich, who was a postdoc who led this. He deserves the credit. I was a co-author and a collaborator. I did some work, but he really does.
Thank you, Oliver. Thank you for pushing this wild science forward. Just to speak to that, the meta process of it. How do you approach asking these big questions and trying to, as a paper, as an experiment, like make a prediction, all that kind of stuff? What's your process?
There's a very interesting thing that happens once you're a theoretical physicist, once you become trained, graduate student, with some papers and whatever. Suddenly, you are the world's expert in a really infinitesimally tiny area of knowledge, right? And you know not that much about other areas. There's an overwhelming temptation to just drill deep, right? Just keep doing basically the thing that you started doing. But maybe that thing you started doing is not the most interesting thing to the world, to you, or whatever. So you need to separately develop the capability of stepping back and going, okay, now that I can write papers in that area, now that I'm sort of trained enough in the general procedure, what is the best match between my interests, my abilities, and what is actually interesting? And honestly, I've not been very good at that over my career. I have my process traditionally was I was working in this general area of particle physics, field theory, general relativity, cosmology, and I would sort of try to take things other people were talking about and ask myself whether or not it really fit together. Like my two, so I guess I have 3 papers that I've ever written that have done super well in terms of getting cited and things like that. One was my first ever paper. I get very little credit for it. That was my advisor and his collaborator, set that up. The other 2 were basically mine. One was right after we discovered that the universe was accelerating. So in 1998, observations showed that not only is the universe expanding, but it's expanding faster and faster. That's attributed to either Einstein's cosmological constant or some more complicated form of dark energy, some mysterious thing that kills the universe. And people were throwing around ideas about this dark energy stuff. What could it be? And so most of the people throwing around these ideas were cosmologists. They worked on cosmology. They think about the universe all at once. Since I like to talk to people in different areas, I was sort of more familiar than average with what a respectable working particle physicist would think about these things. And what I immediately thought was, you guys are throwing around these theories. These theories are wildly unnatural. They're super finely tuned. Like any particle physicist would just be embarrassed if you're talking about things. But rather than just scoffing at them, I sat down and asked myself, okay, is there a respectable version? Is there a way to keep the particle physicist happy, but also make the universe expand? And I realized that there is some very specific set of models that is relatively natural. And guess what? You can make a new experimental prediction on the basis of things. So I did that. People were very happy about that.
What was the thing that would make physicists happy, that would make sense of this fragile thing that people call dark energy?
So the fact that dark energy pervades the whole universe and is slowly changing, that should immediately set off alarm bells. Because particle physics is a story of length scales and time scales that are generally, guess what? Small, right? Particles are small, they vibrate quickly. And you're telling me now I have a new field and its typical rate of change is once every billion years, right? Like that's just not natural. And indeed, you could formalize that and say, look, even if you wrote down a particle that evolved slowly over billions of years, if you let it interact with other particles at all, that would make it move faster. Dynamics would be faster. Its mass would be higher, etc. So the whole story. Things need to be robust, and they all talk to each other in quantity. So how do you stop that from happening? And the answer is symmetry. You can impose a symmetry that protects your new field from talking to any other field. Okay? And this is good for two reasons. Number one, it can keep the dynamics slow. So if you can't tell me why it's slow, we just made that up, but at least it can protect it from speeding up because it's not talking to any other particles. And the other is it makes it harder to detect. Naively, experiments looking for fifth forces or time changes of fundamental constants of nature like the charge of the electron, these experiments should have been able to detect these dark energy fields. And I was able to propose a way to stop that from happening. The detection, yeah. Because a symmetry could stop it from interacting with all these other fields and therefore makes it harder. And just by luck, I realized, this is actually based on my first ever paper, there's one loophole. If you impose these symmetries to protect the dark energy field from interacting with any other field, there's one interaction that is still allowed that you can't rule out. And it is a very specific interaction between your dark energy field and photons. And it has the following effect. As a photon travels through the dark energy, the photon has a polarization, up, down, left, right, whatever it happens to be, and as it travels through the dark energy, that photon will rotate this polarization. This is called birefringence. And you can kind of run the numbers and say, you can't make a very precise prediction, so you're making up this model, but if you want to roughly fit the data, you can predict how much polarization rotation there should be. A couple of degrees. Okay? Not that much. So that's very hard to detect. People can try to do it. Right now, literally, we're on the edge of either being able to detect it or rule it out using the cosmic microwave band. And there it is, just truth in advertising. There is a claim on the market that it's been detected, that it's there. It's not very statistically significant. If I were to do that, I think it would probably go away. It's a very hard thing to observe. But maybe as you get better and better data, cleaner and cleaner analysis, it will persist and we will have directly detected the dark energy.
So if we just take the tangent of dark energy, people will sometimes bring up dark energy and dark matter as an example of why physicists have lost their mind. They're just going to say that there is this field that permeates everything, it's unlike any other field, and it's invisible. And it helps us work out something out. How do you respond to that?
Yeah. Well, two ways. One way is those people would have to say the same thing when we discovered the planet Neptune. Because it's exactly it. Where we have a very good theory, in that case, Newtonian gravity in the solar system. We made predictions. The predictions were slightly off. The motion of the outer planet. You found that you could explain that motion by positing something very simple. One more planet in a very, very particular place. And you went and looked for it, and there it was. Right? That was the first successful example of finding dark.
Matter that we can't see.
Neptune was dark.
Yeah.
There's a difference between dark matter and dark energy, right? Dark matter, as far as we are hypothesizing it, is a particle. It's just a particle that interacts with us very weakly. So we know how much of it there is. We know more or less where it is. We know some of its properties. We don't know specifically what it is. But it's not anything fundamentally mysterious. It's a particle. Dark energy is a different story. So dark energy is indeed uniformly spread and has this very weird property that it doesn't seem to evolve as far as we can tell. The same amount of energy in every cubic centimeter of space from moment to moment. That's why far and away the leading candidate for dark energy is Einstein's cosmological constant. The cosmological constant is strictly constant, 100% constant. The data say it better be 98% constant or better, so 100% constant works, right? And it's also very robust. It's just there, it's not doing anything, it doesn't interact with any other particles. It makes perfect sense. Probably the dark energy is. The dark matter, super important to emphasize here. It was hypothesized at first in the 70s and 80s, mostly to explain the rotation of galaxies. Today, the evidence for dark matter is both much better than it was in the 1980s and from different sources. It is mostly from observations of the cosmic background radiation or large scale stars. So we have multiple independent lines of evidence, also gravitational lensing and things like that, many pieces of evidence that say that dark matter is there. And also that say that the effects of dark matter are different than if you modify gravity. So that was my first answer to your question is dark matter, we have a lot of evidence for it. But the other one is, of course, we would love it if it weren't dark matter. Our vested interest is 100% aligned with it being something more cool and interesting than dark matter, because dark matter is just a particle. That's the most boring thing in the world.
And it's non-uniformly distributed space, dark matter.
Absolutely, yeah. So you can even see maps of it that we constructed from gravitational lenses.
So verifiable sort of clumps of dark matter in the galaxy that explains stuff.
Bigger than the galaxy. Right? We think that in the galaxy, dark matter is lumpy, but it's weaker. Its effects are weaker. But on the scale of large scale structure and clusters of galaxies and things like that, yes, we can show you where the dark matter is.
Could there be a super cool explanation for dark matter that would be interesting as opposed to just another particle that sits there in clumps?
The super cool explanation would be modifying gravity rather than sadly, that doesn't really work. I've tried. That's my third paper that was very successful. I tried to unify dark matter and dark energy together. That was my idea. That was my aspiration, not even an idea. I tried to do it. It failed even before we wrote the paper. I realized that my idea did not help. It could possibly explain away the dark energy, but it would not explain away the dark energy. And so I thought it was not that interesting, actually. And then two different collaborators of mine said, has anyone thought of this idea? Like, they thought of exactly the same idea, completely independently. I said, well, if three different people found the same idea, maybe it is interesting. And so we wrote the paper. And yeah, it was very interesting. People were very interested.
Can you describe this paper a little bit? It's fascinating how much of a thing there is, dark energy, dark matter, and we don't quite understand it. So what was your dive into this work?
So here is what we know about dark matter and dark energy. They become important in regimes where gravity is very, very, very weak. That's kind of the opposite from what you would expect if you actually were modifying gravity. Like, there's a rule of thumb in quantum field theory, etc., that new effects show up when the effects are strong, right? We understand weak fields, we don't understand strong fields. But okay, maybe this is different, right? So what do I mean by when gravity is weak? The dark energy shows up late in the history of the universe. Early in the history of the universe, the dark energy is irrelevant. But remember, the density of dark energy stays constant. The density of matter and radiation go down. So at early times, dark energy was completely irrelevant compared to matter and radiation. At late times, it becomes important. That's also when the universe is dilute and gravity is relatively weak. Now think about galaxies, okay? A galaxy is more dense in the middle, less dense on the outside. And there's a phenomenological fact about galaxies that in the interior of galaxies, you don't need dark matter. that's not so surprising because the density of stars and gas is very high there, and the dark matter is something. But then there's generally a radius inside of which you don't need dark matter to fit the data, outside of which you do need dark matter to fit the data. So that's again when gravity is weak, right? So I asked myself, of course we know in field theory, new effects show up when fields are strong, not weak, but let's throw that out of the window, and I write down a theory where gravity alters when it is weak. And we've already said what gravity is. What is gravity? It's the curvature of space. So there are mathematical quantities that measure the curvature of space. And generally, you would say, like, I have an understanding Einstein's equation, which I explained to the readers in the book, relates the curvature of space-time to matter and energy. The more matter and energy, the more curvature. So I'm saying, what if you add a new term in that says the less matter and energy? No reason to do that, except to fit the data, right? So I tried to unify the need for dark matter and the need for dark.
That would be really cool if that was the case.
Super cool, right? It'd be the best. It'd be great.
But
it didn't work.
It would be really interesting if gravity did something funky when there's not much of it. Like they're almost like at the edges of it, it gets that noisy.
That was exactly the hope. But the great thing about physics is there are, right? And you can come up with the words and you can wave your hands, but then you got to write down the equations, and I did. And I figured out that it could help with the dark energy acceleration universe. It doesn't help with that.
It's just such a the scale of galaxies, the scale of solar systems, which is a sharp way.
Yeah, it does. I agree. And again, that's why it is a little bit, I tear my hair out when people who are not physicists think, accuse physicists, like you say, of sort of losing the plot because they need dark matter and dark energy. I don't want dark matter and dark energy. I want something much cooler than that. I tried, but you got to listen to the equations and to the data.
You mentioned 3 pages. Your first awesome paper ever. Yeah. Your second awesome paper ever. Of course, you wrote many papers, so you're being very harsh on the others.
Well, by the way, this is not awesome news. This is impact, right? There's no correlation between awesomeness and impact. Right? Some of my best papers fell without a stone. Vice versa, right? Yeah. The first paper was called Limits on the Lorentz and Parity Violating Modification of Electromagnetism, or Electrodynamics. So we figured out how to violate Lorentz invariance, which is the symmetry underlying relativism. And the important thing is we figured out a way to do it that didn't violate anything else and was experimentally testable. So people love that. The second paper was called Quintessence and the Rest of the World. So quintessence is this dynamical dark energy field. The rest of the world is because I was talking about how the quintessence field would interact with other particles and fields and how to avoid the interactions you don't want. And the third paper was called Is Cosmic Speed Up Due to Gravitational Physics? So you see the common theme. I'm taking, what we know, standard model of particle physics, general relativity, tweaking them in some way, and then trying to fit the data.
And trying to make it so it's experimentally.
Ideally, yes, that's right. That's the goal.
You wrote the book Something Deeply Hidden on the Mysteries of Quantum Mechanics, and a new book coming out soon, part of that Biggest Ideas in the Universe series we mentioned, called Quanta and Fields. So that's focused on quantum mechanics. Big question first. Biggest ideas in the universe. What to you is most beautiful, or perhaps most mysterious about quantum mechanics?
Quantum mechanics is a harder one. I wrote a textbook on general relativity, and I started it by saying general relativity is the most beautiful physical theory ever invented. I will stand by that. It is less fundamental than quantum mechanics, but quantum mechanics is a little more mysterious. So it's a little bit sludgy right now. If you think about how we teach quantum mechanics to our students, the Copenhagen institution, it's a god-awful mess. Like, no one's going to accuse that of being very beautiful. I'm a fan of many worlds interpretation of quantum mechanics, and that is very beautiful in the sense that fewer ingredients, just one equation, and it could cover everything in the world. It depends what you mean by beauty, but I think that the answer to your question is quantum mechanics can start with extraordinarily austere, tiny ingredients, and in principle lead to the world. Right? That boggles my mind. It's like much more comprehensive. General relativity is about gravity. That's great. Quantum mechanics is about everything, and seems to be up to the task. And so I don't know, is that beauty or not? But it's certainly impressive.
So both for the theory, the predictive power of the theory, and the fact that the theory describes tiny things creating everything we see around us.
It's a monist theory. In classical mechanics, I have a particle here, particle there. I describe them separately. I can tell you what this particle is doing, what that particle is doing. In quantum mechanics, we have entanglement, right? As Einstein pointed out to us in 1935. And what that means is there is a single state for these two particles. There's not one state for this particle, one state for the other particle. And indeed, there's a single state for the whole universe, called the wave function of the universe, if you want to call it that. And it obeys one equation, and is our job then to sort of chop it up, carve it up to figure out how to get tables and chairs.
You mentioned the many worlds interpretation, and it is in fact beautiful, but it's one of your more controversial things to stand behind.
Yeah,
You've probably gotten a bunch of flack for it.
I'm a big boy. I can take it.
Well, can you first explain it, and then maybe speak to the flack you've got?
Sure. You know, the classic experiment to explain quantum mechanics to people is called the Stern-Gerlach experiment. You're measuring the spin of a particle, okay? And in quantum mechanics, the spin is, it's just a spin. It's the rate at which something is rotating around in a very down-to-earth sense. The difference being is that it's quantized. So for something like a single electron or a single neutron, it's either spinning clockwise or counterclockwise. Those are the only two, let's put it this way, those are the only two measurement outcomes you will ever get. There's no spinning faster or slower. It's either spinning one direction or the other. That's two choices, okay? According to the rules of quantum mechanics, I can set up an electron, let's say, in a state where it is neither purely clockwise or counterclockwise, but a superposition of both. And that's not just because we don't know the answer, it's because it truly is both until we measure it. And then when we measure it, we see one or the other. So this is the fundamental mystery of quantum mechanics, that how we describe the system without looking at it is different from what we see when we look at it. So we teach our students in the Copenhagen way of thinking is that the act of measuring the spin of the electron causes a radical change in the physical state. It spontaneously collapses from being a superposition, clockwise and counterclockwise, to being one or the other. And you can tell me the probability that that happens, but that's all you can do. And I can't be very specific about when it happens, what caused it to happen, why it's happening, none of that. That's all called the measurement of quantum. So many worlds just says, look, I just told you a minute ago that there's only one wave function for the whole universe. And that means that you can't take too seriously just describing the electron. You have to include everything else in the universe. In particular, you clearly have to interact with the electron in order to measure it. So whatever is interacting with the electron should be included in the wave function that you're describing. And look, maybe it's just you. Maybe your eyeballs are able to perceive it, but okay, I'm going to include you in the wave function. And if you do that, let's be, since you have a very sophisticated listenership, I'll be a little bit more careful than ever. What does it mean to measure the spin of the electron? We don't need to go into detail, but we want the following thing to be true. If the electron were in a state that was 100% spinning clockwise, and we want the measurement to tell us it was spinning clockwise. We want your brain to go, yes, the electron is spinning clockwise, right? Likewise, if it was 100% counterclockwise, we want to see that, to measure that. The rules of quantum mechanics, the Schrödinger is 100% true. That if you want to measure it clockwise when it's clockwise, and measure it counterclockwise when it's counterclockwise, then when it starts out in a superposition, what will happen is that you and the electron will entangle with each other. And by that I mean that the state of the universe evolves into part saying the electron was spinning clockwise and I saw it clockwise. And part of the state is the superposition with the part that says the electron was spinning counterclockwise and I saw it clockwise. Everyone agrees with this. Entirely uncomplicated, straightforward consequence of the Schrodinger. And then Niels Bohr would say, and then part of that wave function disappears. And we're in the other part. And you can't predict which part it will be, only the probability. Hugh Everett, who was a graduate student in the 1950s, says, I have a better idea. Part of the wave function does not magically disappear. It stays there. The reason why that idea, Everett's idea, that the whole wave function always sticks around, just always was not thought of years before, is because naively you look at it and go, okay, this is predicting that I will be in a superposition. That I will be in a superposition of having seen the electron be clockwise and having seen it be counterclockwise. No experimenter has ever felt like this. You always see an outcome. Okay? Everett's move, which is kind of genius, was to say the problem is not the Schrodinger equation. The problem is you have misidentified yourself in this Schrodinger. You have said, oh, look, there's a person who saw counterclockwise. There's a person who saw clockwise. I should be in that superposition of both. It's like, no, you're not. Because the part of the wave function in which the spin was clockwise, once that exists, it is completely unaffected by the part of the wave function that says the spin is counterclockwise. They are apart from each other. They are uninteractive. They have no influence. What happens in one part has no influence in the other part. So Everett says the simple resolution is to identify yourself as either the one who saw spin clockwise or the one who saw spin counterclockwise. There are now two people once you've done that experiment. The Schrodinger equation doesn't have to be messed with. All you have to do is locate yourself correctly in the wave function. That's my
The number of worlds is
very big.
very, very, very big. Where do those worlds fit? Where do they go?
The short answer is the worlds don't exist in space. Space exists separately in each world. So, I mean, there's a technical answer to your question, which is Hilbert space. Space of all possible quantum states. But physically, we want to put these worlds somewhere. That's just a wrong intuition that we have. There is no such thing as a physical spatial location of the world. The space is inside the world.
One of the properties of this interpretation is that you can't travel from one world to another. That's right. Which kind of makes you feel that they're existing separately.
They are existing separately and simultaneously.
And simultaneously,
Without locations in space.
without locations in space. How is it possible to visualize them existing without locations?
The real answer, the honest answer, is the equations predict. If you can't visualize it, so much worse for you. The equations are crystal clear, probably.
Is there a way to get to the closer to understanding and visualizing the weirdness of the implications of this?
I don't think it's that hard. It wasn't that hard for me. I don't mind the idea that when I make a quantum mechanical measurement, there is later on in the universe multiple descendants of my present self who got different answers to that measurement. I can't interact with it. Hilbert space, the space of all quantum wave functions, was always big enough to include all of them. I'm going to worry about the parts of the universe I can observe. So let's put it this way. Many worlds comes about by taking the Schrodinger equation. The Schrodinger equation was invented to fit the data with the spectrum of different atoms, different emission and absorption. And it's perfectly legitimate to say, well, okay, you're taking the Schrodinger equation, you're extrapolating, you're trusting it, believing it, beyond what we can observe. I don't want to do that, right? That's perfectly legit, except Okay, then what do you do? Come up with a better theory. You're saying you don't believe the Schrodinger equation. Tell me the equation that you believe in. Turns out, when people have done that, turns out it's super hard to do that in a legitimate way.
And many worlds is a really clean.
Absolutely, the most austere, clean, no extra baggage theory.
So if it in fact is correct, isn't it the weirdest thing of anything we know?
Yes. In fact, let me put it this way. The single best reason, in my mind, to be skeptical about things is not because it doesn't make sense or it doesn't fit the data or I don't know where the worlds are going or whatever. It's because to make that extrapolation, to take seriously these things, another requires new philosophy, requires a new way of thinking about identity, about probability, about prediction, a whole bunch of things. It's work to do that philosophy, and I've been doing it, and others have done it, and I think it's very, very doable. But it's not straightforward. It's not a simple extrapolation of what we already know. It's a grand extrapolation very far away. And if you just wanted to be sort of methodologically conservative and say, that's a step too far, I don't want to buy it, I'm sympathetic to that. I think that you're just moving out. I think that you should have more courage. But I get the impulse.
And there is, under many worlds, an era of time where if you rewind it back, there's going to be one initial state.
That's right. All of quantum mechanics, all different versions require a kind of arrow time. It might be different every time. But the quantum measurement process is irreversible. You measure something, it collapses, you can't go back. If someone tells you the outcome, if I say, I measured an electron, it spin its clockwise. And they say, what was it before I measured it? You know there was some part of it that was clockwise, but you don't know how much, right? And many worlds just make it. But the nice thing is that the kind of arrow time you need in many worlds is exactly the kind of arrow time you need anyway for entropy and thermodynamics and so forth. You need a simple, low entropy initial state. That's what you need.
So if you actually look at, under many worlds, the entire history of the universe, correct me if I'm wrong, but it looks very deterministic. In each moment, does the moment contain the memory of the entire history of the universe? To you, does the moment contain the memory of everything that preceded it?
As far as we know, so according to many worlds, the wave function of the universe, all the branches of the universe once, all the world, does contain all the information. Calling it a memory is a little bit dangerous. It's not the same kind of memory that you and I have in our brains, because our memories rely on the arrow time. And the whole point of the Schrodinger equation or Newton's laws is they don't have an arrow time built in. They're reversible. The state of the universe not only remembers where it came from, but also determines where it's going to go.
But our memories doesn't do replay. Can we do this?
We can, but the act of forming a memory increases the entropy of the universe. It is an irreversible process also, right? You can walk on the beach, leave your footprints there. That's a record of your passing. It will eventually be erased by the ever-increasing entropy of the universe.
But you can imperfectly replay it. I guess, can we travel back in time imperfectly?
Oh, it depends on the level of precision you're trying to ask that question. You know, the universe contains the information about where the universe was, but you and I don't. So we're nowhere close.
Because what computationally is very costly to try to consult the universe.
Well, it depends on, again, exactly what you're asking. Like, there are some simple questions. Like, what was the temperature of the universe 30 seconds after the Big Bang? We can answer that, right? That's kind of amazing. We can answer that with pretty high precision. But if you want to know where every atom was, no.
What to you is the Big Bang? Why did it happen?
We have no idea. I think that's a super important question that I can imagine making progress on. right now and more or less maximally uncertain about what the answer is.
I think black holes will help.
No, potentially. Not that much. Quantum gravity will help, and maybe black holes will help us figure out quantum gravity, so indirectly, yes. But we had a situation where general relativity, Einstein's theory, unambiguously predicts there was a singularity in the past. The moment of time, the universe had infinite curvature, infinite energy, infinite expansion rate, the whole thing. That's just a fancy way of saying the theory has broken down. And classical general relativity is not up to the task of what they would really have at that moment. So it is completely possible there was, in some sense, a moment of time before which there were no other moments. And that would be the Big Bang. Even if it's not a classical general relativity kind of thing, quantum mechanics is involved, maybe that's what happens. It's also completely possible there was time before that, space and time, and they evolved into our hot Big Bang by some percent.
And if time and space are emerging from the before you start getting real weird.
Well, I think that if there is a first moment of time, that would be very good evidence, or that would fit hand in glove with the idea of time. If time is fundamental, then it tends to go forever. It's fundamental.
Well, yeah, I mean, the general formulation of this question is what's outside of it. Well, what's outside of our universe. So in time and in space. I know it's a finite question. I understand. I apologize.
That's my life. My life is asking finite questions.
Okay.
Some of them, the answer is, that's not the right way.
Okay. But is it possible to think at all about what's outside our universe?
It's absolutely legit to ask questions, but you have to be comfortable with the possibility that the answer is there's no such thing as outside of us. Absolutely on the table. In fact, that is the simplest, most likely to be correct.
But it's the only thing in the universe that wouldn't have an outside.
If the universe is the totality of everything, it does not have an outside.
It's so weird to think there's not an outside. We want there to be. We want there to be sort of a creator, a creative force that led to this. Like, an outside, like this is our town, and then there's a bigger world, and there's always a bigger world.
Because that is our experience. That's the world we grew up in, right? The universe doesn't need to obey this.
Such a weird thing.
When I was a kid, that used to keep me up at night. Like, what if the universe had not existed?
Right. And it feels like a lot of pressure that if this is the only universe, and we're here, one of the few intelligent civilizations, maybe the only one. It's the old theories that we're in the center of everything. It just feels suspicious. That's why many worlds is kind of exciting to me because it's humbling in all the right kinds of ways. It feels like infinity is the way it's going. Yeah.
There's one pitfall that I'll just mention, because there's a move that is made in these theoretical edges of cosmology that I think is a little bit mistaken, which is to say, I'm going to think about the universe on the basis of imagining that I am a typical observer. This is called the principle of typicality, or the principle of mediocrity, or even the Copernican principle. Nothing special about me, I'm just typical in the universe. But then you draw some conclusions from this. And what you end up realizing is you've been hilariously presumptuous, because by saying I'm a typical observer in the universe, you're saying typical observers in the universe are like me. And that is completely unjustified by anything. So I'm not telling you what the right way to do it is, but these kinds of questions that are not quite grounded in experimental verification or falsification are ones you have to be very careful about.
That to me is one of the most interesting questions. There's different ways to approach it, but like, what's outside of this? Well, how did the Big Bang start? How do we get something from nothing? That's always the thing you're sneaking up to. When you're studying all of these questions, you're always thinking, that's where the black hole and unifying and getting quantum gravity all this stuff. So you're always sneaking up to that question of where did all of this come from? So, and I think that's probably an answer. Right? No. It doesn't have to. Do you think there could be a turtle that refuses to reveal its identity? Yes.
I think that specifically the question, why is there something rather than nothing, does not have the kind of answer we would ordinarily attribute to why questions. Because typical why questions are embedded in the universe. And when we answer them, we take advantage of the features of the universe that we know now. The universe itself, as far as we know, is not embedded in anything bigger or stronger, and therefore it can just be.
So you think it's possible that this whole place is simulated?
Sure.
It's a really interesting, dark, twisted video game while existing.
You know, my own podcast listeners, Mindscape listeners, tease me because they know from my AMA episode that if you ever start a question by asking, do you think it's possible that? The answer is going to be yes. That might not be the answer you care about, but it's possible, sure, as long as you're not, adding two even numbers together and getting an odd number.
When you say it's possible, there's a mathematical yes, and then there's more of like intuitive.
Yeah, you want to know what is plausible. You want to know if there's a reasonable non-zero credence attached to it. I don't think that there's any philosophical knockout objection to the simulation hypothesis. I also think there's absolutely no reason to take it seriously.
Do you think humans will try to create one? I guess that's how I always think about it. I see what I've spent quite a bit of time over the past few years, and a lot more recently, in virtual worlds, and just am always captivated by the possibility of creating higher and higher resolution worlds. And as we'll talk a little bit about artificial intelligence, so the advancement on the Sora front, you can automatically generate those worlds. And the possibility of existing in those automatically generated worlds is pretty exciting. As long as there's consistent physics, quantum mechanics, and relativity that governs the generation of those worlds. Yep. So it just seems like humans will sure exciting.
Yeah, I think they will create better and better simulations. I think the philosopher David Chalmers has done what I consider to be a good job of arguing that we should treat things that happen in virtual reality and in simulated realities as just as real as the reality to be experienced. I also think that as a practical matter, people realize how much harder it is to simulate a realistic world than we naively believe. So this is not a my lifetime kind of work.
Yeah, it's a practical matter of going from a sort of a prototype that's impressive to a thing that governs everything. Similar question on this front is in AGI. You said that we're very far away from AGI.
I want to eliminate the phrase AGI.
So, basically, when you're analyzing large language models and seeing how far they from whatever AGI is, and we could talk about different notions of intelligence, that we're not as close as kind of some people in public view are talking about. So what's your intuition behind that?
My intuition is basically that artificial intelligence is different than human intelligence. And so the mistake that is being made by focusing on AGI among those who do is an artificial agent that, as we can make them now or in the near future, might be way better than human beings at some things, way worse than human beings at other things. And rather than trying to ask how close is it to being a human-like intelligence, we should appreciate it for what its capabilities are. And that will both be more accurate and help us put it to work and protect us from the dangers better, rather than always anthropomorphizing.
I think the underlying idea there, under the definition of AGI, is that the capabilities are extremely impressive. There's not a precise statement, but
No, I get that. I completely agree.
And then the underlying question, where there are a lot of debate is how impressive is it? What are the limits of large language models? Can they really do things like common sense reasoning? How much do they really understand about the world? Or are they just fancy mimicry machines? And where do you fall on that as to the limits of large language models?
I don't think that there are many limits in principle. I'm a physicalist about consciousness and awareness and things. I see no obstacle to, in principle, building an artificial machine that is indistinguishable in thought cognition from a human being. But we're not trying to do that, right? What a large language model is trying to do is to predict text. That's what it does. And it is leveraging the fact that we human beings, for very good evolutionary biology reasons, attribute intentionality and intelligence and agency to things that act like human beings. As I was driving here to get to this podcast space, I was using Google Maps. Google Maps was talking to me, but I wanted to stop to get a cup of coffee. So I didn't do what Google Maps told me to do. I went around a block that it didn't like. And so it gets annoyed, right? It says like, why are you doing it? It doesn't say exactly this, but you know what I mean. It's like, no, turn left, turn left, turn left. It is impossible as a human being not to feel a little bit sad that Google Maps is getting mad at you. It's not even trying to. It's not a large language model. It's not, there's no aspiration to intentionality, but we attribute that all the time. Dan Dennett, the philosopher, wrote a very influential paper on the intentional stance. The fact that it's the most natural thing in the world for we human beings to attribute more intentionality to artificial things than are really there. Which is not to say it can't be really there. But if you're trying to be rational and if you're thinking about this, the first step is to recognize our huge bias towards attributing things below the surface to systems that are able to, at the surface level, act.
So if that huge bias of intentionality is there in the data, in the human data, the vast landscape of human data that AI models, large language models, and video models in the future are trained on, don't you think that intentionality will emerge as fundamental to the behavior of these systems naturally?
I don't think it will happen naturally. I think it could happen. Again, I'm not against the principle. But again, the way that large language models came to be and what they're optimized for is wildly different than the way that human beings came to be and what they're optimized for. So I think we're missing a chance to be much more clear-headed about what large language models are, like judging them against human beings. Again, both in positive ways and negative ways.
Well, I think it's to push back on what they're optimized for. It's different to describe how they're trained versus what they're optimized for. They're trained with very trivial ways, dictating textbooks. Describe what they're optimized for, what the actual task of it is to construct a world model, meaning an understanding of the world. And that's where it starts getting closer to what humans are kind of doing. We're just, in the case of large language models, know how the sausage is made, but we don't know how it's made for us humans.
But they're not optimized for that. They're optimized to sound human.
That's the fine tuning. But the actual training is optimized for understanding, creating a compressed representation of all the stuff that humans have created on the internet. And the hope is that gives you a deep understanding.
Yeah. So that's why I think that there's a set of hugely interesting questions to be asked about the ways in which large language models actually do represent the world. Because what is clear is that they're very good at acting. The open question in my mind is the easiest, most efficient, best way to act human to do the same things to human beings? Or are there other ways? And I think that's an open question. I just heard a talk by Melanie Mitchell at Santa Fe Institute of Artificial Intelligence Research. And she told two stories about two different papers, one that someone else wrote and one that her group was following up on. And they were modeling Othello. Othello, the game was a little rectangular board, white and black squares. So the experiment was the following. They fed neural networks the moves that were being made in the most symbolic form, E5. So it gives a long string. It does this for millions of games, right? Real legitimate games. And then it asks the question, the paper asks the question, okay, you trained it to tell what would be a legitimate next move from not a legitimate next move. Did it in its brain, in its little large language model brain, I don't even know if it's technically a large language model, but a deep learning network. did it come up with a representation of the Othello? Well, how do you know? And so they construct a little probe network. They insert, and you ask it, what is it doing right at this moment, right? And the answer is that this little probe network can ask, would this be legitimate, or is this token white or black or whatever? Things that in practice would amount to it's invented to go the Othello board. And it found that the probe got the right answer, not 100% of the time, but more than by chance, substantially more than by chance. So they said there's some tentative evidence that this neural network has discovered the Othello board, just out of logic. Right? So then Melanie's group asked the question, okay, are you sure that that understanding of the Othello board wasn't built into your probe? What they found was like at least half of the improvement was not all. And look, a Othello board is way simpler than the world. So that's why I just think it's an open question whether or not it would be remarkable either way to learn that large language models that are good at doing what we train them to do are good because they built the same kind of model of the world that we have in our minds, or that they're good despite not having that model. Either one of these is an amazing thing. I just don't think the data are clear on which one is true.
I think I have some intellectual humility about the whole thing because I was humbled by several stages in the machine learning development for the past 20 years. And I just would never have predicted that LLMs, the way they're trained, and the skill data they're trained, would be as impressive as they are. Mm-hmm. And that's where intellectual humility steps in, where my intuition would say something like with Melanie, where you need to be able to have very sort of concrete common sense reasoning, symbolic reasoning type things in a system in order for it to be very intelligent. But here, I'm so impressed by what it's capable to do, train on the next token prediction, essentially. My conception of the nature of intelligence is just completely, not completely, but humbled.
Look, and I think that's perfectly fair. I also was, I don't know if it's pleasantly, I don't know if it's pleasantly or unpleasantly, but actually surprised by a recent rate of progress. Clearly, some kind of phase transition, percolation has happened, right? And the improvement has been remarkable, absolutely amazing. That I have no arguments with. That doesn't yet tell me the mechanism by which that improvement happened. Constructing a model much like a human being would have is clearly one possible mechanism, but part of intellectual humility is to say maybe there are others.
I was chatting with the CEO of Anthropic, Dario Madet, so behind Claude, and that company, but a lot of the AI companies are really focused on expanding the scale of compute. So if we assume that AI is not data limited, but is compute limited, you can make the system much more intelligent by using more compute. So let me ask you, almost on the physics level, do you think physics can help expand the scale of compute and maybe the scale of energy required to make that compute happen?
Yeah, 100%. I think this is like one of the biggest things that physics can help with, and it's an obvious kind of low-hanging fruit situation where the heat generation, the inefficiency, the waste of existing high-level computers is nowhere near the efficiency of our brain. It's hilariously worse. And we kind of haven't tried to optimize that hard on that frontier. I mean, your laptop heats up when you're sitting on your lap, right? It doesn't need to. Your brain doesn't do that like that. So clearly, there exists in the world of physics the capability of doing these computations with much less waste heat being generated, and I look forward to people doing that. Yeah.
Are you excited for the possibility of nuclear fusion?
I am cautiously optimistic, excited to be too strong. I mean, it'd be great. But if we really tried solar power, it would also be great.
I think Elias Discover said this, that the future of humanity on Earth would be just the entire surface of Earth is covered in solar panels and data centers.
Why would you waste the surface of the Earth with solar panels? Put them in space.
Sure, you go, yeah.
Space is bigger than Earth.
Yeah, solar panels out here.
Yeah.
I like it.
We already have fusion. It's called the sun.
Yeah, for sure. And there's probably more and more efficient ways of catching that energy.
Sending it down is the hard part. Absolutely. But that's what I'm hearing, probably. Yeah.
But I just wonder where data centers, the compute centers, can expand to. If that's the future. If AI is as effective as it promises, but as it possibly could be, then it's the scale of computation will keep increasing. But perhaps it's the race between efficiency and scale.
There are constraints, right? You know, there's a certain amount of energy, a certain amount of damage you can do to the environment before it's just not worth it anymore. So, yeah, I think that's a new question. In fact, it's kind of frustrating because we get better and better at doing things efficiently, but we invent more things we want to do faster and we get good at doing them efficiently. So, we're continuing to make things worse in various ways.
I mean, that's the dance of humanity. We're constantly creating better technologies that are potentially causing a lot more harm. And that includes for weapons, includes AI used as weapons, that includes nuclear weapons, of course, which is surprising to me that we haven't destroyed human civilization yet, given how many nuclear weapons.
Look, I'm with you. Between nuclear and bioweapons, it is a little bit surprising that we haven't caused enormous devastation. Of course, we did drop 2 atomic bombs on Japan, but compared to what could have happened, or could happen tomorrow, it could be much worse.
It does seem like there's an underlying, speaking of quantum fields, there's like a field of goodness within the human heart that, like, in some kind of game theoretic way, we create really powerful things that can destroy each other, and there's greed and ego and all this kind of power-hungry dictators that are at play here in all the geopolitical landscape, but we somehow always don't go too far.
Yeah, but that's exactly what you would say right before we went.
Right before we went too far. And that's why we don't see that. So you're, like I mentioned, associated with Santa Fe Institute. I just would love to take a stroll down the landscape of ideas explored there. So they look at complexity in all kinds of ways. What do you think about the emergence of complexity from simple things interacting simply?
I think it's a fascinating topic. I mean, that's why I'm thinking about these things these days rather than papers that I described to you before. All of those papers I described to you before are guesses. What if the laws of physics are different in the following way? And then you can work out the consequences. At some point in my life, I said, what is the chance I'm going to guess right? Einstein guessed right, Steven Weinberg guessed right, but there's a very small number of times that people guess right. Whereas, with this emergence of complexity from simplicity, I really do think that we haven't understood the basics yet. I think we're still kind of pre-paradigmatic. There have been some spectacular discoveries. People like Jeffrey West at Santa Fe and others have really given us true insights into important systems, but still there's a lot of the basics I think are not understood. And so searching for the general principle is what I like to do. And I think it's absolutely possible that it can be a little bit more substantive than that. I think this is kind of a cliche. I think the key is information. And I think that what we see through the history of the universe as you go from simple to more and more complex is really subsystems of the universe figuring out how to use information to do whatever, to survive or to thrive or to reproduce. I mean, that's the sort of fuel, the leverage, the resource that we have for a while anyway, until the heat death. But that's where the complexity is really driven by.
Yeah, but the mechanism of it, you mentioned Jeffrey West. What are interesting inklings of progress in this realm, and what are systems that interest you in terms of information? So, for me, just as a fan of complexity, just even looking at simple cellular automata is always just a fascinating way to illustrate the emergence. So for those of the listeners who don't know, viewers, cellular automata
come from imagining a very simple configuration. For example, a set of ones and zeros along a line. And then you invent a rule that says, okay, I'm going to evolve this in time. And generally, the simplest ones start with just each block of 3 ones and zeros have a rule that they will deterministically go to either one or the other. And you can actually classify all the different possibilities, a small number of possible cellular automata of that form. And what was discovered by various people, including Stephen Wolfram, is some of these cellular automata has a feature that you start from almost nothing, like 0, 0, 0, 0, 1, 0, 0, 0. You let it rip, and it becomes wild. Okay? So this is very provocative, very interesting. It's also not how physics works at all. Because as we said, physics conserves information. You can go forward or backwards. These cellular automata do not. They're not reversible in any sense. You built in an arrow of time. You have a starting point, and then you evolve. So what I'm interested in is seeing how in the real world, with the real laws of physics and underlying reversibility, but macroscopic irreversibility from entropy in the arrow of time, etc., how does that lead to complexity? I think that that's an answerable question. I don't think the cellular automata are really helping in that.
So what is in that? What is the landscape of entropy?
Well, entropy is hard to localize. It's a property of systems, not of parts of systems, right? Having said that, we can do approximate answers to the question. The answer is black holes are huge in entropy. Let's put it this way. The whole observable universe that we're in had a certain amount of entropy before stars and planets and black holes started. 10 to the 88. The single black hole at the center of our galaxy has entropy. 10 to the 90. The single black hole at the center of our galaxy has more entropy than the whole universe used to have. Not too much. So most of the entropy in the universe today is
Okay, that's fascinating, first of all. But second of all, if we take black holes away, what are the different interesting perturbations in entropy across space? Where do we Earthlings experience that?
The interesting thing to me is that if you start with a system that is isolated from the rest of the universe, and you start it low energy, there's almost a theorem that says if you're very, very, very low, then the system looks pretty simple. Because low entropy means there's only a small number of ways that you can rearrange the parts to look like. So if there's not that many ways, the answer's going to look simple. But there's also almost a theorem that says when you're at maximum entropy, the system is going to look simple. Because it's all smeared out. If it had like interesting structure, then it would be complex. So entropy in this isolated system only goes up. That's the second law of thermodynamics. But complexity starts low, goes up, and then goes down again. Sometimes people mistakenly think that complexity or life or whatever is fighting against the second law of thermodynamics, fighting against the increase of entropy. That is precisely the wrong way to think about it. We are surfers riding the wave of increasing entropy. We rely on increasing entropy to survive. That is part of what makes us special. This table maintains its stability mechanically, by which I mean there's molecules, they have forces on each other, and it holds up. You and I we maintain our stability dynamically by ingesting food, fuel, right? Food and water and air and so forth, burning, increasing its entropy. We are non-equilibrium quasi-steady state systems. We are using the fuel the universe gives us in the form of low entropy energy to maintain our stability.
I just wonder what the mechanism of surfing looks like. I mean, that's where, first of all, I think one question to ask, do you think it's possible to have a kind of size of complexity where you have very precise ways or clearly defined ways of measuring complexity?
I think it is, and I think we don't. It's possible to have it, I don't think we yet have it. Because, in part because complexity is not a univalent thing. There's different ideas that go under the rubric of complexity. One version is just homologular complexity, right? If you have a configuration or a string of numbers or whatever, and you compress it so that you have a small program that will help with that. That's the small growth. But that's the complexity of a string of numbers. Okay? It's not like the complexity of a problem, right? Computational complexity, the traveling salesman problem, or factoring large numbers. That's a whole different kind of question. It is also about complexity. So we don't have a sort of unified view of it.
Do you think it's possible to have a complexity in physical systems?
Yeah.
In the same way we do entropy.
Yeah.
You think that's a Sean Carroll paper or what?
We're working on various things. The glib thing that I'm trying to work on right now with the students is complexogenesis. How does complexity come to be if all the universe is doing is moving from low entropy to high entropy?
It's a sexy name.
That's a good name. Yeah, I like the name.
Oh,
I was going to write the paper.
Sometimes a name,
Yeah.
a role play of a name. In which context, the birth of complexity are you most interested in?
Well, I think it comes in stages, right? So I think that if you go from I'm a physicist, so biologists studying evolution will talk about how complexity evolves all the time, complexity of the genome, complexity of our physiology, but they take for granted that life already existed, entropy is increasing and so forth. I want to go back to the beginning and say the early universe was simple and low. Entropy increases with time, and the universe sort of differentiates and becomes more complex. But that statement, which is indisputably true, has different meanings because complexity is different. So sort of the most basic primal version of complexity is what you might think of as configurational complexity. That's what Mosrow gets at. How much information do you need to specify the configuration? Then there's a whole other step where subsystems of the universe start burning fuel, right? So in many ways, a planet and a star are not that different in configurational complexity. They're both spheres. There's density high at the middle and getting less at the left. But there's something fundamentally different because the star only survives as long as it has fuel, right? I mean, then it turns into a brown dwarf or white dwarf program. But as a star, as a main sequence star, it is an out of equilibrium system. But it's more or less static, right? Like if I spill the coffee mug and it falls, in the process of falling, it's out of equilibrium, but it's also changing. A specific kind of system is where it looks sort of macroscopically stationary, like a star. But underneath the hood, it's burning fuel to keep the band in order to maintain that stability. So as stars form, that's a different kind of complexity that comes to be. Then there's another kind of complexity that comes to be, roughly speaking, at the origin of life. Because that's where you have information really being gathered and utilized by subsystems of the universe. And then arguably there's any number of stages past that. I mean, one of the most obvious ones to me is we talk about simulation theory, but you and I run simulations in our heads. They're just not that good, but we imagine different hypothetical futures, right? Bacteria don't do that. So that's the kind of information processing that is a form of. So I would like to understand all these stages.
Yeah, imagination.
Yeah, mental time.
Yeah, the things going on in my head when I'm imagining worlds are super compressed representations of those worlds, where they get to the essence of them. And maybe it's possible with non-human computing type devices to do those kinds of simulations in more and more compressed ways.
There's an argument to be made that literally what separates human beings from other species on Earth is our ability to imagine counterfactual hypotheticals.
Yeah, I mean, that's one of them.
I don't know. Everyone has their own favorite little feature, but that's why I said there's an argument to be made. I did a podcast episode on it with Adam Bully. It developed slowly. I did different podcasts. Sorry to keep mentioning podcast episodes I did, but Malcolm McIver, who is an engineer at Northwestern, has a theory about one of the major stages in evolution is when fish first climb on the land. And I mean, of course, that is a major stage of evolution, but in particular, there's a cognitive shift. Because when you're a fish swimming under the water, the attenuation length of light in water is not that long. You can't see kilometers away. You can see meters. And you're moving at meters per second. So all of the evolutionary optimizations make all of your decisions on a time scale of less than a second. When you see something new, you have to make a rapid-fire decision what to do with it. As soon as you climb on the wing, you can essentially see forever, right? You can see stars in the sky. So now a whole new mode of reasoning opens up. Where you see something far away, rather than saying, "Look up table, I see this, I react." You can say, "Okay, I see that thing. What if I did this? What if I did that? What if I did something different?" And that's the birth of imagination. Right?
You've been critical on Penn.
Right, you noticed that, right?
Can you make the case for Penn? The Penn cycle is the idea that consciousness permeates all matter. Maybe it's the fundamental force or physics of the way of the fabric of the universe.
And psychism, thought, everything, right?
It's one thing to a point of entertainment. The idea frustrates. So as a fan, is wonderful to watch. You've had great episodes with panpsychists on your podcast where you go at it.
I had David Chalmers, who's one of the world's great philosophers, and he is panpsychism curious.
Yeah.
He doesn't commit to everything, but he's certainly willing to entertain it. Philip Goff, who I've had, he's a great guy, but he is devoted. And so, in fact, he is almost single-handedly responsible for the upsurge of interest in panpsychism in the popular imagination. And the argument for it is supposed to be that there is something fundamentally uncapturable about conscious awareness by physical behavior of atoms. So the panpsychist will say, look, you can tell me maybe someday through advances of neuroscience and what have you, exactly what happens in your brain and how that translates into thought and speech and action. What you can't tell me is what it is like to be me. You can't tell me what I am experiencing when I see something that is red or that I taste something that is sweet. You can tell me what neurons fire, but you can't tell me what I'm experiencing. That first-person inner subjective experience is simply not capturable by physics. And therefore, this is an old argument, but then therefore is supposed to be, I need something that is not contained within physics to account for it. And I'm just going to call it mind. We don't know what it is yet. We're going to call it mind, and it has to be separate from physics. And then there's two ways to go. If you buy that much, you can either say, okay, I'm going to be a dualist. I'm going to believe that there's matter and mind, and they are separate from each other. They are interacting somehow. Or that's a little bit complicated and sketchy as far as physics is going to go. So I'm going to believe in mind, but I'm going to put it prior to matter. I'm going to believe that mind comes first. And the consciousness is the fundamental aspect of reality, and everything else, including matter and physics, comes from it. That would be at least as simple as physics comes. Right? Now, the physicalists, such as myself, will say, I don't have any problems explaining what it's like to be you or what you experience when you see red. It's a certain way of talking about the atoms and the neurons that make up you. Just like the hardness or the brownness of this table, these are words that we attach to certain underlying configurations. So ordinary physical matter, likewise sadness and redness or whatever, are words that we attach to you to describe what you're doing. And when it comes to consciousness in general, I'm very quick to say I do not claim to have any special insight on how consciousness works, other than I see no reason to change the laws of physics.
If you don't have to change the laws of physics, where do you think it emerges from? Is consciousness an illusion? Or it's almost like a shorthand that we humans use to describe a certain kind of feeling we have when interacting with the world? Or is there some big leap that happens at some stage?
I almost never use the word illusion. Illusion means that there's something that you think you're perceiving that is actually not there, like an oasis in the desert. It has no causal efficacy. You walk up to where the oasis is supposed to be, you say you were wrong about it being there. That's different than something being emergent or non-fundamental, but also real. This table is real, even though I know it's made of atoms. that doesn't remove the realness from the table. I think that consciousness and feel and things like that are just as real.
Oasis in the desert does have causal efficacy in that. You can get thirsty. Well,
It leads to draw incorrect conclusions about the world.
sure, but imagining a thing can sometimes bring it to reality. You've seen, and that has a kind of a causal efficacy.
Sure, but your understanding of the world in a way that gives you power over it is decreased rather than increased by believing that always. That is not true about consciousness or the state.
You don't think you can increase the chance of a thing existing by imagining its existence?
Unless you build it or make it.
No, that's what I mean. Like imagining humans can fly.
Yeah, right, brother. Imagine that humans are flying.
Right.
In terms of counterfactuals in the future, absolutely. Imagination is good for the future. But that's not an illusion.
Oh, okay. So the possibility of the future versus what reality is. I mean, the future is a concept. And time is just a concept, so you can play with that. But yes, reality. So to you, so for example, I love asking this. So Donald Trump thinks that the entirety of the conversation we've been having about space-time is an illusion. Is it possible for you to still have a case for that, to make the case for and against reality, as I think he writes, that the laws of physics as we know them, space-time, is a kind of interface to a much deeper thing that we don't at all understand, and then we're fooling ourselves by constructing it.
Well, I think there's like part of that idea that is perfectly respectable and part of it that is perfectly nonsensical. And I'm not even going to try to steel man the nonsensical part. The real part, to me, is what is called structural realism. So we don't know what the world is at a deep fundamental level, right? But let's put ourselves in the minds of people living 200 years ago. Like they didn't know about quantum mechanics, they didn't know about relativity. That doesn't mean they were wrong about the universe, but they understood. They had Newton's laws, right? They could predict what time the sun was going to rise perfectly well. In the progress of science, the words that would be used to give the most fundamental description of how you were predicting the sun would rise change. Because now you have curved space-time, things like that, right? You didn't have any of those words 200 years ago. But the prediction was the same. Why? Because that prediction, independent of what we thought the fundamental ontology was, the prediction pointed to something true about our understanding of reality. To call it an illusion is just wrong, I think. We might not know what the best, most comprehensive way of stating it is, but it's still true.
Is it true in the way, for example, belief in God is true? Because for most of human history, people have believed in a God or multiple gods. And that seems very true to them as an explanation for the way the world is. Some of the deeper questions about life itself and the human condition and why certain things happen. That was a good explainer. But to you, that's not an illusion.
No, I think that was completely an illusion. I think it's a very, very reasonable illusion to be under. There are illusions. There are substantive claims about the world that go beyond predictions that we can make and verify, which later found to be wrong. The existence of God was one of them. If those people at that time had abandoned their belief in God and replaced it with a mechanistic universe, they would have done just as well at understanding things, right? Again, because there's so many things they didn't understand, it was very reasonable for them to have that belief. It wasn't that they were dummies or anything. But that is, as we understand the universe better and better, some things stick with us, some things get replaced.
So, like I said, you're a believer of the mechanistic universe. You're a naturalist, and you describe a poetic naturalist. What's the word poetic? What is naturalism and what is poetic?
Naturalism is just the idea that all that exists is the natural. There's no supernatural. You can have arguments about what that means, but I would claim that the argument should be about what the word supernatural is, not the word natural. The natural world is the world that we learn about by doing science. The poetic part means that we shouldn't be too, I want to say, fundamentalist about what the natural world is. As we went from Newtonian space-time to Einsteinian space-time, something is maintained there. There is a different story that we can tell about the world. And that story in the Newtonian regime, if you want to fly a rocket to the moon, you don't use general relativity. You use Newtonian rules. That story works perfectly well. The poetic aspect of the story is that there are many ways of talking about the natural world. And as long as those ways latch on to something real and causally efficacious about the functioning of the world, then we attribute some reality to it.
So the poetic really looks at the let's say the pothead questions at the edge of science. It's more open to them.
It's doing double duty a little bit, so that's why it's, the more obvious respectable duty it's doing is that tables are rigged. Even though you know that it's really a quantum field theory wave function, right? Tables are still real. There are different ways of talking about the underlying deeper reality. The other duty it's doing is that we move beyond purely descriptive vocabularies for discussing these onto normative and prescriptive and judgmental ways. This painting is beautiful, that one is ugly. This action is morally right, that one is morally wrong. These are also ways of talking to the universe. They are not fixed by the phenomenon. They are not determined by our observations. They cannot be ruled out by a crucial experiment. But they're still valid. They might not be subjective, but they're not arbitrary, and they will work.
So you don't think it's possible to construct experiments that explore the realms of morality and even meaning? Those are subjective.
Yeah, they're human. They're personal.
But do you think that's just because we don't have the tools of science have not expanded enough to incorporate the human experience?
No, I don't think that's what it is. I think that what we mean by aesthetics or morality are we're attaching categories, properties, to things that happen in the physical world. And there is always going to be some subjectivity to our attachments and how we do that, and that's okay. But that's what we recognize that and deal with it, the better off we'll be.
But if we deeply, fully understand the function of the human mind, we'll be able to incorporate that.
No. That will absolutely be helpful in explaining why certain people have certain morals. It won't justify it. That's right at all.
Do you think it's possible to have a kind of general relativity, but that includes the observer effect where the human mind is the observer? Sort of like how we morph, the same way gravity morphs space-time, how does the human mind morph reality and have a very thorough theory of how that morphing actually happens?
That's a very flattering question.
I don't think it's possible.
The answer is yes. I think that I think that we're part of the physical world, the natural world. Physicalism would have been just as good a word to use as naturalism, maybe even a more accurate word, but it's a little bit more off-putting. So I do want a snappier, more attractive flavor than physical.
Are there limits to science?
Sure, we just talked about one, right? Science can't tell you right from wrong. You need science to implement your ideas about right and wrong. If you are functioning on the basis of an incorrect view of how the world works, you might very well think you're doing right, but actually wrong. But all the science in the world won't tell you which action is right and which action is wrong.
Dictators and people in power will sometimes use science as an authority to convince you what's right and wrong. Studying Nazi science is fascinating.
Yeah. But there's an instrumentalist view here. You have to first decide what your goals are, and then science can help you achieve those goals. If your goals are horrible, science has no problem helping you achieve them. Science is happy to help out.
Let me ask you about the methods behind the madness of several aspects of your life. So you mentioned your approach to writing for research and writing popular books. How do you find the time of the day? Like, what's the day in the life of Sean? So you don't have a thing where in the morning you're like, you try to fight for 2 hours somewhere.
I don't. I'm really terrible at that. Yes, my strategy for finding time is just to ignore interruptions. But it's a different time every day. Some days it never happens. Some weeks it never happens.
Pull it up. If you're extremely prolific, so like you're able to have days where you don't write and still write the next day. Oh wow, that's a rare thing, right? A lot of prolific writers will carve out 2 hours because otherwise it just disappears.
Right. No, I get that. Yeah, I do. And yeah, it's just like everyone has their foibles or whatever. So I'm not able to do that. Therefore, I have to just figure it out on the fly.
And what's the actual process look like when you're writing popular stuff? You get behind a computer?
Yeah, get behind a computer. And my way of doing it, so my wife, Jennifer, is a science writer. But it's interesting because our techniques are entirely. She will think about something, but then she will free write. She'll just sit at a computer and write. I think this, and then that will be vastly compressed, edited, rewritten or whatever until the final thing happens. I will just sit there silently thinking for a very long time, and then I will write what is almost. So a lot of it happens. There might be some scribbles for an outline or something like that, but a lot of it is in my brain before something.
So that's the case for the biggest ideas in the universe, the quanta book and the space-time motion book.
Yeah, quanta and fields, which is actually mostly about quantum field theory and particle physics. That's coming out in May, and that is I'm letting people in on things that no other book lets them know. So I hope it's worth it. It's a challenge. It's a lot of it.
I mean, you did the same thing with space-time motion. You did something quite interesting, which is you made the equation centerpiece of the book.
Right. There's a lot of equations. Book 2 goes further in those directions than book 1 did. So it's more cool stuff. It's also more mind-bending. Book 3 that I'm writing right now is called Complexity and Emergence.
Oh wow!
And that'll be the final part of the trilogy.
Oh, that's fascinating. So there's a lot of probably ideas there. I mean, that's a really cutting edge.
Well, but I'm not trying to be cutting. In other words, I'm not trying to speculate in these books. Obviously, in other books, I'm very free about speculating. But the point of these books is to say things that 500 years from now will still be true. And so there are some things we know about complexity emergence, and I want to focus on those. I will mention, I'm happy to say, this is something that needs to be speculated about, but I won't pretend to be technical.
You somehow found the balance between the rigor of mathematics and still accessible. Which is interesting.
I tried. I mean, look, these 3 books, the biggest ideas books, are absolutely an experiment. They're going to appeal to a smaller audience than other books will. But that audience should love them. My 16-year-old self would have been so happy to get these books. I can't tell you.
Yeah, in terms of looking back in history, those are books, the trilogy would be truly special.
Word for word written. Why not?
Yeah. Different styles, different topics, same ultimate reality. Like we mentioned, Mindscape podcast, I love it. I do interview a huge variety of experts from all kinds of fields, so just several questions I want to ask them. How do you prepare? How do you prepare to have a good conversation? How do you prepare in a way that satisfies, makes your own curious mind happy? All that kind of stuff.
Yeah, no, these are great questions, and I've sort of struggled and changed my techniques over the years. I'm a 5-year-old, let's see, 6 years old now. I started out over-preparing when I first started. I had a journey that I was going to go down. Many of the people I talked to are academics or thinkers who write books, so they have a story to tell. I could just say, okay, give me your lecture, and then an hour later, stop, right? So the mistake is sort of anticipate what the lecture would be and to ask the leading questions that would pull it out. What I do now is much more, here are the points, here are the big questions that I'm interested in. So I have a much sketchier outline to start, and then try to make it more of a real conversation. I'm helped by the fact that it is not my day job. So I strictly limit myself to 1 day of my life per podcast, on average. Some days take more. And that includes not just doing research, but inviting the guests, recording it, editing it, publishing it. So I need to be very, very efficient with that.
You enforce constraints for yourself in which routine you can emerge.
And look, sometimes if I'm interviewing a theoretical physicist, I can just go in. And where interviewing an economist or a historian, I do
Do you ever find yourself getting lost in rabbit holes that serve no purpose except satisfying your own curiosity and then potentially expanding the range of things you know that can help your actual work and research, right?
Yes, on both counts. I do. Some people have so many things to talk about that you don't know where to start or finish, right? Others have a message. And it's one thing I discovered over the course of these years is the correlation with age. Like, there are brilliant people, and I try very hard on the podcast to sort of get all sorts of people, right? Different ages and things like that. And bless their hearts, the most brilliant young people are not as practiced at wandering past their literal research, right? They have less mastery over the field as a whole, much less how to talk about it. Whereas certain older people just like have their pat hands and that's kind of boring, right? So you want somewhere in between. The ideal person who is has a broad enough a scope so they can wander outside their specific papers they've written, but they're not overly practiced, so they're just giving you their candles.
I feel like there's like a connection to the metaphor of entropy and complexity, as you said,
Educate.
you also do incredible AMA to people to sign up to Patreon. You get to ask questions, Shankar. Well, for several hours, you just answer in fascinating ways. Some really interesting questions. Is there something you could say about the process of finding the answers?
That's a great one. And again, it's evolved over time. So the Ask Me Anything episodes were first, I started doing them were only for Patreon subscribers, both to listen to and to ask questions. But then I actually asked my Patreon subscribers, would you release them publicly if they overwhelmingly voted yes? So I do that. Everyone can listen. And also front with Harold for picking questions to answer is what are the ones I think are interesting answers to give for, right? So that both means if it's kind of the same old question about special relativity that I've gotten 100 times before, I'm not going to answer it because you can just Google that. It's easier. There are some, very clear attempts to ask an interesting question that honestly just I don't have an answer to. Like, I read this science fiction novel. What do you think about it? I'm like, well, I haven't read it, so I can't help you there. What's your favorite color? I'll tell you what it is, but it's not that interesting. And so I try to make it a mix. I try to it's not all physics questions, not all philosophy questions. I will talk about food or movies or politics or religion if that's what people want. I keep suggesting to people asking for relationship advice, but they never do.
Yeah, I don't think I've heard one.
Yeah, I'm willing to do it, but I'm a little reluctant because I don't actually like giving advice. But I do. I'm happy to talk about those topics. I want to give several hours of trying to say things that I haven't said before and keep it interesting, keep it rolling. If you don't like this question,
What kinds of questions?
Rarely, but occasionally, people will ask me a super insightful philosophy question. Like, I hadn't thought of things in exactly that way. I try to be, try to recognize that. A lot of times, it's the opposite, where it's like, okay, you're totally confused, and I'm going to try to explain how the question you should have asked.
Oh, I love those. Yeah, why that's the wrong question or that kind of stuff. That's great.
Right. But the hard questions, I don't know. Like, I don't actually answer personal questions very much. Like, the most personal I would get are questions like, "What do you think of Baltimore?" Right? That much I can talk about. Or, "How are your cats doing?" Happy to talk about the cats. But very personal questions I don't get.
But you even touch like politics and stuff like that.
Yeah, no, very happy to talk about politics. I try to be clear on, what is professional expertise, what is just me babbling, what is my level of credence in different things, where you're allowed to disagree, whether if you disagree, you're just wrong. And you can disagree with that also, but I do think, and I'm happy to go out on a limb a little bit. I'm happy to say, look, I don't know, but here's my guess. Right? I just did a whole solo podcast, which is exactly that. And it's interesting. Like, some people are like, "Oh, this was great," and there's a whole bunch of people like, "Why are you talking about this thing that you are not the world's expert?" So,
well, I love the actual dance between humility and having a strong opinion on stuff. It's a fascinating dance to pull off, and I guess the way to do that is to just expand into all kinds of topics and play with ideas and change your mind and all that kind of stuff.
Yeah, it's interesting because when people react against you by saying you are being arrogant about this, 99.999% of the time, all they mean is I disagree. Yeah, that's all they really mean, right? Like at a very basic level, like people will accuse atheists of being arrogant. And I'm like, you think God exists and loves you? You're telling me that I'm arrogant. I think that all of this is to say, just advice. When you disagree with something, try to specify the subject of disagreement. Try not to psychologize it, right? Try to say, "Oh, you're saying this because of this." Maybe it's true. Maybe you're right. But if you had an actual response to what they were saying, that would be much more interesting.
Yeah, I wonder why it's difficult for people to say or to imply, "I respect you, I like you, but I disagree on this, and here's why I disagree." Like, I wonder why they go to this place of like, "Well, you're an idiot," or "You're egotistical," or "You're confused," or "You're naive," or "You're," all kinds of words. As opposed to like, "I respect you as a fellow human being exploring the world of mysteries all around us, and I disagree."
I will complicate the question even more because there's some people I don't respect. And I once wrote a blog post. I think it was called "The Grid of Disputation," and I had a 2x2 grid, and it's: are you someone I agree with or disagree with? Are you someone who I respect or don't? And all four quadrants are very popular, and so what that means is there are people who I like and I disagree with. Me, and I have no respect for allies, but that was everyone. So, and I just think people are, but if you actually move the conversation forward, forget about whether you like or don't like somebody. Explain the disagreement, explain the agreement. But you're absolutely right. I completely agree. Like, as a society, we're not very good at disagreeing. We instantly go to the insults.
And even on a deeper level, I think at some deep level, I respect and love the human. That general relativity is the most beautiful theory, right?
So far.
What do you find beautiful about it?
Let's put it this way. When I teach courses, there's no more satisfying subject to teach than general relativity. And the reason why is because it starts from very clear, precisely articulated assumptions, and it goes so far. When I give you can find it online. I'm probably not going to give it again. One of the biggest ideas is talk, right? Was building up from you don't know any math or physics. An hour later, you know Einstein's equation for general relativity. And the punchline is the equation is much smarter than Albert Einstein because Albert Einstein did not know about the big bangs. He didn't know about black holes, and that's a miraculous aspect of science more generally, but general relativity is where it manifests itself. Absolutely.
A human question. What do you think of the fact that Einstein didn't get the Nobel Prize for general relativity?
Right. He should have gotten maybe 4 Nobel Prizes. He certainly should have gotten the photoelectric effect was 100% worth Nobel Prize because, and people don't quite get this. Who cares about the photoelectric effect? That's like this very minor effect. The point is his explanation for the photoelectric effect, invented called the photon. That worth the Nobel Prize. Max Planck gets credit for this in 1900, explaining age by saying that when a little object at some temperature gives off radiation rather than continuously. He didn't quite say that's because radiation is discrete chunks, right? It's like having a coffee maker that makes 1 cup of coffee at a time. It doesn't mean that liquid comes in 1 cup quanta, right? It's just that you are dispensing it like that. It was Einstein in 1905 who said light is quanta, and that was a radical thing. So that clearly, that was not a mistake. But also special relativity clearly deserved the Nobel Prize, and general relativity clearly deserved the Nobel Prize. Not only were they brilliant, but they were experimentally verified. Like everything you want.
So separately, you think?
Yeah, absolutely.
Oh, humans.
Yeah.
Whatever the explanation there.
Edwin Hubble never won the Nobel Prize for finding these universes.
Yeah, but and even the fact that we give prizes is almost kind of silly, and we limit the number of people that get the prize and all that.
I think that Nobel Prize has enormous problems. I think it's probably a net good for the world because it brings attention to good science. I think it's probably a net negative for science because it makes people want to win the prize.
Yeah, there's a lot of fascinating
Yes.
human stories underneath it all. Science is its own thing, but it's also a collection of humans, and it's a beautiful collection. There's tension, there's competition, there's jealousy, but there's also great collaborations and all that kind of stuff. Daniel Kahneman, who recently passed, is one of the great stories of collaboration in science. So all of it, that's what humans do. Thank you for being the person that makes us celebrate science and fall in love with all of these beautiful ideas in science, for writing amazing books, legit, still pushing forward the research science side of it, and for these pothead questions through your own podcast. It's stop everything and subscribe and listen to every single episode of Mindscape. So thank you. I've been a huge fan forever. I'm really honored that you would speak with me in the early days when I was still starting this podcast.
I appreciate it. Thanks very much for having me on. Now that you're a big deal, still having me on.
Thank you, Sean. Thanks for listening to this conversation with Sean Carroll. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from Richard Feynman. Study hard what interests you most in the most irreverent and original manner. Thank you for listening. I hope to see you next time.
When we go to the dojos there, we all get thrown by people that never come out to be world champions. You know, they're just in the mix, or they're going through 3 years of university. Then they go. We had a guy.
Yeah.
We had a guy that came in. He was a business guy. He came in with his suitcase and his tie up like that, and he's in his lunch hour. He's in his lunch hour. Right? So got to be quick.
Yeah.
So he comes in and he goes through. He's working his way through the whole of the British team. And we're all lined out, right? 10 minutes later, he's just tying his tie up like that, you know, and back to work, right? Like, you know, imagine sitting behind his desk and his computer.
Yeah.
I'm glad he didn't get out.
Who do you think wins?
I think Yamashita, but I, you know,
Whoa.
Yeah.
You think Yamashita beats Teddy Raniere?
I think so.
Strong words. Following is conversation with Neil Adams, a legend in the sport of judo. He is a world champion, 2-time Olympic silver medalist, 5-time European champion, and often referred to as the voice of judo, commentating all the major events, world championships and Olympic games, highlighting the drama, the triumph, the artistry of the sport of judo, making fans like me feel the biggest wins, the biggest losses, the surprise turns of fortune, the dominance of champions coming to an end, and new champions made. Always speaking from the heart. This is the Let's Freedom Podcast. To support it, please check out our sponsors in the description. And now, dear friends, here's Neil Adams. You are a 5-time European champion, world champion, 2-time Olympic silver medalist. Let's first go to the 1980 Olympics. Where was your mind? What was your preparation like? What was your strategy leading into that Olympics?
That was my first Olympic Games. So my preparation was a little bit different to how it was the 84 and the 88 Olympic Games. And I'd kind of done part of the preparation as well for 76 Olympic Games. I wasn't quite old enough for those, but I was first reserve. So in 1980, I'd had 4 years build up, and I was hungry, and I was one of these young athletes, and I see them so often now that was developing and, you know, full of, I won't say I was full of myself, but I was certainly confident of my ability, and I wanted to conquer the world. And I'd had a couple of really tight matches with the current Olympic world champion, so I knew that there was a possibility that I could get there for the 80 Olympics. So building up to the 80 Olympics was quite interesting, because I was kind of coming through the weights, and I was halfway in between the 71 kilos weight category and the higher weight category of 78 kilograms. And I got third place at the 79 World Championships, the weight below. For the whole year at the higher weight category, didn't lose a contest. So I'd beaten everybody in the world. And then I had to make a decision as to whether to drop to the weight below, because I was seeded in the weight below. It was a different seeding then. And so I decided to drop into the weight below because I was seeded in the top 4. And as it happens, I think it was probably the worst decision I made. Well, because simply because I mean, it was the only contest that I lost was the final of the Olympic Games in that year.
So you're a young kid, what, like 19, 20 at that time, full of confidence, vigor. So the decision to cut weight, how hard was it for you to cut weight to the 71 kg division?
I've got to say that it was the hardest, because as I was going up, I was, you know, it was 73, then it was 74 kilos, 75. So I was moving through the weight category. It wasn't like I was stuck in the middle and then I dropped the odd time to compete. It was literally going up in weight by a kilo every 3 months. And then by the time I came to a month or 2 before the Olympics, it was really hard. Fought the European Championships at the higher weight category and won that. So everybody that was in the on the Olympic roster at the European at the Olympic Games was on my rostrum at the European Championships. So was it a mistake? Yeah, because I didn't have my diet sorted out. My nutrition was appalling. And when it wasn't as kind of readily available as it is now for the nutrition. And I would say that if anything lost me that final, other than the fact that I was fighting somebody who was terrific, he was an excellent, brilliant athlete. But definitely didn't help that my nutrition was not great.
Okay, so you lost to Ezio Gamba. There's probably a lot of that we could say about that particular match. Maybe let's zoom in. What were your strengths and weaknesses, judo-wise, in that Olympics? You said you haven't really lost a match, you won the European Championship leading into it. But if you had weak spots, Okay, you already said diet, but specifically on the mat in terms of judo.
I think that none of the fights lasted time going into the final, so I won fairly quickly, and every match by Ippon, way before time.
Do you remember how you won the match?
I won them by a couple of throws for Ippon, and then arm lock for Ippon. Semi-final was an arm lock, the East German, Kruger. And I was flying through,
What were the throws? Remember?
Tayatoshi, Uchimata, my favorite kind of Tokuwaza, my favorite throws. And then a Jujikatami as well, which was a Jujikatami roll, against an East German who I'd beaten before, but always had a really tough match, but managed to beat him well.
So you had a beautiful exhibition of Japanese type judo in the first two matches. Yeah. You threw people, and then you also did the newaza, you armbarred the person. Great. So you're going into the final. What are the weaknesses going into the final against the Italian?
Like I say, taking nothing away from him as a great athlete and a brilliant judo man, and left, which wasn't good for me. That was definite no, because I hated fighting lefties, still do. But I'll tell you why in a minute.
Great.
It's one of those. But I think as I went through the contest, we had an 8-hour break from the semi-final to the final. They took us back to the Olympic Village. Then we had to come back in, and then we had to start our warm-up again. So I kind of lost my momentum. I had to start again, and I didn't. I had a job to get going. I got halfway through, started to rescue a dying match, and I was kind of half a step behind all the way through. So I never really got into it.
So why do you hate fighting lefties? And lefties are, we should say, overrepresented in terms of the higher ranks of judo. I don't know why that is.
Well, the thing is about a lefty is a lefty will have more opportunity to fight right-handers. Because I mean, 70% of the population are right-handers, 30% left. So they get to fight more right-handers, and it's just a fact, that happens. So the thing that they hate is fighting left against left. They don't like they don't like it left against left. Whereas a right hand will go right against right, but the opposite is awkward for me, because just simply I like to go onto the sleeve, and then I like to dominate the grips, but the actual angle of the opponent wasn't what I wanted, so I had to work really hard against it.
What happened in that match?
It was a split decision in the end, and so to lose an Olympic final on a split decision is pretty, it's something that's still on my mind. And, I think that it's a strange one, because I could still wake up. That one and 4 years later at the Olympics, because I was silver medalist at the Olympics 4 years later as well. And, it still haunts me.
You sometimes wake up and think I should be better. Yeah. Or maybe a specific grip. You're like, I shouldn't take that grip.
I do, I mean, the diet side of it, it's difficult to really admit that, isn't it? That you went to an Olympic Games, and the one thing that you really sucked at, right, was one of the most important things now at world level sport, where you've got the nutrition, we've got it. You would think that most people have got it sorted, but there's still people making mistakes. There's still people that haven't got it totally sorted.
And then there's people like Travis Stevens, who I think doesn't care. He'll just have atrocious nutrition, and it just makes it worse. I think the way he spoke about it is you can't always control nutrition, so it's best to get good at having crappy nutrition.
Maybe that's what I did.
Exactly. Do you remember what you were eating? Are you talking about candy?
Yeah, well, I got a sweet tooth, but it wasn't really. I mean, I didn't have a lot of money at that particular time either, so the diet wasn't steak and good nutritional salads and things like that. I did what I thought was best without, proper advice. And the crazy thing is that I had such good advice as well, when it came to kind of fitness training and things like that. We're quite ahead of our time, and we really had it nailed as far as the conditioning was concerned. The judo training as well was way in advance because I was a good trainer, and I trained more than most. I can honestly say that it probably got me away with a lot.
Where was your mind, your mental preparation going into that Olympics? You said you were confident, but is there some preparation aspect behind that confidence?
I think in the days, I didn't think I was going to lose. I never thought it was possible to lose. And I think that I went into every contest expecting to win. So when it didn't quite go my way, I didn't lose that many contests, So the only ones I lost were in the final of the World Championships or in the final of the Olympic Games. So I didn't lose that many. I never lost a European title. I had 7 golds at the European Championships. 5 seniors, 2 juniors, and 20s. And I never lost the final. So it was, and then I only lost 2 on a split decision. So it was. I didn't lose that many. And my attitude was that I wasn't going to lose, and I couldn't lose. So I was always surprised when something happened.
In Neil Adams' A Life in Judo, written in 1986, you wrote, "Ever since I can remember, I've wanted to win. It wasn't the ordinary feeling that children have when they take part in their first primary school sack race on a grass track, or even the keen determination of a young swimmer prepared to train early in the cold winter mornings in order to make it into the county side. With me, the desire to win was, and still is, as much a part of me as my arms, legs. In other words, it wasn't something I learned as I grew older, but rather was deeply rooted in me. Perhaps this competitive instinct is the greatest difference between my public image and the view from the inside." So people see the kindness, the warmth you have, the charisma, the excitement, but there's this big drive to win inside you. So what's behind that? Can you just speak to that drive to win and how that contributed to you?
When I look back now,
It's a lot of years ago, we should say.
it is a lot of years ago.
Is that true, or
It
was
is.
it
It's
being
not
poetic?
far off. No,
Okay,
it's not. When I think about it now, because I'd like to think that I'm a different person now, and since I've kind of calmed down, I see athletes now, and I see them. They and their kind of arrogance, their walk, and it's a strut, and it's a kind of a confidence, isn't it? And as we're older, and as I've become older, I've calmed down. But it doesn't matter what I'm doing. It's still that will to win. And I'm much better at masking it now if I don't. But it still bothers me as much.
You're talking about, like, I don't know, even just like stupid, silly things, like I don't know, a game of pool or something like this, or just anything.
Yeah, I'm still trying to win. So my son loves to play me at bowls because I'm useless, and I just can't throw a straight bowl. So he loves playing me at that, but it bugs me that I'm not better, and there are certain things that I do. It really bugs me when I'm not good at it. And I guess it's one of the reasons that, long after I'd finished competition, judo, people still want to train with you, and even at an older age, even now, if I do in a seminar or, they still, do you still do you want to still go? And can I feel it? And, one of the things that's in me is that I just, all the way up to 40 years of age, so from 30 when I finished competition up to 40, I could still train with the best, and I could still go with anybody. And then when 40 hit, kind of things started to fall off a little bit, and I used to get, either my hips or the legs and the knees. And I realized that I had to pick my practices, and that rankled as well. And I had to then just calm it down a little bit. Otherwise, I was going to be injured, and I was going to be, it's not a good thing when you're getting older and you've still got the same competitive mind.
So it's still there. You get on the mat, probably even now, right? You get on the mat with a world champion, you're still the current world champion. There's still a little part of you could I still toss this guy?
you know, and
Kids these days are soft.
well, you know what? Some of these athletes, I mean, like I give you a prime example, right? Is Ilias.
Yeah.
All right. I mean, he is a monster, right? And you just, of course, you couldn't, you know, because just at 60 something, you couldn't. But you like to think that you could.
Yeah.
You know,
No, you gotta find out.
you know what you would do? What you can do is you can cause them problems, and they feel it immediately, but you last a minute.
So you trained with Ilias Leotis? Because I got a chance to train with him as well. He's a really nice guy, really great.
He trained with me. We were training together. Every hotel that we used to go into, we'd end up in the gym together and we'd train. And this one time he was in there and he just wanted somebody to grab and grip hold of. And so we ended up doing this kind of grappling in the middle of, you know, like people doing weight training and, you know, different things. Watching these two madmen doing. I'm glad we weren't on a mat at that particular time.
Yeah. What do you think about that guy? He, like you, achieved a lot of success when he was young.
17, you imagine that, 17, 18 years of age, and he's able to compete with the men. There's not many men can do that, you know, and it doesn't happen very often. It happens later with the men. And often they're not physically as developed as they, you know, so for me, for example, I fought Nevzorov, who was world and Olympic champion. He was the current world champion. They sent me to the European Championship senior at 17. And so it doesn't happen very often. And I pulled Nevzorov. So I fought Nevzorov, and I had him really worried, you know, because he expected, without a doubt, to come out pro this kid, you know, and junior.
And he was like thick and shredded, like
he was shredded. Like there's a picture of him in his judogi, and his judogi is just cut. It's, you know, and he looks the business. And there's me in this baggy, like, skinny kid inside this baggy thing. But and the thing was that the more he tried and the harder he tried and the more he panicked, the further it went away from him. And so, you know, of course, he got the decision at the end, and deservedly. But I worried him, you know. And so for me, that was a massive step forward, because a year later, I was, you know, starting to fill out, and 2 years later, I was competing for the Olympic title. So
I don't know if I remember, but Ilias Leotis is interesting because even at 17, I feel like he was doing big throws, like literally lifting them with
it just rips them out of the ground, you know. And I was saying to Nikki, you know, my wife, and she said, "What would you do now that was different than the way you did then?" You know, and I said, "But I never had any pickups, you know. I didn't. That's not what we did, you know." But you have a look at the young Ukrainians, or the you know, the young Russians, or the young Eastern Bloc Mongolians, and they're ripping people out the ground. I mean, it's just different style of judo, and it just looks different. But now they're starting to do traditional style judo as well.
So can you speak to that? What are the different styles of judo? So for you, you mentioned Shimada, Kaitoshi. These how would you describe them? They're like these effortless, less lifting off the ground and power and like strength and more timing and position, movement, momentum, all this kind of stuff. That's more traditionally associated with Japanese judo. It's like for Japanese judo, the traditional judo, like you're supposed to throw people in a big way without much effort.
And of course, 1990, we saw the introduction of all these Eastern Bloc countries. You know, there were so many more. I mean, it was Soviet Union when I was competing, and then of course in 1990 everything changed, and then there were so many more of them out there, different countries. You know, their wrestling styles were introduced into judo. You know, put a jacket on them and let's get into judo. So judo kind of changed shape. It changed shape from this upright standing, you know, and having to know the technicalities of how to get a body that's weighing 40, you know, 14 stone, you know, whatever it is, up into the air, and using the momentum and the balance and the direction and the skill to do that, and knowing how to do it, you know, and how to use movement. And then you get the wrestlers and the leg picks and the double leg, single leg, double legs, and it kind of by 1995, judo was bent over, and so it was the IOC that went to IJF, the International Judo Federation, and they said, you got to change this, or we're just going to have one wrestling style. It looks like wrestling with judo jackets on. So you either change it, or we're going to take one of you out.
By the way, we should sort of clarify. When we say people are bent over, that's usually how you see freestyle wrestling. Wrestlers are more bent over to defend the legs and so on. And traditional judo, people are more standing up because that's the position from which you can do the big throws and all that kind of stuff. But I think the other case to make for banning leg grabs is, a lot of people are using it for stalling and not for beautiful big throws and all that kind of stuff.
Yeah.
So it's not just not to make it different from wrestling. It's also like you want to maximize the amount of epic throws and dynamic judo and exciting stuff to watch, right?
Win by judo, not by wrestling. And I think that the ones that were shouting about it were the wrestlers, right? Because they like to compete with both. They want to do both. They want to do their wrestling matches and then come into judo. So basically, what we've said is then learn to do judo, and there's nothing stopping you then from doing both, right? But not from the other way around. All right. So rules always dictate development. They'll always dictate which direction it goes. So if you introduce a rule that states that you cannot dive at the legs and just pick up, then you'll have to do it standing up. And also, it increases the possibility of defense with the hips, because actually good defense, judo-wise, standing up, is with the hips, as opposed to sticking your arms out and then sticking your backsides out there just to defend. All right, so if you attack me and I move my body in the wrong place, so I'm in the wrong place at the right time, so you don't hit the right target, and then also I use my hips. So again, it's a form of judo that was being lost. So now we got it back.
So let's go there. Let's speak about judo as if we're talking to a group of 5-year-olds. So what is judo? What are some defining characteristics of judo as a sport, as a martial art, as a way of life, all that kind of stuff?
I think when you say it is a way of life, I think the great advantage that we have in judo, my young grandson, so I got two little boys that are 3.5 years of age, love going to our dojo. They love it, So dojo was the first word that they used. It was one of the first. So when I come to see us, so to see my wife and I, it's like dojo. It's not grandma, granddad, it's a dojo. So dojo, they take their shoes off going into the dojo, so they have respect for where they're at, and I think it has that kind of feeling that, like I tried to build my dojo with a feeling of reverence. It's kind of almost peaceful, so I'm not religious, I'm not a religious person, but I like going to old churches, because when I go into an old church, it doesn't matter, what the religion within the church, but there's a reverence in there.
Reverence is a good word. It feels like a really special place, no matter which dojo you go to. It's just you bow and there's a calmness before the storm of battle or whatever it is.
And respect,
Yeah, respect.
Look at the respect. We were just talking about it just before we came on air. We were just saying that we very, very seldom do we have a situation where there is animosity other than them fighting, So I'm not saying that they don't fight each other, because sometimes it does turn into a brawl, and at the end, two people bow off and show their respect, and one of the things that so a champion, I see people winning events, and they're good judoka, they're excellent, they win world championships, might even win the Olympic Games. But a great champion for me is somebody who treats, who does the right thing when they lose. So when you see them lose, that's when you see the true them. And actually that was one of the biggest things that I had to really cope with. So when I lost that Olympic Games in Moscow, and also the one in Los Angeles, things. The hardest thing is when the microphone's in there and you've got to be respectful and nice, and the hardest thing is to smile. But actually, some of the great champions, you know, they'll go, it's just one match. You know, I remember we've got one great champion, Agbegnenu. She's a 5-time world champion, she's an Olympic champion. She's favourite as well to get this Olympic gold medal, French. What a great champion she is, you know, because she lost one of the matches. I mean, she'd come back and she'd given birth, come back after giving birth. And everybody was going, well, was she, you know, but then she lost one of the matches on the way through. And she said, oh, don't be upset, you know, it's just one match. It's just one contest, you know. Next time I'm going to put it right. And she did put it right. And now she's back up there and she won the world title back. So, you know, these are great champions for me.
Yeah, I mean, that's the right way to see it, but it's also tragic to lose the Olympic Games, you know, twice.
Yes, it is tragic. And I do have sleepless nights.
I mean, that's the magic of the Olympic Games. Anything can happen. And your 1980 Olympics were very different from the 1984. But if we just link on the 80, and just what we're talking about, how much you wanted to win. Do you love winning or hate losing more?
I hate losing more, but I love winning. And I won the world title a year later. And I had no doubt when I went in that day that I was going to be world champion. No doubt.
So you won the 81 World Championship?
At the higher weight.
At the 78
Yes.
kg. Actually, can we go there? What was going through your mind? You ended up armbarring a Japanese fighter. I talked to Jimmy Pedro, a friend of yours, somebody who said you were a mentor to him for many years, and he told me a bunch of different questions to ask you, but he said that was a really special time. That was a really special, like, dominant run you had. And especially finishing with an armbar against a Japanese player. So take me through that. What do you remember from that?
I think that it was, so my weight was better. I didn't have to lose weight. That was one thing. So the nutritional side wasn't as important. Probably, you know, it still wasn't as good as it could be, my nutrition. Although it was getting better and I was trying to eat the right things at the right time. But I still trained really well, and I was so confident going into that World Championships that I could win it. I had no doubt in my mind that I was going to win. But, you know, obviously, corner of your mind, you're thinking, just don't make mistakes. But, you know, this is the incredible thing, is that once you start to ask you, once I see contests change direction when I'm commentating, so I can see somebody who's in there just going forward, just trying to win, right? So and that's different to somebody who's trying not to lose. And there's two different ways there, you know. So sometimes when I was world champion, then I had a period of time where every time I stepped out there, I was really afraid of losing. And I think that that's what happens later on in your competitive career. You know, the great champions manage to come through that. Teddy Riner is one of those. You know, he puts it out there and he keeps beating them. You know, so they can't take it away from him. You know, it's fantastic.
Just stepping on the mat, every single encounter, you're trying to win. You're looking for the grips and with the intention to throw big, even when you're ahead on points, all that kind of stuff.
That's a really good point, is that if you go ahead in a match and you look at the clock, it depends when you go ahead. Like sometimes you can go ahead in the first minute and you've still got 3 minutes to go. So I see the ones then that go into, I don't want to lose, because they go into defensive mode, and then sometimes they can lose it on penalties or something can go wrong, and the other one comes on strong and then they can sneak the contest. And so it's really difficult, but when I was coaching, I was trying to always encourage that positive attitude for the full 4 minutes, 5 minutes then.
I've competed a lot in judo and jiu-jitsu. I've always hated that part of myself. When I'm up on points by a lot, you look at the clock, and it's what you do when you look at the clock. A minute and a half, you're really tired, and you kind of quit. You just defend.
Yeah.
And
I
hated that part about myself. It's like that.
Saying don't do it.
Yeah. Well, as opposed to just go out and in judo, that's for a big throw. Just keep going for the throw. In jiu-jitsu, it's go for the submission. Like throw caution, like win in the real way versus on points. I hated that part. I mean, mostly underneath that is cowardice induced by exhaustion.
Exhaustion's the one, isn't it? You
Yeah.
know, but it is, isn't it? It's a mindset as well. You know, so actually trying to get your mind positive all the way through. You know, so I mean, if you listen, when I commentate now, I say I hope that they don't change the mindset and that they keep on, and they are going forward all the time. You know, and actually they're then more difficult to catch. We had one just a couple of weeks ago, and he lost in the final second of the contest. Lost the final. He was the only one to score. He got penalised all the way up. 2 seconds to go, and stepped out of the area, and you know, but he went like that, thinking the bell was just going, and the bell went 1 second after he actually stepped out. So he got penalised, lost the match, and lost all of the points for qualification. So it was, you know, that's paying high price. That's paying high price.
Yeah, I mean, there's a thin line between triumph and tragedy in those competitions, but especially the Olympic Games. So let's just stick on 81 World Championship. What did it feel like to win that World Championship? Like, and also getting an armbar as a Japanese player. Jimmy told me your arms were exhausted.
Yeah, I mean, you just, the thing is sometimes, you know, when it's competitive as well, you know, ours is different intensity to, like, where you can take time a little bit. Ours is bang, it's transitioning from standing down. You've got 10, 15 seconds to go in there. You go in 100%, a bit like running, you know, full out for 10 seconds, like, and then you've got to decide then, especially if they're defending it, whether you let it go, because when you get up, your forearms are blown, you know, and you've got lactic acid in there, and you've still got to grip up, because remember, ours is about gripping as well on the jacket. So if you can't grip up, then you can't gain the advantage, then they can throw you, you know, so you have to decide. So I had a massive attack on him, and we changed directions 4 or 5 times, and then I wasn't going to let him go. But I still, you know, when I was turning him there, I had to decide, am I going to go all out for this and just, or, you know, like there has been occasions when I've kind of released it to just, you know, if I've got a minute to go and just block out. Yeah.
So what you're saying on the feet, there was a change of direction of all different kinds of attempts, and then you went to the ground. And So what was that? Do you remember that decision of like, okay, am I going to finish this?
Yeah, I knew it. I just, as soon as I climbed his back, and then I thought I'm not going to let him up, you know. So I was just changing.
Voice in your head.
You know, something in my head was going, don't, you know, just stick on him, and then it's always about pressure on the arm, and I just, you know, and of course it was like that, you know, where defending, it was almost total bridge trying to get out of it.
Did it start in turtle, or did you
started in turtle because I did an attack, came back out the attack, and then he went onto his front, and then I was on his back, and then I started the whole.
Saw an opening, and you just went for it.
It was an automatic transition. So I mean, the transitions are what we teach, you know, because the ones that are quicker down with the transitions are the ones that catch it. That's our newas. You know, our groundwork is the transition from standing down to ground. It's very, you know, we don't have a situation where you can kind of work your way in. You are in, or you're not in. You're standing, you know. So you got to make sure that you're in. And so I was just on his back like a leech, and I never let him go.
So you see, I mean, yeah. So that's where the arm bars. That's where the attacks on the ground, which is called Newaza, happens in the transition. Yeah. At that level, at that high world class level.
Yeah, I mean, he was no mug either. I think he just got third place in the All Japan Championships, which is all weight categories. So he wasn't a mug, you know. He was strong, and I'd fought him once before, and I knew he was a lefty as well, which was really awkward for me.
Did it feel good?
Better for me than him.
Did it?
It did. It felt amazing, you know, because it was almost like all these things, disappointments, and everything had kind of come to this one point where I was at last kind of champion of the world. You know, it's everything I said as a kid, that I had no idea how difficult it was going to be. You know, so as a kid, as a 14-year-old kid, I remember saying, "I'm going to be world champion. I'm going to be the best in the world." I had no idea how difficult that was going to be.
Well, there's wisdom to that, right? Like there's power and stupidity of youth,
I like that.
right? Like,
Yeah, it is.
Just like I'm going to be world champion, I'm going to win this without knowing how hard it is. And then once you go after it, it's you're trapped. You're going to have to do the work.
Yeah. Well, I mean, you see it a lot with parents as well. Don't
Yeah.
you? You know, parents, you know, how little Johnny is. He's, you know, he's amazing, and he's this, that, and the other. And they have no idea what's, you know, out
Yeah.
there. I remember the very first time I stepped out in 1974 into the European cadets, and I remember that we were fighting. I'd only ever fought in Great Britain. I was the top, you know, I was unbeaten in the juniors, kids, and went out there, and there were these different fighters out there that were treating me with total disdain. And I remember thinking, how dare they? You know, that it just, you know, and I realized when I came back from that event, there's other people out there. There's just a whole, you know, and there are different levels of, you know, the majority of people are just not informed as to what's out there and the different levels that there are out there.
Do you remember like a certain opponent that for the first time you felt like, holy shit? Like,
Yeah.
There's like somebody's just gripped you up, and there's another level to this game.
Ezio was one of them, and I fought him, you know, and I beat him in the European Championships. I beat him in, you know, two times, and then lost to him in the Olympic Games 2 months after I'd beaten him in the European Championship.
Wow.
Yeah. So it wasn't that
So that's
made it even
literally
more
your
difficult, right?
nemesis there.
Yeah.
Wow.
So that made it more difficult, and so Ezio was one, and getting hold of. I remember getting hold of Nishida of Japan, and he had me going up and down, and I thought, wow, this guy is amazing, you know. And I'd never fought. First time I ever fought Japanese in a major tournament, you know, and I felt the danger. I always talk about the danger when we go out to Japan to train. I could go probably months without getting thrown in training here in Europe, and I go to Japan, you know, everybody's throwing you, you know, and that's difficult to accept. And the reason that kind of danger and that kind of a feeling of danger is something that puts a real edge on, you know. And so that was first time when I got hold of Nishida. I thought, oh my God, you know, this guy, you know, it didn't matter which way he was turning like that, he was stretched out, and I thought, this, I want to do this, you know. And then I ended up fighting him again in Japan.
So that feeling of danger is really interesting. Like I've you know, did Randori with a lot of world-class people from different parts of the world, including Elias Eliadis. And like there's certain part, like Eastern European judo, you feel like you're screwed the whole way through. Like the gripping, you really feel it in the gripping.
It's gripping.
But with the Japanese, like really good Japanese style judoka, you don't. It's a terrifying calmness. But at least the experiences that I've had, you don't really feel it in the gripping. You just feel like anywhere you step, you're getting thrown. It's a different
thing, isn't it?
It's a different thing.
So, I mean, mine was kind of a mixture. I liked it to be a mixture because there was the gripping is definitely the key point. So if you get high level guys that are gripping up, and I always used to put this to the referees when we were doing referee seminars when we first started them. And I'd say, how many, because like they would referee to their understanding of the match. So they were penalizing for certain grips that were, you know, and actually, so as an ex-athlete, high level, I would say, have you ever gripped up with high level? All right, because if you haven't, you need to do it, because then you'll understand why they do certain things with the grips. Because these guys are like, when somebody grips you and you think, you're going to go. When Iliadis puts his arm over your back, all right, and you're going to go up and up.
Yeah.
You're going to go over. That's it.
It's a cool feeling. It's like
not,
whatever.
Not for me.
Well, I understand, but it's like, I mean, because it's not. It feels way more powerful than it should.
Yeah.
It's weird. I don't know. You want to attribute it to strength and all that kind of stuff. I think people say you have like immense upper body strength, but it's probably something else. It's like technique. It's some kind of weird.
It's a mix of everything.
Just like something hardened through lots of battles and doing that kind of stuff.
Yeah.
But it's cool that humans are able to generate that kind of power. It's cool.
But when I was 84 Olympics, but I'm just going to go there now too quickly. But there was, we had a freestyle wrestler. He's American actually, but he had the English nationality. So he competed for Noel Logan, his name is. And he competed for Great Britain. He got third place at the Olympics in '84. But he was training, we were training at Budokai, and he was training, he came to do some judo and put a jacket on. And of course, he was training with some of the lower levels, and he was really handling himself well. And then he said, I need to feel, when we did randori, so he did some randori with me. And I immediately thought, I got to catch it. I got to stop single leg and double leg, because he was really quick, right? So strong as well, 90 something kilos. He was like, he's a big guy. So I caught his sleeve, immediately caught and controlled him, and then he couldn't start, right? So he said, I needed to feel the difference. So then I thought, I better reciprocate this. So I said, well, so we did the randori, and I threw him a couple of times. He said, I'm really glad we did that. So then I said, I need to feel the difference as well. So we take the jackets off. So we took the jackets off, and he was a nightmare. This guy was a nightmare, and like a monster, he was like single-legging me. And, it was just totally different, So it was like the jacket makes a massive difference, huge difference to something, and people think it's just a jacket that we're wearing, but it isn't. It's our only tool, actually.
Yeah, and it's control. I mean, it's a way of establishing control over another body. Yeah. And it's a whole art form and a science. I don't even know if you understand it really. You understand it sort of subconsciously through time. Yeah. Because there's so much involved. Because pulling on one part of the jacket pulls other parts of the jacket. And like the physics of that is probably to understand.
It's absolutely insane. And then, they changed the rules for a little while, and they changed the rules so that you couldn't hold, that certain grips were not allowed. You only allowed a certain amount of time, and there were a lot of penalties for them, and then, they had some of the ex-fighters into the referee commission. And so we were pushing for just let them grip, because that's our game, that's what makes us different. Again, if grip up with somebody like, so they were on about Teddy Riner. Yeah. Teddy Riner comes out, takes the sleeve, big arm over the top, and then, he throws people, right? So they were saying, yeah, but stop. You can't stop him doing it. This guy is 6'9", and he is built like God, he's like, and and not only that, he's skillful as well, and he's got that mentality of a winner. He has got that mentality of a winner there. He just wins important matches.
And he goes over the top of the grip. Where's that land now in terms of rules over the top? Because those are some of the most epic, awesome types of grips.
Yeah.
It's just like over the top, just big grab.
Yeah. Well, as long as they're thrown from it, so they can take any grip, as long as you move them and then catch them, kind of action, reaction, really, as long as you catch them on the move, then you can do it.
So as long as you're not using it to stall or that kind of stuff.
Yeah, you can't block out.
Yeah.
So, I mean, like, for example, if I've got dominant grip on you and I just block out and I just stop you attacking me, so then what? I get you 3 penalties, get you off, and you haven't done an attack. So you've got to stop that. You can't have that.
Yeah, definitely. you were the favorite to win the 1984 Olympics. You got silver. I watched that match several times. You probably have it playing in your head. So there was a nice change of direction by your opponent, German Frank Winecki.
Yeah.
It was a fake right Uchimata, and then to a left drop Sayonagi. How did that loss feel?
Devastating is not, it's not enough really. Because, the strange thing is coming into that Olympics, I was tired, really tired. So my mental state wasn't the best, wasn't certainly the same as it was coming into the previous. And I remember thinking I just need to get this over with, and then I'm going to have a break and just have a rest, and that's totally the wrong attitude. It's just not good for going into an Olympic Games. And so I was coming in there with a different mindset. And I remember every match that I had, I was winning well, but I was winning with a struggle. It was really not. I fought Novak, and I was pretty of France, who was one of the strongest physically. That was in the quarterfinals. I beat Brett Barron by an ippon. I arm locked him. I won my first match by ippon as well. And then Michel Novak, I was fighting of France, and I was lucky to win it. I was up. I would scored on him, but I was like starting to defend and just everything that I talked to you about, and then just about held on, and then I won, and so him and I were talking afterwards, like some years afterwards, and he said I was close, wasn't I? I was, no. I didn't mean it.
Yeah.
But I had to say it, right?
Of course.
So no, he was right, and it was one of those. So I was through to the semi-final. I fought Lesak in the semi-final and I fought him in the semi-final of the world as well. I'd never gone time with him, I'd always beaten him fairly easily and by ippon, and that went time. So I was just glad to get it done. I was in the final then against Frank Winecki of Germany, and I'd beaten Winecki before, but he was just a young German coming through. And when I started the final, I thought, right, I started all my techniques just that little bit off. Nothing was coordinated. It was just, I can't really explain why it was just a little bit off. I see it so often now with a lot of the guys that are going for second, third Olympic Games, and I see their technique just not quite there, and they're struggling, and I know when I know what they're going through, and I kind of empathize with them.
Well, it felt like you were dominating that fight.
I dominated it. Yeah, I was winning. Yeah, and actually, if it had got another minute and a half, it would have been all over, and I would have been Olympic champion, and it would have been done. He wouldn't have batted an eyelid, right? Because he would have fought me really, really well, and he would have. We talked about it afterwards, and he said it was just my good day for me, and he knows. He was very respectful. This guy is very respectful.
He was surprised almost. I mean, not almost. He was very surprised and celebrating like a surprise.
Yeah, jumping up and down, like he just, and you can look at that, can't you? Go, well, it wasn't ippon, but would I got it back? I don't know. I think that actually taking the pressure off, because that was another thing as well. Pressure of being favourite, and I see that with a lot of them. And the great champions, the ones that keep coming through, Kapellik. There's a guy, he can look very ordinary, and then comes the big tournament, and he'll win it.
The tragedy of the Olympic Games. I mean, you were the favorite. Just like that, like split moment, you lost it.
Split moment, devastated. And lived it probably, not every day, but, Nikki, my wife, will tell you that woken up in sweats, and I think they contributed as well, because I had a period of my life after where I was drinking too much, and I think kind of when I look back, kind of led into that kind of dark period of my life, and I never ever did it go through my mind anything else, but it definitely affected me, and I was on a downward kind of spiral in a lot of different ways, and would still, even I mean, we have an amazing marriage and we have an amazing family, and everything's great, but I still wake up sometimes and I'll say, I've just dreamt, that, and it's the same reoccurring dream where I'm trying to get somewhere and I'm trying to put it right, and I've got this chance of putting this Olympic final right, in this dream. I've got a chance to do it, but I can't get there, and the traffic's stopping me, or something stops me, and and then I wake up and I'm sweating, and you think, well, after all this time, that's not possible, but it is, and it happens.
Yeah, I mean, in the match itself, there's that feeling. For me, just watching it, like you're going for throws, you're almost getting there with the throws, and it's almost like he's going for a kind of crabby Jimata, and then you're just like, you stop, you're blocking it, and all of a sudden, I mean, that's the beauty of the Olympics. He finds it in himself to switch.
Yeah.
And that, like, against favorite, against sort of the great British judoka, just finds the perfect drop fin on him.
Well, his team doctor and coach, he came up to me afterwards and said, "I'm just really sorry." And that's all they said is, "I'm just really sorry." They were sorry because, obviously the obvious sadness about that, and of course, everybody takes their, I went actually 3 weeks later, the German Open. So he had to compete in the German Open 3 weeks later. So I went over to fight him and beat him in the final of the German Open. And it didn't do anything for me because it was a much tighter match. He was a lot closer. He had a lot more confidence coming in. So he fought me a lot differently. And then it was me pulling it back and just managing to win in the final. And I thought, well, that might appease nothing. Didn't do anything.
When you give your whole life to judo, and your love of winning, it's crazy how much the Olympic Games mean.
It means so much, and I think, but I've got to say this, and this is honestly, if it meant that if I'd have won that Olympic Games and it had changed my life into a different direction, which I probably would have not competed in the '88 Olympic Games then. All right, so if it had changed my life, and then I didn't meet my wife, and I, didn't have my family that I've got now, there's no, I wouldn't swap what I've got now, for anything.
Well, part of the demons that you've gotten to know because of those losses is part of probably the central reason that made you the man you are. A legend of the sport. You could have been not that. Because an Olympic gold is just an Olympic gold.
Yeah. And it is, isn't it? And I think that there's a lot of Olympic champions and world champions that win and then are forgotten. And I said to Nikki, I said, my wife, I said, I don't want to be forgotten and I want to be remembered. So I'm going to do anything I do, if I'm going to do commentary or whatever it is, or coaching, I want to do coaching to a high level. I want to commentate at a high level. I remember the first commentary I ever did, it was terrible. And I just thought, I've got to do better than this. And I thought, I need to do it well. And I've got to do it professionally. So
in the book, A Game of Throws, you have a chapter titled Lessons in Losing. So what are some of the lessons here? What are some of the deeper lessons you've pulled out of losing?
I think great champions are made up of the people that handle it in the right way. And you could say, well, I don't like losing, and and you could throw your dummy out the pram, and you can be a bad loser in front of everybody. And actually, people pick up on that very, very quickly. You know what it's like in broadcasting, right? When somebody has a bad word to say about somebody, and and but actually, the ones that endear themselves to you are the ones that handle it in the right way, the correct way. Doesn't mean that you've got to like it. I didn't like it. And I thought that I handled it certainly in later years in the right way. and I like to see athletes do it in the right way. And I think it's a make or break situation. It's not all the contests they win; it's the one that they lose, and then how they pick themselves up and handle themselves after. So I think that is a big one for me. And also, I mean, I went through, obviously a later divorce, and that was difficult on my son, really difficult on Ashley. And then I think that some of that was the fact that I was, I wasn't drinking all the time, but I was drinking in excess at the wrong times, and I think that that's what a lot of people do sometimes, is that they use it for the wrong reasons, and I used to hear it, I hear it now all the time, and is that, I need to knock the edge off, and I need to just forget, and I need to, and you need to be in a fuzzy place for a while. And I had a lot of time in a fuzzy place, and I needed to get rid of that, and I needed to clear my head.
Where was that place? Some of the lower points in your life that you've reached mentally?
I think, definitely, the fact that my first marriage didn't work, and that was, it's a mix of things that, between us. And then, so that's not where I wanted to be at the time. And the effects that it had on my son, and it took a long time for him then to come around and to trust me again, and to have belief. He always had belief in me, but to trust me again. And then I think that was low. And I think that, when I look back, is that a lot of my bad decisions were when I was in that fuzzy kind of haze, and that it got progressively worse. That got progressively worse to the degree where it was, trying to hide it and trying to hide how much. And I was kind of a functioning kind of drunk. I think you could probably say that. And I was functioning. I was still training most days, crazily enough. I was training to kind of mask it and cover it. And that was probably my savior, that I was still, because I remember I said to my wife, I said to Nikki, I'm probably the fittest, if I'm, a drunk, then I'm the fittest drunk in the world. She said, yeah, you probably are, actually. I was in great condition for a drunk.
So the fuzzy haze, where was your mind? Did you have periods of depression?
I had periods of depression. I can honestly say that my depression wasn't that bad, although I did, when it's like anything that gives you an up, it gives you an even bigger down, doesn't it? And so I hated that feeling, and also hated myself for letting it happen, because I have got this really, it's a bizarre, I don't know whether you can call it a power, but I have the ability to be able to say, stop. And I can just, and that's what I did in the end. In the end, there was an incident when I was working for Belgium judo, and there was an incident. It was Christmas. It was, I tell you exactly the day. It was 20th of December, and me and a Belgian coach, we got absolutely hammered. But we were at the wrong place, and he got noticed, and so I remember they pulled me up in front of this board, and I looked down at these guys, and half of them were people I didn't want to be in that situation with. They're not people that I respected, and they're not people that I trusted. So I said, if you're going to sack me, but I'll promise you now that this is it, I'll stop. I'm just going to stop. I've decided. On the way back in the car, I rang Nikki up, my wife, and I said, whatever you hear now, whatever, I'm just going to stop. So that was it.
You just saw the moment and said, stop.
Stop.
So that fuzzy place, what advice could you give to people about how to overcome that dark place, the depression, whether it has to do with drinking or not?
I think if it's to do with drinking, I can say is that the 2 days or a week into not drinking, you'll feel different. You know, it'll make a physical difference, and you'll like that physical difference. And then from a mental perspective as well, because I think that you know, you have a massive downer, you know, and I think that must be because of drugs as well, because I had a situation with my brother. You know, he was like you know, he was professional wrestling, and the drugs was an element there, and you know, so I'd never touched a drug or even seen one in my life. But you know, I'd let the alcohol side go too far, and then decided never to do that. So then I guess I had people ringing me up, you know, saying, you know, how can we stop? You know, so when they say, "Can I have a word? Can I discuss something with you?" And I know then what they want to discuss with me, you know. And the thing is that I would say, you know, if you stop, then feel the effects of it, and it will make a difference to your everyday life, and that will make a massive difference. And I think about anybody who kind of, you know, is down all the time, is to find the cause of what's pushing you down. You know what I mean? And try and attack that. I mean, because it's never. Somebody once said to me, they said, whatever you got, you know, we've got something special. I mean, we have a great life, and I've had a great competition record. You know, it could have been better, but it was great. But I've had success with my business, and we're still out there, and we have a great life. We travel all the world, and you know, there's people out there that would live in your house at the drop of a hat, wherever you are. They drive your car. You know, no matter what car it is. Some people haven't got a car, you know, and whatever food you're having and you're moaning about food, right? There's somebody out there that would take that and gladly eat that. All right. So there's always somebody worse off than you. And I think that we tend to sometimes, you know, look at the things that we haven't got rather than the things we have got.
Yeah, it's a skill probably just to be grateful for the things you have, exactly as you said. And this sometimes the little things like food and cars, and all that kind of stuff. Just to have gratitude for your family, all this kind of stuff. But it's still, I you know, having talked to a bunch of Olympic athletes, there's you know, when you give so much of your life to winning, and then you lose, sometimes even when you win, but when you lose at the very top, it's a tough thing to go through.
The most difficult thing, I think, for anybody is when they have to decide when to stop.
Yeah.
You know, and you know, that all of a sudden, and I see the ones that are going to second Olympic Games and then third Olympic, and the ones that are there and they're holding on and they're in their 30s now, different to when they were 19 years of age. You know, 30 something is different to 19, and then what are you going to do afterwards? You know, and then how do you become just a normal person? You're never going to be a normal person as such, but I think you've got to do normal things, you know. And then you've got, I remember the first time when I finished the competition, I had good sponsors. This was, you know, 40 years ago, but I had two really good sponsorships, vitamin company and also judogi company. And I had a car, and you know, I had money. I just and I was going all over the world. I was successful, and then I stopped. And they took everything back. They took my car. They did it within 2 weeks as well. They stopped my funding. They, you know, and the vitamin company said, "Thank you very much. It's been a great, you know, we've done well. Bye bye."
This was after your last Olympics.
88 Olympics.
Yeah,
just, you know, when that finished, and then that was it. You know, and then it's right. Okay. First time I had to go in there and buy a tracksuit and a pair of training shoes. And, wow.
Yeah, those are different. Sitting there in the evening by yourself.
So you go from 7 days a week or 6 days a week going into the gym, and you know, you're working out the dojo, and then you don't have to do it. You know, and that's why you get a lot of, when they finish competition, they finish that 30 to 40. Still, I mean, Ilias is still doing it now. He's still in there, and he's still, you know, and because he can, right? Okay, and it's natural, right? Did exactly the same, and then, like I say, you just get to an age, and you just think, just kind of take a step back.
Which is why, like, there's certain athletes like Rio Kotani never stops. It just dominates for 14 years. Probably one of the winningest athletes in judo.
Yeah.
7-time world champ, 2-time Olympic champ, medaled at 5 Olympics. So it's always impressive.
Never stopped.
Never stopped. So that's an option. If you're like the greatest ever.
It'd be interesting, wouldn't it, just to see what they're doing now, you know? I mean, because at some stage you have to get a normal
You do
job.
have to stop.
You do have to stop, you know, at some stage you have to decide what you're going to do. You know, and you know, it's either into coaching, the judo is either into coaching, or if you're not in coaching, then it's into something to do with the media. And you know, I was lucky that it was just by accident, really, with the commentary. Somebody said, would you do a voiceover? So I did this voiceover, and that was back in 1982. I did that.
So you've been commentating since 1982.
I did some voiceovers. I wouldn't call it commentating, but I did some voiceovers, and then I did some. We did some different European Championships, World Championship kind of events, and I did the voiceovers for it. And the way that it was done, it was more narration, and so it kind of turned into. Then somebody asked me to do an event, and when you listen to the intonation of the voice and stuff like that, it wasn't like it is now. But I guess that's just something that developed, as you know, because then it was coming from the heart, and I, you know, started to get excited and just do my thing, and it was just me, really, just my style.
Well, I've listened to your commentary from a while back. I don't know if it's the 80s, but it's still there.
I think your timing as well, isn't it? It's like, you know, you get your timing a bit better and know when to go in, when to come out, when to say something, when not, you know. And I think that in the early days, I tended to want to talk all the time, and you don't have to do that.
Also knowing when to shut up.
That's the key, isn't it?
Yeah, part of the drama is in the silence, building up to the setup and the throw and all that kind of stuff. But also, you're very good at, while radiating passion, being very precise and specific about the details of the throw and the setup and why something worked and didn't. So.
Yeah, I think there's two kinds of commentating. You can commentate what you see, and then you commentate what people can't see, you know. And so if you've got somebody that is not really understanding of what's happening in the inner part of the game, so it might be a technical thing, or it might be the tactical part of the play here that's going on, and if you can introduce that as well, then you've got an advantage.
Quick pause. I need a bathroom break.
Okay, good stuff.
So we just took a little break and went to judotv.com, which is, I guess, an IGF website. IGF is the organization behind a lot of the big judo events in the world. And I just signed up. You should sign up too. It's great.
Absolutely.
You can win.
Cheaper the price. Cheaper the price.
Yeah. And you can watch basically any match from the Grand Slams. Going back to history, I guess.
Yeah, I've got to say, Lex, I mean, everybody, still people are saying to me, oh, you know, we need more judo on television. They've got judo on television every other week that they can access. All of the top people in all the top events. And it costs $100 a year. You know, it's to access everything. And they can play all the videos. I mean, we've just accessed this here, the Paris tournament, and we're going to have a look at Teddy Riner. But, you know, it's so it's cheap at the price.
So we're now at Paris Grand Slam 2024, Teddy Riner final. By the way, it's super cool. Like, you click on the draw, and you can just look at any of the matches. You go at the bottom of the finals, you can go.
Yeah, to anyone.
Any one of them. That's so cool. It's really well done. Really well done, Chris. Anyway, let me first ask a ridiculous big question. Who do you think is the greatest of all time? Is Teddy Riner in the writing?
He's the greatest judo winner of all time. Of that, there's no doubt. You know, I mean, he is the, and I think if you asked him whether he was the greatest judo man in the world of all time, he would say, "No, I'm not." And he's not the greatest judo man. There are people with, more beautiful judo in some ways, although he's got great technique. But he is the ultimate winner.
10-time world champ,
Yeah.
2-time gold medalist in the Olympics. I guess 2-time bronze medalist. He's going to Paris?
Yeah,
He's going after it again. So he's right here. I mean,
he's right there. This is just a couple of months ago, and then last week, he was out again and he won again.
You think he gets gold medal this time?
There's people getting closer to him, right? Because he's obviously, his age-wise and the amount of time that he's been there, he's obviously somebody that is starting not quite at his best as he was when he was younger. But he, like I say, he still puts it on the line. He lays it on the line every single time. And then not only does he lay it on the line, but he beats them all. And last week he just beat Saito, who was a young up-and-coming Japanese fighter, and he beat him in the final. It was close, and he did well. There are certain people, the smaller ones actually, not the taller ones, because we're saying about the big arm over the top that he likes, and the dominant grip that he likes. There are people that can give him a hard time. Now, if at the Olympic Games he has 2 or 3 of those on the trot, it might work against him, and it's by no means an absolute certainty that he's going to win the Olympic gold medal. But he's got to be one of the favourites, top favourites. No matter what happens now, Teddy Riner is the greatest winner that, and if you asked the great Yamashita, he would say the same. There's nobody that's, and Yamashita was unbeaten in international competition, and I trained with Yamashita a lot over a 2-year period and got to know him quite well. And he was one of the greatest of all times. For me, he was one of the greatest judo men. And I'm talking about from a technical point of view, from a spectacular judo point of view, understanding the fundamental principles of how techniques work. Sometimes having, different techniques that work for you. So if one doesn't work and one particular direction doesn't work, you can change the direction completely.
In case people don't know, Yamashita is this legendary judoka, heavyweight. Teddy Riner, heavyweight. That's plus 100 kg. So he
would have caused him all sorts of problems.
Yeah, that's who do you think wins, Yamashita?
Yes, I think Yamashita.
No,
but
wait. Do you think Yamashita beats Teddy Riner?
I think so.
Strong words. You think so? Yamashita is on the shortest side, right?
Yeah, and he finds it more difficult with shorter people, and so it would have been a very interesting confrontation. And I think if you ask Yamashita, he would probably say, that Teddy Riner, he's very gracious. He's really gracious. It would be really good. It would have been an unbelievable matchup. And I've got to say this, that, Teddy Riner is the greatest winner of all time.
Competition-wise. So it's interesting. Both of them, maybe you can correct me, but have this Osoto Gari kind of trip that I never understood.
Yeah.
Like it's a very tricky thing to do, right? It's very easy to do maybe as a white belt, when you can understand. But like to do it at the high level.
You see any of the top guys now, especially if they're second time out, so like they might catch somebody by surprise. They come out, they go bang, and you go, that was amazing, right? But if they fought again 10 minutes later, you go, you're not going to catch me with that, right? You got a different situation here, and so it's slightly different. But the best fighters adapt like that, and they're able to see a situation, feel the situation, and they attack once and then go again and attack second, third time, and in the third time they make it work.
Yeah, both Yamashita and Teddy Riner with the Osoto Gari, they're just like hit it over and over again.
Yeah, sometimes they'll hit first time and it won't go, and then you make a readjustment as a way in. It's a little bit like, if you take a really easy way of understanding it, is that if we're shooting at a target, and all of a sudden you start moving that target. You know, it's different hitting a moving target, but it's also different hitting a moving target that's trying to hit you as well. And that's our game, right? So we're not only trying to throw a moving target, we're trying to throw a moving target that's trying to throw us. So that makes it even more difficult.
Yeah, there's a few folks who you know what's coming. It's like over and over and over. It's the same attack. Anyway, with this Uchimata, it's like it's different. It's different. There's not many people like that where it's like the same attack. I mean, there's other attacks also, but they'll just go after the same thing over and over and over.
When I watch great athletes, most of them can throw over both flanks. Not always going left and right, you know, although our sport always, I mean, the katas are always demonstrated left and right. So, like, if you do something on one side, you know, then can you demonstrate it on the other side, right? Okay, so can you do it equally? No. Well, you do it differently, right, on the other side. So, you know, when I'm teaching, I don't teach left and right. I teach, so if I was teaching you to do a technique, first thing I'd do is say, I need you to take the sleeve and the lapel. All right, so I'd let you decide what was left and right. Okay, because often what happens is we impart on people whether they're going to be left or right when we start teaching. You know, you get a lot of teachers do that. All right, and they'll say immediately, what do you write with, left or right hand? And it's no indicator actually as to how we do that, because I'm left-handed and I do more predominantly right-handed because I lead off my strongest hand. And actually most people do, you know, so actually left and right is a bit of a trap sometimes, you know, when we're teaching. Better to get, you know, because we can go, so my point is that a lot of people can go both flanks. So they'll do something over this side, something over this side.
But anyway, it was one-sided.
He was one-sided, but he could switch it. So he had a Cianagi as well on the other side. So he could switch it.
And by the way, your opponent in '84, was he righty or lefty?
He was a righty.
So that drop left.
Yeah.
Where did that come from?
Well, I mean, again, it was, you know, he could have probably in other contests he'd hit me with it several times, and I'd just stopped it, you know, and, just at the wrong place at the right time for him. Right place at the wrong time for me. Right. Yeah.
All right, let's watch from Peggy.
This is final of Paris tournament, and this is against the Korean. The Korean had a great day, actually.
Shorter.
Again, he's shorter, so he does find that difficult. How about Teddy Renier? Teddy Renier will try and catch the sleeve. He's after the sleeve and then the right arm over the top. That's the key point for Teddy Renier. And of course, what he has done, if he can't always catch the big Osodogari over his right hand side, he's been doing something to the opposite side.
And the Korean just went for drops there. And the Teddy Renier blocked with the hips.
Like I say, it's difficulty always against somebody smaller, dropping with the Cianagis.
Has Teddy Renier ever been thrown for Ippon?
Never seen him thrown for a ton, but he was thrown last week for a nice technique. And he's being caught more and more.
He's getting close.
Yeah, and to say in the final of the World Championships, they had a strange situation there where Tisayev was a technique down and then pulled off a counter, and they didn't count it, but then they overruled it. Unfortunately, I was commentating at the time, and I went for a score for Tisayev, and anyway, they overruled it, and then they awarded a second gold medal to Tisayev.
What can you say about Carmel and Bashayev, who also gave him trouble?
Yeah, Bashayev and Tisayev are the two that could possibly go to the Olympics. So that was a close one there from Renier. That was the closest that he'd actually been.
Oh, wow.
So didn't have the sleeve, and he relies on the sleeve greatly. good support there from the French in the crowd.
And also, maybe can you explain the penalties for stalling?
Yeah, so if they don't attack, if they've got a grip and they've got sleeve lapel or they've got two hands on, if they're too passive and they don't attack, they've got dominant sleeve grip, they don't attack. That was quite close as well from the Korean. So the Korean here, you can see, is having a real go. You know, the penalties will come if they don't attack at the right time. Step outside the yellow area, they'll get penalised as well. That
That's dedication for
absolutely. I mean, it was really close, wasn't it? A nice little Koichigari there from the Korean. And if they touch below the belt line with the arms, so if they're not allowed to grab the legs. They've stopped grabbing the legs.
Wow, the Koreans really go.
Koreans having a real good go at it.
I guess every single person in that division is probably trained for Teddy Riner, right?
I think that Teddy Renee's been there a long time. You know, and he's got another guy here in the final of the Paris. They were saying, yeah, but stop. You can't stop him doing it. This guy is 6'9", and he is built like God. You know, he's like, and he's and not only that, he's skillful as well. You know, and he's got that mentality of a winner. He has got that mentality of a winner. There, he just wins important matches.
And he goes over the top of the grip. Where's that lamb now in terms of rules over the top? Those are some of the most epic, awesome types of grips.
Yeah.
Just like over the top, just big grab.
Yeah. Well, as long as they're thrown from it, so they can take any grip, as long as you move them and then catch them, kind of action reaction, really. You know, as long as you catch them on move, then you can do it.
So as long as you're not using it to stall or that kind of stuff.
Yeah, can't block out.
Yeah.
So I mean, like for example, if I've got dominant grip on you, and I just block out, and I just stop you attacking me. So then what? I get you 3 penalties, get you off, and you haven't done an attack. So you've got to stop that. You can't have that.
Yeah, definitely. You were the favorite to win the 1984 Olympics. You got silver. I watched that match several times. You probably have it playing in your head. So there was a nice change of direction by your opponent, German Frank Winecki. It was a fake right Uchimata, and then to a left drop Sayonagi. How did that loss?
Devastating is not, it's not enough really.